Welcome to the Complete JavaScript course. In this course, we're going to learn how to build complex websites using JavaScript from a beginner to a professional level. And by the end of this course, we're going to build Amazon.com. So this is an interactive multi-page website where we can add products to our cart, create an order, and even track our order. Along the way, we're also going to build some smaller projects like a rock, paper, scissors game, a to-do list, and a calculator. Now, you don't need any previous coding or technical experience to follow along. This course will cover everything that you need to learn JavaScript. We're going to start from the very basics of JavaScript, and we're going to build our way up step by step. We're going to learn the major features of JavaScript and also how to use JavaScript together with other technologies like HTML and CSS. We're also going to learn more advanced features like object-oriented programming, Backend, Callbacks, promises, and Async Await. And we'll use these features together to build a complex project, which is the Amazon project. This will let you practice what you learn and deepen your understanding. You can find the different lessons of this course below the video here and here. If you need to, you can adjust the speed of the video here. And after each lesson, I'm going to give you a bunch of exercises that you can do on your own to practice the skills that we learned. In total, this course will have over 250 exercises. So with that said, let's get started. Before we begin, if something in this course is not working properly, make sure to check the first comment below the video for a list of solutions. I'm going to be doing this course on Windows, but the steps are the same if you're using a Mac. We're going to start from the very basics of JavaScript and build our way up step by step. First of all, what is JavaScript? JavaScript is a technology that we use to create websites. A website is like YouTube.com or Amazon.com. It's how we access YouTube and Amazon on our computer. If we were using a phone, we usually use an app, but on our computer, we use a website. So there's actually three technologies that we use to create websites: HTML, CSS, and JavaScript. Each of these technologies has a specific purpose when creating a website. HTML creates the content of a website. It creates all the buttons, the text, and the images. CSS changes the appearance of the website. By adding CSS, we can make our website look nice. And finally, JavaScript makes our website interactive. So if we only have HTML and CSS, and we click one of these buttons, our website doesn't do anything. But once we add JavaScript, we can make our website do something when we click a button, such as add a product to our cart or create an order. So this course is focused on JavaScript. If you want to learn HTML and CSS in more detail, I have a full course just like this one that you can find in the video description. Let's get started with JavaScript. The first thing we need to do is to install a piece of software called a web browser. A web browser lets us view websites that we create in this course. The most popular web browser for web development is Google Chrome, so I recommend using that. If you don't have Google Chrome, you can open the default web browser on your computer. For Windows, it's Microsoft Edge, and for Mac, it's Safari. Type in google.com at the top and press enter. Search for Google Chrome. Click the result and follow the instructions to download and install. Once we've installed Chrome, we're ready to begin. We're going to start by learning what exactly is JavaScript and how does it work. The easiest way to understand JavaScript is we're basically giving instructions to a computer, and then the computer follows our instructions. I find the best way to learn this is to jump in and give it a try. So first, let's open Google Chrome. Next, we're going to click at the top here and type SuperSimpleDev/JS-Basics and press enter. And now we'll learn how to give our computer some instructions to follow. To do that, we're going to go to a blank area of the web page. We're going to right-click, click Inspect, and then click the Console tab. Now, if your console doesn't show up at the bottom like this, you can click these three dots here, and then select this icon. Okay, so inside the console, we can give some instructions for our computer. Let's learn our first instruction. We're going to type here, and we're going to type alert, open bracket, single quote, hello, single quote, close bracket, and semicolon. Make sure to type this out exactly as I have it here. In JavaScript, if you don't type things out correctly, it won't work. So this is an instruction to create a pop-up with the text hello inside. To get the computer to follow our instruction, we can just press enter. And as you can see, the computer does exactly what we tell it to do. It creates a pop-up with the text hello inside. Now let's press OK. And let's give another instruction to the computer. So we're going to type here again, and we're going to type alert again, open bracket, single quote, but this time we're going to type a different message in the pop-up. Good job, and single quote, close bracket, and semicolon. So this is an instruction to create a pop-up again, but this time with the text good job inside the pop-up. If we press enter, the computer does exactly what we tell it to do, and it creates a pop-up with the text good job inside. And that's basically the main idea behind JavaScript. We're giving instructions to a computer, and then the computer follows our instructions. So note that we can open and use this console on any website. We're just using SuperSimpleDev as an example. Let's press OK. And we're going to learn some terminology, or naming. The instructions we give to our computer, these instructions are called code. When we press enter and the computer follows our instructions, this is called running the code. Now, there are many different languages we can use to write code, called programming languages. It's similar to how we have many human languages that we can use to communicate. Some examples of programming languages are JavaScript, Python, and Java. So here, we're writing our code using the JavaScript programming language. So we call this JavaScript code. Now that we understand the basic terminology, let's look at some more examples of what we can do with JavaScript code. Another thing we can do is math. Let's go back to the console and type here, and we're going to type 2 plus 2. So this is an instruction or code that tells the computer to do some math, to calculate 2 plus 2. When we press enter, the computer follows our instruction or runs this code, calculates 2 plus 2, and gives us the result, which is 4. Let's do another example. We're going to type 10 minus 3 and press enter to run this code. Again, the computer does this math, calculates the result, and gives us 7. So as you can see, JavaScript can do many different things, like create pop-ups and do math. Let's look at one more example of what JavaScript can do. We're going to go to the bottom and type out this code. document dot body dot inner capital HTML equals single quote hello single quote and semicolon. Make sure to write this out exactly as I have it here, with the dots and the capital letters, because JavaScript is case sensitive. Let's press enter to run this code. What this code does is that it removes everything on the page and replaces it with the text hello. In this example, we use JavaScript to modify the web page. Modifying the web page is one of the most important features of JavaScript, and we're going to be using this feature throughout this course. And that's the basics of JavaScript. We're giving instructions to a computer. These instructions are called code, and then the computer follows our instructions. This is called running the code. And also, don't worry about memorizing all this code. You can find a copy of all the code that we write in this course in the video description. Now that we understand the basics of JavaScript, let's learn more about the JavaScript language itself. If we take a look at this code, alert and hello, you might be wondering what the brackets and the quote mean. All of these characters have a special meaning in the language. This is something called syntax. Syntax are the rules that we have to follow when using a programming language like JavaScript. This is sort of like in English, we also have rules that we follow called grammar. The difference is that in English, we don't have to follow the rules of grammar perfectly. People can still understand us. But in programming, we have to follow the rules of syntax exactly. Otherwise, the computer won't understand our code. For example, if we scroll down and we type this code, alert, open bracket, quote, hello, quote, close bracket, and semicolon, but this time we remove the first bracket and press enter, it will give us a syntax error. We're not following the rules of syntax, so the computer doesn't understand this code. Now, JavaScript has a lot of syntax rules, and we can't learn them all at once right now. Instead, we're going to learn the syntax rules one by one as we go through the course. For now, we'll just learn enough syntax to do the exercises at the end of this lesson. What we need to know is that if we scroll up, this part of the code tells the computer to create a pop-up. The text between these quotes is the text inside the pop-up. If we change this text, we can change the text inside the pop-up. Same thing for this code down here. If we change the text between the quotes, it will change the text that appears on the page. And that's all we need to know about JavaScript syntax for now. We'll learn exactly what the other characters like the brackets, quotes, and semicolon mean later on in this course. So in this lesson, we learned that JavaScript is basically giving instructions to a computer. We wrote our first few lines of JavaScript code. We learned how to run our code using the console in our web browser. And we learned about syntax, which are the rules that we have to follow when writing our code. Thanks for watching this course so far. If you want to support this channel, you can check out the premium version of my courses just like this one, where you can get a certificate of completion and a better learning platform. If you're interested in extra videos from me, more in-depth videos, and behind-the-scenes content, you can check out these links here. You can also support the channel by liking the video, subscribing, and sharing this video with others. Thanks again, and let's continue with the course. Here are some exercises you can try on your own to practice what we learned in this lesson. You can find the solutions to these exercises in the video description. Now that we understand the basics of JavaScript, we're going to learn about each feature of the language. In this lesson, we're going to focus on numbers and math. First, we can close the console for now. So I've actually prepared a project that we can use for this lesson. To open this project, we're going to go to our browser, click up here, and type supersimpledev/projects/Amazon and press enter. So this is actually the final project we're going to create in this course. This is an e-commerce website similar to Amazon, where we can add products to our cart and then view our cart by clicking the top right. And on this page, we can see the products in our cart, modify our cart, and create an order. For this lesson, we're going to focus on this right section, which calculates the cost of our cart, including the cost of the products, shipping, and taxes. This section is a great way to learn numbers and math in JavaScript. First, let's open the console again so we can write JavaScript code. We're going to find a blank area of the web page, right-click, click Inspect, and then click the console. So we already saw some examples of math in the previous lesson. For example, we wrote the code 2 plus 2. If we press enter, the computer adds these two numbers and results in 4. We also did 10 minus 3. If we press enter, the computer subtracts these two numbers and gives us 7. In addition to adding and subtracting, we can also multiply and divide. To multiply, we're going to type 10 star 3 and press enter. So star is the character for multiplying. To divide, we're going to type 10/2 and press enter. So / is the character for dividing. Now let's learn the syntax rules for numbers and math. The syntax for math is pretty straightforward in JavaScript. We just write it out like normal math. We can also do math with more than two numbers. For example, we can add 2 plus 2 and then plus another 2. If we press enter, the computer will add these three numbers together and result in 6. And finally, JavaScript can handle decimal numbers like 2.2 plus 2.2. If we press enter, it will calculate these decimal numbers and result in 4.4. Now let's do some practical examples. We're going to calculate the numbers here in our final project. But first, let's set up our cart so we have the same products in our cart. So make sure in your cart you have 2 socks with free shipping and you have 1 basketball with $4.99 of shipping and nothing else in your cart. If you need to, you can modify your cart by clicking Update or Delete, or by going to the home page by clicking in the top left and adding any products that you're missing. Once you have the same products as me in your cart and you have the same numbers on the right, we're ready to begin. Let's start by calculating this number up here. This is the cost of the products before shipping and taxes. To calculate this number using JavaScript, we're just going to add the cost of the products. So in our console, we're going to add the cost of the socks, which is $10.90. We have 2 of them, so we're going to multiply this by 2. And then we're going to add the cost of the basketball. So plus $20.95. If we press enter, the computer will do this math calculation and give us this number. And if we scroll to the top of our project, you'll see that the number that we got matches what we have on the page. So that's how we use JavaScript to calculate this number here. Let's do another example. We're going to calculate this third number, which is the cost of the products plus shipping. Feel free to pause the video if you want to try it yourself first. Otherwise, we'll do it together. Let's go back to our console, and we're going to add the cost of the products again, which is $10.90 times 2 plus $20.95. But this time, we're going to add the cost of shipping, which is $4.99. So 4.99, and press enter. The computer will do this calculation and give us this number, which matches what we see in the final project. Next, we're going to learn a very important feature of math called the order of operations. Adding, subtracting, multiplying, and dividing, these are called operations, and the characters in the middle are called operators. Now, there's a certain order that we do these operations. For example, if we go back to our console and type the calculation 1 plus 1 times 3 and press enter, notice that it multiplies 1 times 3 first, which equals 3, and then adds 1, which equals 4. Notice that it does not add 1 plus 1 first, which equals 2, and then 2 times 3 equals 6. The way math normally works is that multiply and divide are done first. Add and subtract are done after. This is called the order of operations, and JavaScript follows the same rules. Multiply and divide are done first. Add and subtract are done after. The order of operations is also called operator precedence in JavaScript. One thing to note is that multiply and divide have the same priority. So if we have both in a calculation, it will calculate from left to right. Add and subtract also have the same priority. If we have both in a calculation, it will also calculate from left to right. Another feature of the order of operations is that we can use brackets to control which part of the calculation gets done first. For example, let's type out this calculation again. 1 plus 1 times 3. But this time, we're going to add an open bracket and a close bracket around 1 plus 1. If we press enter, now the calculation inside the brackets will be done first. So it will add 1 plus 1 equals 2, and then 2 times 3 equals 6. So when we use brackets, JavaScript will always do the calculation inside the brackets first, and then do the rest of the calculation. Brackets have the highest priority in the order of operations. Now let's learn the syntax rules for brackets. So we just have to have a matching open bracket and close bracket. So something like this doesn't work because we have 2 open brackets and no close bracket. We also need to have a complete calculation in the brackets. So this also doesn't work because 1 plus 1 multiply is not a complete calculation. Now let's do some practical examples using the order of operations. First, we're going to do some more setup in the final project. So we're actually going to remove all the products in our cart. And then once our cart is empty, we'll go to the home page by clicking the top left. And this time, we're going to add some new products. So we'll add 1 basketball and 2 t-shirts. Now let's go back to our cart by clicking the top right. We'll scroll down, and we're going to calculate the numbers in this section again. Let's calculate this number at the top, which is the cost of the products. We'll go back to our console and add the cost of the basketball, which is $20.95, plus the cost of the t-shirts, which is $7.99. And we have 2 of them. So we'll multiply this by 2. If we press enter, this will give us the number that we see in the final project here. Notice that in this calculation, we're taking advantage of the order of operations. Even though multiply is written last, we still multiply these 2 numbers first. So we calculate the cost of 2 t-shirts first, and then we add the cost of the basketball after. Okay, now let's try something a little more difficult. We're going to learn how to calculate this 10% tax here. So how do we calculate 10% of something? Unfortunately, we can't just multiply by 10% in JavaScript. Instead, we have to calculate the percent manually. So how do we do that? 1% is actually equal to 1 divided by 100. That's what percent means. So 10% is equal to 10 divided by 100, which equals 0.1. So to calculate 10% manually, we just multiply this number by 0.1. So we'll type 36.93 multiplied by 10%, or 0.1. If we press enter, it will give us a number that is close to what we have in the final project. It's the same amount of money, but our number is more accurate than we need. So later in this lesson, we'll learn how to round this number down to exactly what we have on the web page. For now, let's do some more practice with the order of operations. Let's calculate the tax again, except instead of using the final number, 36.93, let's calculate this number individually, like here. So at the bottom, we're going to add the cost of the basketball, 20.95, plus the cost of the t-shirts, 7.99 times 2, and then multiply this by the tax percent, times 0.1, and press enter. Unfortunately, this number doesn't match what we got up here. And that's because if we look at this calculation, according to the order of operations, multiply is done first. So it will multiply these 3 numbers first, and then add 20.95 after. However, this is not what we want. We actually want to calculate this number first. This is the cost of the products. So how do we get the computer to calculate this first, and then multiply by the tax percent 0.1? To do this, we can use brackets to control which part of the calculation gets done first. So let's create this calculation again. 20.95 plus 7.99 times 2. But this time, we're going to add brackets around this part of the calculation to make sure that this gets calculated first. And then at the end, we'll multiply it by the tax percent 0.1. And now if we press enter, we will get the same number that we had before. So that's how we use math and the order of operations to calculate the numbers in this section of the final project. So don't worry, you don't have to be good at math to learn JavaScript. This is just to show you how math works in JavaScript. In the rest of this lesson, we're going to learn some more details about numbers and math. The first detail we're going to learn is a weird behavior of math in JavaScript. First, we'll need to learn some terminology. In programming, whole numbers like 2, 3, and 4 are called integers. Decimal numbers like 2.2 and 2.5 are called floating point numbers, or floats. And unfortunately, computers have a problem working with floats. For example, if we go back to our console and type the calculation 0.1 plus 0.2 and press enter, it will give us this weird number here that's close to 0.3 but a little bit inaccurate. So this problem is not specific to JavaScript. Many programming languages also have this problem. The reason this happens is because of how computers store numbers. I'll give a simplified explanation. Computers can only store zeros and ones, while humans can count from 0 to 9. So there's sort of a mismatch between our number systems. For integers, this is not a problem. The computer can just use a bunch of zeros and ones to store it. However, for decimal numbers or floats, sometimes the computer can't store the number properly. For example, here's how the computer tries to store 0.2 using only zeros and ones. At the top is what the computer stores. At the bottom is what this is equal to in human numbers. We can see that the computer gets closer and closer to 0.2, but never actually reaches it. And this is why we get these inaccuracies when calculating with floats, because computers can't store some floats properly. Note that this doesn't happen with all floats. For example, computers can store 0.25 without any problems. So these inaccuracies only happen with some floats, but not all of them. However, when calculating money, we definitely want to avoid any inaccuracies. So let's learn how to do that. First, we're going to set up our cart again. So make sure in your cart you have one basketball with free shipping, and this time you have one t-shirt. So we're going to click Update, change this to 1, and click Save. And this t-shirt also has free shipping. Now let's scroll up, and we're going to calculate this number at the top again, which is the cost of the products. Let's go into our console, and we're going to add the cost of the basketball, $20.95, plus the cost of the t-shirt, which is $7.99. If we press enter, calculating with these floats causes the inaccuracies that we saw earlier. So how do we avoid this problem? The best practice when calculating money is to calculate in cents instead of dollars. So instead of $20.95, we're going to calculate 2,095 cents plus 7.99 cents. Notice we're not using floats anymore, so we avoid the inaccuracies. But now this number is in cents, so we need to convert back to dollars. To do that, we'll surround this calculation with brackets to make sure we calculate this first, and then at the end, we'll divide by 100 to convert back to dollars, because there are 100 cents in each dollar. If we press enter and scroll up, that's how we get the exact number that we see on the page. So remember, in programming, calculations with floats are sometimes inaccurate. And when working with money, the best practice is to do the calculation in cents and then convert back to dollars at the end. The next detail we're going to learn is how to round a number in JavaScript. Rounding just means taking a number and moving it to the nearest integer. To round a number, we can use this code. Capital M math dot round. Open bracket, close bracket. So make sure you use a capital M because JavaScript is case sensitive. Now between the brackets, we can put a number that we want to round, like 2.2. If we press enter, it will round this number down to 2. If we do capital M math dot round open bracket close bracket, and between the brackets we put 2.8 and press enter, it will round 2.8 up to 3. Now let's do a practical example with math.round. We're going to calculate the tax again, but this time we're going to round the result to exactly this number on the page. So first, let's calculate the tax. We'll go into our console and add the cost of the products in cents. So 2,095 cents for the basketball, and plus the cost of the t-shirt, which is 7.99 cents. And we'll surround this in brackets to make sure we calculate this first. And then we're going to multiply this by the tax percent, or 0.1. And finally, we'll convert this back to dollars. So let's surround this in brackets as well to make sure we calculate this first. And at the end, we'll divide by 100 to convert back to dollars. So notice here, we can have brackets inside brackets. In this situation, JavaScript will calculate the inner brackets first, and then the outer brackets, and then everything else. If we press enter, this gives us 2.894, which is close to the number on the page. It's the same amount of money, but our number is more accurate than we need. So now let's learn how to use math.round to round this number to exactly 2.89. First, let's create a copy of this calculation. So we'll select it, right-click, copy, and down here, right-click and paste. By the way, if you paste in the console, you might see this warning message. To fix this, you can type allow pasting and press enter. And now you can paste. So let's continue. And we were trying to round 2.894 to exactly 2.89. So one thing we might try to do is to round this entire calculation. However, this will round 2.894 to 3 because it rounds to the nearest integer. Instead, what we want to round is this number here. So remember that this number is the result in cents, which is 289.4 cents. If we round this number, it will round down to 289 cents, which is exactly $2.89. So to round this calculation, at the front, we'll type capital M math dot round. So we already have brackets around this, so we don't need extra brackets. So this will round to 289 cents. And finally, we'll convert this back to dollars at the end by dividing by 100. If we press enter, that's how we round this calculation to get the exact number on the page. So to summarize, we first calculate the result in cents, and then we round this to the nearest cent, and then at the end, we convert back to dollars. Again, don't worry, you don't have to be good at math to learn JavaScript. These examples are just for learning. Almost all the math we do in JavaScript is more simple than this. I'll give you some exercises at the end of this lesson to help you get more practice. The last thing we're going to learn in this lesson is how to use Google when you're learning to code. So far, I've been giving you different pieces of code, like alert and math.round. You might be wondering, where do I find this code? These pieces of code are features of JavaScript, and I find this code by searching on Google. So we're going to learn how to use Google to learn new features of JavaScript on our own. Let's go to our browser and create a new tab at the top. And we'll click here and type google.com and press enter. And we'll search in Google. So the trick to searching in Google is to search for what we are trying to do. For example, if we want to round a number, we would search for JavaScript how to round a number. If we press enter, sometimes you might get the code right away in the first result, and sometimes you might have to go into the other results to find the code that you need. In my example, I see the code math.round in the first result, so I can click into this result, read about what this code does, and also see some examples of how to use it. One thing to keep in mind is that when you're searching in Google, you might not understand all the code that you get in your results. For example, here, there's a lot of code that we haven't learned yet. And actually, that's okay. We just need to look for the pieces of code that look familiar to us, like this part of the code. We can then use this part of the code in our own code. We don't have to understand every bit of code that we get from Google. And don't worry, as we move through this course, we will understand more and more of this code that we get from Google results. These days, we also have some artificial intelligence, or AI tools, that can help us search for code. I'll provide links to some of these tools in the video description. By the way, to find the links mentioned in each lesson, you can click here in the description. And this page contains all the links mentioned in each lesson. And that's the end of this lesson. In this lesson, we learned how to work with numbers and math. We learned the order of operations and brackets. We calculated the numbers in the final Amazon project. We learned that calculations using floats can be inaccurate and how to avoid this problem when working with money. We learned how to round numbers using math.round, and we learned how to search for code on our own. Here are some exercises to help you practice numbers and math. In the previous lesson, we learned how to work with numbers and math. In this lesson, we're going to learn how to work with text, and we're going to create the text in this section of the final project. First, make sure you have the final project open and you're on the checkout page. Also make sure you have the console open on this page. If not, you can go to a blank area, right-click, click Inspect, and then click the console. Now, we're going to learn a feature of JavaScript called strings. A string represents text. Let's go to our console and create our first string. We're going to type single quote, hello, and single quote, and press enter. This is a string, and it represents the text hello. And we've actually seen this code before. In the first lesson, the first piece of code that we learned was alert, open bracket, single quote, hello, single quote, close bracket, and semicolon. This code creates a pop-up on the page. If we press enter, it creates a pop-up. Now inside these brackets, we actually created a string. This string is the text that appears in the pop-up. So as you can see, a string represents text. Let's press OK. And now let's learn the syntax rules for strings. To create a string, we just write some text like hello, and then surround this text with single quotes, one at the beginning and one at the end. We can also add strings together. For example, let's type the string sum plus the string text and press enter. When we add two strings, it combines the strings together into a bigger string. And this makes sense. We're adding two pieces of text together. We can also add more than two strings at a time. For example, we can type the string sum plus the string more plus the string text. If we press enter, the computer will combine all three strings into one big string. By the way, this is called concatenation when we combine strings together. Now, in the previous lesson, we learned about numbers. Numbers and strings are two different types of values in JavaScript. They represent different things. And we can actually check what type of value something is using this code. Type of, and then space, and then a value, like the number 2. If we press enter, type of will tell us that 2 is a number. If we do type of quote hello quote and press enter, it will tell us that hello is a string. Now, what if we added a string and a number together? For example, let's type the string hello plus the number 3 and press enter. So when we add a string and a number, JavaScript will automatically convert this number into a string. So this gets converted into the string hello plus the string 3. And then it combines them together into the string hello 3. This feature is called type coercion or automatic type conversion. Okay, now that we understand the basics of strings, let's do some practical examples. We're going to use strings and numbers to create the text in this section of the project. First, make sure that in your cart, you have one basketball with free shipping, and you have one t-shirt, also with free shipping, and you have no other products. Let's scroll up, and we'll start by creating this text in the top right. So this is the cost of the products, but this time we're going to have a $sign. So instead of just a number, this will be text. So one thing we can do to create this text is just type out the string directly, like quote $28.94 and quote. However, let's actually calculate this number using math. Remember, the advantage of JavaScript is that it's able to do calculations. So instead of typing out 28.94, we're just going to create the string $sign plus, and we're going to calculate this number using math. So we're going to add the cost of the basketball, which is $20.95, plus the cost of the t-shirt, which is $7.99. If we press enter, unfortunately, this doesn't look right. Instead of doing math and adding these two numbers together, it just sort of put the numbers one after another into the string. So why is this happening? JavaScript adds from left to right. So the first step is to add these two values. And as we learned, if we add a string and a number, JavaScript will automatically convert this number into a string. So the result of this calculation will be the string $20.95 and quote. The next step is to add 7.99. So it will add 7.99. And now we're adding again a string and a number. So JavaScript will automatically convert this number into a string and combine them together. That's why it puts 7.99 at the end of this string instead of doing math. So what we actually want to do here is to add these two numbers first and then combine the total with the string. So how do we do this? The solution is that strings also follow the order of operations, just like numbers. And remember, in the order of operations, we can use brackets to control which part of a calculation gets done first. So let's type this calculation out again. The string $ plus 20.95 plus 7.99. But this time, we're going to add an open bracket and a close bracket around this calculation. This tells the computer to calculate this number first using math, and then combine this result with the string after. If we press enter, now this is doing math, and it solves our original problem. Unfortunately, now we have another problem. This math is inaccurate. So remember from the previous lesson, doing calculations with floats can sometimes cause inaccuracies. And the best practice when calculating money is always calculate in cents and then convert back to dollars at the end. So at the bottom here, we're going to add the string $ plus open bracket, and instead of $20.95, we're going to add 2,095 cents plus 7.99 cents and close bracket. And then at the end, we're going to convert this number back to dollars by dividing by 100. If we press enter, this will give us the text that we see in the final project. Again, strings follow the same order of operations as numbers. Brackets are always calculated first, multiply and divide are done next, and add and subtract are done after. So adding this result to the string is the last step. Now let's do a more complicated example. Let's use strings and numbers to create this entire line of text, not just the dollar text. To create this, we're going to go from left to right. Let's go back in our console, and we're going to start with the string items, open bracket, and here we could just type 2 and close bracket, but let's actually calculate this number as well using math. So this number is the quantity, or the number of products in our cart. Let's go back to our console. We're going to end the string here, and we're going to add, and we're going to calculate the quantity. So we have 1 basketball plus 1 t-shirt. Again, we run into the same problem as before. This gets calculated first and results in a string, and then it will just combine the 1 at the end of the string instead of doing math. To solve this, we're going to use brackets again. So around the 1 plus 1, we're going to add open bracket and close bracket. This tells the computer to add the numbers first and then combine it with a string. All right, let's keep going from left to right. We're going to add the rest of the string, quote, close bracket, colon, and let's just use a space to represent the space between these two. So we'll type a space, $, and then we're going to calculate this number again and add it to the string. So we'll end the string and then plus, and we already did this calculation up here. So we can select this and then right click, copy, and here right click and paste and press enter. By the way, if you paste in the console, you might see this warning message. To fix this, you can type allow pasting and press enter. And now you can paste. And that's how we create this first line of text using strings and numbers. We break up the string into parts, calculate the numbers, and then add the parts back together. All right, now let's take these strings that we created and do something with them. Let's create a pop-up and display this first line of text inside the pop-up. We'll go back to our console and type the code for creating a pop-up. Alert, open bracket, close bracket, semicolon, and then inside the pop-up, we're going to display this string. So let's just make a copy of this code. We'll select it, right click, copy, and between the brackets, right click and paste. If we press enter, the computer displays a pop-up with the first line of text of the final project inside. So that's how we use strings to create the text in the final project. And once we create the strings, we can use them in other JavaScript code. In the rest of this lesson, we're going to learn more details about strings. In JavaScript, there are actually 3 ways to create a string. The first way is to use single quotes, which we already learned. For example, we can type single quote, hello, and single quote, and press enter. The second way to create a string is to use double quotes. For example, double quote, hello, and double quote, and press enter. This creates the exact same string as single quotes. So which one should we use to create a string? Single quotes or double quotes? In JavaScript, I recommend using single quotes by default. They're a little easier to read and type. There is one situation where double quotes might be useful, and that is if we have a single quote inside the string. For example, if we type the string I'm learning JavaScript and single quote and press enter, this doesn't work because there's a single quote inside the string, and this single quote will end the string early. To solve this, we can create the string using double quotes. For example, double quote, I'm learning JavaScript, and double quote, and press enter. So now this works. Because we created the string using double quotes, the single quote no longer has a special meaning, and it will no longer end the string early. So this is a situation where double quotes might be useful. Otherwise, we use single quotes by default. Now, there's actually another solution to this problem, other than using double quotes, and that's by using an escape character. So a character is one letter, number, or symbol in a piece of text. For example, the text hello has 5 characters, H, E, L, L, O. A character can be a letter, a number, or also a symbol. These are all considered characters. Now, in addition to these characters, we have a special set of characters we can also use in a string called escape characters. An escape character looks like this: a backslash and then another character, like single quote. This combination actually counts as one character in a string. This character creates a single quote that is just text. It doesn't have a special meaning, and it doesn't start or end strings. For example, we can create this string with single quotes again. So single quote I, and this time we'll use the escape character / single quote, and then M learning JavaScript and single quote, and press enter. And now this works because the escape character / single quote creates a single quote that is just text. It doesn't start or end the string. Another escape character that's useful to know is / double quote. This creates a double quote that is just text. It doesn't start or end a string. The last escape character we'll learn in this lesson is \n. This is called the new line character. This escape character doesn't create the letter N anymore. It creates a new line of text. For example, let's create a pop-up using alert, open bracket, close bracket, and semicolon, and then inside the brackets, we're going to create a string sum, and then \n text and single quote. If we press enter, you'll notice that this escape character created a new line of text in the pop-up. And that's why we call this the new line character. So that's how escape characters work. They're a set of special characters that start with \, and we can use them in a string. Now let's press OK. And we're going to learn the third way of creating a string in JavaScript, which is using backticks. For example, let's type in our console, and we'll type backtick, hello, and backtick, and press enter. This creates the same string as single quotes and double quotes. Strings created with backticks actually have a name. We call these template strings, and they have a name because they have some special features. The first special feature of template strings is called interpolation. Interpolation lets us insert a value directly into a string. For example, let's say we want to create the first line of text in our project. Earlier in this lesson, we created this text with concatenation, which means we broke it up into parts and added them back together. Interpolation gives us a much easier way to do this. We'll go to our console, and we'll create this text using a template string, because interpolation is only a feature of template strings. So we'll type backtick items, open bracket, close bracket, and backtick. And now between these brackets, we want to insert the quantity, or the number of products in our cart. To insert this with interpolation, we're going to type $, open curly bracket, close curly bracket. So this combination of characters allows us to insert values directly into the string. Between these curly brackets, we can calculate the quantity, which is 1 basketball plus 1 t-shirt. This will add 1 plus 1, which equals 2, and then insert it directly into the string. Let's keep going and create the rest of this line. So we're going to type at the end a colon, space, and $, and now we're going to insert another value into the string, which is the cost of the products. To insert another value, we're going to type $, open curly bracket, close curly bracket again. And between the curly brackets, we're going to calculate the cost of the products, which is 2,095 cents plus 799 cents. And we'll surround this in brackets to make sure we calculate this first. And at the end, we're going to convert back to dollars by dividing by 100. If we press enter, this creates the first line of text again, in our final project. If we compare this code, which uses interpolation, to our previous code, which uses concatenation, you can see that interpolation is a much cleaner way of inserting values into a string. So interpolation is a recommended solution. Next, template strings have another special feature called multi-line strings. Let's go to our console, and we're going to type a backtick, sum, and then press enter, and text, and backtick. Notice that this string is on multiple lines, so we call this a multi-line string, and this feature is only available for template strings. If we press enter, you can see that the new line in the string just creates the new line escape character that we learned earlier. So that's the multi-line string feature of template strings. We're going to use multi-line strings a lot later in this course, but for now, I just wanted to introduce you to this feature. Now you might be wondering again, what should we use to create a string? Single quotes or template strings? Even though template strings have more features, I find that most JavaScript code still uses single quotes by default. So my personal recommendation is to use single quotes by default. And if we need to insert a value into the string or type the string on multiple lines, then use template strings. And that's the end of this lesson. In this lesson, we learned about strings. A string represents text. We learned how to use strings and numbers to create the text in our final project. We learned 3 different ways of creating a string: single quotes, double quotes, and backticks or template strings. We learned about escape characters, and we learned 2 useful features of template strings: interpolation and multi-line strings. Here's some exercises to help you practice working with strings. So far in this course, we've learned some basic features of JavaScript, like numbers and strings. In this lesson, we're going to learn how to use HTML, CSS, and JavaScript together. Because as I mentioned at the beginning of this course, we use all 3 technologies to build a full website. HTML creates the content of a website, like the buttons and the text. CSS changes the appearance of the website, and JavaScript makes the website interactive. The first thing we're going to do is review the basics of HTML and CSS that we will need for the rest of this course. Now, in order to write HTML and CSS code, we'll need to install another piece of software called a code editor. A code editor helps us write and organize our code. The most popular code editor for web development is called VS Code, or Visual Studio Code. To install VS Code, you can go to google.com in your browser, search for VS Code, click the result, and follow the instructions to download and install. Once we've installed VS Code, we're ready to review the basics of HTML and CSS. We'll start with HTML. HTML stands for Hypertext Markup Language. And just like JavaScript, HTML is also giving instructions to a computer. Now, unlike JavaScript, we can't use the console to write and run HTML code. Instead, we write HTML code inside a file using our code editor. Let's do that right now. We'll start by going to our desktop. So I'm going to close my browser to go to my desktop. And then we're going to create a new folder. So we can right-click, New Folder. This folder is going to contain all the code that we write in this course. Let's name this folder JavaScript-course. Next, we're going to open this folder in our code editor. So let's open VS Code. And then we'll click File, Open Folder, and find the folder that we just created. For me, it's on the desktop, and it's this folder right here. So we're going to select the folder, and then click Select Folder. Now we can close this startup message, and we're going to create an HTML file. We're going to click this icon to create a new file, and we're going to name this file website.html and press Enter. Ending the file name with .html tells the computer that this file contains HTML code rather than just text. Now let's review some basic HTML code. We're going to type the code less than, button, greater than. And we also need to type less than / button greater than, but our code editor might autocomplete this for us. So this code tells the computer to create a button. And inside the button, we're going to have the text hello. Now let's save this file by clicking File, Save, or by typing Control-S on Windows or Command-S on Mac. Now to run this HTML code, we're going to open this file in our browser. Let's go back to our desktop. We're going to open the folder that we created, find the HTML file, select it, and then right-click, Open with Google Chrome. As you can see, we have a website, and we created a button with the text hello inside. And if we look back at our code, that's exactly what we told the computer to do. So just like JavaScript, HTML is also giving instructions to a computer. Let's review some more HTML code. First, I'm just going to rearrange my windows here so that it's easy to see the website side by side. Next, we're going to click the end of the first line and press Enter to create a new line. And we're going to type the code less than p greater than. And we also need to type less than / p greater than. So this code creates a paragraph. And inside the paragraph, we're going to put some text. For example, paragraph of text. Now let's save our file by typing Control-S on Windows or Command-S on Mac. And to update our website to the new code, we're going to go to our website and click Refresh, or type Control-R on Windows or Command-R on Mac. And now you can see that the computer created a paragraph of text, just like we told it to do. And that's the basics of HTML. The computer reads our code and then follows our instructions one by one. First, it creates a button, and then it creates a paragraph of text. Now let's review the syntax rules for HTML. Each of these things that we're displaying on a web page, these are called HTML elements. So a button is a type of HTML element, and a paragraph is another type of HTML element. To create an element, we start with a less than symbol, and then the element name, like a button, and then the greater than symbol. So this whole thing is called an HTML tag. This tells a computer to create a button element. Every HTML tag needs a matching tag. The matching tag follows the same syntax, except it has a slash in front of the element name. So this is called the opening tag, and this is called the closing tag. You can think of the opening tag as the start of the button, and the closing tag as the end of the button. And in between, we have the contents inside the button. In this case, it's the text hello. In addition to text, we can also have elements inside an element. For example, we can go to our paragraph element and we can add a button inside. So less than, button, greater than, and we also need less than / button greater than. And then inside the button, we'll also have the text hello. If we save this file and refresh the page, now our paragraph element has a button element inside. By the way, this is called nesting, when we have an element inside another element. The last syntax rule we have to review is that in HTML, if we have multiple spaces, for example, if we go here and type multiple spaces are combined into one space on the web page. So if we save this code and refresh, you'll notice that all of the spaces that we added only show up as one space on the web page. In addition, in HTML, new lines also count as spaces. So if we go back to our code and we type here and press enter to create a new line, and then save and refresh, notice that the new line doesn't appear on the web page. And that's because this new line here is the same as spaces in HTML. So all of these get combined into one space on the web page. At first, this might seem a little weird, but this feature gives us a lot of flexibility when organizing our HTML code. For example, we can go into our code and add a new line here to separate these two elements and make our code easier to read. Another thing we usually do to make our code easier to read is to put the contents of an element on its own line. For example, we're going to type here and press enter, and here and press enter again to put the contents of the button on its own line. Now it's a lot easier to see where this button starts and where it ends. We can do the same thing with the paragraph. We can type here and press enter, and type here as well and press enter, and then remove some of the extra spaces to put the content of the paragraph on its own line. And now if we save our file and refresh, you'll notice that none of the new lines that we added appear on the web page. By the way, a web page is a single page, like the home page or the cart page. Together, we call this a website. So that's the basics of HTML and HTML syntax. Now let's review CSS. CSS stands for Cascading Style Sheets, and CSS changes the appearance of our website. Let's review some CSS code. We're going to write our CSS code inside our HTML file. First, let's type here and create some new lines at the top. And then at the top, we're going to create a special HTML element called the style element. So let's type less than, style, greater than. And we also need the closing tag less than / style greater than. So the style element is unique because it doesn't appear visibly on the page. Instead, the purpose of the style element is that it lets us write CSS code inside. So inside here, let's press enter to create a new line, and we're going to type button, open curly bracket, close curly bracket. And then inside the curly brackets, we're also going to press enter to create a new line. So this is CSS code, and this code tells the computer to change the appearance of all buttons on the page. And then inside these curly brackets, we can tell the computer how to change the appearance. For example, we can type background-color : red and semicolon. If we save and refresh, you can see that this CSS code changes the appearance of all buttons on the page and changes their background color to red. Let's do another example. We're going to go back to our CSS code. I'm going to type here and press enter to create a new line. And we're going to add color :white and semicolon. Let's save and refresh. And this CSS code changes the text color of all buttons on the page to white. Let's do one more example. We're going to type the code border: none and semicolon. Let's save this and refresh. And this CSS code removes the border for all buttons on the page. And that's how CSS works. We tell the computer which elements we want to change, and then how to change the appearance of these elements. Now let's review the syntax rules for CSS. This part of the CSS code is called the CSS selector. It tells the computer which elements we want to change. In other words, it selects which elements to change. Inside the curly brackets, we have some CSS styles. This tells the computer how to change the appearance. For each style, the left side is called the CSS property. This tells the computer what we're changing. The right side is called the CSS value. This tells the computer what we're changing the property to. For example, this style changes the background color to red. We use a colon to separate the property and the value, and a semicolon at the end to tell the computer that this is the end of a style. So that's the basic syntax of CSS. We tell the computer which elements we want to change, and then how to change the appearance of these elements. The next thing we're going to review is HTML attributes. Right now, this CSS selector changes the appearance of all buttons on the page. However, what if we only want to change the appearance of this one button, and we want to style the other button differently? How do we do that? We're going to review a feature of HTML called attributes. Attributes change the behavior of an element. For example, we're going to go to the opening tag of the first button, and then here we're going to add an HTML attribute by typing space title equals double quotes. And then in between the double quotes, we're going to type tooltip. So this is an HTML attribute, and this attribute adds a tooltip to this button. If you're wondering what a tooltip is, if we hover over some code in our code editor, it'll show us this sort of pop-up with more information. This is called a tooltip when we hover over something and this shows up. So if we save our file and refresh the web page, and now we hover over our button, we can see that the HTML attribute added a tooltip to our button. And then inside the double quotes is the text inside the tooltip. For example, we can actually change this to good job. And if we save and refresh and hover over our button, the text between the double quotes is what shows up in our tooltip. So that's an example of an HTML attribute. Now let's review the syntax rules for attributes. We always put attributes on the opening tag, and we add a space between the element name and the attribute to separate them. On the left side is the attribute name. This tells the computer what we're changing about this element. On the right side is the attribute value. This tells the computer what we're changing this attribute to. For example, here we're changing the tooltip of this element to good job. We separate the name and value with an equal sign and make sure there are no spaces around the equal sign. and we surround the value with double quotes. Now let's go back to the original problem. How do we style these buttons differently? We can do this using a very important attribute called the class attribute. Let's review that right now. We're going to go back to our button, and then here, we're going to type space class equals double quotes. And then inside the double quotes, we're going to type red dash button. So the class attribute sort of adds a label to an element. So here, we labeled this button as a red button. And now that we labeled this element, we can select it in CSS. To do that, we're going to go to our CSS code. We're going to remove the button selector and replace it with .red dash button. When we start the selector with a dot, this means that now we're looking for a class. So here, we're going to look for all elements with the class red dash button, which is only this element. If we save and refresh, now only the elements with the class red button gets these styles. We can also add the same class to multiple elements. For example, we can go to our other button and add the class equals red dash button. If we save and refresh, now these styles get applied to both buttons again, because they both have the class red dash button. If we want to style this button differently, we just give it a different class. For example, we can change this to yellow dash button. And then in our CSS, we can add another selector. So we can type dot. This means we're going to select a class, and we're going to select the yellow dash button class. Open curly bracket, close curly bracket. And then inside here, we can add some styles for the yellow button. For example, background dash color colon yellow and semicolon. Now let's save and refresh. And that's how we use the class attribute in HTML to modify specific elements. The final thing we need to review is something called the HTML structure. Let's go back to our website. We're going to find a blank area and then right-click and then click Inspect. So we already learned about the console tab. Here we can write and run JavaScript code. Now we're going to go to the Elements tab, which is for HTML and CSS. So in the Elements tab, we can see all the HTML on the page, as well as all the CSS on the page. And we can play around with the CSS if we want. Now if we go back to the HTML, you'll notice that our web page has some elements that we didn't add before. The HTML element, the head element, and the body element. So this is the structure that we're supposed to follow when writing HTML. In our code, we didn't follow this structure, so the browser actually adds it for us automatically. However, it's still best practice to follow this structure in our code, because it gives us access to some more features of HTML. Let's review the HTML structure and add it to our code. We're going to type up here, and we're going to create some new lines. And now, every HTML file is going to start with less than, exclamation, doc type in capitals, and then space, HTML, and greater than. This is not an HTML element. It's a special line of code that tells the browser to use a modern version of HTML. If we don't have this, the browser might fall back to an older version of HTML that has less features. Next, we're going to create an HTML element. So less than, HTML, and greater than. The HTML element represents the entire web page. So everything on the web page should go inside this element. And then inside the HTML element, we're also going to split it up into two sections: the head element and the body element. So the body element is supposed to contain everything that is visible on the page. In our example, that would be the buttons and the paragraph. So let's actually select this code, and we're going to right-click and cut, and then inside the body, we're going to right-click and paste. The head element contains information about the page. In general, everything that is not visible on the page goes inside the head. In our example, that would be the style element. So let's select this as well. We're going to right-click and cut, and then inside the head, we're going to right-click and paste. And at the bottom, let's just clean up by removing all of the extra new lines. So this is a structure that we're supposed to follow in all of our HTML files. As you can see, this structure uses a lot of nesting, or elements inside elements, to organize our code. Okay, so what are the benefits of following this structure? One benefit is that there are other elements that we can use inside the head. For example, let's type here, press enter, and we're going to add the title element. So the title element sets the text in the tabs. Inside, we can type HTML CSS review. If we save and refresh, the title will show up in the tab. So this is an example of an element that we can now add in the head. Another benefit that we get from this structure is the ability to automatically refresh our web page when we change our code. So far, every time we change our code, we have to save and then manually refresh the web page. We can actually automate this by following the structure and then installing a VS Code extension. So let's click the extension area, and we're going to search for the extension Live Server and click Install. Once we have that installed, we're going to change a setting. Let's open the settings by clicking this icon in the bottom left and then click Settings. At the top, we're going to search for Live Server. And we're going to look for a setting called Live Server Custom Browser. And we're going to change this to Chrome. Now, if Google Chrome is already your default web browser, you don't need to do this step, but it's nice to know. Now let's close the settings and go back to our code. Next, instead of opening this file directly in the browser like before, we're going to use Live Server to open this file. To do that, we're going to right-click this file in our code editor and then click Open with Live Server. If we open a file with Live Server, this web page will automatically refresh when we change our code. For example, we can go here and change the background color to green. If we save, Live Server will automatically refresh the web page, so we don't have to do that back and forth anymore. Let's just change it back to red so that the class name makes sense, and save. And we can also close the previous tab. So this is the HTML structure. It gives us access to more features of HTML. And this is all we need to review about HTML and CSS for now. If you want to learn more, you can check out my HTML and CSS full course in the video description. By the way, to find the links mentioned in each lesson, you can click here in the description. And this page contains all the links mentioned in each lesson. Before we add JavaScript to our website, we're going to review some VS Code setup. So you notice that many of these lines have spaces at the front. These spaces are called indents, and indents make our code easier to read. For example, we can easily tell that this code is inside the brackets because it has an extra indent in the front. If we didn't have indents, here's what the code would look like. It's a lot harder to read. To add an indent, we can type at the beginning of the line and press Tab. To remove an indent, we can press Shift-Tab or just use backspace. Now, by default, VS Code uses 4 spaces per indent. However, in HTML, CSS, and JavaScript, we usually use 2 spaces per indent. So we're going to update this setting. Let's go to our settings by clicking this icon in the bottom left, and then click Settings. And at the top, we're going to search for Tab. And we're going to change the tab size from 4 to 2. Now let's close the settings. And we're also going to change the indents for this file. We're going to go down here and click Select Indent. And we're going to choose Indent using spaces, and then click 2. And now if we type at the start of a line and press Tab, it will only add 2 spaces per indent. So let's reformat our code to use 2 spaces per indent instead of 4. First, we're going to remove all the indents in our code. A shortcut for this is to select all of these lines and press Shift-Tab to remove 1 indent for each line. So we're going to keep pressing Shift-Tab until we remove all the indents. Next, we're going to add the indents back using a similar shortcut. We're going to select the head element and press Tab to add 1 indent for each line, and then select everything inside the head and press Tab to add another indent, and then select everything inside style and press Tab, and then inside each of these brackets, we're going to select the lines, press Tab, and then here, press Tab. We'll do the same thing for the body element. We'll select all these lines and press Tab. We'll select everything inside the body, press Tab, and then inside each of these elements, we're going to press Tab and press Tab. Now, if we save, our website will look the same because all we did was adjust the indents. So there's one other setting in VS Code that we're going to set up, which is line wrapping. If you look at this line of code, you can see that it's really long, and we need to scroll horizontally to see the rest of the line. Instead, we're going to make this line wrap around if it gets too long. Let's go back into our settings by clicking here, and then click the settings. And then up here, we're going to search for wrap. And we're going to look for editor word wrap. And we're going to turn this on. Now, if we close our settings and go back to our code, this line, which is really long, will wrap around to the next line instead of us having to horizontally scroll. So that's the VS Code setup that we need: 2 spaces per indent and line wrapping. Finally, we're going to add JavaScript to this website. So we learned that we can use the console to write and run JavaScript. Well, there's actually another way to run JavaScript, which is inside an HTML file. Let's learn how to do that. So we learned that HTML has a special element that runs CSS code called the style element. Well, HTML has another special element that runs JavaScript code. And this element is called the script element. So inside our body, at the bottom of the body, we're going to add less than script greater than and the closing tag less than / script greater than. And inside the script element, we can put some JavaScript code. We're going to add the code alert, open bracket, quote, hello, quote, close bracket, and semicolon. If we save, live server will refresh the page, and now you'll notice that the computer now runs our JavaScript code, just like it did in the console. It creates a pop-up with the text hello inside. And we usually put the script element at the bottom of the body because we want the web page to be created first, and then we use JavaScript to make it interactive. For the rest of this course, we're going to run our JavaScript code using an HTML file. The console that we used in the previous lessons is more of a way to try out JavaScript code. We wouldn't use the console for a real website. In addition to the script element, we have another way to run JavaScript code inside HTML, and that's by using an attribute. Let's go back to our first button, and here we're going to add another attribute. So let's type space, and this time we're going to add the onClick attribute equals double quotes. So this attribute will run JavaScript code whenever we click this button. That's what onClick means. Between the double quotes, we can write some JavaScript. For example, let's press enter, enter, and then here we're going to type alert, open bracket, quote, good job, quote, close bracket, and semicolon. Now if we save, live server will refresh the page and run this line of JavaScript code. Let's press OK. And now if we click this button, it will run this line of JavaScript code and create a pop-up with the text, good job inside. So those are two places where we can run JavaScript code, the script element and the onClick attribute. The code in the script element runs first when the page is loaded. The code in the onClick attribute runs after when we click the button on the page. And that's how we use HTML, CSS, and JavaScript together on a website. Notice that everything starts from HTML. HTML first creates the website, and then inside the HTML, we can run CSS code to change the appearance, and we can run JavaScript code to make the website interactive. Now let's learn some new features of JavaScript that we haven't seen yet in this course. The next feature we're going to learn is called comments. Comments are pieces of code that the computer ignores. So let's create our first comment. We're going to go down to the script element here and type //. So this is a comment. Anything after the double slash will be ignored by the computer. So we can type anything we want, like this is a comment. If we save, it ignores this line and creates the pop-up in the next line. Now let's close this pop-up and learn why we use comments. Comments are useful for providing more information for people reading our code. For example, we can create a comment above this code, like this code creates a pop-up. This comment helps others and ourselves understand what this code does. So that's one way we use comments. Another way we use comments is if we don't want to run some code anymore, but we also don't want to delete it. For example, this code creates a pop-up every time we refresh the page. And this can be annoying. So I want to stop running this code, but I also don't want to delete it because you might want to review this code later. So what we can do here is to add a double slash in front of this line to turn this code into a comment. Now, if we save, the computer will ignore this line of code and not create the pop-up. This is called commenting out the code. It's useful if we don't want to run some code anymore, but we also don't want to delete it for informational purposes. So JavaScript has another syntax for writing comments, and that syntax is /* and */. Here, anything between the stars is a comment. This is called a multi-line comment because between the stars, we can write a comment on multiple lines. For example, we can type multi, enter, line, enter, comment. On the other hand, double slash is known as a single line comment. Now, just like JavaScript, HTML and CSS also have comments, but they use a different syntax. If we scroll up to our HTML, here we can type less than, exclamation, dash dash. And we also need dash dash greater than. So anything between these double dashes is a comment. For example, this is a comment. In CSS, to create a comment, we can type /**//. So it's the same multi-line comment as JavaScript. Between the stars, we can add a comment. So this is a comment. If we save our file, nothing changes on our web page because comments are ignored by the computer. The last feature of JavaScript we're going to learn is called console.log. Let's go back to our code. And at the bottom in the script element, we're going to type the code 2 + 2. So we learned that this code in JavaScript does some math. However, if we save this file, where is the result of this math? So we might think that the result will show up in the console, but if we right-click, click Inspect, and then click the console, you'll notice that the result doesn't show up here either. And that's because before we were running 2 + 2 inside the console. So the result shows up in the console. But now we're not running this code in the console anymore. We're running this code on the web page. So how do we see this result? The solution is we're going to redirect this result back to the console. To do that, we're going to use this piece of code. Console.log, open bracket, close bracket, and semicolon. Console.log will display whatever's between the brackets back in the console. So if we move this code between the brackets, so we select this and then right-click, cut, and then between the brackets, right-click, paste, and save, the result of this code is displayed back in the console. And console.log works for any code that we learned so far. For example, we can use strings. So let's create a new line and type console.log, open bracket, close bracket, semicolon, and then between the brackets, let's type some strings. Quote, some, quote, plus, quote, text, quote, and save this file. Again, it will display the result of whatever's between the brackets back in the console. So that's how we see the result of JavaScript code that is running in a file. We use console.log. And that's the end of this lesson. In this lesson, we reviewed the basics of HTML and CSS. We set up our code editor VS Code. We learned how to load JavaScript inside an HTML file using the script element and the onClick attribute. We learned how to create comments, and we learned how to use console.log. Thanks for watching this course so far. If you want to support this channel, you can check out the premium version of my courses just like this one, where you can get a certificate of completion and a better learning platform. If you're interested in extra videos from me, more in-depth videos, and behind-the-scenes content, you can check out these links here. You can also support the channel by liking the video, subscribing, and sharing this video with others. Thanks again, and let's continue with the course. Here are some exercises you can try on your own to practice what we learned in this lesson. In this lesson, we're going to learn the next feature of JavaScript called variables, and we're going to use variables to build a simple version of the cart quantity feature of the final project. First, let's create a new HTML file just for learning variables. We're going to go to our code editor and click this icon to show our files, and then click this icon to create a new file. And we're going to name this file 05-variables.html and press enter. So the 05 just means that this file is for lesson 5. Let's also add the lesson number to website.html. We'll select this file and then right-click, rename, and then at the front, we'll add 04- and press enter. Next, we're going to copy all the code in website.html to variables.html. So let's click in this file, and we're going to select all of this code by typing Ctrl-A on Windows or Command-A on Mac. And then we're going to right-click, copy, and then inside variables.html, right-click, and paste. Let's click this icon to hide our files for now, and we'll prepare this file for this lesson. So let's scroll up to the top, and first we're going to change the title to variables. Next, we're going to delete all the CSS because we're going to start over. And we're going to delete all the HTML except for the script element. And let's delete all the JavaScript from the previous lesson. And finally, let's save. And we'll open this file in our browser by right-clicking and then open with Live Server. And now we can close the previous tab and the previous code for now. Now we're ready to learn variables. First of all, what is a variable? A variable is like a container. We can save a value, like a number or a string, inside a variable, and then use it later. Let's do an example and create our first variable. Inside the script element, we're going to type the code let and space. The word let creates a new variable. And now we're going to choose a name for our new variable. Let's name this variable1. So this creates a variable or a container named variable1. And now we can save a value inside this variable. To do that, we're going to type space equals space, and then a value, like a number or a string. So let's save the number 3 inside, and we'll type a semicolon at the end. So here, we used the let to create a new variable. We named this variable variable1, and we saved the value 3 inside this variable. Now that we saved this value, we can use it later. For example, let's type a new line and type the code console.log, open bracket, close bracket, and semicolon. Remember from the previous lesson that this code displays whatever's inside the brackets in the console. So far, we put a value inside, like the number 2. If we save, and then go to our website and open the console, so right-click, inspect, and then click the console, we can see that the number 2 was displayed in the console. So now let's try replacing this value with the variable that we created above. So instead of 2, we're going to console.log variable1. If we save, notice that it now displays 3. So it's displaying whatever value is saved inside the variable. As you can see, we can save a value inside a variable and then use that variable later on. Let's do another example. We're going to create another variable. So we're going to create some new lines and we'll type let. And this time, let's name this variable calculation. And we're going to type space equals space to save a value inside this new variable. And this time, instead of just a number, we're going to save a calculation. 2 plus 2 and semicolon. So this will calculate 2 plus 2 and then save the result, which is 4, into the variable. If we console.log, open bracket, calculation, and semicolon, and save, it will show us that the value 4 is saved inside calculation. Now let's try this code. We're going to type a new line and then console.log, open bracket, and calculation again, and plus 2 and semicolon. So here we're using a variable inside a calculation. What this does is that it takes whatever value is saved inside the variable. Right now it is 4, and then substitutes that value into the calculation. So this will be 4 plus 2, which equals 6. If we save, we can see that in the console, it displayed 6. So we can use a variable wherever we use a value. And JavaScript will substitute whatever is inside the variable into the code. Let's do another example. We're going to type some new lines and create a new variable again using let, and we're going to name this variable result. And we're going to make it equal to calculation plus 2 and semicolon. So this does the same thing as the code before. It will take whatever value is inside calculation, which is 4, and substitute it into this code. So we get 4 plus 2 equals 6. But this time, we have an extra step. We're going to save this result, which is 6, into another variable. So if we console.log result and save, we can see that 6 was saved into the result variable. Again, we can use a variable wherever we use a value. Now, in addition to numbers, we can save any type of value in a variable, including strings. For example, let's create a new variable using let, and let's name this message. And we're going to save inside this variable a string this time. So quote, hello, quote, and semicolon. Again, we're going to console.log this variable. So console.log and message, and a semicolon at the end. If we save, it will show us that the string hello is saved inside this variable. Okay, now that we learned how variables work, let's learn the syntax rules for variables. The word let creates a new variable, and then we give the variable a name. So we can name variables almost anything we want, except for a few restrictions. Number one, we can't use special words like let as a variable name. That's because let already has a special meaning in JavaScript. It creates a variable. So let is a reserved word. However, we can use let1 or let2 as variable names. We just can't use let. Number two, we can't start a variable name with a number. If we start with a number, JavaScript will think this is a number instead of a variable name. However, we can use numbers in the middle or the end. Lastly, we can't use most special characters, like these or a space in a variable name. However, there are two special characters we can use, $ and underscore. So those are the rules for naming variables. And then to save something inside a variable, we just use the equal sign, and then the value we want to save. And that's it. After we create a variable, we can start using it in the rest of our code. Now there's one last part of the syntax that we haven't learned, which is the semicolon. We've seen semicolons in many places already. In JavaScript, a semicolon means this is the end of an instruction. It's similar to a period in English. In English, a period means this is the end of a sentence. So here, this semicolon tells JavaScript that this is the end of an instruction. And now after this, we can add another instruction, like console.log, open bracket, and then the string semicolon, and a semicolon at the end. If we save, it will run these two instructions one after another without any problems. So if we didn't have the semicolon here, and we save, it wouldn't work because JavaScript thinks that this entire line is one instruction. So we need semicolons to separate different instructions in JavaScript. If we save, everything goes back to normal. So JavaScript is a little special because it has a feature called semicolon insertion. That means it will try to insert the last semicolon in a line of code automatically. For example, if we removed the last semicolon and save, this code will work without that semicolon. And that's because JavaScript inserts the last semicolon automatically. However, a lot of companies still prefer to use semicolons in their JavaScript code because semicolon insertion can sometimes put the semicolon in the wrong place. For this reason, we're also going to use semicolons in this course to help you get used to JavaScript code with semicolons. Next, we're going to learn how to change the value that is saved inside a variable. For example, here we save the number 3 inside variable 1. Now we're going to change the value saved inside variable 1. To do that, we're going to go to the bottom and create some new lines. And we're going to type the variable name again. So variable 1. And now to change the value saved inside, we're just going to type the equal sign and then a different value like 5 and semicolon. And now if we console.log this variable, console.log variable 1 and semicolon and save, it will show us that 5 is now saved inside variable 1. Notice also that if we scroll up to the top, the first console.log still displays the value 3. And that's because at this point in the code, variable 1 still contained 3. We didn't update the variable yet. So when we first saved a value inside this variable, this is called assigning a value to a variable. Then when we change the value inside this variable, this is called reassigning a value to a variable. Now let's learn the syntax rules for reassigning a value. Notice that we don't use the word let when reassigning. That's because let creates a new variable. So if we try to use let again, it would try to create a new variable named variable1. However, variable1 already exists, and we can't create two variables with the same name, so this would cause an error. Instead, to reassign a variable, we just type out the variable name and make it equal to something else. So that's the syntax for reassigning a variable. Now we're going to do one last example before working on the project. Let's go to the end of our code. We're going to type some new lines. And this time, we're going to reassign variable1 again. So we can reassign a variable as many times as we want. So let's type variable1 and then equals, and we're going to type variable1 plus 1 and semicolon. So we learned earlier that we can use a variable inside a calculation, and it will substitute whatever value is inside the variable. Here, we're also using a variable inside the calculation, but we're using this variable itself. So it's essentially taking this variable, increasing it by 1, and then saving it back. If we console.log this variable, variable1, and save, variable1 now contains 6. So it took the previous value in variable1, which was 5, added 1, and then saved it back. So this is how we increase the value of a variable by a certain number. Okay, now that we know how to create and reassign variables, we're ready to work on a project. So I actually prepared a project that we can do for this lesson. And we can see this project by going to our browser, clicking at the top, and typing supersimpledev/projects/variables and press enter. So we're going to work on the cart quantity feature of the final project. So in the final project, we have a number in the top right corner that shows how many products are in our cart. When we click the Add to Cart button, this quantity will increase. So what you see here is a simple version of the cart quantity feature that we can create right now. Let's go over how it works. First, make sure you have the console open on this page. Now when we click the Show Quantity button, it will show us that there are 0 products in our cart. If we click the Add to Cart button, it will increase the quantity by 1 and display it in the console. If we click Add to Cart again, it will increase the quantity by 1 again. Now in the final project, we can also add more than one product at a time using this dropdown. For now, we're going to build a simpler version of that. We're going to use the +2 and +3 buttons to add multiple products. So when we click the +2 button, it will increase the quantity by 2 and display it in the console. And when we click the +3 button, it will increase the quantity by 3. And finally, when we click the Reset Cart button, it will reset the quantity back to 0 and display this message in the console. So now that we understand how this project works, let's build this step by step. First, let's create a new HTML file just for this project. We're going to go to our code editor and click this icon to show our files, and then click this icon to create a new file. Let's name this file 05-cart-quantity.html. variables.html and press enter. Next, let's open variables.html, and we're going to copy all the code here into our new file. Let's type Control A on Windows or Command A on Mac to select all this code, and then right-click, copy, and then in our new file, right-click and paste. Let's close this for now. And in the new file, we're going to change the title to cart quantity. And let's remove all of our JavaScript code, but keep the script element because we're going to write new JavaScript code. Now we're ready to begin. Let's start by creating these buttons. Let's go to the body element. I'm going to create a new line. And here, as we learned in the previous lesson, we can create a button using this HTML code, less than, button, greater than, and the closing tag less than / button greater than. Inside this button, we're going to have the text show quantity. And let's save. Now let's open this file in Live Server by right-clicking and then open with Live Server. And we can see that we created the first button. Now let's create the other buttons here. Feel free to pause the video if you want to try it yourself. We're going to go back to our HTML and create another button. Inside this one, we're going to have the text add to cart. Let's create another button. This one is going to have the text +2, and we'll create another button. This one is going to be +3, and finally, we'll create the last button. And this one is reset cart. And now let's save. And if we go back to our tab, we've created all the buttons. Now let's make this web page interactive with JavaScript. First of all, we need somewhere to save the cart quantity. So as we learned in this lesson, variables are the perfect solution for this. Variables let us save a value. So let's go into the script element, and we're going to create a variable by typing let. And this variable is going to save the cart quantity. So let's just name it cart Q quantity. So the cart quantity will start out at 0. So we're going to type equals 0 and semicolon. Next, when we click the show quantity button, we want to display the quantity in the console. To do this, we learned a special HTML attribute in the previous lesson called the onClick attribute. So we're going to type in this opening tag here, space onClick equals and double quotes. So the onClick attribute runs some JavaScript when we click this button. And between the double quotes, we can write JavaScript code. So let's press enter, enter. And now when we click this button, we want to display the cart quantity in the console. So let's type console.log, open bracket, close bracket, semicolon. And then between the brackets, we're going to display a message. Now, if we go back to SuperSimpleDev and we click show quantity, we want to display this message in the console. So in our code, between the brackets, we're going to type the string quote cart quantity : 0. Now let's save and go back to our tab to try it out. So we're going to open the console first by right-clicking and then click Inspect and then click the console. And now when we press the Show Quantity button, it should display that message in the console. Okay, So we just made our project interactive. However, we obviously don't want to display 0 every time. We want to display the value inside cart quantity. So we'll need to insert this value inside this string. Remember from the strings lesson, when we want to insert a value into a string, we're going to use a template string. So let's switch the single quotes to backticks to create a template string. And now instead of 0, we're going to insert a value using $, open curly bracket, and close curly bracket. And in between these brackets, we're going to insert this variable, cart capital Q quantity. Remember that JavaScript is case sensitive, so make sure you type the variable name exactly the same. Now let's save and click Show Quantity again. And now it displays the value inside cart quantity in the console. So notice that variables also work with string interpolation. Again, we can use a variable wherever we use a value, and it will just substitute whatever value is saved inside this variable into the code. Now let's make the rest of the buttons interactive. So when we click the Add to Cart button, we're going to add 1 to this cart quantity and display it in the console. So again, we're going to type here and type space on click equals double quotes, and between the double quotes, we're going to add JavaScript. Let's also add some new lines here to make our code easier to read. Okay, so in the onClick attribute, we're going to do 2 things. The first one is increase the cart quantity by 1. We can do that by reassigning the cart quantity variable. So we're going to type just the variable name, cart quantity, and we're going to make it equal to itself plus 1 and semicolon. Next, we're going to display the updated quantity in the console. So let's press enter, and we're going to display this message again. So we can actually just copy this code. So we'll select it and then right click and copy. And then here, right click and paste. Now if we save and click the Add to Cart button, we'll see that it increased the quantity by 1 and displayed the updated quantity in the console. Let's press it again to make sure it works. So it increases it by 1 again and then displays it in the console. So that's basically how the cart quantity feature works in the final project. First, we need a variable to save the quantity, and then when we click a button, we're going to update the quantity. So now let's make the rest of these buttons interactive. Feel free to pause the video if you want to try it yourself. For the +2 button, we're going to add the onClick attribute again. OnClick equals double quotes. And inside, we're going to increase the cart quantity by 2. So cart quantity, and then we'll just make it equal to itself plus 2 and semicolon. And again, we're going to display the updated quantity in the console. So we can create a new line and just copy this code. So select it, right click, copy, and here, right click and paste. Let's save and click +2 a few times. And we can see that it adds 2 to the cart quantity and displays it in the console. For the +3 button, we'll do the same. Let's type an onClick attribute. Click equals double quotes. And here, we're going to increase the cart quantity by 3. So cart quantity equals itself plus 3 and semicolon. And we're going to display this in the console again. So we'll select this, right click, copy, and here, right click and paste. Let's save again and try it out to make sure it works. So +3, +3. And finally, let's do the reset cart button. So we'll add the onClick attribute again. onClick equals double quotes. And inside the double quotes, we're going to do something a little different this time. Instead of increasing the cart quantity, we'll set it back to 0. To do this, we can just reassign the cart quantity variable. So cart quantity, and just make it equal to 0 and a semicolon. Now, if we go back to SuperSimpleDev and try out this reset cart button, you'll notice that it displays two messages. The first message is cart was reset. So we're going to display that message in our code first. Console.log and the string cart was reset. And the second message is the same message as the other buttons. So we can just select this and then right click, copy, and then here, right click and paste. And now let's save and go back to our tab and give this a try. So the cart quantity starts at 0. When we press add to cart, increases by 1. This increases by 2. This increases by 3. And when we click reset cart, it'll display cart was reset and reset the cart quantity back to 0. And that's it. We just created a simple version of the cart quantity feature of our final project, using everything that we learned in this course so far. Now we're going to learn some shortcuts for reassigning variables. So if we look at this line of code, here, we're increasing the value of this variable by 2, and then saving it back. Well, there's actually a shortcut for this, and that shortcut is cart quantity plus equals 2 and semicolon. So this does the same thing as the line above, but it's just shorter. The plus means we're going to add 2 to cart quantity, and equals means we're going to save that result back to cart quantity. So we can actually delete this line, and the code will work the same way. If we save and try it out, it will still add a 2 and then save it back in cart quantity. Let's scroll up and practice by using this shortcut for cart quantity plus 1. So instead of this line, we can type cart quantity plus equals 1 and semicolon. So it turns out that in programming, plus equals 1 is so common that we have an even shorter shortcut for plus equals 1. And that shortcut is cart quantity plus plus and a semicolon. So this is the same thing as plus equals 1. And all three lines do the same thing. So we can remove these lines, and the code will work the same because it's just a shortcut. If we save, so if we click add to cart, it will add 1 every time. So those are some shortcuts for reassigning variables. We also have these shortcuts for the other operators, like minus equals, multiply equals, divide equals, and minus minus. I'll leave some exercises for these other shortcuts at the end of this lesson. Next, we're going to learn some best practices for naming variables. So if we scroll down, notice that our variable cart quantity has 2 words in it, cart and quantity. We learned earlier that we can't have spaces in a variable name. So if we want to have multiple words, we have to combine them together, like this. Now you might be wondering why we wrote it this way, with a lowercase c and a capital Q. This is actually a naming convention called camel case. In camel case, we combine the words together and capitalize every word except the first word. So for cart quantity, we capitalize quantity, but we keep cart lowercase because it's the first word. Camel case is actually the standard naming convention for JavaScript. All of our variable names should use camel case. Now in programming, there are other naming conventions that exist. Another one is called Pascal case. Pascal case is the same as camel case, except we capitalize the first word. So for cart quantity, Pascal case would be capital cart and capital quantity. In JavaScript, there is one feature where we use Pascal case, which we'll learn later in this course. For everything else, we use camel case. Another naming convention is kebab case. Here, we keep the words lowercase and combine them with a dash, like cart-quantity. Kebab case doesn't work in JavaScript because the dash is already a minus symbol. However, we use kebab case in HTML and CSS, and also in our file names, as you can see here. And finally, we have snake case, where we keep the words lowercase and combine them with underscores. Snake case is used in other languages, but it's not really used in JavaScript. So those are the common naming conventions that we use in programming. Now, one more thing I want to note is that when we name our variables, try to pick a name that is not too short or too long. For example, instead of cart quantity, we could have named this variable C. But this name is too short. It's hard to understand what C means. We could also use a name like this: quantity of products in the cart. But this name is too long. It's hard to read this in the code. So try to have a balance between a name that is understandable but not too long, like cart quantity. The last thing we're going to learn in this lesson is there are 3 ways to create variables in JavaScript. Let's go back to our variables.html file, and we're going to learn those 3 ways. So the first way is to use let, which we already learned. The second way to create a variable is to use the word const. So at the bottom, we can type const space and then a variable name, like variable2, and make it equal to 3. So const creates a variable just like let, except we can't change its value later. This value stays constant. That's why it's called const. If we try to change its value, like variable2 equals 5, and then we save this, and we open this file in the browser by right-clicking, and then open with live server. And then open the console, so right-click, inspect, and then click the console. It will give us an error when we try to change this variable. So this doesn't work. Let's remove this line and save. So why would we ever use const instead of let? Well, const makes our code safer and easier to understand. When we create a variable with const, we know for sure that this variable will always contain 3. For let, however, if we create a variable, it's hard to know what value is inside this variable, because later on we can change this value in our code. So in order to keep our code safer, it's actually a best practice to use const by default, and only use let when we know that we need to change the variable. So here, it's actually best practice to use const to create this calculation variable, because we're not changing it later. Same thing for the result variable and the message variable. Now for variable 1, we have to use let because we're changing it later in this code. So that's const. It creates a variable that can't be changed later. Finally, the third way of creating a variable is to use another word, var. So at the bottom, we can type var space and then a variable name, like variable 3, and make it equal to 3. So var creates a variable just like let, and this variable can be changed later. Var is actually the original way to create variables in JavaScript. Var means variable. However, var has some issues that we'll learn later in this course. And because of these issues, we don't use var in new JavaScript code. You might see var in older JavaScript code, so it's still useful to know. So those are 3 ways to create variables in JavaScript: let, const, and var. We use const by default, and if we have to change a variable, then use let. So one more thing we're going to learn is that we can use type of with variables. So remember that type of tells us what type a value is. For example, if we wrote console.log type of 3 and save, type of will tell us that 3 is a number. Well, we can actually use type of with a variable. So if we change this to variable 2 and save, type of will tell us the type of value inside the variable, which is a number. And that's what we see in the console. Now let's check the type of this variable, message. So message contains a string. And if we do console.log type of message and save, this will tell us that the value inside the message variable is a string. So we can use type of to check the type of value that is saved inside a variable. And that's the end of this lesson. In this lesson, we learned about variables, which are a way to save values and use them later. We learned how to reassign a variable. We created the cart quantity feature of the final project. We learned some shortcuts for reassigning a variable. We learned some naming conventions and best practices for variable names. And we learned 3 ways to create a variable: let, const, and var. Here are some exercises to help you practice using variables. In this lesson, we're going to learn 2 more features of JavaScript called Booleans and If-Statements. And we're going to use these features to build this rock, paper, scissors project. Let's start by creating a new HTML file for this lesson. We're going to go to our code editor and click this icon to show our files, and then click this icon to create a new file. We're going to name this file 06-booleans.html and press enter. Let's open variables.html, and we're going to copy all this code into our new file. Let's select the code using Control-A on Windows or Command-A on Mac, and then right-click, copy, and in here, right-click and paste. Let's close this for now and prepare this file for this lesson. So we'll scroll to the top and change this to Booleans, and then remove all the JavaScript code, but keep the script element. Now let's save and open this file in Live Server by right-clicking and then open with Live Server. And we can close the previous tabs as well as the previous code for now. We'll start by learning what are Booleans. So far in this course, we learned two types of values in JavaScript, numbers and strings. Booleans are another type of value in JavaScript. But Booleans are special because there are only two Boolean values, true and false. Let's click in the script element and type true. Press enter and type false. So these are the only two Boolean values that exist, true and false. So what's the purpose of Boolean values? A Boolean value represents whether something is true or false. For example, in JavaScript, we can compare two numbers. Let's create some new lines and type the code 3 less than 5. So this code checks whether the number 3 is less than 5. And of course, this is true. So if we console.log this code, console.log, and save, and then go to our website and open the console, right-click, inspect, and console, it will show us that the result of this code is the Boolean value true. Let's try another example. Let's delete this less than symbol and replace it with a greater than symbol. So now this code checks whether 3 is greater than 5. And we know that 3 is not greater than 5. So if we save, the computer will tell us that the result of this comparison is the Boolean value false. So as you can see, a Boolean value represents whether something is true or false. Now let's learn the syntax rules for Booleans. To create a Boolean, we just type true or false. Note that we don't surround these with quotes like this. If we surround them with quotes, this is now a string, not a Boolean. We can use type of to check this. So at the front, we can type console.log type of true. If we save, this will tell us that this is a string. Now, if we remove the quotes and save, this will tell us that this is now a Boolean. So when creating a Boolean, don't put quotes around true or false. Let's save. Now, one way to create a Boolean is to compare two numbers. For example, 3 greater than 5. So this greater than symbol is called a comparison operator. And there are many other comparison operators we can use. We saw less than earlier, and we also have greater than or equal to, less than or equal to, triple equals, which checks if two values are equal to each other, and exclamation double equals, which checks if two values are not equal to each other. Now, JavaScript is a little special because it has two ways to check if two values are equal, triple equals and double equals. The difference is that double equals tries to convert both values into the same type. For example, in our code, let's create some new lines and console.log, and let's check if the number 5 is equal to the string 5.00. If we save, it will tell us that these two values are equal to each other, even though one of them is a number and the other is a string. And that's because the double equals converts both values into the same type. So it converts both of these into the number 5 and then compares them. So that's why they are equal. However, this is not a good idea because this value is a number and this value is a string. It's a piece of text. So they shouldn't really be equal to each other. That's why in JavaScript, we always use the triple equals to check if two values are the same, so that we avoid the conversion behavior of double equals. So if we save, now it will tell us that these two values are not equal to each other. because one value is a number and the other value is a string. So this rule also applies to not equal to. In JavaScript, we always use exclamation double equals instead of exclamation equals to avoid the conversion behavior. All right, so those are comparison operators. In the order of operations, comparison operators have a lower priority than math. So if we did something like 5 and then minus 5, this would calculate 5 minus 5 first, which is 0, and then compare the two numbers. So 3 is now greater than 0. So if we save, the first comparison will now be true. So comparison operators have a lower priority than math operators. Now that we know what Boolean values are, we're going to combine them with a really useful feature called if statements. An if statement lets us write multiple groups of code and then decide which code to run. Let's do an example and create our first if statement. We're going to go to the bottom and create some new lines and type if and open bracket, close bracket, and open curly bracket, closed curly bracket. Between these round brackets, we're going to put a Boolean value like true. And in between the curly brackets, we're going to put some code to run. For example, console.log hello. So the way that an if statement works is that if this Boolean value is true, then we're going to run the code in the curly brackets. If this Boolean value is false, then we're not going to run the code. If we save, the value between the brackets is true, so we're going to run this code and display hello. Now if we change this to false and save, it will not run this code. So an if statement lets us decide whether or not to run some code based on this Boolean value. Now if statements have another useful feature called else. Let's go to the end of this if statement and type else, open curly bracket, close curly bracket. And then inside these curly brackets, we're going to put some different code like console.log else. The way else works is if this Boolean value is true, the computer will run this code. Otherwise, we will run the code inside else. Let's give it a try. We'll change this Boolean value to true and save. And because it is true, it will run this code and display hello. Now, if this Boolean value is false and save, because it is false, it will not run this code and it will run the code inside else and display else. So using if and else, we can write two groups of code and then decide which code to run. Now let's do a practical example. We're going to write some code to check if someone is old enough to drive. Let's go to the bottom and create some new lines. And we're going to type if, brackets, and curly brackets. And inside here, we're going to compare two numbers. The first number is a person's age. Let's pretend we have a person who is 30 years old. So we're going to type 30. Then we're going to check if this age is greater than or equal to the legal driving age. Let's pretend the legal driving age is 16. Notice that between the brackets, we don't have to just put a Boolean value. We can put any code that results in a Boolean value. So this comparison results in the Boolean value true. That means the computer will run the code between the curly brackets. So in here, let's type console.log you can drive. Now, if this is not true, let's run some different code. At the bottom, we'll type else and curly brackets. And then inside these brackets, we'll type console.log. You cannot drive. Now let's save. And it will tell me that this person who is 30 years old can drive. If we go back and change this to a person that is 15 years old and save, this comparison will result in false. So it will display you cannot drive. So that's how we use if statements. We can write multiple groups of code for different situations and then decide which code to run. Now let's learn the syntax rules for if statements. To create an if statement, we type if, and then round brackets with a Boolean value inside. This is called the condition. If this condition is true, we will run the code inside the curly brackets. We can also add an else statement. This code will run if the condition is false. The else statement is optional. We don't have to have one. So these curly brackets and the code inside, these are called branches because it's like a tree branch. The code is splitting off into two directions, and we either run this code or we run this code. One more thing to know is in a branch, if we only have one line of code, the curly brackets are actually optional. So we can delete these and the code will still work. However, if we have more than one line of code in this branch, for example, if we add another line, console.log, congrats. Now this branch has two lines of code, so the curly brackets are mandatory. So we have to add them back. Now we're going to learn another feature of if statements, which is we can have more than one condition. For example, we're going to go to the end of this if branch and type else if, and then brackets and curly brackets. Else if lets us add another branch to our if statement. Between these round brackets, we can add another condition. For example, if a person is almost old enough to drive, let's display a different message. So inside this condition, let's check if this person's age, which is 15, is greater than or equal to 14. So we're checking if they are almost old enough to drive. And now inside the curly brackets, we're going to display a different message. Console.log almost there. So the way this works is that the if statement checks the conditions one by one. First, it checks if this is true. If it is, it will run this branch. Then it checks if this is true. If it is, it will run this branch. And if none of the conditions are true, it will run the else branch. So here, this condition is false, so we're not going to run this code. But now the second condition is true, so we're going to run this code. If we save, we display almost there in the console. So using else if branches, we can add as many conditions as we want to an if statement. The next thing we're going to learn is that we can combine if statements with variables from the previous lesson. For example, here we wrote the person's age 2 times. So we can actually save this age in a variable and then reuse that value. So above the if statement, let's create a variable using const, and let's name this variable age, and we'll make it equal to 15. Remember, the best practice for creating a variable is to use const by default, and only use let if we're going to change this value later. And now that we saved this number in a variable, we can use the variable inside the if statement. So we'll replace 15 with age, and here as well with age. So this will take whatever value is inside the variable and substitute it into the code. If we save, the if statement works the same way as before, and we run this line. Okay, now we're ready to use Booleans and if statements to do a project. We're going to build a rock, paper, scissors game. First, let's take a look at the project. We're going to go to our browser, and at the top, create a new tab, and we're going to type here SuperSimpleDev/projects/Booleans and press enter. Here, we can see a simple version of a rock, paper, scissors game. And if we click this link, it will take us to the final version of this game. So in this game, we can pick a move, and then the computer will pick a random move, and it will show us the result. And we also have a score of how many times we won, lost, and tied. So we're going to build this as we go through the course. But for now, let's go back, and we're going to start by building this simple version of the game. So how this simple version works is we click one of these buttons to pick a move. So let's pick rock. Then the computer will randomly pick a move. In this case, it's paper, but for you, it might be different. And it will compare the two moves and display the results in this pop-up. So the rules of rock, paper, scissors are rock beats scissors, paper beats rock, and scissors beats paper. Let's press OK, and we'll get started on this project. First, we'll create a new HTML file just for this project. Let's go to our code editor and click here and create a new file. And we're going to name this file 06-rock-paper-scissors.html and press enter. Next, let's copy all the code from booleans.html into this new file. So we'll open this again, and then Control A or Command A to select all the code, and then right-click, copy, and in here, right-click and paste. Let's close this and prepare this file. So we'll change this to rock, paper, scissors, and remove all of the JavaScript code that we had before. Finally, let's save and open this file in the browser by right-clicking and then open with Live Server. Let's take a look at the project again. So we're going to start by creating the text first, because this text is in the final version of the project. So in our HTML, we're going to create a paragraph element for this text. So less than p greater than, and the closing tag less than /p greater than. Inside our paragraph, we're going to have the text rock, paper, scissors. Next, let's create the buttons. So we'll go to our HTML and create a button. And inside this first button, we'll have the text rock. Let's create another button. This one will be paper. And we'll create the last button. This one will be scissors. Now let's save and check our new tab. And now we created all the elements that we need. Next, let's make these elements interactive with JavaScript. So when writing JavaScript, a good strategy is to think about what steps we need to do and then convert those steps into code. So here, when we click a button, the first step is the computer will randomly select a move, and then we're going to compare the moves to get the result. And finally, we'll display the result in a pop-up. By the way, this is called an algorithm. An algorithm is a set of steps to complete a task or to solve a problem. Now that we know what steps we need to do, we're going to convert these steps or this algorithm into code. First, we're going to run some JavaScript when we click these buttons. So let's use the onClick attribute again. We'll go to the opening tag of the button and type onClick equals double quotes. And then inside these double quotes, we can add our JavaScript. So now we have to figure out how to randomly select a move for the computer. To do this, we need to learn a new piece of JavaScript code. So here, we're going to type M math.random, open bracket, close bracket. Math.random generates a random number between 0 and 1. So if we console.log this, console.log, and save, and click this button, and then check in our console by right-clicking, inspect, and the console, it will display a random number between 0 and 1. If we click this button again, it will generate a different random number. So every time we run math.random, it generates a different random number between 0 and 1. Now, to be more precise, it actually generates a number greater than equal to 0 and less than 1. Now let's save this random number in a variable so we can use it later. So we'll replace the console.log with const and then a variable name. Let's just name it random N number and then equals. So we saved this random number inside this variable. Next, we need a way to convert this random number into a move, like rock, paper, or scissors. To do this, let's imagine the space between 0 and 1, and then divide the space into 3 equal parts. Each part represents a move. If we generate a random number and it's between 0 and 1/3, the move will be rock. If it's between 1/3 and 2/3, the move will be paper. And if it's between 2/3 and 1, the move will be scissors. This is how we can convert the random number into a move, and this will give the computer an equal chance of picking rock, paper, or scissors. Now let's convert these steps into code, and an if statement is the perfect solution for this. This already looks like an if statement. So in our onClick attribute, let's add some new lines and type if, brackets, and curly brackets. For this first condition, we're going to check if the random number is between 0 and 1/3. So let's check if random number is greater than or equal to 0. But in this case, we also need to check that random number is less than 1/3, because we're checking if the number is between 0 and 1/3. But how do we do this? How do we check that two comparisons are both true? To do this, we're going to learn another type of operator in JavaScript called logical operators. Logical operators let us combine Boolean values, which is what we need to do here. Let's go back into booleans.html, and we're going to learn logical operators. So first, let's open the tab for this file, and we're going to comment out all the previous code so our console doesn't get too messy. /*, and then at the bottom, */. Now let's create some new lines. And the first logical operator we're going to learn is called the AND operator. Let's type console.log a Boolean value true and another Boolean value true. So this is the AND operator, and it checks if two Boolean values are both true. So it checks if the left side is true and the right side is true. That's why it's called the AND operator. So here, the left side is true and the right side is also true. So the AND operator will result in true. If we save, this displays true. Now, if one of these sides is false, for example, if we change this to false. Now let's check, is the left side and the right side both true? In this case, no. So and will now result in false. If we save, it now displays false. So that's the logical AND operator. It checks if the left side is true and the right side is also true. So this is exactly what we need for our project. For example, let's create a new line and type console.log. And let's say that we generated a random number like 0.2. And we want to check if it's between 0 and 1/3. So we can do 0.2 is greater than or equal to 0. And we're also going to check if 0.2 is less than 1/3. So we're using the logical AND operator to check if the left side is true and the right side is also true. So in this example, both sides are true. 0.2 is between 0 and 1/3. So if we save, this whole thing will display true. Now in the order of operations, logical operators like AND have a lower priority than math and comparisons. So in this example, it will calculate the math first, and then it will calculate the comparison on the left, and then the comparison on the right, and then at the end, the AND operator checks if both sides result in true. Now let's use the AND operator in our project. Let's go back to the file for our project, and then inside this first condition, we're going to check if the random number is greater than or equal to 0, and at the same time, is the random number less than 1/3. So this is how we check if a number is between 0 and 1/3. In this case, the computer will pick rock. So between the curly brackets, let's just type console.log rock. Let's get some practice and create the other two branches for picking paper and scissors. Feel free to pause this video if you want to try it yourself first. So here, we're going to type else if to add another branch, and then brackets and curly brackets. And in this condition, we're going to check if random number is greater than or equal to 1/3 and random number is less than 2/3. So if this random number is between 1/3 and 2/3, inside here, we're going to console.log paper. And finally, let's create another branch using else if random number greater than or equal to 2/3 and random number less than 1. And console.log scissors. If we save and then go back to our rock, paper, scissors tab and then click the rock button a few times, it will pick some random moves for the computer. So that's how we generate the computer's move. One thing I want to point out is that I use the less than comparison instead of less than or equal to. I just did this so that the comparisons don't overlap. Before we continue in the project, we're going to learn two other logical operators we can use. Let's go back to Booleans.html, and let's also open the tab for this file. The next logical operator is called the OR operator. For example, let's type some new lines and type console.log true or false. So this is the logical OR operator. It checks if at least one side is true. So it checks if the left side is true or the right side is true. That's why it's called the OR operator. So here, one of these sides is true, so the OR operator will result in true. If we save, this displays true. If both sides are true, it will also result in true because at least one side is true. The last logical operator we're going to learn is called the not operator. For example, let's create a new line and type console.log exclamation true. So the exclamation is called the not operator. The not operator only uses one Boolean value, and it flips it into the opposite value. So if this value is true, the not operator will flip it into false. So if we save, this will result in false. Now, if you think about it, if we say that something is not true, that's the same thing as saying that it is false. So that's why this is called the not operator. Now, if we change the value to false, again, the not operator will flip this into true. So if we save, this will now result in true. So those are the logical or and not operators. We don't need to use these in our project right now, but I'll leave some exercises for these at the end of this lesson. Now let's go back and continue the project. Let's open the code and open the tab. The next step is to compare the computer's move to our move, which is rock. So first, let's save the computer's move in a variable so we can compare it later. So instead of console.log, we're going to create a variable with const computer capital M move and make it equal to the string rock. And we'll do the same thing here. Const computer move equals paper. And here, const computer move equals scissors. And now at the bottom, let's console.log the computer move variable to make sure that it worked. If we save and then click our rock button, unfortunately, it gives us an error telling us that computer move is not defined, even though we created it right here. So what is happening here? If statements have a special feature. They create something called a scope. A scope limits where a variable exists. Basically, whenever we have these curly brackets like this, any variable we create inside the curly brackets will only exist inside the curly brackets. And we can't use these variables outside the curly brackets. So this is called a scope. Scopes are a feature of many programming languages, and they help us avoid naming conflicts. For example, if I create a variable here called random number equals 0.5, and this didn't create a scope, so if I delete these curly brackets, this variable name will now conflict with the variable name up here, because we can't have two variables with the same name. So you can imagine that if we didn't have scope, and we had hundreds or even thousands of lines of code, we would quickly start to run out of variable names. So by creating a new scope here, all the variable names inside the scope only exist between the curly brackets, and it won't affect anything outside in the code. So scopes help us avoid naming conflicts. Okay, so I'll delete this example, and we'll learn how to access this variable outside of this scope. So to access this variable outside of the if statement, we have to create this variable outside of the if statement. So above here, we can create this variable, const computer move. And let's just make it equal to the empty string for now. So this variable was not created inside any curly brackets, so it's accessible from all of this code inside the onClick attribute, including inside the if statement. And then inside the if statement, instead of creating a new variable, we're just going to save the move inside this variable up here because we can access this variable anywhere else in the code. So instead of using const, we're just going to reassign computer move. And we're going to remove it here as well and here as well. And remember, when we reassign a variable, we have to switch from const to let. And now if we save and then click the rock button, we're able to console.log computer move because computer move is no longer inside this scope. It's up here. So we can access it in this line of code. So that's how scope works. Any variable that we create inside curly brackets will only exist inside the curly brackets. So remember in the previous lesson, we learned a third way of creating variables called var. The issue with var is that it doesn't really follow the rules of scope. For example, here, if we create a variable with var, like var and random number equals 0.5, this variable will conflict with the variable up here with the same name, even though it's inside a scope. So that's why we don't use var anymore, and we just use const and let, because var doesn't really follow the rules of scope. So we can remove this for now and move on to the next step. So we generated a random move for the computer. Now we have to compare our move, which is rock, to the computer's move to get the result and see who wins. To do that, we'll use another if statement. So at the bottom here, let's type if, and then brackets and curly brackets. And then inside this condition, let's check if the computer move is equal to rock. So remember in JavaScript, we always use triple equals instead of double equals to avoid the conversion behavior. And now if the computer's move is rock and our move is rock, then inside the curly brackets, the result is going to be a tie. And let's save this string in a variable so we can use it later. Again, we have the same situation as before. We don't want to create the variable inside here because then it only exists in this scope between the curly brackets. Instead, we're going to create the variable above, outside the if statement. So we'll use let to create this variable because we're going to reassign it in the if statement. Let's name this variable result and just make it equal to the empty string at the top. And then in the if statement, we'll save the result into this variable. So result equals tie. Now let's create the other branches of this if statement. So here we'll add else, if, brackets and curly brackets, and we'll check if the computer move is equal to paper this time. If the computer move is paper and we picked rock, then we lose. So the result is equal to you lose. And finally, we'll add another else, if, brackets and curly brackets, and we'll check if the computer move is equal to scissors. And if the computer picked scissors and we pick rock, the result is that you win. So that's how we compare our move to the computer's random move using an if statement. The last step is to display this result in the pop-up. So at the bottom, let's create a pop-up using alert, open bracket, close bracket, and let's go back to SuperSimpleDev to see the message in the pop-up. So we'll click this, and in the pop-up, it shows our move, the computer's move, and then the result. So we can actually just copy this, right-click, copy, and then in here, right click and paste. So obviously the computer is not going to pick this move every time, and this is not going to be the same result every time. Instead, we want to insert computer move into here, and we want to insert result into here. So because we want to insert values, we're going to turn this into a template string using backticks. And now instead of paper, we're going to insert a value using $ and curly brackets, and we're going to insert the variable computer move. And instead of this text every time, we're going to insert the variable result. And now if we save, and we can click OK to close this, and go back to our tab and click the rock button, we're going to pick rock. The computer will pick a random move, and it will show us the result in a pop-up. So that's how we create this simple version of rock, paper, scissors. In our code, we did things step by step. First, we generated a random number, we converted it into a move for the computer, and then we compared our move to the computer move, and we displayed the result in a pop-up. So as you can see, when we're writing JavaScript, we first figure out what steps we need to do. This is called an algorithm. And then we convert these steps, or this algorithm, into code. So now we can actually remove this console.log because we don't need it anymore. And the last step is to make the other buttons here interactive. So feel free to pause this video if you want to try it yourself first. For the paper button, let's add some new lines to make it a little easier to read. And again, we'll add the onClick attribute. And then inside here, we can actually make a copy of all the JavaScript we wrote. So we can select all of this, and then right-click, copy, and then in here, right-click and paste. If the formatting doesn't look right, we can select all of these lines and press Tab to add indents until the formatting looks good. The one thing we have to change here is that now we picked paper, so the result is going to be different. If the computer picks rock and we pick paper, that means you win. If the computer picks paper, now it means that we tie. And if the computer picks scissors, that means you lose. And here we'll also change you pick rock to paper. And that's it. The last step is to make the scissors button interactive. So again, on click equals double quotes, and then we'll make a copy of the code. So I already have it, so just right click and paste. And then again, select the code that we need to fix the formatting for, and press Tab. And here we pick scissors. So if the computer picks rock, then the result is you lose. If the computer picks paper, the result is you win. And if the computer also picks scissors, the result is a tie. And we'll change you picked rock to scissors. Now if we save and try out our game, if we click rock, we're going to pick rock, computer picks a random move, and it will show us the result here. Let's press OK and try paper. This also works correctly. Let's press OK and click scissors. And this also works correctly. And that's it. We just finished creating a simple version of this rock, paper, scissors game. In the rest of this lesson, we're going to learn more details about Booleans and if statements. Let's go back to booleans.html and open the tab for this file. And let's comment out the previous code using /* and // and create some new lines. The next thing we're going to learn is called truthy and falsy values. So if statements don't just work with Boolean values like true and false. They actually work with any type of value, including numbers and strings. For example, let's type if, brackets, and curly brackets, and inside this condition, instead of putting a Boolean value, we're going to put a number, like 5. And then inside the curly brackets, let's console.log the string truthy. If we save, the number 5 behaves just like true. It causes the if statement to run this code. So we call this value a truthy value because it behaves just like true. Now let's change this value to a different number, 0. If we save, the number 0 behaves just like false. It causes the if statement to not run this code. We call this value 0 a falsy value because it behaves just like false. So how do we know if a value is truthy or falsy? In JavaScript, the list of falsy values are false, the number 0, the empty string, nan, undefined, and null. Any value that is not on this list is a truthy value. So why do we use truthy and falsy values? One way we use them is like a shortcut in our code. For example, let's create a variable at the bottom using const, and let's call it cart quantity and make it equal to 5. Next, let's create an if statement. If, brackets, and curly brackets, and inside the curly brackets, let's type console.log the string cart has products. Now let's say that we only want to display this message if our cart has products. Usually, inside this condition, we would check if cart quantity is greater than 0. But now, instead of doing this comparison, we can actually just type cart quantity, and it will behave the same way. If the cart quantity is not 0, they will both behave like true. If the cart quantity is 0, they will both behave like false. So here, the cart quantity is 5, which is a truthy value. If we save, this causes the if statement to run this code. As you can see, instead of doing comparisons, we can use truthy and falsy values as shortcuts. Truthy and falsy values also work with logical operators. For example, if we console.log the not operator and the number 0, 0 is a falsy value. It behaves just like false, so the not operator will flip it into true. If we save, this will display true. Now that we understand truthy and falsy values, let's go over the list of falsy values, because there are some that we haven't learned yet. We already learned false, 0, and the empty string. The next falsy value is nan, which means not a number. We get nan if we do some invalid math. For example, at the bottom, let's type console.log the string text divided by the number 5. So obviously, this is not valid math. If we save, JavaScript will tell us that the result of this calculation is not a number, or nan. The next falsy value is undefined. Undefined represents that something doesn't have a value. For example, at the bottom, if we create a variable with let variable 1 and we don't give it a value, and then we console.log this variable, and we save, it will show us that variable 1 contains the value undefined. So undefined represents that this variable doesn't have a value. One thing to note with undefined is that we can only use this syntax with let. We can't use it with const. If we really want to use this with const, we have to type out equals undefined directly. The last falsy value is null. We'll need some extra knowledge to understand null, so we'll learn about null later in this course. The last thing we're going to learn in this lesson are some shortcuts for if statements, called the ternary operator, the guard operator, and the default operator. First, let's comment out this code so our console doesn't get too messy. /*, and then at the bottom, */. And let's scroll down, and we'll start by learning the ternary operator. We're going to type a Boolean value like true, and question mark, another value, for example, the string truthy, and then colon, and another value, like the string falsy. So this is the ternary operator. This is similar to an if-else statement. The first value is like the condition. If it's truthy, the result of this code is the value after the question mark. If the first value is falsy, the result of this code is the value after the colon. So you can think of the question mark as the if branch and the colon as the else branch. This is sort of like a shortcut for an if statement like this. Now, an advantage of the ternary operator over an if statement is that we can save a ternary operator in a variable. So at the front, we can do const result equals. And now if we console.log the result and save, the first value is true. So the value after the question mark gets saved in the variable. As always, we can use truthy and falsy values instead of just true and false. So here, if we change the first value to a falsy value like 0, this will cause the value after the colon to get saved inside the variable. If we save, that's exactly what happens. So this is the ternary operator. It's sort of a shortcut for an if-else statement like this. The next shortcut is called the guard operator. Earlier in this lesson, we learned the AND operator, which checks if two sides are both truthy. The AND operator has a special feature. Let's say we have an AND operator, and the left side is false. In this situation, we already know it's impossible for both sides to be truthy, so we don't even need to check the right side. So the AND operator actually stops early and doesn't even run the code on the right. This is called a short circuit evaluation. For example, let's go into our code and create some new lines, and we'll type false and console.log hello. If we save, the left side is falsy, so the AND operator stops early or short circuits, and it doesn't even run the code on the right. So as you can see, we can use the value on the left to block or guard the code on the right. So when we use the AND operator like this, we call it the guard operator. This is sort of like a shortcut for an if statement like this. And just like the ternary operator, we can save the guard operator in a variable. For example, let's create a variable const message and make it equal to false and the string hello. If the first value is falsy, The guard operator will stop early, and the result will be the first value. If we console.log this message and save, the value false will be saved inside this variable. Now let's change this value to a truthy value, like the number 5. Now it will not stop early, and it will give us the second value as the result. If we save, the string hello is now saved inside this variable. This is sort of like a shortcut for an if statement like this. So don't worry if it's a bit confusing. All of these are just shortcuts for an if statement. They're sort of like an if statement that we can write on a single line. The last shortcut is called the default operator, which is similar to the guard operator but uses OR. Earlier in this lesson, we learned the OR operator, which checks if at least one side is truthy. Let's imagine we have an OR operator, and the left side is true. In this situation, we already know the result of the OR operator, because the left side is already truthy. We don't even need to check the right side. So the OR operator also stops early or short circuits if the first value is truthy. For example, let's create some new lines. And let's say that in our final Amazon project, we can choose a currency to pay for our order. Let's create a variable with const currency and make it equal to the string EUR, or euros. Now let's say that choosing a currency is optional. If we don't choose a currency, we'll use a default value of USD, or United States dollars. To create a default value, we can go to the end and type or the string USD. So here, the left side is truthy. So the OR operator will stop early, and it will result in the value on the left. If we console.log the currency and save, it will display euros. Now let's say that we didn't choose a currency because it's optional. So let's go here, and we're going to change this currency to undefined. Now the left side is falsy, so the OR operator does not short circuit. It will continue, and the result will be the value on the right. If we save, now the string USD is saved inside currency. As you can see, we can use the OR operator to set a default value. So when we use the OR operator like this, we call it the default operator. The default operator is sort of a shortcut for an if statement like this. So don't worry, remember that everything that we learned in this last section are basically some shortcuts for if statements. We don't have to use them, but they can save us some typing. And that's the end of this lesson. In this lesson, we learned about Booleans and if statements. Boolean values represent whether something is true or false. We learned how to use if statements to make decisions in our code. We learned how to use comparison and logical operators. We learned about algorithms and created a simple version of rock, paper, scissors. We learned about truthy and falsy values. And we learned some shortcuts for if statements: the ternary operator, the guard operator, and the default operator. Here are some exercises to help you practice Booleans and if statements. In this lesson, we're going to learn the next feature of JavaScript called functions. And we're going to use functions to improve our rock, paper, scissors project. First, let's create a new file for this lesson. we'll go to our code editor and create a new file. And let's name this file 07-functions.html and press enter. Next, let's copy booleans.html to functions.html. So we'll click this file and then select all this code using Control-A or Command-A, and then right-click, copy, and in here, right-click and paste. And we'll hide our files and prepare this file for this lesson. So at the top, we'll change the title to functions, and we'll remove all the code in the script element. And let's save, and we'll open this file in Live Server by right-clicking, Open with Live Server. And we're going to open the console as well. So right-click, Inspect, and then click the console. And finally, we can close the previous tabs as well as the previous code. Okay, now we're ready to learn functions. First of all, what is a function? A function lets us reuse code. Let's create our first function. We're going to go to the script element and type the word function and space. So this creates a new function. And then we're going to give a name to our function. We can name it almost anything we want, but for now, let's just name it function1. And then we're going to type round brackets and curly brackets. Then inside these curly brackets, we're going to create a new line, and we're going to type some code. So console.log the string hello, and we'll also type console.log 2 + 2 and save. So this creates a function. Now let's learn how to use this function. We're going to type at the bottom the function name. So function1, and then open bracket, close bracket, and semicolon. When we type the function name with brackets, this will run the code inside the function. If we save, notice that it runs the code inside the function and displays the two lines in the console. So why do we use functions? A function lets us reuse code. So if we wanted to run both these lines of code again, all we have to do is type the function name again with brackets. So function1 and brackets again. If we save, this will run the code inside the function 2 times. And we can reuse this code as many times as we want by typing the function name with brackets. So that's what a function is. It lets us reuse code. Now let's learn the syntax rules for functions. The word function creates a new function, and then we choose a name for our function. The rules for function names are the same as variable names. We can't use special words like function, we can't start with a number, and we can't use special characters, although $ and underscore are allowed. And just like variable names, the best practice is to use camel case for function names. And inside these curly brackets, we put the code that we want to run when we use the function. This is called the function body. Now, one very important thing to remember is that this code only creates a function. It doesn't run the code in the function or do anything else. In order to actually run the code, we have to use the function like below by typing the function name with brackets. This is known as calling the function. It's also known as running the function or executing the function. Now that we learned the syntax rules for functions, let's do a practical example. We're going to use functions to improve the code of our rock, paper, scissors project. First, let's click here to show our files. And we're actually going to make a copy of the project just for this lesson. So we're going to right-click this file, copy, and then at the bottom, right-click and paste. And we're going to rename this file. So right-click, rename, remove copy at the end, and then at the beginning, we'll change this to 07 and press enter. Next, we're going to open this file in Live Server by right-clicking and then open with Live Server. And let's also open the console on this page. We'll right-click, inspect, and then click the console. All right, now if we look at the code for generating a computer move, you'll notice that this code is the same for all three buttons. So this is a perfect situation to use a function because a function lets us reuse code. So let's scroll down to the script element and we're going to make a function here. So let's type function and then a function name. Let's name this function pick computer move, and then brackets and curly brackets. So one recommendation for function names is to use a verb or an action in the name, such as pick. So next, we're going to move all the code for picking a computer move into our new function. So let's create a new line here, and we'll scroll up to the scissors button because it's the closest one, and we'll select all of this code for picking a computer move, and then right-click, cut, and inside the function, right-click and paste. If we need to fix the formatting, we can select these lines and press Tab to add indents. So the reason we created this function in the script element is because remember that the script element runs when the page is loaded. So we want to make sure that we create the function first, and then we use it in the buttons after. Now remember, this code just creates a function. It doesn't actually run the code inside. To run the code inside, we're going to call this function. So let's scroll up to the scissors button, and we're going to call this function by typing the function name pick computer move, open bracket, close bracket, and semicolon. If we save and then click the scissors button, unfortunately, it now gives us an error saying computer move is not defined. Now, this might seem weird because down here, we actually create the computer move. So what's going on? The reason this happens is because functions create a scope. In the previous lesson, we learned about scopes, which limit where a variable exists. We learned about if statements, and that if statements create a scope between the curly brackets. This means that any variable created between the curly brackets only exists between the curly brackets. Functions also create a scope. Any variable that is created between these curly brackets only exists inside the curly brackets, and we can't use it outside the curly brackets like we do here. So that's why we're getting this error. So how do we solve this problem? Remember that with if statements, we solve this by creating the variable outside of the if statement, like this. We can use a similar solution with functions. To make this variable exist outside the function, we just have to create it outside the function. So let's select this code. We're going to right-click and cut and remove these lines. And then outside the function, we're going to right-click and paste. So now this variable is no longer inside the function's scope, and it can be used anywhere else in the code. So variables like this that can be accessed anywhere are called global variables. If we save and now click the scissors button, everything is working again because this code above can now access this variable. Now let's press OK, and let's use this function to reuse this code. So we'll scroll up to the paper button, and now instead of all this code again, we're just going to remove it and call the function pick computer move, open bracket, close bracket, semicolon, and also with the rock button. We'll select all this code and remove it and just call the function pick computer move, brackets and semicolon. Now, if we save and click the rock button, it works just like before. We'll press OK and click the paper button. It also works just like before. So as you can see, functions let us reuse code, and they make our code a lot cleaner by removing all the duplication that we had. Another benefit of removing duplication is that before, if we ever wanted to update the code for picking a computer move, we had to update it in 3 places in each of the buttons. But now, if we scroll down, we only have to update it in 1 place inside this function. So functions also make our code easier to update in the future. Next, we're going to learn a feature of functions called a return statement. A return statement lets us get a value out of a function. So at the end of this function, let's type some new lines, and we're going to type return, and then a value like the number 5 and semicolon. Now, whenever we call this function, it will result in a value, the number 5. So up here, when we call this function, this will result in the number 5. So we can actually console.log this, console.log, and then save and click the scissors button, and it will show us that calling the function now results in the number 5, and we display it in the console. So that's how a return statement works. It lets us get a value out of this function. Let's press OK and do another example. We'll scroll down, and this time let's change this value to the string rock. Now, whenever we call this function, it will result in the string rock. If we save and then click scissors and scroll up here, calling this function now results in the string rock, and then we display it in the console. So now let's press OK, and we'll learn the syntax rules for a return statement. So we just have to type the word return and then a value, and it will get this value out of the function. Now, instead of just a value, we can also return a calculation or a variable or anything that results in a value. So this is known as returning a value from a function. And this value is known as the return value. We also don't have to return anything from a function. If a function doesn't have a return statement, or we return without a value, like this will return the value undefined. So if we save and then click scissors again, the function will return undefined. And lastly, when we use a return statement, it ends the function immediately. So after the return statement, if we type console.log the string after and press OK here and save this file, and then click the scissors button, notice that it doesn't run this code. And that's because once we return, the code returns back to where we called the function. That's why it's called a return statement. So it's not going to run anything after the return. So we can remove this code and press OK. So now that we understand return statements, we're going to learn a better way of getting the computer move out of this function. So first, let's actually move this variable back into the function. So we'll right click and cut, and then in here, right click and paste, and delete these lines. So now we're back to the original problem. How do we access computer move outside of the function? So another solution is to return this variable, because remember, a return statement lets us get a value out of the function. So down here, we're going to return the computer move. So this will take whatever value is saved inside computer move, which is one of these values, and return it out of the function. If we save and then click the scissors button, we were able to get the move scissors outside of this function. So what happened here is that we returned this move, and then up here, we took the move and displayed it in the console to get scissors. So that's another way of getting the computer move out of a function using the return statement. However, now we're back to this problem with computer move not being defined because we moved it back into the function's scope. So let's scroll up and remember that this return value is just a value. We can use it like any other value. For example, we can console.log it, or we can also save this in a variable. So let's do that right now. We're going to remove this and create a new variable with const, and let's just name this variable computer move to match what we use down here. And we'll use equals to save the return value inside this variable. So note that even though we use computer move here as well as here, they're different variables. This one is inside the function's scope, so it prevents it from conflicting with variables outside the function's scope. That's one of the main benefits of scopes. So now that we save the return value into this variable, and we're using this variable down here, the code should now work. If we save and click scissors, everything is back to normal. And let's press OK. So don't worry, functions can be a little confusing at first because the code is no longer simply going from top to bottom. It sort of jumps around a little bit. So let's go through this step by step. When we click this button, we're going to run this function. So the code is going to jump down here, and then it's going to run all of this code from top to bottom. At the end, we're going to return whatever is inside computer move back to where we called this function. So we're going to return all the way back here. And then we're going to save that return value into a new variable, computer move, and then use computer move down here. So following the code line by line like this is called tracing the code. It's a useful technique to understand exactly what the code is doing. Now let's compare the two solutions that we used, a global variable and returning a variable. So returning a variable like this is actually preferred over using a global variable. And that's because a scope can help us prevent naming conflicts. So all the variables inside here will not conflict with anything outside the scope. So generally, it's a best practice to keep things inside a scope if we can. Now let's move on and use this function in the other buttons. Feel free to pause the video if you want to try it yourself first. So we'll scroll up to the paper button. And then here, we're going to save the returned computer move into a variable. So const computer move, so that it matches the code down here. Make it equal to whatever is returned. And then same thing for the rock button. We're going to save the return value in a variable const computer move equals. If we save and click the rock button, it works. Let's press OK and click the paper button, and this also works. And let's press OK. So that's how we use a return statement to take advantage of the benefits of scope. Next, if we look at the rest of this code, where we compare our move and display the result, you'll notice that this code is very similar for each of the buttons. The only thing that's different is the result and the message that we display. So we can actually use functions here as well to reuse code that has small differences. To do this, we're going to need another feature of functions called parameters. So let's go back into functions.html, and let's open the tab for this file. And let's also comment out the previous code by typing /* and at the bottom */ and create some new lines. And now we're ready to learn parameters. So parameters are sort of the opposite of a return statement. A return statement gets a value out of a function. A parameter puts a value into a function. So let's do an example. Let's say that we're working on the final Amazon project, and we need to calculate the tax for our order. Let's create a function to calculate the tax. So function, let's name it calculate tax, brackets and curly brackets. And then inside the curly brackets, let's say that the cost of our products is 1,000 cents or $10, and the tax is 10%. To calculate the tax, we can do 1,000 times 0.1, which is 10%. Let's also display this number in the console. So at the front, we'll type console.log and brackets. Now let's save. And remember, this code only creates a function. It doesn't run the code inside. To run this code, we're going to call this function. So down here, we're going to type the function name, calculate tax, and then brackets. If we save, it runs this code, and then it displays the tax, which is 100 cents or $1. However, right now, this function only calculates the tax for 1,000 cents. What if we want to calculate the tax for a different amount? How would we modify this function to work with any number? To do this, we're going to learn a feature of functions called parameters. A parameter lets us put a value into a function. So let's finally create our first parameter. So inside these round brackets, we're going to choose a name for our parameter. So let's just name this parameter 1. A parameter works the same way as a variable. We can save a value inside this parameter and then use it just like a variable. So first, let's save a value inside the parameter. To do that, we're going to go to where we call the function. And then inside these brackets, we're going to put a value. For example, 2,000. This will save this value into this parameter. And now we can use it just like a variable. So instead of 1,000, we're going to type parameter 1. And it will take whatever value is inside parameter 1, in this case 2000 and substitute it into the code. If we save, it now calculates 2000 times 0.1 to give us 200 cents as the tax. Now, every time we call the function, we can save a different value into the parameter. For example, let's create a new line and call the function calculate tax. And this time, we're going to save the value 5,000 into parameter 1. If we save, this line of code will calculate the tax for 5,000 cents and result in 500 cents. So as you can see, a parameter lets us put values into a function, and this allows our function to work with any value. Now let's learn the syntax rules for parameters. To create a parameter, we just typed the parameter name between the brackets. Parameter names follow the same rules as variable names. We can't use special words, we can't start with a number, and we can't use special characters other than $ and underscore. And the best practice is to use camel case. Let's actually change this parameter name to cost so the code makes more sense. And save. Next, when a function has a parameter, we usually say this function takes a parameter. If this parameter should be a number, we say this function takes a number. When we put a value into the function like this, we call this passing a value into the function. Another name for this value is called the argument. And believe it or not, we've actually used functions and parameters this whole time. The first code that we learned in this course was alert. Alert is actually a function. You can tell it's a function because of the round brackets. And between the brackets, we put a string. So this is an example of a parameter. And lastly, a parameter only exists inside the function's scope. So we can only use this parameter between the curly brackets. We can't use it outside the function. Next, a function can actually have more than one parameter. For example, right now, our calculate tax function can only calculate a 10% tax. But what if we're in a different country and we want to calculate a different tax percent? To solve this, we can add a second parameter by typing after the first parameter a comma and then another parameter name. Let's name this tax percent. And now to save a value into the second parameter, we'll go to where we call this function and also type a comma and a second value like 0.2 or a 20% tax. So the first value gets saved in the first parameter and the second value gets saved in the second parameter. And now we can use our second parameter just like a variable. So instead of 0.1 every time, we're going to calculate it with tax percent. And it will substitute whatever value is inside tax percent into the code. If we save, this first line will multiply 2000 by 0.2 and give us 400 cents as the result. So we can have as many parameters as we want in a function. We just have to separate them with a comma. Now notice that the second time we call this function, we didn't give a value for the second parameter. If we don't save a value into the parameter will get the value undefined. So here, if we console.log the second parameter, tax percent, and save, it will show us that the second time tax percent is undefined. And then multiplying the cost times undefined is not valid math, so we get the result nan, or not a number. So now let's remove the console.log and we'll learn how to fix this. So to fix this, we can either pass a second value into the function, like this line, or we can also set a default value for the parameter. To set a default value, we can just type after the parameter and then add $, and a default value, like 0.1. If we save, the second function call will multiply 5,000 by the default value 0.1 and give us 500. So that's how we add a default value for a parameter. All right, now that we learned parameters, we're going to go back to the rock, paper, scissors project and reuse even more code. So let's go back to the file for the project and also the tab for this project. And now, if we look at the code inside each of the buttons, you'll notice that the code is basically the same for all three buttons. The only small difference is the move that we picked. So this is a perfect situation to use a parameter. So inside the script element, let's create a new function to reuse all of this code. We'll type function, and let's name this function play game, brackets and curly brackets. Next, let's move all of this code inside the function so we can reuse it. We'll select this code and then right-click, cut, and inside the function, right-click and paste. And if we need to reformat, we can select these lines and press Tab. So the value that is different for each button is the move that we picked. So we're going to turn this move into a parameter. So at the top, between the brackets, we're going to create a new parameter. Let's name it player move. And now let's save a value into this parameter. So inside our scissors button, we're going to call this function and run all this code. So let's type play game and call this function. And for the scissors button, let's save the string scissors into player move. To do that, we'll type between the brackets here and type the string scissors. So as we learned, this will save scissors into player move. And now we can use player move just like a variable in the function. Now let's modify the code based on the parameter. So here, this code calculates the result. However, this only works if the player move is scissors. So we're going to put this in an if statement. So we'll type if player move equals scissors and curly brackets. Inside this if statement, we're going to put this if statement. So let's select this and then right click, cut, and then inside here, right click and paste. And select these lines and press Tab. So notice that we can put an if statement inside another if statement. And we did this because this code only makes sense if the player move is scissors. And finally, let's modify the code that displays the message. So here, instead of displaying scissors every time, we're going to display whatever is saved inside player move. So we'll replace it with $, open curly bracket, close curly bracket. And in between, we'll insert player move. And that's it. We modify this function to use a parameter instead of always using scissors. Now let's save and click the scissors button. And you'll notice that it works. We display the move scissors and we calculated the result correctly. Let's press OK. And we're going to use this function to reuse the code for the other buttons. So we'll scroll up And for the paper button, we're going to use a different if statement to calculate the result. So let's actually copy this into the function. We're going to right-click, click copy, and then inside the function, we're going to create another branch if the player move is paper. So here, let's type else if brackets and curly brackets. Inside this condition, we're going to check if the player move is equal to paper this time. And then inside these curly brackets, we're going to paste the if statement we copied earlier. So right-click and paste. And we can select these lines and press Tab to reformat. So now we have the code that determines the result for paper. Down here, we don't need to modify this code because we're always displaying whatever is inside player move. Finally, we can scroll up to the paper button and remove all this duplicated code and just use our function, play game, and we're going to pass paper inside. So now paper will get saved inside player move, and it's going to run this if statement instead. If we save and click the paper button, in this example, I picked paper, computer picked rock, and it calculated the result correctly. Let's press OK and use this function for the rock button. Feel free to pause the video if you want to try it yourself first. So let's scroll up to the rock button. And first, we need to copy this if statement into the function. So let's right-click, copy, and then inside the function, let's create a branch for rock. Else if player move is equal to rock, and then curly brackets. And inside here, we're going to right-click and paste the if statement we copied earlier. And now let's select these lines and press Tab a few times to reformat. And again, this doesn't need to change. The last step is to scroll up to our rock button. And instead of duplicating all of this code, we're going to remove it and just call our function instead. Play game, brackets, and then inside we'll have the string rock. Now let's save and click the rock button. So I picked rock, the computer picked paper, and we calculated the result correctly. Let's press OK. So by using a function with a parameter, we were able to reuse all of the code in our buttons. And you can see that it made our code a lot cleaner. So lastly, notice that inside a function, we can call other functions. Let's go through the code step by step so that we understand how it works. So here, when we call the play game function, we go inside here, and then we call the pick computer move function. So now we're going to go inside this function and run all the code. And then when this function returns, we're going to return back to where we called it and then keep going and run the rest of the code. And then when the play game function finishes, it's going to return back to here. So inside a function, we can call other functions. Now, one last thing we're going to do for this code is we'll scroll down and we're just going to add some new lines to this if statement to separate the branches and make the code a little easier to read. And save. And let's scroll up. And that's the end of this lesson. In this lesson, we learned about functions, which let us reuse code. We learned how to get a value out of a function using return, we learned how to put values into a function using parameters, and we improved the code for our rock, paper, scissors project by reusing the code and removing duplication. Thanks for watching this course so far. If you want to support this channel, you can check out the premium version of my courses just like this one, where you can get a certificate of completion and a better learning platform. If you're interested in extra videos from me, more in-depth videos, and behind-the-scenes content, you can check out these links here. You can also support the channel by liking the video, subscribing, and sharing this video with others. Thanks again, and let's continue with the course. Here are some exercises you can do on your own to practice using functions. In this lesson, we're going to learn another type of value in JavaScript called objects, and we're going to use objects to create a score in our rock, paper, scissors project. First, let's create a new file for this lesson. We'll go to our code editor and click this icon, and then click this icon to create a new file. And we'll name this file 08-objects.html and press enter. Next, we'll copy all the code in functions.html to objects.html. So we'll type here and press Ctrl A or Command A to select the code, and then right click, copy, and in here, right click and paste. Now let's hide the files for now, and we'll prepare this file for this lesson. So we can change this to objects and remove all the code in the script element. Finally, let's save and open this in Live Server by right-clicking, Open with Live Server. And let's also open the console on this page. So we'll right-click, click Inspect, and click the console. Let's close our previous tabs and also the previous code. And now we're ready to learn objects. So what is an object? An object groups multiple values together. Let's do an example and create our first object. We'll go to the script element and we'll create a variable using const, and we'll name this variable product and make it equal to open curly bracket, close curly bracket, and semicolon. So this is an object. Inside this object, we can add some values. So we'll type enter and then name, colon, and then a value like the string socks. And at the end, we'll type a comma and then price, colon, and another value like the number 1090. So inside our object, we just added two values. So at the bottom here, let's try console.logging this object. Console.log product and save, and it will display both values into the console. So as you can see, an object lets us group multiple values together. So for each of these values, we have some code on the left. This code is called the property, and using the property, we can access specific values in the object. For example, let's type and enter and console.log. We're going to type the object product and then a dot and then a property like name. So .name will access the value that is associated with the name property, which is the string socks. So if we save, it will display the string socks in the console. Let's do another example, and we'll access this second value using the property price. So we'll type enter console.log, the object, product, and then a dot, and then a property, price. So this will access the value associated with price, which is 1090. If we save, that's what gets displayed in the console. Now we can also use the property to change a value inside an object. To do that, we're going to type the object's name, product, and then dot and a property like name, and just make it equal to something else, like the string cotton socks. So this code will change the value associated with the name property to cotton socks. So at the bottom, if we type console.log, the product again, and save, you'll notice the value associated with the name property was changed to cotton socks. So that's how an object works. We group multiple values together, and then we can access or change these values using the properties on the left. Now let's learn the syntax rules for objects. To create an object, we start with an open curly bracket and end with a closed curly bracket. Inside the object, we can put multiple values. For each value, the code on the left is called the property. This is how we access the value inside the object. We separate the property and value with a colon, and this is called a property value pair. We can have many property value pairs in an object, and we separate them with a comma. To access a value inside the object, we type the object's name, and then dot, and then the property we want to access, like name. This will give us the value associated with the name property. This syntax is called dot notation. If we access a property that doesn't exist, the value will be undefined. To change a value in an object, we can use the dot notation again. So product.name, and just make it equal to something else. Now using this syntax, we can also add a value to an object. We can type a property that doesn't exist. For example, here we can type product.new property and make this equal to something, like the Boolean value true. If we console.log the product again and save, it will add this value to the object along with the new property. We can also remove a value from an object by typing delete, and then the object, product, dot, and then the property we want to delete, like new property. If we console.log the product again and save, this code will delete new property from the object. And lastly, notice that an object is just another type of value. We can save an object inside a variable, and we can also console.log objects. If we check the type of this value, so type of product, and save, and scroll up in the console, it will tell us that product is an object. So let's remove this and save. And now we'll learn why we use objects. So objects make our code more organized. Instead of creating a bunch of variables for the product's values, like the name and the price and other details, we can just group all these related values together into one object. Objects also allow us to use multiple values together. Instead of console.logging each of these values individually, we can just console log the whole object and display all the values at once. So objects let us group multiple values together and let us use multiple values together. Next, let's do a practical example with objects. We're going to add a score to our rock, paper, scissors game. So I've actually prepared a project we can use for this lesson. To see this project, we're going to go to our website and then create a new tab. And then up here, we're going to type supersimpledev/projects/objects and press enter. So this is our simplified rock, paper, scissors game again, except in this project, when we play the game, it's also going to keep track of a score. So how many times we win, lose, and tie. And also, if we click OK, we have a reset score button. So if we play the game a few times and add to our score, and then click the reset score button, this will reset the score back to 0. So if we play the game again, the score starts from 0 again. So we're going to learn how to use objects to create this feature. Let's press OK. And first, let's create a copy of our project just for this lesson. We'll go to our code editor and click this icon to show our files. And we'll make a copy of the rock, paper, scissors project from the previous lesson. So we'll right click and copy. And down here, right click and paste. And we'll right click and rename this file. We'll remove the copy at the end, and at the front, we'll change this to 08 and press enter. Now let's hide these files, and we can close the 07 file for now. And let's open this in Live Server by right-clicking and open with Live Server. Let's also open the console on this page. So right-click, inspect, and the console. All right, now let's go into our code and add a score to our game. So remember, when writing JavaScript, a good strategy is to think about what steps we need to do. This is called an algorithm, and then convert those steps into code. So we already had an algorithm for the rock, paper, scissors game. Let's update this algorithm to include the score. So first, the computer randomly selects a move. This step will stay the same. Number 2, we're going to compare the moves to get the result. This step will also be the same. But now we're going to add an extra step. After getting the result, we're going to update a score. And finally, we'll display the result and the score in a pop-up. Now let's convert these updated steps or this algorithm into code. The first thing we need to change is we added a third step. We're going to save and update a score. So first, we need somewhere to save our score. So one place we can save it is inside a variable. Let's go to our script element, and at the top, we're going to create a variable for our score using const score and make it equal to an object. And inside this object, we're going to have the property wins. So this will keep track of how many wins that we have. We'll type colon and the number 0 because the score starts at 0, and then a comma, and then another property, losses. This will be how many losses we have, and then colon and 0, and then another comma, and ties, colon and 0. So we use an object here because these values are related to each other. You could use separate variables, but we're using an object for convenience. Another thing you'll notice is that we're creating this variable outside of a function and outside of a scope. And that's because every time we make a move, we need to update the score from last time. So in order to save the score from last time, we need to keep it outside the function. If the score was inside the function would create a new score every time, which is not what we want. So in this situation, in order to save a score from last time, we're going to keep this variable outside. Now, every time we play the game, after we calculate the result, we're going to update the score. So let's scroll down to where we calculate the result, which is here. And then below it, we're going to type some new lines and type the code for updating the score. So we can do that with an if statement. So we'll type if, brackets, and curly brackets. And inside the condition, we're going to check if the result is a win. If it is a win, we're going to update the wins property and increase it by 1. So down here, if the result is equal to the string you win, and make sure that this string matches the string up here. Inside the curly brackets, we're going to update score.wins, and we'll make it equal to itself plus 1. So this is how we increase the wins property in the score object by 1. Now remember from the variables lesson that we have a shortcut for increasing something by 1. And that shortcut is plus equals 1. Next, let's add another branch to this if statement for the other two results. So else if, brackets and curly brackets, and in the second condition, we're going to check if result is equal to the string you lose. And make sure this string matches the string up here. So if the result is you lose, we're going to update score.losses property and increase it by 1. So plus equals 1. And finally, we'll check if the result is a tie. Else if, brackets and curly brackets, result equals to the string tie. And here we'll update score.ties plus equals 1. So we converted this step in the algorithm to code. The score starts at 0, and every time we play the game, after we calculate the result, we're going to update the score using this code. Now let's convert the last step into code. We're going to display the result and the score in the pop-up at the end. So let's actually go back to the SuperSimple.dev project, and we'll see what the pop-up looks like. We'll click one of these buttons, and in this pop-up, on the second line, we display the score. So in our code, this is the code that displays that pop-up. So how do we add a second line to the pop-up? Remember that template strings have another special feature called multi-line strings. So we can type at the end of this template string and press enter to add another line to this string. So here we can type wins, colon, and we're going to insert a value using $, open curly bracket, close curly bracket. And here we're going to insert the number of wins that we have, which is score.wins. So we'll type score.wins. Next, we're going to show the number of losses that we have. So after this, let's type a comma and losses, colon, and insert another value. Here we'll insert score.losses. losses. And finally, we'll type a comma and we'll display ties, colon, and insert a value, score.ties. And this will display our score in the pop-up. So let's save this and give it a try. We'll click OK, and then go back to our tab and play the game. So now on the second line, we will display the score. One small issue here is that we have a lot of spaces on the second line. So these spaces correspond to the spaces here. When we use multi-line strings, these extra spaces will show up in the pop-up. So to remove these spaces, we can just remove them in the code, like this. Now if we save, press OK, and play the game, it will show our score on the second line without those extra spaces at the front. Let's press OK. We're going to add one more feature to this project. If we go back to SuperSimpleDev, we have a reset score button, which will reset the score back to 0 when we click it. Let's add this button in our project. So we'll scroll up, and inside the HTML, we'll add a button with the code less than button greater than. And inside the button, we'll have the text reset score. And now when we click this button, we'll run some code using the onClick attribute equals double quotes. And then in here, we're going to write some code to reset this score back to 0. So one way we can do it is, because this score is an object, we can use dot notation to change everything back to 0. So we can type score.wins and make it equal to 0. We'll also type score.losses and make it equal to 0. And finally, score.ties and make it equal to 0. Now let's save and go back to our tab and play the game a few times to get a score. Let's press OK and press reset score, and then play the game again. And you'll notice that the score started from 0 again. So that's how we create the reset score button. We just set all of these properties back to 0. And that's it. That's how we add a score feature to our rock, paper, scissors project, using an object to save the score. Let's press OK. And we're going to learn more details about objects. Let's go back to objects.html. And we'll open the tab for this file. And let's also comment out the previous code using /* and at the bottom, // and save. Now let's scroll to the bottom and we'll do some setup. So first, let's create a variable with const. We'll name it product2 and make it equal to another object. Inside this object, we'll have the property name, colon, and the string shirt. And we're going to console.log this object. So console.log product2 and save. So the next detail we're going to learn about objects is another way to access the values inside. We previously learned the dot notation to do this. For example, console.log product2.name. This will access the value associated with the name property. In JavaScript, we have another way of accessing values inside objects, which is using square brackets. So we'll create a new line and type console.log product2, and this time we'll type square brackets. And then inside the square brackets, we'll have a string with name. So this is called bracket notation. And this does the same thing as dot notation up here. It gets the value associated with the name property. If we save, these two lines of code both access the string shirt, which we see here. So when do we use the bracket notation instead of the dot notation? Bracket notation lets us use properties that normally don't work with dot notation. For example, at the bottom, we can type console.log product2 and then use a dot and try to access a property called delivery-time. If we save, this property will give us an error. And that's because JavaScript thinks that this dash is a minus sign and it's trying to do math. So in order to use a property like this, we have to use bracket notation. So we're going to replace the dot with square brackets and turn this into a string. Now, if we save, it no longer gives us an error. And because delivery time does not exist in the object, we get the value undefined. So using bracket notation, we can also add values to the object when we create it. So here, we can add a comma, and we'll add another property using bracket notation and a string delivery-time and a colon, and then a value like the string 1 day. If we save, this lets us add a delivery-time property to this object. So as you can see, bracket notation lets us use properties that normally don't work with dot notation. Another feature of bracket notation is that between the brackets, we don't just have to use a string. We can use a variable, a calculation, or anything that results in a value. So you might be wondering, which one should we use, dot notation or bracket notation? We usually use dot notation by default because it's shorter and easier to read. But if we need to use properties that don't work with dot notation, then we use bracket notation. Now a shortcut here is when we create the object, if we only have a string between the brackets are actually optional. So we can just type this. If we save, the code will still work. Okay, the next detail we're going to learn is that inside an object, we can save any type of value. So this includes numbers, strings, booleans, as well as other objects. Because remember, objects themselves are also values. For example, we can type a comma and add a property called rating, colon, and then an object, open curly bracket, close curly bracket. And inside this inner object, we can add more properties like stars, colon, 4.5. This is how many stars a product has, and then a comma, and a property called count, colon, 87. This is how many ratings a product has. So this is called a nested object, or an object inside an object. We can use nested objects to make our values more organized. So inside the product, the number of stars that it has and the number of ratings that it has are both related to a rating. So it makes sense to group them together further inside the product. Now to access values inside the inner object, we just use the dot notation or bracket notation multiple times. For example, at the bottom, we can type console.log product2 dot rating. This will get the value associated with rating, and this is an object. So we can use the dot notation again, count. So this will get the count inside the rating object, which is this value right here. So if we save, it will display 87. And finally, another type of value we can put in an object is a function. So in this object, let's type comma and another property, fun, colon, and we're going to create a function here. So let's type function, and we'll name the function function1 brackets and curly brackets. And then inside the function, we're going to have some JavaScript code like usual. So console.log, the string function inside object. This saves a function inside the object. And this works because a function is actually just another type of value in JavaScript. But we'll learn more about this feature of functions later in this course. For now, just know that functions are also values, and we can save them in an object. To access this function, we can use the dot or bracket notation as usual. So at the bottom, we can type the object product2, and then a dot, and then the property fun. So this will access the value associated with the fun property, which is a function. And because this is a function, we can call it as usual using brackets. If we save, this will run the function here, and it will display function inside object into the console. So when we save functions inside an object, this is called a method, and we've actually been using methods this whole time. Console.log is actually a method. Console is an object provided by JavaScript, and log is a function that is saved inside the console object. If we go to the bottom and type console.log type of console and save, this will confirm that console is just an object. And if we change this to console.log and save, this will show us that console.log is a function. So log is a function that is saved inside the console object. So we call this a method. Another example of a method is math.random, which we used in the rock, paper, scissors project. Math is also an object provided by JavaScript, and random is a function saved inside the math object. So we call math.random a method as well. So we've actually been using objects and methods all throughout this course, and now we understand all the code that we've been using so far. Next, we're going to learn about built-in objects. So the console object and the math object are known as built-in objects because they are built into the language. They are provided by the language. We're going to learn two more built-in objects called JSON and local storage. And we will use these objects to improve our rock, paper, scissors project. Let's start with the JSON built-in object. This object helps us work with something called JSON. JSON stands for JavaScript Object Notation. The easiest way to understand JSON is it's basically a syntax. It's a similar syntax to a JavaScript object, but it has less features. For example, the code on the left uses JavaScript object syntax, and the code on the right uses JSON syntax. So one difference is that all properties and strings must use double quotes in JSON. JSON does not support single quotes. Another difference is that JSON does not support functions. So as you can see, JSON is basically a syntax that's similar to a JavaScript object syntax, but with less features. So why would we use JSON syntax instead of a JavaScript object syntax? A JavaScript object only makes sense in JavaScript. On the other hand, JSON syntax can be understood by almost every programming language, so JSON syntax is more universal. For this reason, we use JSON when we send data between two computers that might use different programming languages. We'll learn how to do this later in the course. We also use JSON when we store data. We'll learn how to store data in this lesson. Now that we understand what JSON is, let's learn about the built-in JSON object. The JSON object helps us convert a JavaScript object to JSON. For example, let's convert our object product2 to JSON. So we'll create some new lines and we'll type the JSON object dot stringify and open bracket, close bracket. So stringify is a method of the JSON object. So it's a function that is saved inside this object. And we can call this function using brackets. Between the brackets, we can give it a JavaScript object we want to convert, like product2. This will convert the object into JSON. So now let's console.log the result and save. And in the console, it will display the product using JSON syntax. If we scroll up, you'll notice that the function that we saved in the object is not inside the JSON, and that's because JSON does not support functions. So one thing to note about stringify is that it actually results in a string. So at the front, if we type of and save, it will tell us that the result that it gives is actually a string. So if we remove this and save, now this JSON string is ready to be sent to another computer or to be saved in storage. Next, let's learn how to convert the other way, from a JSON back to a JavaScript object. To do that, we'll use another method in the built-in JSON object called json.parse. At the end, we'll type json.parse and brackets. And between the brackets, we can put a JSON string that we want to convert. So we actually have a JSON string up here. So let's just make a copy of this. We'll select it, right-click, copy, and let's create an extra variable to make it more clear. Const JSON string, and make it equal to right-click and paste. And now let's convert this JSON string back into an object by putting it into parse. And finally, we'll console.log this result. So console.log and save. And json.parse will turn the JSON string back into a JavaScript object. So that's the built-in JSON object. It helps us convert back and forth between a JavaScript object and JSON. Now we're going to learn the next built-in object called local storage. Local storage is used to save values more permanently. So far, we've been saving our values in variables. However, variables are temporary. They only exist on the current page. If we refresh the page or close the page, all the variables are deleted. For example, if we go back to our rock, paper, scissors project and open the tab for this project, and we play a few games and play it again, so we have 2 games. If we refresh the page, notice the score starts from 0 again. And that's because when we refresh the page, all of these variables are deleted and the score gets reset back to 0. However, if we press OK and go to SuperSimpleDev and we refresh the page and we play the game, notice that the score doesn't start from 0. It starts from the previous score even though we refreshed the page. And that's because this project saves the score in local storage, and local storage doesn't get deleted when we refresh the page. Now let's learn how to use local storage in our project. Let's press OK, and we'll go back to our code, and we'll scroll down to where we update the score. So here, after we update the score, we're going to save it in local storage. But first, let's learn how local storage works. So at the bottom here, we're going to type the local S storage object. To save a value inside local storage, it has a method called setItem. So we can type .set I item and brackets, because this is a method or a function saved inside the object. And we're going to give 2 strings to this method. The first string is a name. This is how we're going to access the value that we save later. So let's use the string message as the name. And we'll type a comma, and then we'll type the value that we want to save into local storage. So local storage only supports strings. So let's save the string hello inside local storage. If we save and then go back to our tab and play the game, it will run all this code and save the string into local storage. Now let's learn how to get this string out of local storage. We'll press OK, and we'll scroll to the top. And when we first load the page, we're going to get that value out of local storage by typing local S storage dot get item this time, and brackets. So the get item method gets a value out of local storage, and we're going to give it 1 string. So this string is the name that we used earlier, which was message. So we'll type the string message. Now let's console.log this result. So console.log and a bracket at the end, and save. It will get the value that we saved earlier out of local storage. So we saved the string hello, and that's exactly what gets displayed in the console. So using local storage, we were able to get the value that we saved earlier, even though we refreshed the page. Now let's save our score into local storage, so it doesn't get reset when we refresh the page. So let's scroll to the bottom. And instead of using the name message, we're going to use the name score to save our score. And instead of the string hello, we're going to save the score object. Now, one problem here is that local storage only supports strings. So we need to convert our object into a string. And we actually learned how to do this earlier using json.stringify. So at the front, we can type json.stringify and then brackets around the score. And this will convert the JavaScript object score into a JSON string. And then it's ready to be saved in local storage. So if we save this and then play the game, it will run this code and save our score into local storage. Now let's press OK, and then scroll up to the top. And now instead of getting the message, we're going to get the score out of local storage. If we save, now when we load the page, we're able to get the score that we saved from last time as a JSON string. The last step is, instead of resetting the score to 0 every time, we're just going to use the score from local storage. Before we do that, remember that this is just a string, so we need to convert this back to an object. We also learned how to do this earlier using json.parse. So at the front, we can type json.parse and then open bracket, and at the end, a close bracket, and it will convert this back to an object. If we save, it will convert the score from a JSON string back to an object. So now we can use it up here. So instead of doing this, we'll remove it and replace it with this code. So right-click, cut, and then here, right-click and paste. And we'll remove console.log and save. So now when we load the page, it will load the score from local storage. If we play the game, notice that the score doesn't start from 0. It starts from the score that we had last time. Let's review what we did step by step. First, when we update our score in this code, after we update the score, we're going to save it in local storage using localstorage.setItem. Now, local storage only supports strings, so we have to convert our score object into a JSON string using json.stringify. And then after we've saved this into local storage, when we load the page up here, we're going to load the score that we just saved from local storage using localstorage.getItem. And the score was saved as a JSON string, so we need to convert it back into an object using json.parse. So that's how we use the JSON object and the local storage object to save our score more permanently. Let's press OK. And the last feature we're going to add is when we click the Reset Score button, we also need to remove the score from local storage. Otherwise, if we press Reset Score and refresh, and then play the game, it would just grab the old score from local storage. So Reset Score doesn't really work here. Let's press OK and fix this issue. So here in the Reset Score button, at the end, we're going to remove the score from local storage. So we'll type local storage and then a method called .remove item and brackets. And between the brackets, we're going to tell local storage which value we want to remove. So we're going to remove the score. So we'll type the string score. If we save and we click the reset button, and then we refresh the page and try to play the game again, unfortunately, it now gives us an error. So what is happening here? So remember that we removed the score from local storage. So now when we load the page, this actually doesn't exist. When something doesn't exist in local storage, it's going to give us a value called null. And at the bottom, if we try to access any property on null, it will give us an error. So that's what we see here. So how do we solve this problem? If we scroll up, one way to solve this problem is that if there is no score in local storage, we're going to give it a default value. Let's look at how we can do that. So after this line, we're going to check if the score is null. We can do that using an if statement. If, brackets and curly brackets, and we'll check if score is equal to null. And if it is equal to null, we're going to give this a default score. So inside the curly brackets, we'll just make the score equal to the default object we had earlier, which was wins 0, and then losses 0, and ties 0. And remember, if we need to reassign a variable, we have to change it from const to let. If we save, the score will be null because we removed it earlier, and now this will give it a default score. So everything should work as before. If we play the game, you'll notice that the score starts from 0, or this default score, and everything is working again. So that's how we create the score feature in the rock, paper, scissors project, as well as the reset score feature. Next, we're going to use some shortcuts to simplify our code. So these shortcuts are things that we learned in the Booleans lesson. So remember that null is a falsy value. That means it will behave just like false. So a shortcut we can use here is, instead of checking if the score is equal to null, we can also remove this and check if not score. So not score does the same thing as checking if it's null. If the score is null, not score will flip it into true. So both of these will return true. If the score exists, it's an object, then both of these will return false. So instead of checking if a value is equal to null, we can just use the not operator as a shortcut. Now, also from the Booleans lesson, we have an even shorter shortcut for doing this. So notice here that this code basically sets a default value if the score doesn't exist. In the Booleans lesson, we learned a technique called the default operator, which is exactly what we need here. So on this line, we can remove the semicolon and type or, and then a default value. So we want our default value to be this object. So let's select it and then right click, copy, and then here, right click and paste. And I'll select these lines and press Shift Tab to remove an indent. And I'll add a semicolon back at the end. So the way that the default operator works is that if the left side is truthy, so in this case we have a score, it will use the left side. If the left side is falsy, or in this case the score is null, then we will use the right side as a default value. So this does the same thing as this code below, but it's just a shortcut. So now let's comment out this code using /* and at the bottom */. So we'll leave it here just for reference and then save. And if we click reset score again and refresh and play the game, it will still work. So this is a perfect situation to use the default operator to simplify our code. So let's press OK. And that's all we're going to do for this project in this lesson. Now let's move on and learn more details about objects. The first thing we'll learn is the value null. So null is one of the falsy values in JavaScript. It's similar to the value undefined. They both represent that something doesn't have a value. So what's the difference between null and undefined? We use null when we intentionally want something to be empty. For example, in the previous lesson, we learned that if a function has parameters, we can give the parameter a default value. If the parameter is undefined, it will use the default value. However, if we set this parameter to null, it will not use the default value, and it will just use null. So null means we intentionally want something to be empty. In most cases though, null and undefined work the same way. Okay, so the next detail about objects we're going to learn is called auto boxing. Let's go back to objects.html and open the tab for this file. And let's also comment out the previous code so our console doesn't get too messy. So /* and at the bottom, */ and save. So let's scroll down. We learned in this lesson that objects can have properties and methods. So you might be surprised to learn that other values also have properties and methods. For example, at the bottom, we're going to type console.log, the string hello, and then the dot notation, and a property called length. So strings can also have properties. The length property tells us how many characters or letters are in this string. So hello has 5 letters. So if we save, the length property will be 5. Here's another example. We'll type console.log, the string hello, and then the dot notation and a method this time. To capital U upper, capital C case, and brackets. So this string also has a method called toUpperCase. And this method gives us a copy of the string with all letters capitalized or in uppercase. If we save, it will give us hello in capital letters. So as you can see, simple values like strings can also have properties and methods. So now you might be wondering, these are strings, not objects. How can strings have properties and methods? The answer is that JavaScript has a special feature called auto boxing. JavaScript automatically wraps this string in a special object first, and this object has the property length and the method toUpperCase. So this is done automatically. We don't see the special object that's wrapped around this string. So this feature is called auto boxing because JavaScript automatically wraps the string in an object, like a box. So auto boxing also works with other types of values, like numbers and Booleans. The only thing is that auto boxing does not work with null and undefined. It would just give us an error. The last detail we're going to learn about objects is a really important detail, and that is objects are references. To demonstrate, let's create a new variable with an object. So const object1 and make it equal to an object. Inside this object, let's have a property message, colon, and the string hello. So you might think that when we create an object like this, we create a value that has other values inside, and we save the whole thing in a variable. However, this actually works a little differently. When we create this object, the actual value is created somewhere in the computer's memory. And this variable actually just gets a reference that points to that location in the computer's memory. This is like a shortcut on your computer. A shortcut points to where the actual file or folder is. So there's no way to actually see this reference, but just know that this is a reference, and the object is somewhere else in the computer's memory. So the reason it works this way is to make the language more efficient. For example, below this line, we can create a variable, const, and call it object2, and make it equal to object1. So this code doesn't actually make a copy of the object. It just makes a copy of the reference that points to the object. So this makes the language more efficient, because if we had a really big object here, it's not good to copy the entire object over and over again. Instead, JavaScript just copies the reference, which is much faster. This is called copy by reference. Now that we learned that objects are actually references, let's learn some interesting behaviors of references. So at the bottom here, we're going to change the property message in this object. We can do that by typing the object one dot message property and make it equal to something else, like the string good job. And now if we console.log object1 and save, notice that we were able to change the message property even though we created object1 with const. And that's because this variable just contains a reference that points to the object. So const prevents us from changing the reference in the variable, but it doesn't prevent us from reaching into the reference and changing the object that it's pointing to. So just be careful when you're working with objects. Even though we use const, we can still change the values inside the object. Another interesting behavior is that on this line, we're not actually copying the object into this variable. We're copying the reference. So object2 actually has the same reference as object1. They actually point to the same object in the computer's memory. So at the bottom, if we type console.log object2 and save, you'll notice that for object2, the message property was also changed, even though we only changed object1. The last interesting behavior is that we can't compare objects directly. For example, let's go to the bottom and we'll create a new object using const object3, and we'll make it equal to an object. And then inside, we're going to have the same values as object1. So we'll have the property message, and the value is the string good job. So now let's try comparing object3 to object1. So here, we'll type console.log and check if object3 is equal to object1. If we save, it will tell us that these two objects are not equal to each other, even though they have the same values inside. And that's because, remember, objects are references. So object3 also contains a reference. And this code compares the references and not the values inside the object. So because object3 is a different reference than object1, that's why this code results in false. If we did console.log and we check if object2 is equal to object1, object2 has the same reference as object1. It points to the same object in the computer's memory. So if we save, this will tell us that these two variables have the same reference. So just remember that when you're comparing two variables that contain objects, you're actually comparing the references, not the values inside. If we want to compare the values inside, we would do that manually by checking the message property against this message property. So don't worry, object references are a little confusing at first, but the more you work with it, the more you just get used to it. The last thing we're going to learn in this lesson are some shortcuts for objects. So first, let's make a copy of object3. We'll select the code and right-click, copy, and then at the bottom, we'll scroll down and right-click and paste. And let's rename this variable to object4. So now let's say that we want to get the message property out of this object. We can do that by typing object4.message. And now let's also say that we want to save this in a variable, also called message. So at the front, we'll type const message and make it equal to this value. So now, if the variable name and the property name are the same, we actually have a shortcut for this. To use a shortcut, we're going to type const and curly brackets, message, and make it equal to object4. So this shortcut is called destructuring. This will take the message property out of object4 and save it in a variable called message. So this line of code does the same thing as the code above. So let's comment out this line using /, and we'll just keep it for reference. So at the bottom, if we type console.log message and save, it will display good job. So the destructuring shortcut took the property out of the object and saved it in this message variable. Next, we can use this destructuring shortcut for multiple properties. For example, let's add another property to this object using comma, and we'll add a price property, $7.99. And now we can take the price property out of this object by typing after message a comma and price. So this will take the price property out of the object and save it in a variable called price. If we console.log the price and save, it will display $7.99. So that's the destructuring shortcut. It's an easier way to take properties out of an object. The next shortcut we're going to learn is called the shorthand property. So at the bottom, let's create some new lines. And let's say we want to create a new object. So we'll type const, and let's name this object5, and we'll make it equal to an object. And inside this object, let's say we want to create a message property. So we'll type message : and for the value, let's type the variable message. So what this does is that it takes whatever is inside the message variable and substitutes it into this code. So at the bottom, if we console.log object5 and save, this object will have a property called message, and the value is whatever is inside the message variable, which is good job. So now we actually have a shortcut for this code. If the property and the variable name are the same, we can actually just type it out once, like message. So this code does the same thing as message : message, and this shortcut is called the shorthand property. So if we comment out this line using / and save, you can see that this shortcut creates the same object that we had before. The last shortcut we're going to learn is called the shorthand method. So at the end, let's create a new property, comma, and let's name it method, : and we'll save a function in this property. So we'll type function, and let's name it function1, brackets and curly brackets. And inside this function, let's console.log method. And now here at the bottom, let's run this function by typing object5.method. So this will access this function, and we'll run it by typing brackets. If we save, this will run the code in the function and display method in the console. So we actually have a shortcut for writing this. So at the bottom, we can type method again, and just type brackets and curly brackets, console.log string method. So this code does the same thing as the code above. So these brackets will create a function just like here. So this function name is actually not needed. So if we comment out these lines of code and save, it will still display method in the console because this is a shortcut for these lines of code. So this shortcut is called the shorthand method syntax. And that's the end of this lesson. In this lesson, we learned another type of value called objects. Objects group related values together. We added a score to our rock, paper, scissors game. We learned about built-in objects and used the JSON and local storage objects to save our score more permanently. We learned more details about objects like null, autoboxing, and references. And we learned some useful shortcuts like destructuring, shorthand properties, and shorthand methods. Here are some exercises to help you practice working with objects. In this lesson, we're going to learn one of the most important features of JavaScript called the Document Object Model, or the DOM. And we're going to use the DOM to improve our rock, paper, scissors project. So first, we'll create a new file for this lesson. Let's go to our code editor and click this icon to show our files, and then click this icon to create a new file. And we'll name this file 09-dom.html and press enter. Next, let's copy objects.html into dom.html. So we'll click here to open the file and then click inside and then type Control A or Command A to select the code and then right click, copy, and in here, right click and paste. Now let's hide these files and we'll prepare this file for this lesson. So let's scroll to the top and we'll change the title to DOM, and let's delete all the JavaScript code from the previous lesson. Now let's save this file and we'll open it in the browser by right-clicking, Open with Live Server. And let's also open the console on this page. We'll right-click, click Inspect, and then click the console. And now we can close the previous tabs as well as the previous code for now. And for this lesson, we're going to do an extra step in the setup. Inside the body, we're going to create a button. So here, let's type the code less than button greater than. And inside the button, we'll have the text hello. Now let's save, and we should have a button on the page. And now we're ready to learn the Document Object Model, or the DOM. In the previous lesson, we learned about objects, which group multiple values together. We also learned about built-in objects, which are objects that are provided by JavaScript. Some examples of built-in objects are console, math, JSON, and local storage. The DOM is another built-in object called the document object. So let's go to our script element and we're going to type document. So this is a built-in object provided by JavaScript. And we've actually seen this document object before. In the first lesson, one of the first pieces of code that we learned was document.body.inner capital HTML equals the string hello and semicolon. So this code removes everything on the page and replaces it with the text hello. If we save, it will remove the button and just put hello. And now that we learned objects in the previous lesson, we can fully understand this syntax. Document here is a built-in object, and this is the dot notation. This means we're accessing a property of the document object called body. Now body is also an object, so we can use the dot notation again to access a property of the body object called inner HTML. And finally, we use an equal sign to change the inner HTML property to the string hello. But as you can see, there's something very special about the inner HTML property. When we change this property, it also changes the web page. So this document object and the web page are linked together. Let's do another example. We'll go to the end here and press enter, and we'll type the document object again, and we'll use the dot notation again. And this time, let's access the property title. And we'll change the title property using an equal sign, and we'll change it to the string good job. If we save, changing the title property will also change the title at the top of the tabs here. So now this says good job. Again, as you can see, the document object is linked to the web page. So from these examples, it shows us that the document object represents or models the web page. And that's why we call this feature the document object model, or the DOM. Now that we know what the DOM means, let's learn the syntax rules for the DOM. So the DOM is just this built-in document object, and this object works the same way as any other object. It contains properties like body and title that we can access using the dot notation. Now, the special thing about the document object is that it is linked to the web page. That means if we change certain properties in this object, it will also change the web page. Now, in addition to properties, the document object also has methods we can use, and we'll learn about them later in this lesson. Now that we understand the syntax of the document object, let's learn about the properties and methods we can use. First, let's comment out this previous code using /**//, and we'll create some new lines at the top. So the first property we're going to learn is called document.title. So this property will give us the title at the top of the tabs here. So if we console.log this property, console.log, and save, this will give us the text at the top, which is DOM, and that's what gets displayed in the console. If we change the document.title property, it will change the text at the top of the tab. So here, if we type document.title and make it equal to the string changed and save, now the title at the top of the tab will be changed. So as you can see, the title property is linked to the title at the top of the tab. We can use it to get the title, and we can also use it to change the title. Next, we're going to learn another property called document.body. So let's go into our code, and let's type document.body. Now, document.body is a very special property. So this will literally get this body HTML element and put it inside our JavaScript. So let's actually console.log this to see how it works. console.log, open bracket, and then close bracket, and save. And inside the console, it will tell us that document.body is the body HTML element. And if I hover over this, it will tell us that it is exactly the body on our page. If I expand this, you can see that this code is exactly the code that we have here. And this shows us one of the most important features of JavaScript. We can have HTML elements inside JavaScript. The document object, or the DOM, combines JavaScript and HTML together, and it gives JavaScript control of the web page. Okay, so now that we have an HTML element inside our JavaScript, what can we do with it? A really important thing to know is that when an HTML element is inside our JavaScript like this, the HTML element is converted into a JavaScript object. So for example, if we do console.log type of document.body and save, it will tell us that the body HTML element is just an object when it's inside JavaScript. So just like any other object, this has properties and methods we can use. So one useful property of the body element is inner HTML, which we saw earlier. So down here, let's type document.body.inner capital HTML. So the inner HTML property controls all the HTML inside the body. That's why it's called inner HTML. So if we access this property, it will give us all the HTML inside the body. So let's console.log to confirm. Console.log and save. And inner HTML will give us all of this HTML inside the body element. And if we change the inner HTML property, it will change the HTML inside the body element. So let's create a new line, and we'll type document.body.inner capital HTML, and we'll change it to the string changed. So this will replace all of the HTML inside the body with the text changed. If we save, that's exactly what it does. And we can actually confirm this by going into the Elements tab. So this tab is for HTML and CSS. We can find the body element, expand it, and you can see all of the HTML that we had before was replaced with changed. And don't worry about this part. This part is just added by live server after. So this shows that inner HTML gives us control of all the HTML inside the body. We can get this HTML, and we can also change this HTML. Now, another feature of inner HTML is that we can replace this HTML with new HTML code, not just text. So for example, instead of just text, we can replace it with the code less than, button, greater than, and also less than / button, greater than. So this is HTML code for creating a button. And inside the button, let's put the text, good job. And now this code will replace all the HTML inside the body with this new HTML. If we save, it removes all the previous HTML, and this new HTML creates this button. So using this inner HTML property, JavaScript can replace the HTML inside the body to whatever we want. We have full control of the web page. All right, now we're going to learn a method of the document object that we can use. As a reminder, a method is a function that is saved inside an object. So we're going to learn a very important method called document.querySelector. We just learned that document.body lets us get the body element and put it inside our JavaScript. Document.querySelector lets us get any element from the page and put it inside our JavaScript. Let's give it a try. So first, we'll comment out the previous code using /* and //. Let's create some new lines at the top. And let's type document.query S selector and brackets. So document.querySelector lets us get any element from the page and put it inside our JavaScript. Between these brackets, we're going to put a string. This string tells JavaScript which HTML element to get from the page. So if we type button, this will get the first button element from the page and put it inside our JavaScript. So let's console.log this to confirm. Console.log, close bracket, and save. And let's go back to our console. Now it will tell us that document.querySelector got this button element and put it inside our JavaScript, which you can see in the console. And if I hover over this button element, it will tell us that it is exactly the button on the page. So that's what document.querySelector does. It can get any element from the page and put it inside our JavaScript. This string tells it which element to get. If we type button, it will get the first button element from the page. If we type body, this will now get the first body element from the page. So it will do the same thing as document.body. But for now, let's just change this back to button as an example and save. So remember, when an HTML element is inside JavaScript, it's just a JavaScript object. So this button element is also just an object, and it has properties and methods we can use. Every HTML element actually has a property called inner HTML, which lets us control the HTML inside the element. So for this button element, let's type at the end .inner HTML, and this will give us the HTML inside the button. If we save, it will give us hello. And again, if we change the inner HTML property, it will change the HTML inside the button. So let's make a copy of this code. We'll select it and right-click, copy, and down here, right-click and paste. And let's change the inner HTML property using an equal sign and the string changed. So this will only change the HTML inside the button, which is here, to changed. If we save, you can see that the text inside the button is now changed. A little syntax shortcut I'm going to show you is that for the dot notation, we can actually put it on multiple lines. So we can type document.querySelector and then put .inner HTML on a separate line to make it easier to read. And make sure to put a tab at the front so that we know it's a continuation of the previous line. Okay, so using document.querySelector, we can get any element from the page, put it inside our JavaScript, and then we can control the HTML inside that element. And this allows us to only change the parts of the page that we need. Next, what if we have two buttons on the page? So let's go up here and we'll create another button using less than button greater than. And we'll have the text second button and save. So now we have two buttons on the page, but document.querySelector will only get the first button on the page. How do we get this second button? The solution is that we're going to add an attribute to this button called the class attribute. So in the opening tag, we're going to type space class equals double quotes. So the class attribute sort of adds a label to this button. So inside the double quotes, we're going to label this button a JS-button. And now that we labeled this button, we can select it using document.querySelector. So at the bottom here, we'll type document.querySelector again, and brackets, and we'll type a string inside. And this time, we're going to start with a dot. When we start with a dot, this means that it's going to look for a class rather than an element name. So we're going to look for the class JS-button. And now document.querySelector will select an element with the class JS-button, which is this element here. So let's confirm this by console.logging this code and save. And now you will see that this code gives us the second button on the page. So using a class attribute and then starting with a dot in querySelector, we can get any specific element from the page and put it in our JavaScript. By the way, when we start with a dot, this is called a class selector. And this is also used in CSS to style elements with a specific class. In fact, anything we use in CSS can also be used in this string. And also, a common practice is to start the class with JS- to make it clear that this class is being used in JavaScript. And again, HTML elements are JavaScript objects. So this second button is also just an object. And remember, objects are values, and we can save them inside a variable. So instead of console.log, let's create a variable using const, and we'll name the variable button capital E element. We usually end the variable name with element or lm to make it clear there's an HTML element inside this variable. And finally, we'll type an equal sign to save this element. And we can remove this extra bracket. And now if we console.log this variable, console.log button element, and save, it will tell us that the second button was saved inside this variable. So using the DOM, we can get HTML elements from the page, put it inside our JavaScript, and then save it in a variable. So the DOM combines JavaScript and HTML together. It gives JavaScript full control of the web page. All right, now that we learned how to use the DOM, let's do some practical examples. So I've actually prepared some projects that we can do for this lesson. To open these projects, we'll go to our browser and create a new tab at the top. And here we'll type SuperSimpleDev/projects/DOM and press enter. On this page, we'll be working on 3 projects: the YouTube subscribe button, the rock, paper, scissors project we've been working on for the last few lessons, and this Amazon shipping calculator. And you'll notice that these projects modify the web page. So we're going to be using the DOM to create these projects. And in the next lesson, we're going to use CSS to style these projects and make them look nice. And you can preview that by clicking here. So using CSS, we can make the subscribe button look like the actual subscribe button on YouTube. And if we click this link to see the rock, paper, scissors game, you'll see that we'll make it look really nice with these icons. But for this lesson, we're only going to focus on the functionality and not the styling. So let's go back to the projects. We'll click back and click back again until we're at projects/DOM. And we're going to create the functionality for these projects first. So before we start, let's create a new file just for these projects. We'll go to our code editor and click this icon, and then click this icon to create a new file. Let's name this file 09-dom-projects.html and press enter. Now let's copy dom.html into this file. So we'll open it and then click in here and type Control A or Command A to select the code, and then right click, copy, and in here, right click and paste. Now let's close our files and we'll prepare this file. So let's scroll up and we'll change the title to DOM projects. And let's remove our HTML, but keep the script element. And we'll also remove the JavaScript from before. Finally, let's save this file and we'll open it in the browser by right-clicking, open with live server. And let's also open the console just in case. Right-click, click inspect, and then click the console. All right, we're ready to start with the projects. Let's go back to SuperSimpleDev, and we'll start by creating the YouTube subscribe button. Let's actually press refresh to get it back to normal, and when we click this button, it will change to subscribed. First, let's create the HTML elements for this project. We'll go to the body, we'll create some new lines, and let's create the paragraph first. We'll type less than p greater than, and inside the paragraph, we'll have the text YouTube subscribe button. And now let's create the button. So on the next line, we'll type less than button greater than, and inside the button, subscribe. Now let's save and go back to our tab. And now we have the HTML elements that we need. So now let's make this interactive with JavaScript. And remember, we have a process for this. First, we'll figure out what steps we need to do. This is called an algorithm. And then we'll convert these steps into code. So the steps that we need here are when we click this button, if the text is subscribe, we'll change it to subscribed. Otherwise, we'll change it back. Now let's convert these steps into code. Let's go to our button element, and we're going to add an onClick attribute. We'll type space onClick equals double quotes, and inside here, we'll write some JavaScript. So first, we need to get the text inside the button. And we learned how to do this earlier. We can use document.querySelector to put this button into our JavaScript and then use inner HTML to get this HTML inside the button. So in our code, let's type document.querySelector, brackets, and a string. And as we learned, we're going to use a class attribute to select this specific button. So in the opening tag, let's add a class attribute, and let's make the class JS-subscribe-button. And then inside document.querySelector, we're going to type a dot to select a class, and we're going to select the class JS-subscribe-button. And now let's console.log this to confirm that we got this button. So at the front, console.log, and save. And now let's click our button, and it will show us that document.querySelector got the button on the page. So now let's save this button in a variable so we can use it later. Instead of console.log, let's type const to create a variable, and we'll name it button element and make it equal to this result. So now that we have the button inside our JavaScript, we're going to check if the text inside the button is subscribe. To check the text, we can use an if statement. So at the bottom here, we're going to type if, brackets, and curly brackets. And inside this condition, let's get the text inside the button. So we'll type button element dot inner capital HTML. And we're going to check if it's equal to subscribe. So we'll type triple equal the string subscribe. Now, if it is equal to subscribe, inside the curly brackets, we're going to change the text in the button to subscribed. So let's type the code button element dot inner capital HTML, and we'll change it with an equal sign to the string subscribed. And the last step is otherwise we'll change it back. So we'll add an else to this if statement. Else and curly brackets, and inside we're going to change the text back to subscribe. So let's type button element dot inner capital HTML and make it equal to the string subscribe, and save. Now, before you try out this project, make sure that the text inside the button has no spaces or new lines around it, and it looks like this. And I'll show you why in a second. Let's go to our project and try it out. So when we click this button, it will change to the text subscribed. If we click it again, it will go back to the original text. So that's how we create the subscribe button project using the DOM. So now let's go back into our code, and I'll show you why if we add new lines and some spaces around this text, there's actually going to be some problems. So if we save this code and then go back to our project and click the button again, you'll notice that it no longer changes the text. And that's because now we have a bunch of spaces around this text, and these spaces will show up in inner HTML. And now inner HTML will not equal exactly subscribe. So how do we solve this problem when there are spaces around our text? To solve this, we're going to use a different property of an HTML element. So instead of the inner HTML property, we're going to use the property inner capital T text. So inner text will give us the text inside this element, but without all the spaces around it. So now this will equal exactly subscribe. If we save and go back to our project and click it again, it'll start working again. So that's the inner text property of an HTML element. It gets us the text without the extra spaces. So before we move on to the second project, I'm going to show you how to make our code cleaner. Right now, we're mixing HTML and JavaScript together. So to make our code cleaner and easier to read, we're going to separate the JavaScript code. And to do that, we're going to put this code in a function instead. So inside the script element, let's create a function using function, and we'll name the function subscribe brackets and curly brackets. And inside these curly brackets, we're going to move all of this code. So let's select this code, and we'll right click, cut, and in here, right click and paste. And if we need to fix the formatting, we can select these lines and press tab a few times. And now that we have this function, we're going to go to the onClick attribute, and we're going to call this function. So we'll type the function name, subscribe, and brackets. So this will run all the code inside the function. So it will do the same thing as before, except now our code is cleaner because we grouped all the JavaScript code at the bottom, and we're no longer mixing as much HTML and JavaScript together. Now let's move on to the second project. We'll go back to SuperSimpleDev, and we're going to work on the rock, paper, scissors project. So let's click this link, and it will show us the next version of this project. So you'll notice a few changes here. The first change is that we're going to show the score on the page instead of in a pop-up. And the second change is that when we click one of these buttons to play the game, it will show us the result and the moves that we picked on the page rather than in a pop-up. Let's create a new file for this rock, paper, scissors game for this lesson. So let's go to our code editor, and we'll click this icon and click this icon to create a new file. And we'll name this 09-rock-paper-scissors.html and press enter. And let's copy the previous rock, paper, scissors, which is here. We'll click here and type Control A or Command A, right click, copy, and here, right click and paste. And let's hide our files. And let's save this file. And we can also close 08 rock, paper, scissors. And finally, we'll open this in the browser by right-clicking, open with live server. Now we're ready to begin the second project. So let's go back to the project at SuperSimpleDev, and we're going to start by putting the score on the page. So to do this, we're going to need somewhere to put the score. So let's create an HTML element for this. We'll scroll up to our HTML, which is here. And after the scissors button, let's add a paragraph element where we're going to put our score. So less than, P, greater than. And let's add a class attribute so we can select this element in our JavaScript. So in the opening tag, we'll type space class equals double quotes JS-score. Now that we have a class, let's get this element in our JavaScript. So let's just do it down here. So we'll type document.query selector brackets and a string, and then we're going to type a dot, and we're going to select the class JS-score. So JS-score. So this will get the paragraph element from above and put it inside our JavaScript. And now let's put the score inside the element. To do that, we can use inner HTML. Dot inner capital HTML, and we'll make it equal to the score. If we scroll down, we actually create the score down here. So we can actually just copy this string. So we'll select it, right click, copy, and let's scroll up to here. And I'll actually put this on a separate line to make it easier to read. And now here, we're going to type a string using backticks. And inside the string, we're going to right click and paste. So this will put the score that we used to have in our pop-up inside this element, so inside this paragraph. If we save and then go back to our tab, you can see that now it displays the score on the page. Now before we move on, I want to point something out with HTML. So remember that our reset score button was beside our other buttons, and now it's below them. So what determines if an element appears beside something or below something? So the paragraph element here is known as a block element. A block element will always take up an entire line by itself. So this line already has some buttons, so the paragraph will take up the entire line under the buttons. That's why this text appears under the buttons and not beside them. And also, because a block element like this paragraph takes up this entire line, the next button has to appear below it. So that's why we get this layout here. So this is just a short review of layouts. If you want to learn this in more detail, you can check out my HTML and CSS full course in the video description. All right, the next feature we're going to do is if we play the game, we also want to update the score. Right now, if we play, it doesn't update it on the page. Let's fix this in our JavaScript. So let's go down to where we update the score. So we'll scroll down, which is right here. We update the score and save it in local storage. And after we do this, we're also going to update the score on the page. So we can actually use the same code that we used above, which is here. So let's make a copy of this code, right click, copy, and down here, right click and paste. And I'll add a tab at the front. If we save and then try out our game, we'll click a move, press OK, and now you'll notice the score also updates on the page. So let's go back into our code and do some cleanup. So you notice that this code is the same as the code we had above. And this is a great situation to use a function to reuse this code. So at the bottom here, let's create a function using function, and we'll call it update score element, brackets and curly brackets, and we'll move this code into the function. So we'll select it, right click, copy, and in here, right click and paste. And now instead of writing this code multiple times, we're just going to call the function update score element and brackets. This will run all the code inside the function, so it does the same thing as before, except we can reuse the code. So let's scroll back up. And instead of typing out all this code again, we can just use our function. Update score element and brackets. Now let's save. It will display the score on the page at the start. And when we click a move, and click OK, it will update the score on the page. So the last feature we're going to do in relation to the score is when we click the Reset Score button, we also want to update the score on the page. Right now, if we click it, it doesn't actually update it. So let's go into our code and let's go to the Reset button, which is here. And after we reset the score, we're going to call that function again. Update score element and brackets. If we save, and now let's play the game and press OK. So we have a score, and if we click Reset Score, it will reset everything back to 0. So now we've finished the score. Let's go back to SuperSimpleDev and play the game. And now we're going to work on this section. We're going to show the result and the moves that we picked on the page. So first, let's create some paragraphs for these as well. We'll go to our HTML, and above the score, let's add a less than p greater than. This is going to be the result. So let's give it a class of JS-result. And let's create another paragraph, less than p greater than. And we'll give this one a class equals JS-moves. Now let's use the DOM to put the result and the moves in these paragraphs. Feel free to pause the video if you want to try it yourself first. So let's scroll down to where we display the result, which is here. So we display it in a pop-up. And instead of a pop-up, we're going to get the paragraph and put this result inside the paragraph. So we'll type document.query selector, brackets, and a string, and we'll type a dot and select the class JS-result, and then dot inner capital HTML, and we'll change this to result. And now let's also display the moves. So we'll type some new lines and document.query selector again, brackets and a string, dot JS-moves, dot inner capital HTML, and make it equal to this text right here. So let's type a template string because we're going to insert our moves inside the string, and we'll type U, and we'll insert the player move, dollar curly brackets, player move, and then a dash, and then the computer's move. So dollar curly brackets again, and computer move, computer at the end. So now that we're displaying everything on the page, we don't need this pop-up at the end. So we can actually delete this pop-up. All right, now let's save and go back to our tab and play our game. Now it will show the result and the moves that we picked on the page instead of in a pop-up. Let's play it again to make sure it works. And finally, when we click Reset Score, it will reset everything back to 0. And that's it. Now we're displaying everything on the web page using the DOM. Now let's move on to the third and final project. We'll go back to SuperSimple.dev, and we'll click back to go back to our projects. And we're going to create this third project here, which is an Amazon shipping calculator. The way this works is that inside this text box, we're going to type the cost of an order in dollars. If the order is under $40, for example, $25 and we click calculate, it will add $10 of shipping and display the total down here. But if we type a cost that is over $40, like 50, and press calculate, it will be free shipping. So it will display the same total down here. So let's learn how to create this using the DOM. Let's go back to our 09 DOM projects file, and we'll start by creating the HTML elements. So under our subscribe button, let's create this paragraph using less than p greater than Amazon shipping calculator. And next, let's create this text box. So the HTML element for a text box is called input. So we'll type less than input greater than. So the input element is special because it doesn't require a closing tag. This is called a void element. And lastly, let's create the button. So here, we'll create less than button greater than calculate. Now let's save and open the tab for this file, which is right here. And we have the text box, and the button that we need. Now, one other thing we're going to add is that in the final project, if we don't have anything in the text box, we're going to have this gray text. So this is called a placeholder. To add a placeholder to a text box, we're going to use the placeholder attribute. So inside our input element, we're going to type space placeholder equals double quotes. And inside the quotes, we'll put the text we want as the placeholder, which is cost of order, and save. Now, if we go back to our project, we now have a placeholder in our text box that disappears when we start typing. So that's all the HTML that we need. Now let's work on the JavaScript. And again, we'll figure out what steps we need to do. So when we click this button, we're going to get the text inside the text box. If the amount is below $40, we'll add $10 of shipping, and then we'll display the total on the page. Let's convert these steps into code. So we'll go to our button and add an onClick attribute. And inside here, let's also create a function to separate our JavaScript code like we did before. So in the script, we're going to create a function, and let's name it calculate total, brackets and curly brackets. And inside onClick, we're just going to call the function. So calculate total, brackets. The next step is to get the text inside the text box. So first, let's get this input element and put it inside our JavaScript. To do that, we can use document.querySelector again. So we'll add a class to this input so we can select it. Class equals js-cost-input. And then inside our JavaScript, we'll use document.querySelector, brackets, and a string, and a dot, and this class, js-cost-input. So this code will get the input element and put it inside our JavaScript. Let's confirm by console.logging the result and save. And now when we click the calculate button, it will give us the input element from the page. Let's save this input element in a variable so we can use it later. Instead of console.log, we'll use const, and we'll name the variable input element and make it equal to this element and remove the extra bracket. And next, we need to get the text inside the input element. So far in this lesson, we've been using the property inner HTML to do this. However, for input elements, you'll notice that there is no HTML inside. So for input elements, we're going to use a different property called value. So at the bottom here, we're going to type input element dot value. This is how we get the text inside a text box. So let's console.log this to confirm that it works. So we'll console.log and save. And now let's type something in the text box like 50 and click calculate. And input.value will give us the text inside the text box. Let's save this text in a variable so we can use it later. Const, and we'll name the variable cost and make it equal to the text in the text box. The next step is to check if this cost is under $40. If it is, we'll add $10. So down here, let's type if brackets and curly brackets. And inside the condition, we'll check if cost is less than 40. And if it is, inside the curly brackets, we'll do cost equals itself plus $10 of shipping. And remember, when we change a variable, we have to switch from const to let. And finally, we're going to display the total cost on the page. So let's create a paragraph where we can display the cost. So down here, we'll create a paragraph less than p greater than. Let's give it a class js-total-cost. And now inside our JavaScript, let's use document.querySelector brackets and string, and we'll type a dot and the class js-total-cost. And we're going to put the cost inside the paragraph. We can use dot inner capital HTML and make it equal. And let's use a template string. So backticks, and we'll have a dollar, and we're going to insert the cost using dollar and curly brackets cost. Now let's save and try out this project. So first, we'll type a cost that is over $40, like 50. If we press calculate, we're not going to add $10 of shipping, and we'll display the same total on the page. Now let's try a number under $40, like 25, and press calculate. And this number doesn't look right. It's saying that we have to pay $2,510. So what's going on here? Let's go into our code, and let's use console.log to figure out what's wrong. So first, let's console.log the cost to make sure that we're getting the right number from the text box. So down here, console.log the cost and save. And then let's type 25 again and press calculate. And it will give us 25. So we're getting the correct text from the text box. Now let's console.log down here to see if the math is working. So we'll type console.log cost and save. And let's try 25 again and calculate. And down here, when we add 10, this is where things go wrong, and it results in 2,510. so it's not doing math properly here. So let's check if cost is a number to make sure that it's doing math. So here, we'll type console.log the type of cost and save. Let's type 25 again and calculate, and aha, it's telling us that the cost is a string. So this is actually not a number, it is a string. That's why it's not doing math. So remember from the strings lesson, when we add a string with a number, JavaScript will automatically convert this number into a string and combine them together. That's why it just combines 25 and 10 here. This is called type coercion. So whenever we get a value from the DOM like this, the value will be a string. So in order to do math, we have to manually convert this string into a number. To do that, JavaScript has a built-in function called number. So before this code, we're going to type capital N number, open bracket, and close bracket. So the number function takes whatever's between the brackets and manually converts it into a number. So now if we save and we type 25 and press calculate, the cost is now a number and it will do the math properly and give us 35. So remember, whenever we get a value from the DOM, the value will be a string. So if we want to do math with it, we have to manually convert this value into a number first. So now let's remove the console.logs that we used to figure out this problem. And save. Okay, we're going to add one more feature to this project. Let's go back to SuperSimpleDev, and inside the text box, we're going to type 25 and press enter. So pressing enter will also calculate the total and display it on the page. So let's learn how to create this feature. So if we go back to our code, so far in this course, we've been using the attribute onClick, which runs some JavaScript when we click an element. HTML has another attribute we can use called onKeyDown, which runs JavaScript when we press a key down on our keyboard. So inside the input this time, let's add the attribute onKeyDown equals double quotes, and then inside here, console.log and the string typing. So now every time we type in the input, it will console.log this message. Let's save it and give it a try. We'll go to the tab for this file, and then inside the text box, we'll type some numbers. And you can see that every time we type something, it will run this code and display this message. So that's how we do something when we type in an element. So clicks and keydowns are known as events. OnClick and onKeyDown are known as event listeners. They check for events and runs JavaScript when those events happen. Now, in addition to clicks and keydowns, there are many other events we can listen for in JavaScript. Okay, so now let's figure out what steps we need to do for this project. When we press a key down in the text box, we're going to check if the key is the enter key. If it is, we'll do the same thing as the calculate button. So how do we know what key we pressed? Inside onKeyDown, we're actually given a special object called event. So instead of this string, let's remove it and we'll console.log event. So this is an object that's provided to us by JavaScript, and it contains information about the event. Every event listener, including onClick, also gets an event object. If we save and type in this text box, it will show us that event is this object. And inside the object, it has a bunch of information, including the key that we typed. So here, let's use the event object, and we'll get .key and save. So now inside this text box, if we type something, it will tell us the key that we pressed. And if we press enter, it will tell us that the key is enter. So the next step is to check if the key is enter. And we can do that using an if statement. So in our code, we'll type a new line, if, brackets, and curly brackets. And inside the condition, we'll check if event.key is equal to the string enter. If it is equal to enter, we're going to do the same thing as the calculate button. So we can actually just use this function again. Inside the curly brackets, we'll type calculate total and brackets and save. So now let's go back to our project and type 25 enter, and it will calculate the total and display it on the page. So that's how we create this keyboard feature of this project. Lastly, let's clean up our code and move this into a function like the rest of our code. So inside the script element, let's create a new function using function, and we'll name it handle cost key down brackets and curly brackets. And let's move this code into the function. We'll select it, right click, cut, and in here, right click and paste. If we need to fix the formatting, we can select these lines and press tab. And let's remove this console.log. And now up here, we're going to call this function handle cost key down and brackets. Now, the last thing we have to do is that event does not exist inside this function. So we have to put the event object into the function. And remember, to put a value into a function, we can use a parameter. So between these brackets, we can create a parameter called event. And now to save something inside this parameter, we're going to go up to these brackets and type event. This will take the event object and put it inside the function, where we can use it just like a variable. So now if we save and try out the project, 25 enter, so this still works. And now we've finished all three projects in this lesson. So in the rest of this lesson, we're going to learn some more details about JavaScript. In the last project, we learned how to manually convert a string into a number using the number function. We can also convert the other way, from a number to a string. So let's go to the top of the script element, and we can type capital S string and brackets. So the built-in string function will convert a value into a string. Between the brackets, we can put a number like 25, and this will convert the number into the string 25. The next detail we're going to learn is a special behavior of strings. So below this line, we can type console.log the string 25 minus 5. So if a string only contains a number and we subtract, multiply, or divide, JavaScript will automatically convert this string into a number. So this gets converted into the number 25 minus 5. And if we save, it will do math and give us 20. So this is another example of type coercion or automatic type conversion. However, it's not recommended to do math with strings like this because adding works differently. For example, on a new line, let's type console.log the string 25 plus 5 and save. This will convert the number into a string and combine them together into 255. So because adding strings works differently, the best practice is always do math using numbers. Don't do math using strings. If we need to, we can manually convert the string into a number using the number function, like we did here. The last thing we're going to learn in this lesson is another built-in object called the window object. So in this lesson, we learned about the document object. The document object represents the web page. The window object represents the browser. So let's go into our script element and try it out. Below this, we'll type window. So this is the window object, and it represents the browser. Because it represents the browser, everything inside the browser is inside the window object. So let's think, what's inside the browser? Well, the web page is inside the browser. So the document object is inside the window object. If we type window.document, this will give us the same document object that we've been using in this lesson. So what else is part of the browser? Well, the console is also part of the browser. So here, if we type window.console, this will give us the same console object we've been using in this course. So we can actually do console.log and the string window and save. And this will do the same thing as console.log. What else is part of the browser? Well, pop-ups are also part of the browser. So if we type window.alert, this will give us the same alert function that we've been using in this course to create pop-ups. However, you might have noticed that we never type window.document or window.console.log. And that's because the window object has a shortcut. We don't have to type window dot at the front. We can just type document or console, and JavaScript will automatically add window dot at the front for us. So window is a built-in object that represents the browser. We don't have to type out window dot ourselves because JavaScript adds it for us automatically, but it's still nice to know how this works behind the scenes. And that's the end of this lesson. In this lesson, we learned about the document object model, or the DOM, which allows JavaScript to fully control the web page. We learned how to use document.querySelector to get elements from the web page and put them inside our JavaScript. We learned how to use inner HTML to modify the HTML inside an element. We worked on 3 projects using the DOM. We learned how to make elements interactive with the keyboard using onKeyDown, and we learned some more details about strings, as well as the window object, which represents the browser. Here are some exercises you can do on your own to practice using the DOM. In this lesson, we're going to add CSS to all of our projects, and we're going to finish our rock, paper, scissors project. CSS is a different language that changes the appearance of our website. It's one of the 3 languages that we use to create websites. So first, let's look at the projects we're going to work on in this lesson. We'll go to our browser and create a new tab at the top. And here, we're going to type supersimple.dev/projects/dom-with-css and press enter. So these are the same 3 projects we created in the previous lesson, except this time we're going to add CSS to make these projects look nice. Let's start by creating a copy of the project's HTML file from the previous lesson. We'll go to our code editor and click this icon to show our files. And then here, we're going to select 09-dom-projects. We're going to right click, copy, and down here, right click and paste. And let's rename this file by right clicking, rename. At the end, we're going to remove copy. And at the beginning, we're going to change it to 10 and press enter. Now let's hide our files. And we're going to open 10 DOM projects in the browser by right-clicking, open with Live Server. Now we can close our previous tabs, as well as the previous code from lesson 9, which is this file and these 2. And now we're ready to add CSS to our projects. We'll start with the YouTube subscribe button. Let's go to the tab for our project, and we're going to style this button first. So we reviewed CSS in lesson 4, and one of the ways we can write CSS code is using the style element. So inside the head section, we're going to create an element using less than, style, greater than. So the style element lets us write CSS code inside. So inside here, we're going to write button, open curly bracket, close curly bracket. So the code in front of the brackets is called the CSS selector. This tells the computer which elements we want to style or change the appearance. So button will style all button elements on the page. But in this situation, we only want to style the subscribe button, because the calculate button will be styled differently. So to style a specific element, we can use the class attribute. So if we look at our button, currently it already has a class of JS subscribe button. But this class is being used by our JavaScript. A good practice is to add a different class that would be used by CSS. So an element can have multiple classes. We just separate them with a space. So inside this class attribute, we're going to type space and add another class, subscribe-button. Now this element has 2 classes, and we're going to use this second class in our CSS. So to style a specific class, we're going to remove button, and we're going to type a dot. So starting with a dot means we're going to style a class rather than an element name. So we'll style the class subscribe-button, which is this button right here. And now inside these curly brackets, we're going to tell the computer how to style this button. For example, border, colon, none, and semicolon. If we save, this will remove the border from the button. So it no longer has a border like this button. So that's how we style a specific element with CSS. We add a class to the element, and then inside CSS, we start with a dot and the class. And between the curly brackets, the code on the left is called the property. This tells the computer what we want to change. On the right is called the value. This tells the computer what we want to change the property to. we separate the property and value with a colon, and we end the whole thing with a semicolon. So this is also called a property value pair. As a reminder, this is just a review of CSS. If you want to learn CSS in more detail, you can check out my HTML and CSS full course in the video description. So we just added one style to this button. We're going to add more styles so that it looks like our final design. To make this easier, I'm going to rearrange my windows, and I'm going to put the final design at the bottom and then our project at the top. This will make it easier to compare the two designs. Next, to make it look like the final design, we're going to style our element one by one. Let's go back to our code and press enter. And next, let's change the background color to black. To do that, we'll type background-color :black and semicolon and save. Now our button has a black background. Let's keep going one by one. We'll change the text color to white next. So in our code, we'll type color: white and semicolon and save. Now, if you're wondering how I know all these properties, you can usually find them by searching in Google. Just make sure you search for what you are trying to do. Let's keep going one by one. The next thing we'll change is we're going to add spacing on the inside of the button. In CSS, space on the inside of an element is called padding. So we'll create a new line, and we'll use the property padding-top: 10px and save. So this will add space on the inside of the element called padding at the top of 10px. So the px here means pixels. A pixel is a unit of measurement in computers. Your screen is made up of many small little squares. Each of these squares is called a pixel. So a pixel is the smallest thing that you can have on your screen. Screen sizes are measured in pixels. Images and video sizes are also measured in pixels. And don't worry, the more you work with pixels, the more you'll get used to how big a pixel is. So in this example, 10 pixels is equal to this amount of space, and it looks pretty close to the final design. So let's keep going. We'll add space on the inside of the element at the bottom this time. So we'll create a new line and type padding-bottom: 10px again and save. And that adds space at the bottom of the element of 10 pixels. Next, let's increase the space on the left and the right. We'll go into our code and add padding-left: 10 pixels and padding-right: 10 pixels. Let's save. And it added some extra space on the left and right, but I think our final design has a little more space on the left and right. So let's go back and increase our padding. So instead of 10, let's try 15 on both sides. So we'll save, and now the spacing looks close enough to the final design. So in CSS, it's normal to do some trial and error to get the styling right. Let's keep styling this one by one. Next, we'll make the text thicker or bold. So let's go into our code, and to change the thickness of the text, we'll use the property font-weight: bold. Let's save, and that will make our text bold. So we're almost there. Now let's make the corners rounded, like in the final design. We'll go back to our CSS, and the property for making the corners round is called border-radius. radius. And we'll make it colon 5 pixels. Let's save. And you can see that it made our corners round. So the pixels here tells the computer how round we want the corners to be. The higher the pixels, the more round it will get. So if we change this to 10 pixels and save, it will make the corners even more round. So let's change this to something really big to make it completely round. We'll change this to 50 pixels and save. And now our button is completely round. The last style we're going to add is in the final design. If we put our mouse over the button, it turns into this hand icon. So we call this a pointer. And we're going to do the same thing in our project. So let's go to our code. And to create that pointer icon, we're going to use the property cursor :pointer. And let's save and put our mouse over the button. And you'll notice it turns into this hand pointer icon. And that's it. Now our subscribe button looks like the final design. Next, let's click the subscribe button. You'll notice that it only changes the text. But if we click the final design, it also changes the background color and the text color. So we're going to learn how to change the CSS when we click a button. Let's go back to our code, and this time we're going to scroll down to our JavaScript, which is here. So we learned in the previous lesson, we can get HTML elements from the page and put them inside our JavaScript. And we also learned that these HTML elements are just JavaScript objects, and they can have properties like inner text and inner HTML. Every element has another property we can use called class list. Class list gives us control of the class attribute. So one solution we can do is when we click the button, we can add a class. And then this class will have different styles. So let's see how we do that in our code. We'll scroll down to the subscribe function. And when we click the button and make the button subscribed, we're also going to add a class. So let's create a new line and we'll type button element dot class capital L list. So class list itself is an object, which means it has properties and methods we can use. One method is called .add, which adds a class to an element. So after this, let's type .add and brackets. And now inside these brackets, we're going to put a string. So this string is a class that we want to add when we click this button. Let's add a class called is-subscribed and save. So now every time we click this button, it will add a class to the button called is-subscribed. Let's give it a try. First, we'll right-click on the page and then click Inspect. And we'll go to the Elements tab. And I'll rearrange my windows so you can see it. And then inside the HTML, pay attention to the class of the button. Now when we click the button, it's going to add an extra class called is-subscribed. So that's what this line of code does. And now that this button has the is-subscribed class, we can style it in our CSS. So let's go back to our code and we'll scroll up to our CSS. And here we'll type dot to style a class, and we'll style the class is-subscribed. Is-subscribed. And curly brackets. And now inside these curly brackets, let's change the background color to gray and the text color to black. Background dash color colon gray, and then color colon black. And make sure to type these styles below the subscribe button styles so that these styles will override the styles above. Now, if we save and then click our button, it will add the isSubscribed class, and now this button will get our new styles that we added here. So that's one way to change the CSS when we click a button. All right, now I'm going to move this back to the top. And notice that our background color is different from the final design. The final design uses a much lighter gray. So how do we get this exact color? To do that, we're going to open the Elements tab again. So on this page, we're going to right-click, click Inspect, and then click the Elements tab. And I'll rearrange my windows so we can see it. So in this section, in the Style section, we can see the CSS that the element has. So first, let's actually find this button, which is right here, and we'll click it. And here, it will show us the CSS that this button has. And it will show us the background color that we should use. So let's make a copy of this color and put it into our code. Right-click, copy, and here, we'll remove it and right-click and paste. Now let's save and go back to our project and try it out. And now we get the exact same color as the final design. So by the way, this color is known as an RGB value. RGB means red, green, and blue. And computers can create any color using a combination of red, green, and blue. So the first number here is how much red we want in our color. The second number is how much green we want. And the third number is how much blue we want. Each number goes from 0 to 255. 0 means less color and darker. 255 means more color and lighter. So this color here uses 240 for all of the colors. So it's close to 255 and will give us a very light gray color that you see here. Next, if we go back to the final design and we click our button again, it will change back to the original style. So we're going to create this feature in our project as well. So one way to do this is when we click the button again, we can remove this class. So let's scroll down to the bottom to the subscribe function. And when we click the button and we change it back to subscribe, we can remove this class. To do that, ClassList has another method we can use called remove. So let's create a new line and we'll type button element dot class capital L list dot remove and brackets. So this does the opposite of dot add. It will remove a class from this element. So inside the brackets, we'll type a string and the class we want to remove, which is is-subscribed, and save. Now let's try out our project. We'll click the button. It will get the class isSubscribed and get the extra styles. And now when we click the button again, it will remove the class and it will remove the extra styles. So notice here that when we add a class, we just type the class name. We don't type a dot and the class name like we did for query selector. Typing a dot only makes sense in query selector. Next, we're going to style the text on the page. Let's scroll up to our CSS. And one thing we can do is to style all the paragraph elements on the page using this code, P and curly brackets. However, we're going to use a better solution. Instead of styling all the paragraphs, we're just going to style the body element. When we change the text in the body element, it will change the text in the entire page. So inside these curly brackets, let's change the text here. So we're going to use a different style of text. This is called a font. To change the font, we're going to use this property, font-family, colon, and we'll change it to Arial, which is what I used in the final design. So let's save, and this will style all the text inside the body and change the font to Arial. And a good practice is to write any styles for the body at the top. So if we need to, we can override it later. So let's move these to the top. We'll right click, cut, and then up here, create some new lines, and right click and paste. And we're going to add one more style before moving on. Let's add some space between the subscribe button and the second project. So earlier, we learned that space on the inside of an element is called padding. Space on the outside of an element is called margin. So inside our subscribe button, at the bottom, let's add a property called margin-bottom, colon, 30 pixels, and save. So this will add space on the outside of the element at the bottom of 30 pixels. Now let's move on and style the Amazon shipping calculator with CSS. Again, we'll add a class to these elements and then style them in our CSS. Let's scroll down to the text box, which is the input element, and we're going to add another class by typing space, and let's use the class cost-input. And now we're going to style this in CSS. So let's scroll up, and here we'll style the class using .cost-input and curly brackets. And inside, we'll style this one by one. Let's look at our final design and see what styles we need. So first, let's change the text size because our text is a little smaller than the text here. So to change the text size, we're going to use font-size, colon, and let's try 15 pixels and save. And now our text looks close enough to the final design. Next, let's add some space inside the text box. So remember, space inside an element is called padding. So we're going to type padding dash top of 10 pixels, padding dash bottom also 10 pixels, and let's add padding to the left 10 pixels and padding dash right of 10 pixels. So this will add a space on the inside of our text box in every direction. If we save, now it looks just like the final design. Now I'm going to show you a shortcut for padding that will save us some typing. So if we create a new line, we can actually use a property called padding and colon, and then type 10 pixels. This padding property lets us add padding on multiple sides at once. If we type one value here, like 10 pixels, it will add 10 pixels to every side. So this line does the same thing as these 4 lines above. So let's actually comment this out using /* and */ and save. And you can see that this one line of CSS did the same thing as the other 4 lines of CSS. So this shortcut can save us some typing. Next, let's move on and style the calculate button. Again, we'll add a class to this button so we can style it. So in this button, let's add a class attribute. Class equals calculate dash button. Now let's style this in our CSS by scrolling up. And here we'll type dot calculate dash button and curly brackets. And inside these curly brackets, we're going to style this button one by one. So let's start with the background color. So we'll type background dash color colon green and semicolon and save. Next, let's change the text color to white. So we'll type color colon white and save again. Okay, let's keep going and we'll remove the border around this button. So we'll type border colon none, save. Next, let's make our text a little bigger, like in the final design. So we'll type font dash size and make it 15 pixels and save. Okay, so now let's add the space on the inside of the button. So we're going to use this shortcut again. We'll type the padding property colon, and this time we're going to give it two values separated by spaces, 10 pixels and maybe 50 pixels. So it's easier to see what this does. So when we give two values to padding, the first value is the vertical padding, so the top and bottom. The second value is the horizontal padding, or left and right. If we save, so you can see that the left and right has a lot of padding, which is 50 pixels. So now let's make this match our final design. So instead of 50 pixels, let's bring it down to 15 pixels and save. Okay, so that looks pretty close. Let's also increase the padding on the top and bottom so that the text box and the button line up with each other, like in the final project. So let's change the vertical padding to maybe 12 pixels and save. The last thing we'll style for this project is when we put our mouse over the button, it turns into the pointer icon. So to create this, we're going to use the property cursor colon pointer and save and give it a try. And that's it. We just finished styling the Amazon shipping calculator. So now let's give this a try. We'll type 25 in the text box and press calculate. And at the bottom, it will add $10 of shipping and show $35. Finally, we're going to style the last project in this lesson, which is the rock, paper, scissors project. And this will finish the project. Let's go back to SuperSimple.dev and we'll scroll down on this page and then click this link to show the final design for rock, paper, scissors. So I'll rearrange my windows so we can see this. And we're going to change the buttons to these nice big icons for each of the moves. And when we click a move, it will show the result in bold and show an icon of the move that we picked and the move that the computer picked. So we're going to make this project look really nice. Now let's get started. I'm going to rearrange my windows back so we have it at the bottom. And let's create a copy of the rock, paper, scissors project for this lesson. We'll go to our code editor and click here to show our files. And we're going to make a copy of 09-rock, paper, scissors. So let's click this file and then right click, copy, and down here, right click and paste. And we'll rename this file by right clicking, rename, and at the end, we'll remove copy, and at the beginning, we'll change it from 9 to 10 and press enter. Now let's click here to hide the files, and we can close the 09 file. And let's open the 10 rock, paper, scissors file in the browser. So we'll right click and then open with live server. And I'll move this tab to the top here so we can see it side by side. So let's start by styling the body. We want to make the background color of the entire page this dark gray color. We'll go into our code and let's create a style element so we can write some CSS. Inside the head, let's type less than style greater than, and then inside here, we're going to style the body. So we'll type body and curly brackets. Now inside here, we're going to change the background color. So background dash color colon, and we're going to get the color that we see here by right clicking, click inspect, and then go to the elements tab, and I'll rearrange it so we can see it. And then here we'll find the body element and click it. And in this style section, we can find the background color that we need. So let's select this and right click, copy, and in here, right click and paste, and a semicolon at the end. Let's save, and I'll move this back to the corner. And now our project has the same background color as the final design. Next, let's make the text color white. So in our CSS, we'll use the color property and colon white and semicolon and save, and that will make our text white. Next, let's change the style or the font of this text. We'll type font dash family colon Arial, which is what the final design uses, and save. All right, now let's style these elements one by one to match the final design. We'll start with this paragraph at the top. So inside the paragraph element, let's add a class so we can style it in CSS. We'll add class equals, let's call this the title, and then in our CSS, we can style this class by starting with a dot and then title and curly brackets. So let's make our title really big, like the final design. We'll change the font dash size colon 30 pixels and save. So that looks close enough. Next, let's make the text bold. In our CSS, we'll use font dash weight colon bold and save. Now let's move on to styling the buttons. So first, we're going to need these images in our project, and I'll show you how to get them. We'll put our mouse over the rock image, and we'll right click, and we'll click Save Image. And now we're going to find the folder that contains all of our code. So for me, it's on the desktop, and it's this folder right here. So I'll double click this folder, and then leave the file name as the default, rock-emoji, and click Save. And now in our code editor, if we click here, we should be able to see the rock image. Let's do the same with the paper and scissors image. So we'll hover over it, right click, Save Image, and in the same folder that contains our code, we're going to save the paper image. And finally, right click, Save Image, and we'll save the scissors image. All right, now that we have these images in our code editor, let's learn how to load them onto the page. So we can do this using an HTML element. So we'll go back to our HTML code and we'll scroll down. And inside the button, we're going to add an image element. So let's type less than img and greater than. So this is the image HTML element. It loads an image onto the page. The image element doesn't require a closing tag. This is called a void element. Now to load an image, we're going to add an attribute to this element called src. So src stands for source. It tells the computer which file or image to load. So let's look in our project. For this button, we're going to load rock-emoji.png. Inside the source attribute, we'll type rock-emoji.png. So what this does is it will look for the file with this name beside the HTML file, and it finds it right here, and it will load it onto the page. If we save, now inside our button, it loaded the rock image. Right now, this image is too big, so let's use CSS to decrease the size of this image. We'll hide the files, and let's give a class attribute to the image element so we can style it. So we'll type class equals, and let's call this a move-icon. And I'm also just going to add some new lines to make the code a little easier to read. So we'll scroll up to the CSS, and we're going to style this class using .move-icon and curly brackets. And let's decrease the height of this image. We can use the property height, colon, and a pixel value, 50 pixels, and save. So this will make the height of this image 50 pixels, and it will also resize the width automatically so that the image keeps its shape. So this size looks pretty close to the final design, so we can move on. Another feature of the source attribute is that we can put our files into folders. So let's open the files by clicking here. And let's say that we want to organize all of our images into a folder. So we're going to create a folder by clicking this icon. And let's name this folder Images. And we're going to drag these images into this folder. And drag this in here and in here. Now, unfortunately, you can see that the image doesn't load anymore. And that's because if we look at our code, source tells the computer to look for this file beside this HTML file. And right now, there is no file called rock-emoji.png because we put it in a folder. So to tell the computer to look inside this folder, we're going to type the folder name at the start, which is images. And then we're going to type a slash to go into the images folder and then look for this file, which is right here. If we save, the computer is now able to find this image and load it onto the web page. So this feature is called file paths. We can tell the computer to look for a folder beside the HTML file, like images, and then use a slash to tell it to go into the folder and look for a file. Now let's use this code to load the other images onto our page. So for the paper image, we're going to go to this button, remove the text, and then create an image element less than img greater than. And we'll give it an attribute source equals, and we'll locate the image. It is in the images folder. So we'll type images and then slash to go into the folder. And we'll load the file paper-emoji.png. paper.emoji. So paper-emoji.png and save. So our image is really big. Let's give it the same class that we gave the rock image. So we'll add a class equals move-icon and save. So these styles get applied to all elements with the class move-icon. So it applies to both of these elements. Now let's do the same thing for the scissors button. We'll remove the text and we'll replace it with an image element. And we'll give it the source attribute, images/scissors-emoji.png. And we'll also give this a class of move-icon to resize the images like up here. Let's save. And now we have all the images that we need. Now let's make these buttons look like the final design. We'll scroll up and let's add a class to these buttons so we can style them with CSS. So we'll add class equals, and let's use move-button. And for this button, we'll add the same class equals move-button, as well as for the third button, class equals move-button. Now let's scroll up to our CSS, and we're going to style this class using .move-button and curly brackets. So first, let's change the background color to match the background color of the page. So we'll use background-color, and we'll use a special value called transparent. And this will make the button see-through. If we save, now these buttons are see-through. Next, let's add this white border to our buttons. So we'll use the border property, and we're going to give it 3 values. The first value is our border width, or how thick the border is. Let's use 1 pixel for now. The second value is the border style, and we'll use solid because it's a solid border. Other values we can use here are dotted or dashed. And the third value is the border color. So we're going to use white. And semicolon at the end and save. And that will add a border. So let's make our border a little thicker like the final design. We'll change this first value, which is the border width, to 3 pixels and save. Okay, so that looks pretty close. Now let's change the size of our buttons. Usually we use the padding to add space on the inside of an element, but in this case, our images have different sizes. So we're going to use width and height to set an exact size. So in our CSS, we'll type width, and let's make it 100 pixels, and height, and also 100 pixels, and save. So it looks like our final design is a little bigger than what we have here. So let's increase the width and the height. So let's try 120 pixels and save. All right, so that looks pretty close. Now let's make these buttons round. And the property for that is called border-radius, and to know how much we need to make it round, we can set it to half of the width or the height. So we'll set it to 60 pixels and save. Okay, so it's coming along really well. And lastly, we're going to add some space between the buttons. So remember that space outside of an element is called margin. So let's add some margin on the right. So we'll type margin dash right colon and maybe 10 pixels and save. And finally, when we put our mouse over the button, it turns into a pointer. So the property for that is cursor colon pointer and save. And now our buttons match the final design. So let's keep moving and style the next part of the project, which is the result and the moves. If you don't see this here, you can just play the game and it'll give us a new result. So to make this easier to style, we're going to go into our code. We're going to find the result, which is here, and we're going to add some fake results like you win. Let's save. And now we have this result and we're going to style it. So let's give this a class of result. And then in our CSS, we're going to style the class dot result and curly brackets. So let's make the text bigger. We're going to use font dash size colon and maybe 25 pixels and save. Okay, that looks pretty good. Let's make the text bold. So we'll use font dash weight colon bold and save. And finally, we're going to add extra spaces between this and the buttons. So we'll add margin dash top and maybe 50 pixels and save. Okay, so I think that looks close enough. Now let's style the moves. And again, we'll scroll down and we're going to add some fake moves in here so it's easier to style. So we'll type U and then an image. So let's use the less than image and the source attribute. And let's just load the rock image and the scissors image for the computer. So to load the rock image, we'll look inside the images folder, slash to go into the folder, and then rock-emoji.png. So rock-emoji.png and greater than. And we'll add another image, less than image source equals images slash the scissors emoji, scissors dash emoji dot png and greater than, and finally the text computer. Let's save, and this will create some results, although the images are really big. So we can use the class move icon to resize them to be the same size as the buttons. So for both of these images, let's add the class move dash icon. And here as well, class equals move dash icon and save. And now our images look good. Next, let's style this score section. So the only thing we need here is to add spaces between these two. So in this score element, let's add a class of score, and we'll scroll up and style this element using dot score brackets, and let's add some margin at the top. So margin dash top colon 50 pixels and save. And let's compare it. And it looks like our final design has a little more spacing than this. So let's change this to 60 pixels and save. And that looks close enough. And finally, we'll style the reset score button. So let's go back to our HTML. We'll add a class to this button. So here, class equals reset dash score dash button. So at the top, we'll type dot reset dash score dash button, curly brackets, and we'll make the background color white. So background dash color colon white. And let's also remove the border from our button using border colon none. Let's save and see how it looks. And then let's increase the size of this text because the final design looks a little bigger. So we'll add font dash size colon 15 pixels and save. Now let's add some extra space on the inside of the button. So that's padding colon, and we'll give it 2 values. The first value is the vertical padding. Let's use 10 pixels. And the second value is the horizontal padding. So let's use 15 pixels and save. And it looks like our final project is a little shorter than our button. So let's change the vertical padding to maybe 8 and save. And the last step is to add the cursor pointer. So here, cursor colon pointer and save. And that's pretty much it. We finished styling our rock, paper, scissors project. So now I'm gonna rearrange my windows so we can see the entire design, and it looks really nice. The last step here is to remove these fake results and use JavaScript to insert these results instead. So let's scroll down and we'll remove this result. And let's actually copy this code because we want our JavaScript to generate this code. So we'll right click and copy. And let's scroll to the bottom to where we insert the moves onto the page, which is here. And instead of this text, we're going to right click and paste the code that we had before. And this time, instead of picking rock every time, we're going to substitute this with the player move. So we'll remove this. And because this is already a template string, we can insert a value directly inside using $ and curly brackets. And we'll insert the player move. Let's also insert the computer's move in here. So we'll remove this and insert a value using $ and curly brackets, and we'll insert computer move. And now that we're inserting this with JavaScript, we can scroll up and remove the fake result, which is here. So we can select it and delete it. Now let's save. And we're not going to have anything in our results. And when we click a move, it will show us the result and also show us the moves that we picked. And that's it. We finished the rock, paper, scissors project. The last thing we're going to learn in this lesson is how to organize our code into different files. So notice that right now, all of our HTML, CSS, and JavaScript is in one HTML file. And this makes the code harder to read because the file is bigger and it mixes 3 different languages. To make our code more organized and easier to read, we're going to separate each language into its own file. So let's scroll down and we'll start by separating our JavaScript into its own file. We'll click here to show our files and then click this icon to create a new file. And we'll name this file 10-rock-paper-scissors.js and press enter. So when we end a file with .js, it tells the computer that this file contains JavaScript code, not just text. Now let's go back to our HTML file And we're going to move all of this code into the JavaScript file. So we'll select this code, and then we'll right-click and copy. And inside the JavaScript file, we'll right-click and paste. Now let's save, and we'll go back to the HTML file, and we can delete all this JavaScript code. And now we're just going to load our JavaScript file onto the web page. To do that, we can use an attribute of the script element called src, or source. So we'll make it equal, and this does the same thing as the image element. It tells the computer which file to load. If we type 10-rock-paper-scissors.js, this will look for a file called 10rockpaperscissors.js beside our HTML file, which is this file here, and it will run all the JavaScript inside this file. So it does the same thing as before, except now our JavaScript code is in its own file. And this makes our code cleaner because each file only contains one language, and each file also contains less code. Now let's go back to the HTML file and save. And you'll notice that our project works the same way as before. We just organized our code better. Another feature of the source attribute is that it also uses file paths. So we can put this JavaScript file in a folder and we'll be able to find it. For example, let's show our files and let's create a new folder by clicking this icon. And let's name this folder scripts. So this folder will contain all of our JS files. So we can drag this file into the folder. And now we can locate it using the source attribute by typing the folder name, which is scripts, and then a slash to go inside this folder and look for this file. And it will find it right here. If we save, everything works as normal. Another feature is we can use multiple script elements. This lets us split our JavaScript into multiple files and then load them all onto the page from top to bottom. Next, we're going to learn how to separate our CSS into its own file. Let's scroll up to our CSS. So we can do the same thing with CSS. So let's click the HTML file and let's create a new folder, and we'll call this folder styles and press enter. So this folder will contain all of our CSS code. Let's click the folder and we'll create a new file by clicking this icon, and let's name this file 10-rock-paper-scissors.css and press enter. So ending the file with .css means this file contains CSS code. And now we can go back to our HTML and move our CSS into its own file. So let's select all this code and then right click, copy, and in here, right click and paste. And save this file. Now let's go back to our HTML and we can remove this code. And we'll learn how to load our CSS file onto our website. So we're not going to use the style element for this. We're going to use a different element called the link element. So we'll type less than, link, greater than. And the link element doesn't require a closing tag. This is another void element. So the link element uses two attributes. The first attribute is called REL. REL means relation. this tells the computer what type of file we're loading. So we're going to set this attribute to style sheet. This means we're loading a CSS file. And then we'll add a second attribute called href. So href tells the computer which file we want to load. So this also supports file paths. So we can type the styles folder. This will look for a folder beside the HTML called styles, which is this one right here. And then we'll type slash to go inside the folder and look for this CSS file, which is 10-rock-paper-scissors.css. So this will load all the CSS inside this file and apply it to our page. So it does the same thing as before, except we separated each language into its own file. If we save, everything still works and all the styles get applied. And just like the script element, we can also use multiple link elements to load multiple CSS files. So that's how we separate our code into separate files using the script element and the link element. It makes our code a lot easier to read because each file contains one language and it contains less code. And that's the end of this lesson. As a final reminder, the CSS we learned in this lesson is just a review. If you want to learn CSS in more detail, you can check out my HTML and CSS full course in the video description. So in this lesson, we reviewed CSS and added CSS to all of our projects. We learned about the class list property, which lets us control the class attribute of an element. We finished our rock, paper, scissors project, and we learned how to organize our JavaScript and CSS code into separate files. Thanks for watching this course so far. If you want to support this channel, you can check out the premium version of my courses just like this one, where you can get a certificate of completion and a better learning platform. If you're interested in extra videos from me, more in-depth videos, and behind-the-scenes content, you can check out these links here. You can also support the channel by liking the video, subscribing, and sharing this video with others. Thanks again, and let's continue with the course. Here are some exercises to help you practice using HTML, CSS, and JavaScript together. In this lesson, we're going to learn two more features of JavaScript called arrays and loops. And we're going to use these features to create this to-do list project. First, let's create a new file for this lesson. We'll go to our code editor and click up here to show our files. And this time, make sure you have one of these HTML files selected so we don't create the new file in one of these folders. So now we're going to click this icon to create a new file, and we're going to name this file 11-arrays-and-loops.html and press enter. Now let's copy the previous lesson into this file. So we'll click on 10 DOM projects and we'll type here and type Control A or Command A to select the code, and then right click, copy, and in here, right click and paste. Now let's hide our files and we'll prepare this file for this lesson. So we can scroll to the top and we'll change the title to arrays and loops, and let's remove all of the CSS. And we'll also remove the HTML, which is right here. And we'll remove all the JavaScript. Now let's save, and we'll open this file in the browser by right-clicking, open with live server. And let's also open the console. So we'll right-click, click inspect, and click the console. And now we can close the previous tabs and the previous code for now, until we just have the lesson 11 file. Now we're ready to learn arrays. An array is another type of value in JavaScript, and it represents a list of other values. So let's do an example and create our first array. We'll go into the script element, and we're going to type open square bracket and closed square bracket. And inside the square brackets, we'll type a value, like the number 10. And then we'll type comma and another value, like the number 20, and then comma again, and a third value, like the number 30. So this is an array, and it represents a list of 3 numbers, 10, 20, and 30. Now, arrays themselves are also values, which means we can save them in a variable. So at the front, we can create a variable using const, and let's name it my array, and we'll make it equal to this array. And we'll add a semicolon at the end. So now we created a list of values, and we saved this list in this variable. Let's create a new line, and we'll console.log my array and save, and it will display the list of values in the console. So that's basically what an array is. It's a list of values. Now to get a specific value in an array, we can use square brackets. So let's create a new line, and we'll type my array and square brackets. Inside these brackets, we'll put a number like 0. This number represents the position in the array. So 0 means the first value. If we console.log this code and save, my array square bracket 0 gives us the first value, which is 10, and that's what's displayed in the console. Now, if we change this to 1, this will get us the second value in the array, which is 20. If we save, it displays 20. So this number represents the position in the array. 0 is the first value, 1 is the second value, 2 is the third value, and so on. We can also change a value in an array, also using square brackets. So let's create a new line, and we'll type my array square brackets, and let's say we want to change the first value. So we'll type 0 for the first value, and we just make it equal to something else, like 99. Now if we console.log my array again and save, you can see that this changed the first value to 99. So that's basically how arrays work. We can access a value inside an array, and we can also change a value inside an array. Now that we understand the basics of arrays, let's learn the syntax rules. To create an array, we start with an open square bracket, and we end with a closed square bracket. Inside, we can put a list of values, and we separate each value with a comma. We can also write an array on multiple lines, like this. We just put the new lines after the comma. Now to get a value inside an array, we can use square brackets and a number, like 1. This number is called the index. It represents the position in the array that we want to get. So the first value is index 0, the second value is index 1, third value is index 2, and so on. Notice that the index starts as 0. This is called a zero-indexed array. Now, inside an array, we can put any type of value. For example, let's create a new line, and we'll create a new array using square brackets, and inside we can put the number 1 and then comma, and we can also put a string like hello and another comma, and we can put a Boolean value like true and another comma, and we can even put an object like curly brackets, name, colon, socks. Now, an array itself is also a value. That means we can save arrays in variables like this, or even save it in an array. For example, in this array, we can add an array inside, like 1, 2. Next, arrays have a weird behavior when we try to check the type of an array. So on a new line, let's type console.log type of, and then square brackets 1, 2, and save. This will tell us that an array is an object. And that's because an array is actually an object, but it's just a special type of object. If we want to check if something is specifically an array, we can use this code. Capital A array dot is array, brackets. And inside the brackets, we'll put an array like square brackets 1, 2. So this will check if this value is an array. If we console.log this result and save, it will display true. And finally, because arrays are just a type of object, they also have properties and methods we can use. So one useful property is called .length. So we'll type console.log my array.length. This will tell us how many values are in the array. So my array has 3 values. So if we save, it will display 3. Next, we'll learn a useful method of an array called .push. This adds a value to the end of the array. If we did my array.push 100, this will add 100 to the end of my array. If we console.log my array and save, you can see that 100 was added at the end. The last method we're going to learn for now is called .splice. This removes a value from an array. For example, my array.splice and brackets, and a splice takes 2 numbers. The first number is the index that we want to remove. So let's say we want to remove the first value, which is index 0. The second number we give to splice is the number of values we want to remove. If we give it 1, it will remove 1 value at index 0. If we give it 2, it will remove 2 values starting at index 0. So for now, let's just remove 1 value. And let's create a new line and console.log my array and save, you can see that splice removed the first value from the array, or index 0, which was 99. All right, now that we understand the basics of arrays and the syntax rules, let's do some practical examples. So I've prepared a project we can do for this lesson. We'll go to our browser, create a new tab at the top, and here we'll type SuperSimpleDev/projects/arrays and press enter. So this page contains the to-do list project we're going to create in this lesson. So down here is the final version of the project. We can type a name for our to-do, like make dinner, give it a due date, and then click add, and it will add it to our list. We can add another to-do, like wash dishes, and then select a due date, and click add again, and it will add another to-do to our list. And each to-do also has a delete button, so we can delete it when we're finished the task. So this is the final version of the project. And these two up here are simpler versions of the project that we're going to use to work our way up. So let's start with the first project up here. We're going to open our console by right-clicking, click Inspect, and click the console. And the way this first project works is we can type a to-do in this text box, like make dinner. And when we click add, it will add the to-do to an array and display it in the console. If we type another to-do, like wash dishes, and click add, it will add it to the array and display it in the console. So let's create this project. We'll start by creating a file for this project. We'll go to our code editor and click up here to show our files, and click this icon to create a file, and we'll name this 11-to-do-list.html and press enter. Now let's copy the code from arraysandloops.html. So we'll click here, Control A or Command A, and then right click, copy, and down here, right click and paste. And let's close this for now. We'll scroll up and change the title to to-do list and remove all the JavaScript code. And this time, instead of writing all the JavaScript in here, let's actually put the JavaScript in a separate file, which we learned in the previous lesson. So we'll open our files again, and this time we'll go to our scripts folder. We'll click this JS file, and we'll click this icon to add a new file to this folder. And let's name it 11-to-do-list.js and press enter. Next, we're going to load this file into our HTML file. So let's open this. And in the script element, we can remove the spaces, and we're going to add an attribute called src equals, and we're going to load the JavaScript file that we just created, which is inside the scripts folder. So we'll type scripts and then a slash to go into this folder, and we'll load the file 11-to-do-list.js and save. So now I'm going to drag this file down here so I can see both the HTML and JavaScript at the same time. Close this for now, and I can close the other code for now as well. And finally, let's open this in our browser. So we'll right click, open with live server. And let's also open the console on this page. Right click, click Inspect, and click the console. Now, one more thing I'm going to do for this video is I'll rearrange my windows so that we can have the final design at the bottom. Let's start by creating the HTML elements. Let's go to the body, and we'll actually create a paragraph element to start. Inside the paragraph, we'll put the text to-do list. Next, let's create the text box. So to create a text box, less than input greater than, and we'll add a placeholder to this text box. Placeholder equals to-do name. Finally, let's add this button. So on a new line, let's type less than button greater than, and inside the button, we'll have the text add. Now let's save, and this creates all the HTML elements that we need. Next, let's write our JavaScript. So first, we're going to create an array to store our to-dos. And then when we click the add button, we're going to get the text from the text box and add it to our array. And finally, we'll console.log the array. Now let's convert these steps into code. Let's create a new array first. Using const, let's name it to-do list, and we'll make it equal to square brackets. So this is an array with no values inside. We also call this an empty array. Next, when we click the button, let's get the value from the text box. So let's go to our button and add an onClick attribute. And then inside here, let's create a function for this. So down here, let's create a function. We'll name it add to-do brackets and curly brackets. And then inside the onClick attribute, we're just going to call this function. Add to-do and brackets. The next step is to get the text in the text box. We can do that using document.querySelector. So to use query selector, we're going to put a class on this input element. So we'll type the class attribute js-name-input, and then in here, document.querySelector, brackets and a string, and we'll type a dot to get a class, and we'll get this class, js-name-input. As a reminder, this gets an element with the class JS-name-input, which is this element, and puts it into our JavaScript. And now let's save this in a variable. So at the start, let's type const input element and make it equal to this result. So now we took this input and put it into our JavaScript. To get the text out, we're going to use a property of the input element called value. So down here, input element dot value. And let's save the value in the text box in a variable so we can use it later. At the front, const name, and we'll make it equal to whatever's in the text box. Before we continue, let's console.log the name to check if this is working. So let's save this JavaScript file, and let's also save this HTML file. We'll go to our browser, and I'll resize it so we can see the console. And now if we type something in the text box, like make dinner, and click add, it will get the text from the text box and then display it in the console. Okay, so it's looking good so far. The next step is to add this name to our to-do list. So we learned how to do this earlier. We can use a method called push. Push will add a value to the end of the array. So let's remove this for now. And at the bottom, we're going to type our array to-do list dot push brackets, and then between the brackets, we're going to add our name here. And now the last step is to console.log the entire array. Console.log to-do list and save. Now let's give it a try. We'll type make dinner in the text box and click add. It will take this text, add it to the array, and then console.log the array. And now we have our to-do list. Let's add another to-do. We'll type wash dishes and click add. Again, it will get the text in the text box and then add it to the array. So now our array has two values, and then we display them in the console. So that's how we create this first version of the to-do list project. Now, one more feature we're going to create is if we add something to our to-do list and click add, it will reset the text box. To do that, let's go into our code and we'll create some new lines. And remember that the value property represents the text in the text box. So to change the text in the text box, we can simply change the value property. So we'll type input element dot value and change it to the empty string. So this will make the text in the text box become empty. If we save and now type something in the text box and click add, it will reset the text in the text box. Let's move on to the second version of the to-do list. So here, when we type something in the text box, like make dinner and click add, it will actually display it on the page. If we type something else, like wash dishes and click add, it will also add it to the page. So how do we take our array and display each value on the page? To do this, we're going to learn another feature of JavaScript called loops. Loops let us run some code over and over, like a loop. So let's go back to our 11 arrays and loops file, and we can close this JavaScript file for now, and we're going to learn loops. So first, let's comment out the previous code by typing /* and at the bottom */. Let's scroll down and we'll create our first loop. We'll start by creating a variable using the word let, and we'll name this variable I, and we'll make it equal to 1. Next, we're going to type the word while, and then brackets and curly brackets. And then inside these curly brackets, we're going to put some code that the computer will run over and over, just like a loop. Let's put the code console.log I. So this will display the variable I in the console over and over again. Now, obviously, we don't want to loop this forever. So how do we get this loop to stop? We can do that using the round brackets up here. Inside these round brackets, we're going to put some code that results in true or false. For example, we can check if I is less than or equal to 5. So the way this works is that if this code results in true, the loop will keep going over and over. Once this results in false, the loop will stop and it will go to the next line. Now you may notice that this code will never result in false because I is equal to 1 and 1 is always less than or equal to 5. So when does this actually become false and stop the loop? The answer is, inside this loop, we're also going to update this variable I. So we'll type I and we'll make it equal to itself plus 1. So now every time we loop over this code, we're going to increase I by 1. And eventually, I will be greater than 5. This will return false, and it will stop the loop. If we save, and then go back to the tab for this file, and I'll rearrange my windows so we can see the console, this loop makes the computer count from 1 to 5. So let's go over this code step by step to make sure we understand how it works. First, we create a variable I and we make it equal to 1. And then we do a loop. So if this condition is true, the computer will keep running this code over and over again. So the first time it loops, I equals 1, and then it displays 1 in the console, and then we increase I to 2. Now we go back to the top and we check this code. 2 is less than or equal to 5. This is true. So we're going to run this code again. This time I equals 2, and we display it in the console, and then we increase I to 3. And now 3 is still less than or equal to 5, so this is true, which means we keep running this code. And eventually, this is going to increase I to 6. Once I is 6, this will become false, which will cause the loop to stop, and then we go to the next line. So that's why it counts from 1 to 5, and then it stops at 5. So this is called a while loop. While this condition is true, it will keep running this code over and over again, just like a loop. As soon as this condition is false, it will stop the loop. All right, now that we understand how a while loop works, let's learn the syntax rules. To create a while loop, we type the word while, and then round brackets and curly brackets. The code inside the round brackets is called the loop condition. The code inside the curly brackets is called the loop body. The variable I at the top is called the loop variable. Every time we loop, we're going to increase the loop variable. This is known as the increment step. The increment step makes sure that the loop ends at some point. Without this increment step, the loop would just keep going forever. This is known as an infinite loop. Now remember that I equals I plus 1 has a shortcut. Instead of this, we can just do I plus equals 1. And remember, we actually have an even shorter shortcut for plus equals 1. Instead of this, we can also do I plus plus. So this will increase the value of I by 1 every time, just like before. So those are the three major parts of a loop: the loop variable, the loop condition, and the increment step. Now, each time we run this loop, this is called an iteration. So in this loop, we did 5 iterations. We ran this code 5 times. And lastly, loops create a scope. Any variable that we create between these curly brackets will only exist inside the curly brackets. So that's a while loop. While this condition is true, it will keep running this code over and over again. Once this condition becomes false, it will stop the loop and go to the next line. So in JavaScript, there's actually 2 types of loops. The first type is a while loop, which we just learned. Now we're going to learn another type of loop called a for loop. To create a for loop, we'll create some new lines, and then down here, we'll type for, and brackets and curly brackets. Inside these brackets, we're going to type 3 pieces of code. The first piece of code is a loop variable, which is the same thing as this line up here. So we'll type let I equals 1, and then semicolon, space, and we'll type a second piece of code, which is the loop condition. So here, we'll type I less than equal to 5, and then semicolon and space. And the last piece of code is the increment step, which is this line right here. So we'll type I++. And between these curly brackets, we'll write the code that we want to loop over and over. So let's just type the code console.log I and save. So this for loop does the same thing as the while loop above. It counts from 1 to 5. And if we look at this code, we can see that a for loop is just a shorter version of this while loop. Instead of writing the loop variable, condition, and increment step separately, we group all of them together at the top. So this loop works the same way. First, we create a loop variable, and then as long as this loop condition is true, we will keep running this code over and over. And every time we run this code, we're also going to increase the loop variable by 1. So now that we learned 2 ways of doing a loop, which one should we use? If we're doing a standard loop, for example, it has a loop variable, a condition, and an increment step every time, it's recommended to use a for loop because a for loop is shorter and more organized than a while loop. However, if it's a non-standard loop, then it might be better to use a while loop. So what's an example of a non-standard loop? So let's say we want to generate random numbers until we get a number that's at least 0.5. To create this loop, we'll create a variable that will store the random number using let random number and make it equal to 0 to start. And then we'll do a while loop, brackets and curly brackets. Now inside the loop condition, we want to keep running this loop until random number is at least 0.5. So we'll check if random number is less than 0.5. Because if it is less than 0.5, we want to keep running this loop until we get a random number that's at least 0.5. And then inside this loop, we're going to generate a random number between 0 and 1, and then save it in the variable up here. So we'll type random number and make it equal to capital M math.random. So if this random number is less than 0.5, it will keep generating random numbers until we get a number that is at least 0.5. So at the bottom, if we console.log random number and save, it will give us a random number that's at least 0.5. So notice that this is a non-standard loop. It doesn't really have a loop variable that we increase every time, and it also doesn't have the increment step. So in this situation, when we have a non-standard loop, it's better to use a while loop because they're a bit more flexible. All right, now that we learned the basics of loops, let's do some practical examples. We're going to learn a technique called looping through an array. This means we're going to go through each value of an array one by one and do something with each value. So first, let's comment out the previous code using /* and */. At the bottom, let's create an array of strings. So we'll create a variable const to-do list equal to an array. And inside this array, we'll have the string make dinner, another string wash dishes, and another string watch YouTube. Now let's take each value in this array and display it in the console. To do that, we're going to run a loop, and this loop is going to count from 0 to the last index in the array. So remember that the index is the position of a value in the array. The first value is index 0, the second value is index 1, third value is index 2, and so on. So below this, let's type for brackets and curly brackets. Inside these brackets, we're going to create the loop variable. So here, we're going to count the indexes. Let index equals 0, semicolon space, and we'll do the loop condition. So we'll keep looping as long as the index is less than or equal to the last index. So remember that the index starts from 0. This means that the last index in an array will be the number of values in the array minus 1, or the array.length minus 1. To-do list dot length minus 1. And here we'll add another semicolon, and we'll add the increment step, which is index plus plus. So we'll increase it by 1 every time. Now inside these curly brackets, we can do something for each index of this array. For now, let's just console.log this index and save. So this will count from 0 to 2, which is exactly all the indexes in this array. And now, using this index, we can also access the value at this index. So instead of just the index, here we can do to-do list and then square brackets, and between the brackets, index. This will take whatever the index variable is and access that index in the array. So if the index variable is 0, this will access to-do list index 0, which is the first value. When the index is 1, it will access to-do list index 1, which is the second value, and so on. So for now, let's save the value in a variable using const value and make it equal to-do list bracket index. And now let's console.log the value instead. If we save, this will loop through each index of the array, get the value at each index, and then display each value, which is what we see in the console. So this technique is called looping through an array. We use a loop to go through each value of an array, and then we can do something with each value. Now, I'm going to show you a few shortcuts we can use when looping through an array. Instead of checking if index is less than or equal to-do list.length minus 1, we can shorten this to index less than to-do list.length. So this check does the same thing as before. The loop will stop at index equals length minus 1, but it saves us some typing. Another shortcut is, instead of naming the loop variable index, we can shorten this to I. And we'll shorten this as well, and this as well. And that's why we often name the loop variable I. I means index. Next, we're going to learn a technique that we can combine with looping through an array, called the accumulator pattern. So first, let's comment out the previous code. using /* and */. And at the bottom, let's say we have an array of numbers like this. How do we calculate the total of all the numbers in the array? Let's set up this problem. Let's say we have an array of numbers, const nums equals array, and then the numbers 1, 1, and 3. And we want to calculate the total of all the numbers in this array. To calculate the total, we'll learn the accumulator pattern. The first step of the accumulator pattern is to create a variable to store the result. So below this, let's create a variable const total, and we'll make it equal to 0. And the next step is to loop through this array and update the result. So down here, for brackets and curly brackets, and inside the round brackets, we'll create the loop variable let I or index equals 0, semicolon space, and we'll create the loop condition I less than nums dot length, and then semicolon, and the increment step I plus plus. So as we learned earlier, this loop will go through each index of this array. And now between these curly brackets, first, let's use the index to get each value. So we'll type nums and then square brackets and access the index I. And let's save this in a variable using const num equals this value. And finally, we're going to add each number to the total. We can type total and make it equal to itself plus each number. And remember, we have a shortcut for this, which is plus equals. And finally, since we're changing this total variable, we have to change from const to let. All right, so after this loop, we should have added each number in the array to the total. So at the bottom, let's console.log the total and save, and it will display 5, which is the exact total of all the numbers in this array. So that's the accumulator pattern. We first create a variable to store the result, and then we loop through the array and update the result. So notice that as we loop through the array, we're adding or accumulating the results into this variable. And that's why this is called the accumulator pattern. And we call this variable the accumulator variable. All right, let's do another example using the accumulator pattern. Let's say we're given this array of numbers again, and we want to create a copy of the array where each number is doubled. So if the array is 1, 1, 3, we're going to create a new array with 2, 2, 6. So at the bottom, we'll create some new lines and use the accumulator pattern. The first step is to create a variable to store the result. Let's type const, and let's name this nums doubled. And we'll make it equal to an array this time. So notice in the previous example, the accumulator variable was a number. In this example, the accumulator variable is an array. So we can use different types of values to accumulate the result. It all depends on the problem we're trying to solve. So now the next step is to loop through this array and update the result. At the bottom, we'll create a for loop, brackets and curly brackets. Inside the round brackets, we'll create the loop variable let I equals 0, and we'll create the loop condition I less than nums dot length, and then the increment step, I plus plus. And now between the curly brackets, we're going to get the number at each index. So const num equals nums square bracket I, and then we're going to update the result. So down here, we're going to add this number doubled to this array. So remember, to add a value to an array, we can use the method push. So we'll type nums doubled dot push brackets, and we're going to add to this array the number num multiplied by 2. And now at the bottom, let's console.log the result, nums doubled, and save. So this second loop will create an array where each number is doubled. So that's how we solve this example. All right, now that we understand how to loop through an array and the accumulator pattern, let's go back and we'll create the second version of our to-do list. So when we add something to the list, it will appear on the page. Let's go to our code editor and we'll open 11todolist.html, and we're also going to open the JavaScript file. So it's this one, and for the video, I'm going to drag it to the bottom of my code editor so that I can see the files side by side. So I'll close this for now, and I'll rearrange my windows a bit. Let's open the tab for this project. So we'll review what we have so far. We can click in this text box and type a to-do like make dinner and click add, and it will add this to-do to this array, which is this array right here. We can type another to-do like wash dishes and click add, and it will add it to the end of the array. So now that we have this array of to-dos, we want to display it on the page. To do that, we're going to loop through this array, and we're going to create some HTML code for each to-do, and then put that code on the web page using the DOM. So first, let's loop through this array. To make this easier, let's make a copy of this array. So right-click, copy, and then here, we'll remove this and right-click and paste. So this will give us some default values to work with. So at the top, let's loop through this array using a for loop. So we'll type for brackets and curly brackets. And then inside the round brackets, we're going to create the loop variable let I or index equal 0, semicolon, and the loop condition I less than to-do list dot length, semicolon, and then the increment step I plus plus. So this will loop through each index of this array. And then inside the curly brackets, let's get the string for each index. So we'll create a variable to save it, const to-do, and we'll make it equal to to-do list, square brackets, and I. And now for each to-do, we're going to create some HTML code. So we'll create a new line and create a variable const HTML and make it equal, and we'll create some HTML code using this to-do, using a template string. And then inside, we'll create a paragraph element. So less than p greater than, and then less than /p greater than. Inside this paragraph, we're going to insert this to-do. So we'll type $ and curly brackets and to-do. All right, so now we're looping through this array, and for each to-do, we created some HTML code. And now we're going to combine all of this HTML code together and put it on the web page. To combine this HTML together, we're going to use the accumulator pattern. So at the top of the loop, we'll create a variable to store the result, let to-do list capital HTML, and we'll make it equal to the empty string at the start. And then as we loop through the array, we're going to add this HTML to the variable up here. So let's create a new line, and we'll do to-do list capital HTML plus equals HTML to combine all of this HTML code together. So now after the loop, let's console.log to-do list HTML to see what we get. If we save, we took this array of strings, generated paragraph elements for each string, and then combined them all together. So now that we have all this HTML, we can put it on the page using the DOM. So first, let's create an element where we can put this HTML. So inside the HTML file, after the button, we're going to create a different type of element called a div element. So we'll type less than div greater than. So the div element represents a container. Its purpose is to contain other elements inside, like paragraphs, buttons, and even other divs. So in this situation, we can't actually use a paragraph element because in HTML, we cannot have a paragraph inside another paragraph. So that's why we have to use a div element here. For now, let's put some text inside this element so we can learn more about it. We'll type text and save. So like the paragraph element, the div element is a block element. That means it will take up an entire line by itself. And that's why it appears below the text box and the button. Now, one difference between a div and a paragraph is that a paragraph adds extra space above and below the paragraph, while a div does not add any extra space above or below. So it doesn't have any default styling. All right, so now that we learned the div, let's put this HTML code inside this div. First, we need to get this element into our JavaScript. And to do that, we'll add a class to this element, class equals js-to-do-list. And then down here, let's scroll down, and we'll put this div element inside our JavaScript. We can do that using document.querySelector, brackets and a string, and we'll type a dot to select a class, and we'll select the class js-to-do-list. So this will get this div element and put it inside our JavaScript. And then every HTML element has a property called .inner capital HTML, which controls the HTML inside this element. And now to put the to-do list HTML into this div element, we're going to make the inner HTML equal to the to-do list HTML. And now let's save this file and also save the HTML file. So this code will take the HTML that we created using the loop and put it into the div element. And that's how we make them show up on the page. So now let's try adding another to-do. We'll type watch YouTube and click add. And unfortunately, this new to-do doesn't show up on the page. And that's because when we click add, it will run this add to-do function. and update the list, but we didn't actually update the HTML on the page. So to update the HTML, we need to run all this code again every time we add a to-do. So let's create a function for this code so we can reuse it. So at the top, we'll create a function, and let's name this render to-do list, brackets and curly brackets. So the word render means to display something on the page. So we'll put all of this code into this function. So we can delete this curly bracket, and then at the end, we'll type a closed curly bracket. And let's reformat this code by selecting these lines, and then press Tab to add an indent. So now let's use this function. At the start, we'll display this to-do list on the page, so we'll call this function by typing render to-do list and brackets. And then let's scroll down. Every time we add a to-do to the list, we're also going to display the list again. So at the bottom, render to-do list and brackets again. So if we save, at the start, it will display the list on the page. And then if we add to the list, like watch YouTube and click add, it will add it to the list and also display it on the page. So that's how we create the second version of the to-do list project. By the way, if we scroll up to the render to-do list function, this technique is called generating the HTML. Instead of writing all the HTML by hand up here, we looped through an array and we generated the HTML using JavaScript. So when creating websites with JavaScript, we usually follow a 3-step process. First, we save the data. In this case, we saved our data as an array. Next, we use the data to generate the HTML, which we did here. And finally, we make the website interactive, which we'll do later in this lesson. This is the main idea of JavaScript, and we follow this overall process when creating websites. The rock, paper, scissors project from the previous lessons was a bit different because all the HTML we needed was already there. We just had to modify it with JavaScript. So this process we're using for the to-do list is one step above what we did for rock, paper, scissors. We need to generate some HTML. And this is the standard process for creating websites. We're going to use this process for the to-do list and later the Amazon project, as well as websites that you build beyond this course. Let's take a break before continuing with the rest of this lesson. Here are some exercises that will help you practice what we learned so far. Now let's create the final version of the to-do list. We'll go back to SuperSimple.dev, and then here we'll scroll down and we'll create this final version. So in this version, we can type a to-do like make dinner, and we can also add a due date. And when we click add, each to-do will now have a name and a due date. And they will also have a delete button that we can click to remove it from the list. So let's build this out one feature at a time. We'll start by creating this delete button. We'll go into our code, and remember, we're generating the HTML for the to-do list. So for each value in the array, we create a paragraph element. So to add a delete button, we just have to add a delete button inside here. So inside the paragraph, we'll create a less than button greater than, and then less than slash button greater than. And then inside this button, we'll put the text delete. Let's save. And in the console, you'll see that the HTML we generated now has a delete button inside the paragraph. And that's what shows up on the page. Next, we're going to reformat this HTML to make it a little easier to read. So we'll create some new lines here and at the end. And let's put the content of the paragraph on its own line, like this. And also put the delete button on its own line. So remember that template strings have a feature called multi-line strings. So this is perfect for writing HTML code. The last step in the process is to make the website interactive. So next, let's make our delete button do something when we click it. To do that, we use the onClick attribute as usual. So inside this button, we're going to add an onClick attribute equals double quotes. And then inside these double quotes, we can run some JavaScript when we click this button. So this works the exact same way as what we've been doing so far in this course. The only difference now is that here we're generating this HTML using JavaScript. Okay, so when we click one of these delete buttons, we want to remove this to-do from the list. Earlier in this lesson, we learned how to remove a value from an array using a method called splice. So inside this onClick attribute, we're going to type the to-do list dot splice and brackets. So splice takes two numbers. The first number is the index that we want to remove. So if we click this delete button, how do we know which index to remove? Well, if we look at our loop up here, we already have the index. It's this variable I. So we're going to insert I into this string. And we can do that by typing dollar, curly brackets, and I. Now splice also takes another number. So we'll type comma, and the second number is how many values we want to remove. So here, we just want to remove one value at this index. And finally, because we updated the to-do list, we need to display the list again on the page. To display the list, we can use this function, render to-do list. So down here, we're going to type render to-do list and brackets. Now, if we save, you can see that in the generated HTML, when we click the first delete button, it will remove the value at index 0, which is the first value. If we click the second button, it will remove the value at index 1, which is the second value. So we're basically generating all this HTML using a loop. So now if we click this delete button, it will remove it from the list and then display the updated list on the page. So that's how we create the delete button. Next, let's go back to SuperSimple.dev, and we're going to create the due date feature. So first, let's create this date selector in our HTML. We'll go to our HTML file, and then under the text box, we're going to add another input element. So less than, input, greater than. And to make it a date selector, input elements have an attribute called type. So this attribute determines what kind of input it is. If the type is text, which is the default value, it's going to be a text box. Now, if we change the type to date and save, it's going to create a date selector. Now let's go back into our JavaScript code. And first, we're going to scroll up. And remember that right now, our to-do list is just an array of strings. But this time, each to-do is also going to have a due date. So how do we group the name and the due date together? We can do that using an object. So here, instead of just a string, we're going to create an object. And we'll give it a name property, which is make dinner, and we'll give it a due date property. And we'll make the due date a string. So you can type whatever date you have on the page. For me, it's 2022-12-22. And I'll end this object with a curly bracket, and I'll turn this second to-do into an object as well. So open curly bracket, name, and due date. 2022-12-22, and closed curly bracket. Now that each to-do is an object, we need to update the rest of our code. Let's scroll down, and we'll start with the render function. So here, inside the loop, each to-do is no longer just a string, it's an object. So let's change this variable name to to-do object to make it more clear. And now we need to get the name and due date out of this object. So we'll type const name equals to-do object dot name and const due date equals to-do object dot due date. And now instead of inserting to-do, which no longer exists, we're going to insert the name. And we're also going to insert the due date. If we save, now each to-do will also display a due date. Before we continue, we're going to review a shortcut we can use with objects called destructuring. So here, you'll notice the variable name is the same as the property name. We actually have a shortcut for this using const curly brackets name equals to-do object. So this is called destructuring. This takes the name property out of the object and puts it in a variable also called name. And this is a shortcut for this line up here. So we can comment out this line. We can also use multiple properties in this shortcut. To also take the due date out of the object, we can just add a comma and due date. So this will do the same thing as this line of code, and we can comment this out. If we save, everything still works. Next, let's scroll down, and we're going to update our add to do function. So this time, when we click the add button, we're going to get the name and the due date and put it into our list. So let's get the due date out of this date selector first. We can do that using the DOM like we did here. So let's add a class attribute so we can get it using query selector js-due-date-input. And then down here, let's create a variable const date input element and make it equal to document.query selector and a string dot, and then the class we want to select, which is this class, js-due-date-input. So this will get the date selector element and put it into our JavaScript. And now below this, let's get the due date out of the element. We can do that using the value property again. So let's create a variable first, const due date, and we'll make it equal to the date input element dot value. So this will get the date that we selected and save it in this variable. And now when we add a to-do to our list, instead of just a name, we're going to add an object. So open curly bracket, we'll add a name property, and the value will be the name variable up here. So name, and then comma, and a due date property. And the value will be this due date variable up here. So due date, and then a closed curly bracket. And remember that objects also have a shortcut for this. If the property and the variable name are the same, we can just type it out once, like this. This will do the same thing as this line above. Same thing with the second line. If the property and the variable name are the same, we can just type a comma and type it out once. This is called the shorthand property syntax. So these two lines do the same thing as these lines above. So we can comment this out using double slash and double slash. So that's all the code that we needed to update. Now let's save our JavaScript file, and we'll also save our HTML file. And let's go to our project. We'll add a new to-do like watch YouTube and select a date and click add and scroll down. You can see that it added our new to-do with a name, due date, and a delete button. If we click this delete button, it will remove that to-do. If we click this one, it will also remove the correct to-do. And that's actually all the functionality that we need for this project. So let's go into our code, and we're going to clean up by removing the console.log here and the console.log up here. And save. Finally, let's add CSS to our project to make it look like the final design. We'll go into our code editor and scroll to the top. And instead of writing all the CSS in here, let's put the CSS in a separate file, just like our JavaScript. So we'll click here to show our files, and then find the styles folder. And we'll click the styles folder and click this icon to create a new file inside. And we'll name this file 11-to-do-list.css and press enter. And for the video, I'm going to take this CSS file and put it at the bottom of my code editor so I can see these files side by side. And now I'll click here to close it, and we'll load this CSS into our HTML. To do that, we can use a link element. So inside the head section, let's type less than link greater than, and we're going to give it two attributes. Rel equals style sheet, and href equals the file that we want to load. So we created this in the styles folder. So we'll type styles and then a slash to go into the folder, and we'll load this file 11-to-do-list.css and save. Now let's style our project one by one until it matches the final design. We'll start with the text on the page. We're going to change the font. So in here, let's type body, curly brackets, and then we'll change the font dash family colon Arial and save. So that looks pretty good. Now let's work on styling the to-do list. First, let's add some more to-dos to the list. So we'll type watch YouTube, and then we'll select a date and click add. And we're going to learn how to style our list to look like this. So notice that this list creates a sort of grid. We're going to create this grid using a feature called CSS Grid. So let's go into our HTML first. We're going to add a class to this div element so we can style it. To-do-grid. And let's save. And inside our CSS, we're going to style this class using dot to-do-grid and curly brackets. And to turn this into a grid, we're going to use the property display and grid. And we're going to add another property called grid-template-columns. So this basically sets how many columns are in our grid. The number of values that we give it is the number of columns. For example, if we give it 200 pixels, 150 pixels, and 100 pixels, this will create 3 columns in the grid. The first column will be 200 pixels, the second column will be 150 pixels, and the third column will be 100 pixels. And now each element inside this div will go into the columns. So the first element will go in the first column, second element will go in the second column, and the third element will go in the third column. If we have more than 3 elements, it will wrap around and create a new row. So let's save. And unfortunately, that didn't quite work. And that's because if we go back to our JavaScript, remember that each to-do is one paragraph element. So this entire to-do with the name, due date, and delete button will go inside the first column, and then the next entire to-do will go inside the second column. But what we actually want is for the name to go in column 1, due date column 2, and delete button column 3. To do this, we're going to separate this element into 3 elements so that each element will go into each column. So instead of one paragraph, let's actually use a div element. So less than, div, greater than, and less than / div greater than. And in between, we'll insert the name. So the reason we used a div element is because div elements don't have any default styling, so it's a little easier to style with CSS. For the due date, let's also create a div element. So less than div, and then at the end, less than / div greater than. And finally, for the delete button, we already have an element. So let's just reformat these lines. We'll select these lines and then press Shift-Tab to remove the indent. Let's remove the extra line, and we basically separated each to-do into 3 elements. If we save, now the grid is working because this element goes into the first column, this element goes into the second column, and the button goes into the third column. And that's how we lay out these elements in a grid, like the final design. Next, let's also lay out the inputs and the add button in a grid. We'll go to our HTML, and let's put these 3 elements in a div so we can use grid. So we'll create a less than div greater than, and then inside, let's remove this, and we'll add it at the end, less than / div, and let's reformat these lines by selecting them and then press Tab to add an indent. And now let's make this div a grid as well. Let's go back to our CSS and we'll add a class to this div. Class equals, let's call it to-do-input-grid. And instead of writing all the CSS again, we can use a feature of CSS. So here, we're going to type a comma and enter. So when we type a comma, we can style multiple classes at the same time. So we're also going to style dot to do dash input dash grid. If we save the CSS file, and let's also save the HTML file, now the input and the add button are also laid out in the same grid. Next, let's adjust the spacing inside our grid. So grid has some properties for this. We'll go to our CSS, press enter, and we'll use the property column dash gap. So this sets the spacing between the columns of the grid. So let's make this colon 10 pixels and save. So now it will add 10 pixels between each column. Let's add some spacing between the rows as well. And grid has another property for this. Row dash gap colon 10 pixels and save. So that will add 10 pixels of space between the rows. Now notice it didn't add space between these two rows. And that's because these two are separate grids. This is the to-do list, and this is the to-do input grid. So to add space between them, we're just going to use margin. At the bottom, we'll style dot to-do dash input dash grid, and we'll just add some margin under this grid. So margin dash bottom colon 10 pixels and save. All right, now let's move on to styling the inputs and the buttons. We'll start with the inputs first. Let's add a class so we can style them. Here, let's add a class name dash input. And down here, let's also add another class do dash date dash input. Let's save. And now inside our CSS, we'll style both of these inputs. So we'll style dot name dash input curly brackets. And first, let's make the text bigger, like the final design. We'll set the font dash size colon 15 pixels and save. Okay, so that looks pretty good. Now let's add spacing on the inside of this input. So we'll add padding 6 pixels and save. And that looks pretty good. Let's move on to the due date input. So we actually want the same styles as the name input. So again, we can use that feature of CSS. We'll type a comma and then dot due dash date dash input. So now these styles will be applied to this class and to this class. Let's save. And that looks pretty good to me. Let's move on and style the buttons. We'll go into our HTML and find the add button. Let's add a class so we can style it. And we'll use add dash to do dash button. Let's save. And then inside our CSS, we'll style that class using dot add dash to do dash button curly brackets. And let's start with the background color. We'll set the background dash color colon green and save. Now let's do the text color. Color colon white and save. Now let's remove the border around our button using border colon none, save. And let's make the text a little bigger. So we'll do font dash size colon 15 pixels and save. And the last thing we'll add is when we put our mouse over the button, it turns into this pointer icon. We can do that using cursor, pointer, and save. Next, let's style the delete buttons. So these delete buttons are created in our JavaScript. We'll go into our JavaScript file, and then here, let's add a class to each of the delete buttons so we can style them. So we'll add class equals double quotes, and then delete dash to do dash button. Let's save. And then inside our CSS, at the bottom, we'll style dot delete dash to do dash button, curly brackets. And let's start with the background color. So we'll set background dash color, and for this design, I use the color dark red, and save. So that will style our delete buttons. Now let's change the text color to white. So we'll use color, white, and save. Now let's remove the border using border, none, save. And let's also make the text bigger using font dash size, 15 pixels. Save. Let's add this pointer icon using cursor, pointer. Save. And let's add some padding at the top and bottom of the button. So we'll add padding dash top, 10 pixels, and padding dash bottom, 10 pixels, and save. So that's all the styles we need for the delete button. And we can also close the console to see the entire list. However, now we have another problem, which is this text and this button are not vertically aligned in the center. To vertically align in the center, we're going to go back to the grid styles. So we'll scroll up to the to-do grid, and CSS Grid has another property for vertical alignment, and that is align dash items, center, to vertically align in the center. If we save, now the text is aligned with the button. But now we have a new problem. Our add button is no longer stretching to be the same as the inputs. So by default, align items is stretch. That's why this button stretches to match the inputs. And now that we changed it to align center, it's no longer going to stretch. So to solve this problem, we just have to make this grid stretch. So down here in the to-do input grid styles, we'll change align dash items back to stretch and save. And that will cause this grid at the top to stretch vertically again. And that's it. That's all the styling that we need. And now we finished this to-do list project. In the rest of this lesson, we're going to learn more details about arrays and loops. So I'm going to put this back in the same window, and I'll rearrange this window. And now let's go back to 11 arrays and loops.html, and we'll open the tab for that file. And we can also close these other files for now. And first, let's comment out the previous code using /* and at the bottom, */. And we'll scroll down and save. The first detail we're going to learn is that arrays are references. So in the object lesson, we learned that objects are references. Arrays work the same way. So for example, if we create an array const array1 equals the array 1, 2, 3, this variable doesn't actually contain the values 1, 2, 3. This array is saved somewhere in the computer's memory, and this variable only contains a reference that points to where this array is in memory. And that means if we create a copy of this variable, const array2 equals array1, array2 doesn't contain a copy of the values. It actually just contains a copy of the reference. So now both of these variables are pointing to the same array. So if we did array2.push 4, and then we console.log array1, and we console.log array2, and save, it will show us that even though we added 4 to array2, array1 and 2 were both modified. And that's because arrays are references. So both of these point to the same array in memory. To avoid this behavior, we can create a copy of the values in the array using a method called slice. So here, if we did array1.slice instead, this will make a copy of the values in array1. And now these two variables point to two different arrays. If we save, now you'll see that this line only affected array2. The second detail we're going to learn is a shortcut called destructuring. So at the bottom here, let's create a new array, const array3 equals the array 1, 2, 3. And let's say we want to get the first value and the second value out of this array. One way to do this is to use the index like this. Another way is to use a shortcut called destructuring. So here, we're going to replace this with square brackets. And now we can type some variable names. If we type first value, it will take the first value and save it in a variable called first value. If we type comma and second value, it will take the second value and save it in this variable. So this is an easier way to get values out of an array and save them inside a variable. Next, we're going to learn more details about loops. So loops have two features called break and continue. Break lets us exit a loop early. For example, let's create some new lines, and let's create a loop that counts from 1 to 10. So as usual, we can use a for loop. Let I equals 1, I less than or equal to 10, and I plus plus. And we'll console.log I and save. So this will count from 1 to 10. So now let's say that when I is 8, we want to stop this loop early. So first, let's check if I is equal to 8. If it is equal to 8, we're going to stop this loop by typing break and semicolon. If we save, once this reaches 8, break will cause this loop to stop. And now it only counts up to 8. So that's the break feature of a loop. It lets us stop a loop early. The next feature is called continue. Continue lets us skip one iteration of the loop or one run of the loop. For example, let's say we want to skip the number 3. So at the top, we can check if I is equal to 3. And if it is, we can use the code continue. This will skip the rest of this code and go back up to the top of the loop and do I equals 4. If we save, this will skip 3 in the loop. So continue lets us skip one iteration of the loop. So now let's say that we want to skip a number if it's divisible by 3. Divisible by 3 means the number can be divided evenly into 3. For example, 3 and 6 are both divisible by 3, but 7 is not divisible by 3 because there's one remaining. This is called the remainder, and we can calculate the remainder using the remainder operator, which looks like this. So to check if a number is divisible by 3, we can check if the remainder is 0. So here, we're going to replace this with I remainder 3, and we'll check if the remainder is equal to 0. If we save, this will skip 3 and 6 because they're both divisible by 3. Next, let's use continue in a while loop. So at the end here, we'll create some new lines. And let's say we want to count from 1 to 10 using a while loop. So we'll create a loop variable, let I equals 1, and we'll create a while loop, I less than or equal to 10, curly brackets, and the increment step, I plus plus. And inside the loop, we'll just console.log I and save. So this will count from 1 to 10 again. And let's say we want to not count numbers that are divisible by 3. So 3, 6, and 9. So at the top here, we can check if I remainder 3 is equal to 0 and curly brackets, and we might just try to do continue. However, in a while loop, continue will actually skip the increment step, and this will cause an infinite loop. So when using continue in a while loop, we have to do this increment step manually. So before continue, we have to do I plus plus to avoid an infinite loop. If we save, it will skip the numbers that are divisible by 3, which is 3, 6, and 9. So remember, in a while loop, if we use continue, always do the increment step manually. In a for loop, however, the increment step is done automatically after every iteration. All right, the last detail we're going to learn is how to use loops with functions. So let's say we have an array of numbers, and we want to create a copy of this array where each number is doubled. So we already have the code for this. We can scroll up, and the code for this is here. So let's actually make a copy of this code from before. We'll right-click, copy, and scroll down here. And at the bottom, right-click and paste. At the top, let's create an array called nums. So const nums equals array and 1, 1, and 3. If we save, this will create an array where each number is doubled. Now, what if we wanted to use this loop on a different array other than 1, 1, and 3? We can do that using a function. So let's create a function around this loop. We'll create function. Let's name it double array, brackets, and curly bracket. We'll remove the closed curly bracket, and at the bottom, we'll add it back. And we'll select these lines and press Tab. So now, instead of doing this loop on the same array every time, we can turn this into a parameter. So at the top here, we'll create a parameter called nums. And we're going to delete this line. And we're going to loop over this parameter instead. So at the bottom, we can call our function using double array and brackets. And between the brackets, we're going to save an array into nums. So square bracket, 1, 1, and 3. If we save, this will do the same thing as before. But now because it's in a function, we can use this loop with any array, not just 1, 1, and 3. So at the end, we can do double array brackets and an array 2, 2, 5 this time, and save. And it will create an array where these numbers are doubled. So using a function, we can reuse this loop for any value. Another feature of using a function with a loop is that we can break out of this loop using a return instead. So first, let's actually use a return in this function. Instead of console.log, we're going to return nums doubled. And here, we're going to console.log the result. Console.log and console.log. And save. So this does the same thing as before, except we're returning the result and console.logging outside of the function. Now let's say that if we see the number 0, we want to stop this loop early. To do that, we can click here and check if num is equal to 0. And if it is, we can break out of this loop. Now, when we're inside a function, we can also use a return statement to break out of this loop. So we can also do return nums doubled. So a return statement will end this function immediately. So this is another way of ending the loop. So down here, if we add the number 0 and then 5 and save, you'll notice that the loop stops when we see the number 0. So return is another way of breaking out of a loop when it's inside a function. And that's the end of this lesson. In this lesson, we learned about arrays, which represent a list of values. We learned about loops, which let us run some code over and over, just like a loop. We learned a technique we can use with loops called the accumulator pattern, and we used it to create a to-do list project. We learned that arrays are references and the destructuring shortcut, and we learned more features of loops, like break, continue, and using loops inside a function. Here are some exercises to help you practice arrays and loops. In this lesson, we're going to learn some advanced features of functions, and we're going to use them to improve our previous projects. First, let's create a new file for this lesson. We'll go to our code editor and click here to show our files, and click here to create a new file. And we'll name this 12-advanced-functions.html and press enter. Now let's copy 11 arrays and loops into this file. So we'll click here, Control A or Command A, and then right click, copy, and in here, right click and paste. And we can close this for now. And let's prepare this file for this lesson. So we'll scroll up and change the title to Advanced Functions. And let's remove all the JavaScript code from before. And now let's save and open this file in the browser by right-clicking, Open with Live Server. And let's also open the console on this page. So we'll right-click, Inspect, and open the console. And now we can close the previous tabs as well as the previous files. And now we're ready to begin. So first, we're going to review how to use functions. Inside the script element, let's create a function using the word function. We'll give it a name, greeting, brackets, and curly brackets. And inside the function, we'll type the code console.log, the string hello. So this is a function, and it lets us reuse code. To run the code inside this function, we can type the function name, which is greeting, and then brackets. If we save, this line of code will run the code inside the function and display hello. This is known as calling the function or running the function. So now that we understand functions, we're going to learn an advanced feature of functions, which is functions are values. So we learned many types of values in this course, like numbers, strings, and Booleans. And we can save a value in a variable. For example, let's create some new lines, and we'll create a variable const num equal 2. So this will save the value 2 inside the variable num. Now functions are also values, and this means just like a number, we can save a function inside a variable. So let's give it a try. We'll create a new line and type const function 1, and we'll make this equal to a function this time. So we'll just type function and a name, greeting, brackets, and curly brackets. And inside the function, we'll type console.log, the string hello 2. And we'll put a semicolon at the end, since we're saving in a variable. So this variable now contains a function. We're using the exact same syntax as before, except we're just taking this function and saving it in a variable, because functions are values. So now that this function is inside this variable, let's actually console.log it. So we'll console.log function 1 and save. And this will show us that the variable function 1 actually contains this function. Now on a new line, we can also do console.log and check the type of function 1 and save. And it will tell us that the type of this variable is a function. So as you can see, a function is just another type of value, and we can save it in a variable. We can also run the function inside this variable by typing the variable name function 1, and because this contains a function, we can actually just call it using brackets. So this will run the code inside this function. If we save, it displays hello 2. Now let's do some cleanup in this code. In JavaScript, as long as there's a way to access a function, this function name is not needed. So here, we can access this function using this variable. So this function name is not needed, and we can actually just delete it, like this. And now this is called an anonymous function, which means a function without a name. Now, an interesting thing to know is that the function syntax that we've been using this entire course up here is actually a shortcut for this code. Now, even though this syntax uses var, and we usually don't recommend var, this syntax actually has a couple advantages. Number one, it's easier to read, and number two, it gives us a feature called hoisting, which means we can call this function greeting brackets before we create it in the code. So using hoisting, we don't have to worry about what order we write this code. Hoisting doesn't work when we create our function and save it in a variable like this. So in JavaScript, functions are values, and just like any other value, we can save it in a variable. Now let's think, what else can we do with a value? Well, we can save a value in an object. For example, let's scroll down and create some new lines, and we'll create an object. Const object1 equals curly brackets. And inside this object, we'll have a property num with the value 2. So this saves the number 2 inside this object. Now, because functions are values, we can also save a function inside this object. So we'll type comma, and then a property fun, colon, and we'll create a function this time. Function, greeting, brackets, and curly brackets, and inside we'll type console.log the string hello 3. So this saves a function inside this object under the property fun. Now to access this function, we just use the dot notation as normal. So object1 dot fun. And because this value is a function, we can call it using brackets. If we save, this will run the code inside the function and display hello 3. So remember, this is called a method when we have a function saved inside an object. Again, as long as there's a way to access this function, for example, using object1.fun, then we don't need this function name. So we'll delete it and use an anonymous function. Now let's think, what else can we do with a value? We can pass a value into a function. For example, down here, let's create a function display brackets and curly brackets, and we'll give this function a parameter. So in here, we'll create a parameter and name it param. And inside the function, we can use a parameter just like a variable. So we'll console.log the param. And then down here, let's call this function using display brackets and 2. This will take the value 2, save it inside param, and then we can use it just like a variable. If we save, this will display 2 in the console. So this is known as passing a value into a function. Now, because functions are values, we can also pass a function into a function. So let's give it a try. Down here, we'll create a new function run brackets and curly brackets. And this function will also have a parameter. Let's call it param. And down here, we'll call this function run brackets. And between the brackets, we're going to give it a function this time. So we'll type function brackets and curly brackets. And inside the function, we'll type console.log the string hello 4. So this will take this function and save it inside param. And now up here, we can use param just like a variable. So we can type param, and because param contains a function, we can actually just call it using brackets. If we save, this code will run the function that we created down here and display hello 4. So this is called passing a function into another function. The function that we're passing in is called a callback function or a callback. So to summarize, functions are values. Anything we can do with a value, we can also do with a function. Now let's do some practical examples using functions as values. We're going to learn a feature of JavaScript called setTimeout. SetTimeout allows us to run a function in the future. First, we'll comment out the previous code using /* and at the bottom, */. And let's create some new lines. And we're going to type the code set capital T time out. So setTimeout is a built-in function. So we can type brackets to call this function. Now setTimeout takes two parameters. Inside these brackets, the first parameter is a function that we want to run in the future. Let's create a function, brackets, and curly brackets. And inside this function, let's type console.log the string timeout. So here we're using a function as a value and we're passing it into another function. At the end, we'll type a comma and we'll give setTimeout a second parameter. The second parameter is how long to wait before running this function. So this is a number in milliseconds. 1000 milliseconds is equal to 1 second. So if we type 3000 milliseconds, this is equal to 3 seconds. So setTimeout will wait for 3 seconds and then call this function. If we save, after 3 seconds, it's going to display timeout in the console. So that's setTimeout. We give it a function and it will call this function after a certain amount of time. So now we're going to learn an important concept called asynchronous code. So after setTimeout, let's type console.log the string next line and save. So notice that it displays next line first, and then after 3 seconds, it displays timeout. So what's happening here? Why are they reversed? setTimeout sets up a timer, and after 3 seconds, it will call this function. However, it doesn't actually wait for the 3 seconds to finish. It just sets up the timer and immediately goes to the next line. So that's why this line is displayed first. So this is called asynchronous code. Asynchronous code means the computer won't wait for this line to finish before going on to the next line. So for setTimeout, it'll just set up the timer and then immediately go to the next line. Synchronous code, on the other hand, means the computer will wait for one line to finish before going to the next line. So all the code we've written in this course so far has been synchronous code. In addition, all the code inside this function is also synchronous code. So if we added console.log the string timeout2 and save, the code inside the function will still run line by line. It will wait for each line to finish before going to the next line. And after 3 seconds, it will display timeout followed by timeout2. So don't worry, all the code that we normally write will be synchronous code. It will run line by line as usual. The only time that code becomes asynchronous is when we use certain features of JavaScript, like set timeout. So set timeout is the only part that is asynchronous. Now, the advantage of set timeout being asynchronous is that it doesn't block our code for 3 seconds, waiting for this timer to finish. It just sets up the timer in the background and then goes to the next line of code. So this allows our code to do other things while this timer is running in the background. And this is similar to real life. If you set up a timer on your alarm clock, you're not going to stop and wait for the timer to finish. You're going to go and do something else. Asynchronous code is the exact same concept. Next, we're going to learn a similar function to set timeout called setInterval. So at the bottom, let's type the code set capital I interval, and setInterval is another built-in function, so we can call it using brackets. And setInterval takes the same 2 parameters as setTimeout. The first parameter is a function that we want to run in the future. So let's type function, brackets, and curly brackets, and inside we'll type console.log the string interval. Now let's add a comma, and the second parameter is also a number in milliseconds. So we'll type 3000 milliseconds or 3 seconds. So setInterval will run this function 3 seconds in the future, but this time it will keep running the function every 3 seconds. If we save in the console, every 3 seconds it will run the function and display interval. So setInterval is also asynchronous. Below it, if we type console.log the string next line 2 and save, it will set up the interval and then immediately go to the next line and display next line 2. So that's setInterval. We give it a function and it will keep running this function after a certain period of time. So now let's do a project using what we learned so far. Let's go to our browser and we'll create a new tab at the top. And here, let's type supersimpledev/projects/advanced-functions and press enter. So this is basically the rock, paper, scissors game that we created earlier, except this time it has an extra button called autoplay. If we click this button, every second the computer will play by itself. So this feature will help us practice using setInterval. So first, let's make a copy of the project files. We'll go into our code editor and click this icon to show our files. And let's make a copy of 10 rock, paper, scissors for this lesson. So we'll right click, copy, and down here, right click and paste. And I'll stop this for now. So here, we're going to change the name by right clicking, rename. We'll remove copy at the end, and at the beginning, we'll change it to 12 and press enter. And let's also make a copy of the JavaScript and CSS files. So we'll click this file and right click, copy, and then click the folder, right click, paste, and we'll rename this file. Right-click, rename, remove copy at the end, and at the beginning, change it to 12, and press enter. And let's also make a copy of the CSS file. Select it, right-click, copy, click the folder, right-click, and paste. And right-click, rename, remove copy, and at the front, change it to 12, and press enter. Now let's scroll down to 12 rock, paper, scissors, and I'll close this for now. And inside the head, let's change this to load 12 rock, paper, scissors. And we'll scroll to the bottom. And here, instead of the lesson 10 file, we'll load the lesson 12 JavaScript file. Let's save. And we'll open this in the browser by right-clicking, open with live server. So now we're ready to begin. Let's go back to SuperSimple.dev. And the first thing we're going to create is this auto play button. So beside the reset score button, which is here, we're going to create a new button, less than, button, greater than, and inside we'll have the text auto play. Let's save and go back to our tab. And now we have this button. So next, let's style this button with CSS. So we'll give it a class equals auto-play-button, and save. And now let's open the CSS file. I'm going to take this file and then drag it to the bottom so I can see it side by side. So I'll close this for now and rearrange this a little bit. And then down here, and we're going to style the auto play button. So let's just make the style the same as the reset score button. So in the CSS, we'll scroll down to the reset score button styles. So we'll add a comma at the end and type dot auto-play-button. So now these styles will apply to the class reset score button and the auto play button. If we save, now we styled our project. So next, let's make this button interactive. So at the top here, we'll add an onClick attribute. And then in here, we're going to run some JavaScript code. Let's actually create a function so we can separate the JavaScript into its own file. So we'll run a function called auto-play and brackets. So now let's save. And right now, this function doesn't exist. So we have to create this function in the JavaScript file. So for me, the file is right here. I'll select it and then drag it down here so I can see it side by side. So let's scroll down. And I'm going to create it just above the play game function. So here, we'll create some new lines and type function auto play, brackets and curly brackets. And now inside this function, we want to play the game every second. So we can use set interval to run some code every second. So let's type set interval brackets, and inside the brackets, we'll give it a function that we want to run. So brackets and curly brackets. And then at the end, let's type a comma, and we'll give it 1000. So this means it will run this function every 1000 milliseconds, or 1 second. And now inside this function, we're going to automatically play the game. And to play the game, we can use this function right here, play game. So here, we'll type play game brackets. Now we need to provide this function with a player move. And remember, we have another function, pick computer move, which will give us a random move. So above this line, let's create a variable const player move, and we'll make it equal, and we'll pick a random move using pick computer move and brackets. And finally, we'll take this move that we picked and pass it in to this function. So player move. So now when we click this button, it should play the game every second. Let's save and click autoplay, and it works. The computer is playing against itself every second. So now let's make this button stop playing when we click it again. So at the top, let's create a variable to keep track of whether or not we're playing. So we use let is auto playing, and at the start, we'll make it equal to false and save. And now inside this function, we'll check using an if statement, brackets and curly brackets. And inside this condition, let's check if we're not playing. So not is auto playing. So if we're not playing, then we want to start playing the game, which is this code down here. So let's select this code and then right click, cut, and in here, right click and paste. And also, after we start playing the game, we're going to change this variable to true. So is auto playing, and we'll make it equal to true, because now we are auto playing. So now let's add the else branch to this statement. Else, curly brackets. So now we need to stop this interval. So how do we do that? The answer is that setInterval actually returns a number, and this number is like an ID. We can use this ID to stop the interval. So at the front, let's create a variable to save this ID. Const interval ID and equals. However, there's another problem here. Every time we run the function, we're going to get a different ID. So in order to save the ID from last time, we need to put this variable outside the function. So let's select this and remove it for now. And we'll scroll up. And here, we'll create the variable let interval ID. And we'll leave it undefined to start. And now down here, we're going to save the return value into this variable by typing interval ID equals setInterval. And now at the bottom, we're going to use the interval ID to stop the interval. Let's scroll down, and to stop an interval, we can use a function called clearInterval. So we'll type clear, capital I, interval, and brackets. And between the brackets, we're going to give it an ID that we want to stop. So we'll give it this interval ID. Interval ID. And then at the bottom, let's also change is auto playing to false, because we just stopped it. So is auto playing equals false, and save. So now if we try out this button, it will start playing the game by itself every second. And if we click the button again, it will stop playing the game. So that's how we stop an interval. We need to save the ID and then call clearInterval with this ID. So now I'll clean up the code a little by removing this extra line and save. And now we're finished with this feature. So next, let's go back to our advanced functions file. So I'll click up here And then at the bottom, I'll open 12 advanced functions and hide the files for now. And we're going to learn some more features of functions as values. So let's actually close the other files that we opened. And first, let's comment out the previous code with /* and at the bottom, */. Let's scroll down and save. And let's open the tab for this file. So now we're going to learn another way to loop through an array. First, let's create an array. We'll type square brackets, and inside the array, we'll have the string make dinner and another string wash dishes and another string watch YouTube. So in the previous lesson, we learned how to loop through an array using a for loop or a while loop. Another way to loop through an array is using a method of the array called for each. So at the bottom, let's type dot for capital E each and brackets. So this is the for each method, and it allows us to loop through this array. Inside these brackets, we're going to give for each a function. So we'll type function, brackets, and curly brackets. So again, we're just passing a function into another function. However, this function will be a little different. We're going to give it a parameter. So up here, let's create a parameter called value. So what for each does is that it loops through the array, and for each of these values, it will save the value in the parameter and run the function. So let's console.log value and save. So this will loop through the array and display each value in the console. So let's go through this step by step. So it'll take the first value, save it in this parameter, and run the function. Then it will take the second value, save it in the parameter, and run the function. Then it will take the third value, save it in the parameter, and run the function. So the for each method is actually the preferred way to loop through an array, because this is easier to read than a for loop like this. And for each also has another feature. We can give this function a second parameter. So we can type comma, and the second parameter is the index, or the position of the value in the array. So for the first value, index will be 0. For the second value, index will be 1. Third value, index will be 2, and so on. So above this line, let's also console.log the index and save. And this will also display the index of each value. All right, now let's do a practical example using the for each method. We're going to go back to the to-do list project that we created in the previous lesson. So we'll click up here to show our files. And let's scroll up. And let's open 11todolist.js. So in this code, we used a for loop to display the to-do list on the page. We're going to switch this to using a for each method instead. So first, let's actually make a copy of the files for this project. We'll click up here, and let's click 11 to-do list, and right-click, copy, and let's click the script folder, right-click, and paste. And now we'll rename this by right-clicking, rename, remove copy from the end, and change the beginning to 12, and press enter. Let's also make a copy of the CSS and HTML file for this project. So we'll click the CSS file, right-click, copy, click the styles folder, right-click, and paste. Right-click, rename, remove copy, and at the front, change it to 12, and press enter. And finally, we'll scroll down, click 11 to-do list.html, right-click, copy, and then down here, right-click and paste. Right-click, rename, remove copy at the end, and at the beginning, change it to 12, and press enter. Now we can hide these files, and we can close the lesson 11 files. And now here, we're going to change the CSS file that we load to 12 to-do list. And we'll scroll down, and we'll also change the JavaScript file that we load to 12 to-do list. Now let's save, and we'll open this in the browser by right-clicking, open with live server. Okay, now let's go back to the JS file. So I'll take this file and drag it to the bottom, and I'll rearrange the windows here. We're going to scroll down, and we'll change this for loop to use a for each method. So first, let's type above this for loop, and we'll type the array that we want to loop through, which is to-do list. And we'll type dot and use the for each method and brackets. Inside the brackets, we'll give it a function that we want to run for each to-do. So we'll type function, brackets, and curly brackets. And this function can have two parameters. The first parameter will contain each value in the array. So we'll call it to-do object. We'll type a comma, and the second parameter contains each index in the array. So we'll just call it index. And now inside this loop, we basically want to do everything that we did here. So let's just make a copy of this code, right-click, copy, and then up here, inside for each, right-click, and paste. So now if we scroll up, we already have the to-do object up here. So we don't need to get it from the array like before. So we can remove this line. And let's also remove these comments. The other thing we have to change is that previously we were using I for the index, but now the index is called index. So we just change this to index. So that's how we use a for each method instead of a for loop. If we compare this code to the for loop that we had before, the for each method is easier to read. So for the rest of this course, we're going to prefer to use for each instead of a for loop. So we're going to remove this for loop. Let's scroll back up and save, and the project still works. So that's a practical example of using the for each method. Now let's go back and learn some more details about for each. We'll close the JavaScript file for now and go back to advancedfunctions.html and open the tab for this file. So in the previous lesson, we learned a feature of loops called continue. Continue lets us skip to the next iteration or the next run of the loop. For each methods don't have continue, but we can do the same thing with a return statement. So let's say in this loop, we don't like washing dishes. If the value is wash dishes, we're going to skip it and not display it in the console. So above, we'll create an if statement. And then inside the condition, we'll check if value is equal to the string wash dishes. And then in the curly brackets, if it is equal, we'll return and semicolon. So this return statement will end this function early, and it will go on to the next function. So it basically does the same thing as continue in a for loop. If we save, you'll notice that it skipped wash dishes. In the previous lesson, we also learned a feature of loops called break. Break lets us exit a loop early. Unfortunately, there's not an easy way to break in a for each loop. So if we need to use break to exit this loop early, then it's better to use a regular for loop. Let's take a break before continuing with the rest of this lesson. Here are some exercises that will help you practice what we learned so far. So next, we're going to move on and learn a shorter way to write functions called arrow functions. So let's go to the bottom of this code. We'll create some new lines, and let's create a variable, const. And we'll name the variable arrow function. And we'll make it equal to brackets, equal, greater than, or an arrow, and then curly brackets. Inside the curly brackets, we'll type some code, console.log brackets and the string hello. And we'll put a semicolon at the end. So this is an arrow function. It works the same way as a regular function. For example, we can call this arrow function by typing the variable name, arrow function, and brackets. If we save, this line of code will run the code inside this arrow function and display hello. So arrow functions mostly work the same way as regular functions. So to compare them, let's actually type above this code. We'll create some new lines and type const regular function equals the word function, brackets, and curly brackets, console.log string hello. So these two syntaxes do the same thing. The difference is that instead of using the word function, an arrow function just uses an arrow. Now, parameters work the same way in an arrow function. We just type the parameter between these round brackets. So here, let's type param, and here as well. If we want multiple parameters, it also works the same way. Up here, we can type comma param2, and down here, comma param2. And finally, return statements also work the same way. So in this function, we can return 5, and in the arrow function, we can also return 5. So now let's learn some differences between these two. Arrow functions have a few shortcuts that regular functions don't have. For example, at the bottom, let's create an arrow function using const, and we'll name it oneParam, and make it equal to an arrow function, brackets, arrow, and curly brackets. Now in this arrow function, we're going to give it one parameter, param. And inside the function, we'll console.log param plus 1. So when an arrow function only has one parameter, these round brackets are optional. so we can actually remove them. If we do 1 param brackets 2, if we save, it will display 2 plus 1, which is 3. Let's learn another shortcut. We'll create some new lines and type const 1 line and make it equal to an arrow function, brackets, arrow, and curly brackets. And inside, we'll return 2 plus 3. So when an arrow function only has one line like this, we can actually put it on the same line as the arrow. And now that everything's on the same line, the curly brackets are actually optional. So we can remove them, and we can also remove the return statement. So this is a one-line arrow function. If we just have an arrow, it will automatically return the result on the right. So at the bottom, we can console.log and call the one-line function with brackets. If we save, this function will return 2 plus 3, and it will display 5 in the console. So that's arrow functions. It's a shorter way of writing a regular function, and it has a few shortcuts. For now, let's get some practice using arrow functions. So let's scroll up in this code to the for each method. So let's use an arrow function here instead. We just have to remove the word function, and after the round brackets, add an arrow equals greater than. If we save, the loop still works. So when we're passing a function into another function like for each, it's recommended to use arrow functions because it makes our code easier to read. So now let's use arrow functions in some of our previous projects. We'll start with the rock, paper, scissors game. Let's open our files by clicking here, and we'll find the 12 rock-paper-scissors.js file. And then inside this file, we're going to scroll down to the autoplay function. So here, we're passing a function into another function. So it's recommended to use an arrow function. Let's remove the word function and add an arrow. So now this code is a little easier to read. Now, what about this function up here? Function autoplay. Should we also switch this to an arrow function? So this situation is more personal preference. So above this, let's actually create an arrow function version of this. Const autoplay equals brackets and arrow and curly brackets. So even though we could create an arrow function version of this, I actually prefer the regular function syntax here for two reasons. Number one, I think this is easier to read than this. And number two, this function syntax enables hoisting, which means we can call this function before we create it, and we don't have to worry about which order we write the code. So for these reasons, I actually prefer this situation to use a regular function syntax and not an arrow function. So we'll comment out the arrow function using // and //. Now let's save, and let's open the tab for this project, and we'll give it a try. So click autoplay, and this still works after replacing with an arrow function. Next, let's go to the to-do list project and switch to arrow functions. So we'll go to our code editor and find the to-do list project, which is here. And let's scroll down. So inside render to-do list, we're using for each, and we're passing this function into another function. So it's recommended to use an arrow function here. So we'll remove the word function, and after the brackets, we'll add an arrow. And again, I'll leave this function syntax as a regular function because it's easier to read and enables hoisting. So let's save and go back to our to-do list, and everything still works. Next, let's go back to 12 advanced functions.html, and we'll scroll to the bottom, and we'll open the tab for this file, and we'll review another place we could use arrow functions, which is inside an object. So at the bottom here, let's create a new object, const object2 equals object. And then inside, let's type the property method, colon, and an arrow function, brackets, arrow, and curly brackets. So even though we could save an arrow function inside an object like this, objects already have a shortcut for functions. So at the bottom, we could just type method, brackets, and curly brackets. So this syntax is called the shorthand method syntax. So this shorthand method syntax is actually easier to read than an arrow function. So when saving a function in an object, it's actually recommended to use this syntax instead. There's also another difference between regular functions and arrow functions, but we'll learn about it later in this course because it's a more advanced feature. Now let's move on, and we're going to learn another improvement we can make to our projects. So let's comment out this code. We'll scroll up and type /*, and at the bottom, */ and save. And next, we're actually going to scroll up to the very top of this file. And we're going to create a button on the page. So inside the body, we'll type less than, button, greater than. And inside the button, we'll have the text click. Now let's say that we want to run some JavaScript code when we click this button. So here, we can type on click equals double quotes and write some JavaScript inside this double quotes. Now we're going to learn a better way of doing this called add event listener. To use add event listener, first we're going to get this button and put it into our JavaScript using document.querySelector. So let's add a class to this button so we can select it, and we'll set it to JS-button. And now inside the script element, we're going to use document.querySelector, brackets, and the string .js-button. So now let's save this button in a variable so we can use it later. At the front, we'll type const button element equals this result. Now every HTML element has a method called add event listener. Add event listener lets us run some code when we interact with the element. So it sort of does the same thing as on click. So at the bottom, let's type button element dot add capital E event capital L listener and brackets. So add event listener has two parameters. The first parameter is the event, or what type of interaction we want to listen for. So between these brackets, let's type the string click. So this will run some code when we click the button. The way to find these event names is to look at this attribute. The word after on is the event. Next, the second parameter is a function that we want to run when we click this element. So we'll type a comma And because we're passing a function into another function, we're going to use an arrow function. So we'll type brackets, arrow, and curly brackets. So inside here, let's just do console.log string click and save. And now when we click this button, it will run this function and display click. So this code does the same thing as the onClick attribute. However, add event listener has some advantages over using an attribute. First, it lets us add multiple event listeners for an event. For example, let's add another click event listener. We can select this code and right-click, copy, and then down here, right-click and paste. And let's change this to log click 2. If we save and click the button, it will run both these functions. So add event listener lets us add multiple listeners to one event. Another advantage of doing this is that we can remove an event listener using a method called remove event listener. So under this code, we can type button element dot remove capital E event capital L listener and brackets. And remove event listener also has two parameters. The first parameter is the event. So in this case, it is the string click. And we'll type a comma. And the second parameter is the function that we want to remove, so that when we click this button, it will no longer run that function. Now, we can't just type a copy of this function. We need to use this exact function inside remove event listener. To do that, we'll save this in a variable first. So above this, let's create a variable const event listener equals, and we'll select this code, right-click, copy, and in here, right-click and paste. And now we'll replace this with the variable event listener. And down here, we'll remove this same variable, event listener. If we save and click the button again, it will only display click 2 because we added this event listener and then we removed it. So it will no longer run this function when we click the button. So as you can see, add event listener gives us more control over event listeners. We can add multiple listeners to an event, and we can also remove a listener from an event. So because of these advantages, the best practice is to use add event listener instead of an onClick attribute. So let's go back into our projects and switch to using add event listener. We'll start with the rock, paper, scissors project. So we'll open our files and we'll open 12 rock, paper, scissors and click here and save. And we'll scroll up to 12 rock, paper, scissors.js. And for the video, I'll drag this down to the bottom. And I'll hide the files for now. And then rearrange the windows. And finally, open the tab for this file. Now let's go to the HTML. We'll scroll up to these move buttons, which is up here. So here, we're using the onClick attribute, and we're going to switch it to add event listener. So first, let's get this button into our JavaScript. We'll add a class so we can select it, js-rock-button, and save. And then down here, let's go below the autoplay function, right here. and we'll use add event listener. So we'll get this button into our JavaScript using document.query selector brackets and a string dot js dash rock dash button, and we're going to use dot add event listener brackets. So we're going to listen for a click and a comma, and we'll give it a function that we want to run. So a common mistake here is to actually run the function. For example, play game brackets and the string rock. So we're supposed to give a function to add event listener. However, this doesn't result in a function. This will actually run play game and give us the return value, which is undefined. So this code will actually result in undefined, and then we're giving undefined to add event listener, so it won't work. So in order to give add event listener a function, we need to create a function here. So let's remove this code, and we'll create a function using brackets, arrow, and curly brackets. And then inside this function, we're going to call play game. So we'll type play game brackets and rock. So now when we click the rock button, it will run this function and play the game. So let's remove the onClick attribute and save the HTML, and also save the JavaScript, and then go to our project and click the rock button. You can see that it works, except this time we're using add event listener. So let's do the same thing for the paper and the scissors button. Feel free to pause the video if you want to try it yourself. So we'll scroll down here, and let's add a class to the paper button so we can select it, js-paper-button, and then in our JavaScript, we'll make a copy of this code. So right click, copy, and then down here, right click and paste. And now we're going to replace the rock button with paper. And when we click this button, we're going to play the game with paper. Now let's save, and we'll remove the onClick attribute and save the HTML. If we click the paper button, it works as before. Finally, let's do the scissors button. So we'll add a class js-scissors-button, and then inside our JavaScript, we'll make a copy of this, right click, copy, and then down here, create some new lines, right click, and paste. And now switch to the scissors button and play game with scissors. Let's save and remove the onClick attribute, save the HTML, and try the scissors button. So everything still works. And I'll leave switching the reset score button and the auto play button as exercises. So now let's try add event listener with a different event. We'll use it with key down. So let's say that in our project, we want to make it so we can play the game with our keyboard. If we type R, it will play rock. If we type P, it will play paper. And if we type S, it will play scissors. Let's go into our JavaScript, and we'll scroll down. And we're going to add an event listener to the body this time, so that if we type anywhere on the page, we can run some code. So we're going to get the body element using document.body and then dot add event listener. and brackets. This time, the first parameter, or the event, will be the string key down. And let's type comma and give it a function that we want to run. Brackets, arrow, and curly brackets. Inside here, let's just type console.log key down for now and save. So now if we go to the project and we open the console, right click and click inspect, click the console, and then click on the page. If we type a key on our keyboard, it will run this function and display key down. So now we have to check what key was pressed and play the game. So how do we know which key that we pressed? Earlier in this course, we used the attribute onKeyDown, and we learned that it gets a special object called event, and the event object contains which key was pressed. addEventListener also provides this event object, but it provides it as a parameter to this function. So inside the round brackets, let's add a parameter event. Now every time we type on our keyboard, addEventListener will save the event object in here and run the function. And this event object contains the key that we pressed. So in the console.log, let's display event.key this time and save. Now if we click on the page and type R, event.key will contain R. If we press P, event.key will contain P. So that's how we know which key we pressed. So now let's close this. And instead of console.log, we'll create an if statement to check which key we pressed. So if, brackets, and curly brackets. And here, we'll check if event.key is equal to the string R. If it is, we're going to play the game with rock. So inside here, we can just run this play game function. Play game and brackets, and inside we'll type the string rock. Now let's check if we pressed P. So we'll add another branch, else if, brackets, and curly brackets. And in this second condition, we'll check if event.key is equal to the string P. If it is, we'll play the game with paper. So inside here, we'll run play game, brackets, and the string paper. And finally, we'll check if we pressed S. So at the end, we'll add another else if, brackets, curly brackets, and inside here, we'll check if event.key is equal to the string S. If it is, we'll play the game with the string scissors. Now let's save, click our page, and type R, and it plays a game with rock. If we type P, it will play the game with paper. And if we type S, it will play the game with scissors. So that's an example of using addEventListener with a different type of event with a key down. If we need the event object, we can get it using a parameter up here. So those are all the features we're going to create for our rock, paper, scissors project. Now let's move on to the to-do list project and switch to addEventListener. We'll go into our code editor, click up here, and find 12todolist.html. We'll also scroll up to the scripts folder, find 12todolist.js, and open this file. And I'm going to put it at the bottom here so I can see it side by side. I'll close this for now and close rock, paper, scissors, and then open the tab for this project. Okay, So let's start by switching the Add button to use Add Event Listener. We'll go into our HTML and find the Add button, which is here, and we're going to add a class so we can select it in JavaScript. JS-add-to-do-button. Now let's go to our JavaScript and scroll down. Above the Add to Do function, we'll get this button into our JavaScript using document.query selector brackets and then a string dot and the class we want to get, js-add-to-do-button. And then after this, we'll use .add event listener brackets. Inside these brackets, we'll give it the event, the string click, comma, and then a function to run when this event happens. So brackets, arrow, and curly brackets. And in here, we just want to do the same thing as the onClick attribute, which is add to do and call this function. Let's save. And then in the HTML, let's remove the onClick attribute and save. And let's try it out. So we'll type a to do, watch YouTube, select a due date, and then click add. And the add button still works as before, but we're just using add event listener. Next, let's switch all the delete buttons. Let's scroll up to where we create these delete buttons, which is here. And first, we'll add a class to all the delete buttons so we can select them in JavaScript. js-delete-to-do-button. And now we're going to use document.query selector and add an event listener to all of these buttons. However, there's two problems here. First is that at this point in the code, this is just a string. We haven't actually put this button on the page yet. We do that down here in this line of code. We put the HTML that we generated onto the page. So in order to add an event listener, we need to put the HTML on the page first. So we have to do it after this code. So down here, we're going to type document.query selector brackets and the string dot, and we'll select this class, js-delete-to-do-button. However, there's also a second problem here, which is we're going to have multiple delete buttons, and query selector only gives us the first one. So how do we select all the buttons on the page that match this criteria instead of just the first one? To do that, the document object has another method called query selector all. So query selector all will give us all the elements on the page that have the class js-delete-to-do button. So down here, let's console.log this result to see what it looks like. Console.log brackets and close bracket and save. And then here, right click, inspect, and the console, and expand this. You'll see that document.querySelectorAll gives us a list of elements. And this list works just like an array. This is index 0, or the first button, and this is index 1, which is the second button. So now let's remove console.log and add event listeners to all of these buttons. To do that, we're going to loop through this list of delete buttons. So again, this list works like an array, so we can use a for each method to loop through it. So at the end, let's type enter and tab, and then dot for each and brackets. As usual, we'll give for each a function that we want to run for each of these values. So we'll type brackets, arrow, and curly brackets. And now every time we loop through the list, for each will give us two parameters. The first one is the value in the list, which is a delete button element. So let's name it delete button. And we'll type comma. And the second parameter is the index. So index. So now we want to add an event listener to each delete button. So inside here, we'll type delete button dot add event listener and brackets. Inside these brackets, we'll tell it what event we want to listen to, which is the string click and comma, and then a function that we want to run when this event happens. So brackets, arrow, and curly brackets. So now when we click a delete button, we want to do the same thing as this onClick attribute above. So let's select this code. We'll right click, copy, and then down here, right click and paste. And now we can remove these characters because we're not in a string anymore. And that's all we need to do. So to summarize, we used query selector all to get a list of all the delete buttons on the page, and then we looped through the list using for each. And for each delete button, we added a click event listener and ran the same code that we did before. So now we can scroll up and remove this onClick attribute and save. Go back to the page, close the console, and try out the delete button. And you can see that it still works. So that's how we switch the to-do list project to use add event listener. So now we're finished improving all of our projects. In the rest of this lesson, we're going to learn more features that use functions as values. So let's close this for now, and we'll go back to 12 advanced functions.html. And we'll open the tab for this file. And let's also comment out this JavaScript code using /* and */. Let's save. And now let's scroll to the bottom of this code and create some new lines. So in this lesson, we learned the array method for each, which lets us loop through an array. Now we're going to learn two more array methods called filter and map. So let's start with filter. Let's say we have an array of numbers and we want to create a copy of this array with all the negative numbers removed. So let's go up here and create an array of the number 1, -3, 5, and type the method .filter and brackets. So filter works the same way as for each. We give it a function, so bracket, arrow, and curly bracket. And this function has two parameters, the value and the index. So filter will take the first value, save it in here, and run the function. Then it will take the second value, save it in here, run the function, and the third value, save it, and run the function. Now the only difference is that this time, this inner function will return a value. So we'll type return. And we're going to return a Boolean, like true. So now the return value matters. So what filter does is it creates a new array. If the inner function returns true, it will put this value in the new array. if the inner function returns false, it will not put this value in the new array. For example, at the front, let's console.log the result of this. So we'll type console.log, open bracket, and down here, close bracket, and save. So in this example, the inner function always returns true, so all three values will be in the new array. If we change the return value to false every time and save, all three values will not be added to the new array. So now let's use this to solve our problem. We want to remove the negative numbers from this array. So inside this inner function, we're going to return true if the number is positive and return false if the number is negative. So we'll check if value is greater than or equal to 0, curly brackets, we'll return true and include it in the new array. Else, we'll return false and not include it in the new array. So let's remove this and save. So now only values that are greater than 0 will be in the new copy. So using this, we can sort of filter out values based on a criteria. That's why this method is called filter. Now we can shorten this logic by using this code. Return value greater than or equal to 0. So this comparison will return true if it's greater than or equal to 0, and it will return false otherwise. So this line does the same thing as this code up here. So we can comment this out with /* and // and save. And as always, we can return a truthy or falsy value instead of just true or false. The last array method we're going to learn is called map. So let's create some new lines and scroll down. And let's say we have an array of numbers again, like the array 1, 1, 3. And we want to make a copy of this array with each number doubled. So at the end, we'll type dot map brackets, and map works just like for each and filter. Between the brackets, we'll give it a function, bracket, arrow, and curly brackets. And this function will get two parameters. The first parameter is each value in the array, and the second parameter, comma, is the index. So map will take the first value, save it in this parameter, and run the function. Take the second value, save it in this parameter, run the function. Third value, save it, and run the function. And inside this function, we're going to return a value. So what map does is it creates a new array, and then whatever we return will be added to the new array. So if we return 10, and then we console.log this result, console.log, and close bracket, and save, it will create an array where each value becomes 10. Now, the interesting thing is that we can actually use the value itself in the return. So here, if we did value plus 10 and save, it will take each value in the original array, add 10, and put it in the new array. So map will transform an array into another array based on the return value. So if we want to return an array where each number is doubled, we just have to multiply each value by 2 and save. And this will give us 2, 2, 6. Next, we're going to review some shortcuts of arrow functions to make this code more compact. First, let's make a copy of this code. Right-click, copy, and down here, right-click, and paste. So notice in the inner function, we're not using index. So let's just remove it for now. And now that this arrow function only has one parameter, these round brackets are optional. So we can also remove these to make the code more compact. Another shortcut is if we only have one line of code in an arrow function, we can put the code on one line like this. And now the curly brackets and the return are optional. So we can actually just remove all of this code. So if we have just an arrow, it will automatically return this result on the right, and we don't have to type return ourselves. So this code does the same thing as the code above. But as you can see, these shortcuts make our code very compact and clean. So let's save, and this will give us the same result. The last thing we're going to learn in this lesson is a feature of functions called a closure. A closure means if a function has access to a value, it will always have access to that value. So let's take a look at an example. We're going to go back to the to-do list project. So we'll click up here and then scroll up to 12todolist.js and close this, and then open the tab for the to-do list, which is here. And let's scroll down to the query selector all. So we're going to focus on this inner function here. So notice that this function uses index from above. Now the interesting thing about index is that as soon as this for each ends, index gets deleted. For example, if we add some new lines and we try to console.log index and save, and then go into our project, right-click, inspect, and the console, it'll tell us that the index is not defined. So as soon as we end the for each loop, index doesn't exist anymore. However, if we move this into the inner function, so inside here, and we console.log index and save, and we click a delete button, it will tell us that the index is 0. So even though index gets deleted right away down here, if we click one of these buttons later on, it still has access to index. This feature is called a closure. If a function has access to a value, it will always have access to that value. The value, like index, gets packaged together or enclosed with the function. That's why we call it a closure. So even if the value index gets deleted after the loop, we can click the delete button 5 seconds later or even 5 minutes later, and this function will always have access to index. So closures are something that naturally happens as we write JavaScript code, and it's nice to know how this feature works. There are some advanced techniques that we can do with closures, but they're not used that often, so I won't be covering them in this course, but maybe in a different video. Now let's remove console.log and save. And that's the end of this lesson. In this lesson, we learned that functions are values. We learned set timeout and set interval, which lets us run a function in the future. We learned an array method called for each, which is a cleaner way of looping through an array. We used for each, arrow functions, and add event listener to improve our projects. We learned 2 more array methods, filter and map, and we learned a feature of functions called closures. Here are some exercises to help you practice what we learned in this lesson. In this lesson, we're going to start the Amazon project, and we're also going to learn a very useful technology called Git. So first, let's take a look at the Amazon project to see how it works. We're going to go to our browser and create a new tab at the top, and we're going to type supersimpledev/projects/Amazon and press enter. So this is going to be the project we're going to build in this course. This is an e-commerce website that looks like Amazon, where we can see a list of products on the home page, and then we can add these products to a cart by clicking Add to Cart. And then we can see our cart by clicking the top right. And on this page, it will show us which products are in our cart, and it will also show us the cost of our order, including shipping and taxes. And once we're ready to create an order, we can click this button to create the order, and it will take us to this page, which shows us a list of our past orders. We can also track our order by clicking this Track Package button, and it will take us to this page, which tells us the progress of our order, whether it's preparing, it's shipped, and it's delivered. So that's an overview of the project we're going to build. This is a complex multi-page website where the different pages interact with each other to create a full app. The first thing we're going to do is to download the starting code for this project. We're going to create a new tab, and here we're going to type github.com/supersimpledev/javascript-amazon-project and press enter. You can also find the starting code in the description by clicking here, and then going to the links for this lesson. And on this page, we can see the starting code for the Amazon project. So this code contains all the HTML and CSS that we need. The reason we're going to use some starting code instead of writing all of this ourselves is because this course is focused on JavaScript, not HTML and CSS. If we were to write all of this code ourselves, it would just take up too much time, and it would be an entire course by itself. If you want to learn how to create this code, you can check out my HTML and CSS full course, which will teach you all the skills that you need. But for this JavaScript course, we're going to start with the HTML and CSS here, and we're just going to focus on adding JavaScript to this website. So now, let's download all of this code. We can do that by clicking this green code button here, and then click Download Zip. Once that's finished downloading, we're going to go to our Downloads folder. So for me, it's this folder right here called Downloads. And then we're going to unzip this file by double-clicking it. And this will give us a folder that contains all the code. So we're going to select this folder and move it to our desktop. Next, let's go to our desktop. So we're going to close this for now, and I'll hide the browser. And on the desktop, we're going to select the folder that we downloaded, and we're going to rename this. So at the end, we'll remove main and press enter to rename it to JavaScript Amazon project. Next, we're going to take this folder and open it in our code editor. So let's open VS Code, and we're going to click File, Open Folder, and we're going to find the folder that we downloaded. For me, it's on the desktop, and it's this folder right here. So we'll click this folder, and then click Select Folder. And then we can close this welcome message. Okay, So now we have our starting code, and we're going to set up the project. So first, let's open our browser again, and we can close the GitHub page, as well as the tabs for the previous lessons. So we'll close these tabs right here, but we'll leave the final Amazon project open. Next, let's go back to VS Code, and we're going to open this project in our browser. So we're going to select this file, amazon.html. So this file corresponds to the home page here. So let's select this file, and then right-click, open with Live Server. So I'm just going to rearrange my windows here so we can see these side by side. And now we're ready to begin. So let's take a look at the code that we have to start with. As I mentioned, all we have here is the HTML and CSS for this website. There's currently no JavaScript at all on this page. So one thing you'll notice is that we can actually create almost all of the website using just HTML and CSS. We actually don't even need JavaScript to create all of this. We're able to create the header at the top, as well as 3 products to start with. And this shows that HTML and CSS can pretty much create everything that we see visually on the website. Where JavaScript comes in is that JavaScript makes this website interactive. So right now, if we click the Add to Cart button, it looks pretty nice, but it doesn't actually do anything. And that's because we haven't added JavaScript yet. So the role of JavaScript is to make our website interactive after we created all the content and the styling. Now, before we begin adding JavaScript to this website, we're actually going to take some time and learn another very useful technology called Git. So Git is a technology that lets us track changes in our code. For example, do not follow along here, but let's say that I'm working on this website and I go into my code editor and I change some code here. So let's say that I add some code here, and then in this file, I'm going to delete some code. So I just select some code and delete it, and then save. And then in this file, I'm going to change some code at the bottom. So now, let's say that I made a mistake, and I want to undo all the changes that I just made. So how would I do that? How would I remember all the code that I changed in the different files? So right now, this is really difficult, and this is a problem that we run into in bigger projects. We're changing lots of code in different files, and it's really hard to keep track of what code has changed. And this is where Git comes in. Git lets us track changes in our code, and it helps us solve this problem. So here's what it looks like if I have Git set up in my project. I can go into this section of VS Code. This section is for Git, and then here, Git will tell me which files I changed. And if I click these files, it will tell me which lines I changed and exactly which code I changed. If I want to, I can click this button to reverse all the changes in this file. I can also click here to reverse all the changes in all the files. So as you can see, Git helps us track changes in our code, and it lets us easily undo our changes if we need to. And this technology is really useful in bigger projects, like this Amazon project, where we're going to be changing lots of code in many different files. So before we start this project, we're going to learn how to set up and use Git. The first thing we need to do is to install Git. To do that, we can go to this section of VS Code called Source Control. Now, if this section looks like this, with a button Initialize Repository, that means you already have Git installed. Otherwise, if you're on Windows, you can click this button and then click Open, or you can go to this website directly and then click this link to download Git. Once it's finished downloading, we're going to run the installer and then just go with the default options. If you're using a Mac, you can click up here and then type terminal and press enter. And inside here, you're going to type git and press enter. And then click this link and install Git. All right, after installing Git, we're going to restart VS Code. And make sure you have the Amazon project open. And now if we go into the Git section, it should look like this, with the button Initialize Repository. So now that we've installed Git, we're going to set up Git in our Amazon project. We can do that by clicking Initialize Repository. If this button doesn't work for you, you can also try going to the Terminal menu and click New Terminal. And then inside this terminal, type git init and press enter. So a repository is just a folder where changes are being tracked. By clicking Initialize Repository, this turns the current folder, which is JavaScript Amazon project, into a repository. And now all the changes inside this folder will be tracked by Git. So to start off, Git will tell us that all of these files are new files. And that's because we just set up this repository. So all of these files are considered new changes that we're starting to keep track of. Next, we need to configure a username and email with Git. Now don't worry, this information is not used anywhere online. This is just for Git to add an author to the changes that we make. So to configure a username and email, we're going to go to the top and open the Terminal menu and click New Terminal. And then inside here, we're going to type git config user.name and double quotes. Now, if this looks familiar to you and you've already done this before, you can skip this step and the next step. So between these double quotes, we'll pick a username that we want to use. So for me, I'll use SuperSimpleDev and press enter. And we'll also configure an email by typing git config user.email, double quotes, and between these double quotes, we'll put an email. So I'll put simon@supersimple.dev and press enter. So now that we configured a username and email, we can close this terminal. Next, we're going to save these changes into Git so that Git will start tracking any new changes that we make. To save these changes, we're just going to type a message here describing what we changed. So let's just type the message, add the starting files. And then we're going to click commit. And if this pop-up shows up, we're going to click yes. So that will take all of our changes and save them into Git. So now that we've saved those changes into Git, any new changes that we add will start showing up here. So let's do an example, and let's change some code in a couple of different files for practice. So let's click this icon up here to show our code, and let's go into amazon.html, and we'll just change this title to Intro to Git, and save. And then let's go into checkout.html. And at the top, let's actually remove the title and save. And then let's open orders.html. And at the top, let's just add something to the title, like page. If we save and then go into the source control section or the Git section, it will tell us all the changes that we just made in our code in the 3 different files. If we click one of these files, it will actually tell us exactly which code that we changed. Now, if your Git section looks like this, where the changes are on top of each other instead of side by side, if you want to, you can change this by clicking these 3 dots here, making sure that inline view is unchecked, and also unchecking use inline view when space is limited. So now it's very easy to undo this code. We can just take the code on the left and then copy paste it on the right to undo this change. We can also click here to undo all the changes in this file. And up here, we can also click this button to undo all the changes in all the different files. So that's an intro to Git. It helps us keep track of changes in our code, and it's very useful for bigger projects like this Amazon project, where we're going to be changing lots of code in many different files. If you want to learn about Git in more detail, you can check out my Git and GitHub full course in the video description. So now that we've set up Git, let's start the Amazon project. So first, make sure that this section is empty, and we've reversed all the changes that we made when practicing Git. Next, let's click this icon to show our files, and let's remove the previous code. And we're going to start in the amazon.html file. And let's close the Git page, and then open the tab for this file. It should say amazon.html up here. So we'll start by creating the list of products on the home page. So right now, we start with 3 products. If we go to the final project, we're going to add the rest of the products that you see here. And we're also going to make this interactive so that when we click the Add to Cart button, it will add this product to our cart. So let's go back to our project. And in order to create this, we're going to learn the main idea of JavaScript. So when using JavaScript, we usually do a 3-step process. The first step is to save the data. And then we generate the HTML. And finally, we make it interactive. Let's go through each step to create this list of products. So right now, we have 3 products on our page to start with, and we're going to add more products to this page. So let's start by finding the HTML for one of these products, because we can always just copy and paste this to create another one. Now we're going to learn a very important skill for bigger projects, which is how to find the code for something on this page. So let's say that we want to find the code for one of these products. We're going to right-click and click Inspect, and this will bring up the console. And I'm actually going to click these 3 dots and click this icon to move the console to a separate window so that we can see the whole web page. So now we're going to click this icon in the top left, and we're going to hover over and click the thing that we want to get the code for. So I want to get the code for this entire first product. So I'll click in this space, and this will tell us that the code for the product is this code, a div with the class product-container. So now we're going to take this class and then search for it in our code editor. So let's open VS Code, and we're going to type Control F on Windows or Command F on Mac to search for code in this file. So we're going to search for the class that we saw earlier, which is product-container. And this will take us to the code for one of these products. So we can actually click the arrow on the left to collapse this code, and we'll see another product container, which corresponds to the second product, we can click this arrow again, and we'll see a third product container, which corresponds to the third product. So that's how we find the code for something on the page. Now, to add another product to this page, one thing we can do is to take this HTML and just make a copy of it at the bottom of the page. However, this is not a good idea, because if we add lots of products, we're going to be copying this HTML over and over. And if we expand this, you can see that each product has a lot of HTML code. So we don't want to be copying all of this over and over again. It's going to be a lot of code, and it's going to be hard to manage. Instead, another strategy is to generate this HTML code using JavaScript. So let's learn how to do that. Before we can do that, we need to add JavaScript to this page. So we're going to create a JavaScript file. So let's click up here to show our files. And first, let's create a new folder to contain all of our JavaScript code. So let's name this folder Scripts and press Enter. Next, let's click on our folder, and we're going to click this icon to create a new file. And we'll name this file Amazon.js and press Enter. So this will be the JavaScript file for this HTML file. Next, inside this JavaScript file, let's type the code console.log hello, just to make sure that this works, and save. Next, we're going to load this JavaScript file in our HTML file. So let's go back to amazon.html, and then at the bottom of the code, we're going to scroll down, and then right above the closing tag for the body, we're going to add a script element. And we're going to give this element an attribute src, or source, equals double quotes, and we're going to load this JavaScript file. So this JavaScript file is in a folder called scripts. So here, we're going to type the folder name scripts and then a / to go into the folder, and we'll load the file amazon.js and save. So now let's go back to the page, and we'll open the console, right-click, inspect, and then click the console, and it should display hello. So now we're loading JavaScript on this page. So let's open up VS Code again, and we're going to generate all of this HTML using JavaScript instead. So the first step in our process is to save the data. What does this mean? Data means information. So in this case, the data is the information about our products. For example, the product's name, the price, ratings, and the image. So right now, the information about the products, or the data, is inside our HTML. So in our code, if we click here to expand this element, you can see that the information about the products, for example, the name and the image, is inside the HTML. So what we need to do is to take this data and save it inside our JavaScript so that our JavaScript can use it. So let's go to our JavaScript file, and I'm just going to put it down here so we can see it side by side. And we're going to move this data into our JavaScript. So let's remove console.log, and let's create a variable to save the data. So we'll type const, and let's name it products, and make it equal. And now we want to create something that closely matches our data. So in this case, we have a list of products. So in here, we're going to create an array, because an array represents a list. And now each product in the list has many values, like an image, a name, and a price. So we're going to use an object to represent each product. because an object lets us group multiple values together. So inside this array, we're going to create an object using curly brackets. And now inside this object, we're going to save the data for the first product. So first, let's find the data in our HTML. We're going to search for the product's name by typing Control F or Command F, and we'll search for black and gray. And this will take us to the code for the first product. So this is the name of the first product. So let's actually scroll up, and we're going to get the image for the first product. And we're going to take this and save it in our JavaScript. So let's select this code. We're going to right-click, copy, and then inside this object, let's create a property called image, colon, and then here, right-click and paste. And let's save this as a string. So at the front, we'll type a single quote, and at the end, we'll type a single quote. So we just saved the image inside our JavaScript. Let's move on and save the name inside our JavaScript. So we'll scroll down, we'll select this code, and then right-click, copy, and in this object, we'll type comma and a property called name, colon, a string, and we'll right-click and paste. Next, we're going to save the rating into our JavaScript. So we'll type comma, and let's create a property called rating, colon. For the rating, there's actually two parts, the stars and the number of ratings that it has. So let's actually group these two values into an object because these values are related to each other. So in here, we'll make the rating an object. And each rating will have the stars, and for the socks, it's 4.5, comma, and the rating will also have a count. And for the first product, it's 87. Next, let's save the price into our JavaScript. So we'll create another property called price. And for the first product, the price is $10.90. However, JavaScript has problems doing math with decimal numbers or floats like this. So a best practice when calculating money is to calculate in cents instead of dollars. So for this reason, we're going to save the price as cents. So we'll save it as 1,090 cents. As a reminder, $1 is equal to 100 cents. And because we're saving in cents, it's helpful to rename this property to price cents instead. So now if we scroll up, we just saved all the information or the data about the first product into our JavaScript. Next, let's go to the end here and type comma and create another object. And we're going to save the data for the second product into this object. So feel free to pause the video if you want to try it yourself first. So again, let's find this product in our HTML. We'll go to our HTML and type Control F or Command F to search for code. And we'll search for the name intermediate size basketball. So now this is the code for the second product. We're going to scroll up a bit and find the image for this product, and we're going to select it, right-click, copy, and then inside the second object, we'll create an image property, just like we did up here. And we'll save it as a string, and we're going to right-click and paste. And let's type comma, and we'll save the name inside the second object. So we'll scroll down and select the name, and then right-click, copy, and then down here, create a string, and right-click and paste. And we'll type a comma, and we'll save the rating, object, and we'll save the number of stars, which is 4, and the number of ratings that it has, count, 127. And finally, we'll type a comma, and we'll save the price of the product in cents, 2,095 cents. So now the data for the second product is saved inside our JavaScript. Let's go to the end and type comma and create another object. And we're going to save the data for the third product inside. Again, feel free to pause the video to try it yourself first. So let's save the image. We'll find the code for this product in our HTML. So up here, we'll type Control F or Command F, and we'll search for the product name, which is Adults Plain Cotton T-shirt, and scroll up, and we're going to save the image first. So let's select this, right-click, copy, and then down here, create an image property, and a string, and then right-click and paste. And we'll create a comma, and let's save the name in our JavaScript next. Create a string, and then we'll scroll down here. We'll select the name, right-click, copy, and then in here, right-click and paste, and comma, and we'll save the rating, and object, and we have the number of stars. For this one, it's 4.5, and the count. And for this one, it is 56. And lastly, type a comma, and we'll save the price in cents, $7.99. And now let's save our JavaScript file. Now, one really important thing is to make sure that in each of these objects, we have the same properties. So we have the image property, the name property, and the same rating property with the same structure. We want all of our objects to have the same structure so that our code can handle each product the same. So that's what it means to save the data. We create something in JavaScript that closely matches the data that we have on the page. By the way, this is called a data structure because it structures or organizes the data, and this represents a list of products. So we usually use a combination of objects and arrays to create a data structure in JavaScript. So now that we've saved the data, the next step is to use this data to generate the HTML instead of writing the HTML manually. To generate the HTML, we can loop through this array. And for each of these products, we're going to create some HTML. So let's go ahead and loop through this array first. We'll scroll down to the bottom, and we'll type the name of the array, which is products, and then we'll loop through this array using a for each method. So we'll type dot for capital each brackets, and inside we'll create a function using brackets, arrow, and curly brackets, and we'll give it a parameter called product. So I'm going to move this back to the top here so we can see more of the code. So the way that for each works is that it takes each object, saves it in this parameter called product, and then runs the function. So it takes the first object, saves it in product, runs a function, takes a second object, saves the product, runs a function, and so on. So for each of these products or each of these objects, we want to create some HTML. So inside this function, let's create a variable, const HTML equals, and we'll create a template string using backticks. And now inside this template string, we're basically going to copy all the HTML for one of these products. So let's go back to our HTML file. And how do we find the HTML for one product? So we learned this earlier. We can right-click, inspect, and then click the top left icon, and click the element we want to get the HTML for. So this HTML represents one product, and we can search for this class product-container in our code. So we'll go back to our VS Code. Inside the HTML file, we can Control F or Command F to search for code, and we'll search for the class product-container. And let's go to the first result. So we'll go to the first result, which is here, and let's copy all of the code inside this element. One trick we can do is to click the arrow on the left to collapse it, and then we'll select all this code, and we'll right-click, copy, and then inside our JavaScript file, inside the string, we're just going to right-click and paste the HTML. And if we need to fix the formatting, we can select all of this code and then press Tab a few times to add some indents. And here we can remove the indent. And let's save. So now we're basically looping through the array of products, and for each product, we're creating all of the HTML that we had before. So we're generating this HTML using JavaScript. Now let's console.log this HTML to make sure that it's working. We'll scroll down to the bottom. And here, let's console.log the HTML that we just created. If we save and then go back to our page, right-click and inspect, and click the console, you can see in the console that we just generated all this HTML, and we generated 3 of these. Let's go back to our code and scroll up. Now, one problem here is that in the HTML that we generate, we don't want to have the name black and gray socks every time. For the second product, we want to have a different name and a different image. And for the third product, we want to have a different name and a different image. So how do we create slightly different HTML for each product? To do that, we're going to replace this part of the code with whatever the image property is. So for here, we're going to delete it, and we're going to insert the property image into this string. So to insert values into a template string like this, we can use $, open curly bracket, close curly bracket. And then inside here, we're going to insert the product.image property. So it's going to take whatever the image property is of the product and put it inside this HTML code. Same thing for the name. Instead of black and gray socks every time, we're going to delete this and then insert a value. We're going to insert the product dot, and we'll insert the name property this time into this HTML. So dot name. And we'll do the same thing for the other pieces of data. So for each product, the number of stars could be different. So instead of 4.5 every time, let's delete this, and we're going to insert the product's rating and stars. So product dot rating dot stars. One thing we have to watch out here for is that this image has to exist. So right now, if we substitute the product.ratings.stars into this, we will get this image. And if we go into our files by clicking here and open the images folder, and then open the ratings folder, we can see that there's no image called rating-4.5. Instead, there's an image called rating-45. So if the rating is 4.5, we should convert it into 45 so that this image actually exists. Similarly, if the rating is 4, we should convert it into 40 so that this image actually exists. So in here, we should actually multiply this by 10 so that this points to an actual image that exists here. Next, let's move on. And we'll work on replacing the count. So we'll remove this and dollar curly brackets, and we'll replace it with the products dot rating dot and the count property. So count. And finally, we're going to replace the price for each product. So in here, we're going to remove this and substitute product dot price cents. And remember that this is a number in cents, but when we display it on the page, we want to display it as dollars. So we're going to divide this by 100 because there are 100 cents in each dollar. So now in the HTML that we're generating, we're actually inserting the details about each product. If we save and then go back to the console, right-click Inspect and Console, and look at the HTML that we generated, you'll see that it's different for each of the products. So that's how we use JavaScript to generate all the HTML here. So now the last step is we're going to combine all this HTML together into one string and put it on the web page. Let's go back into VS Code, and to combine all this HTML together, let's create a variable at the top for combining all the strings together. So we'll type let's call it products, capital HTML, and make it equal to an empty string to start. And then each time we go through the loop, we're going to add this HTML string up here. So instead of creating a new variable, we're just going to add products HTML equals itself products HTML plus this string. And remember, a shortcut for this is to just type plus equals. So this is called the accumulator pattern. We loop through an array, and each time we're adding to the result. So we're accumulating the result. And now that we combine all the HTML into this variable, we can scroll to the bottom. And let's remove this line because this doesn't exist anymore. And then after the loop, let's console.log the products HTML and save. And now if we go into our console, we combined all the HTML for all the products together. And now the last step is to take this HTML and put it on the page. And we can do that using the DOM. So let's go back into our code. And to use the DOM, we're first going to get an HTML element from the page and put it inside our JavaScript. So first, let's go to our HTML file. And remember that a product-container represents one of these products here. So we're going to look for this element here, a div products-grid. So this element contains all of our products. So we're going to use the DOM to take this element, put it into our JavaScript, and replace all the HTML inside. So to put this element in our JavaScript, we're going to give it a class. So let's add a class js-products-grid and save. And let's go into our JavaScript. So I'm just going to move this down to the bottom again so we can see it side by side. And then inside our JavaScript, at the bottom, we're going to use the DOM by typing document.querySelector, brackets, and a string. And we're going to type dot to select a class, and we're going to select js-products-grid. So the dot means we're going to look for a class called JS-products-grid, which is right here, and it's going to take this element and put it inside our JavaScript. And now we can change the HTML inside the element. To do that, we'll use the property dot inner capital HTML, and we'll change it to the products HTML that we created above. So products capital HTML and save. So it's not going to look any different, but now we're actually generating all the HTML with JavaScript and then using the DOM to put this HTML inside here. So now we can actually delete all of this because we're generating this with JavaScript. If we save this file, our products will still be here because even though we deleted the HTML, we're now generating it with JavaScript. Now, one problem that I see here is that the price shows up with 1 decimal, but we actually want it to show up as 10.90. So let's scroll up to this part in the code. So we'll scroll up here and look for price cents. And the reason this happens is because price cents is 1090. So if we divide that by 100, the result is actually 10.9. If we want to force this to show 2 decimals, like 10.90, we actually have a special method that we can use with a number. So here, we can add brackets around this to make sure we calculate this number first. And numbers have a special method called dot to capital fixed and brackets. So to fixed will convert a number into a string, but we can tell it how many decimals we want between the brackets. If we type 2, it will show 2 decimals. So if we save, now it shows correctly on the page. If you're wondering how to find this method, you can find it by searching in Google or using an AI tool. Okay, let's take a break here and take a look at Git to see all the changes that we made. So I'm going to expand this here, and we're going to click the Git section. And it's going to tell us that we changed 2 files. If we click the HTML file, Git will tell us that we deleted all of the HTML code for the products, which is correct. If we open the JavaScript file, Git will tell us that we added all of this new JavaScript code, including the data and the loop for generating the HTML. So Git helps us track all of the changes that we made. So now let's actually take these changes and save them into Git so we can track new changes. At the top, let's type a message to describe the changes that we made. So let's type generate HTML with JavaScript and click commit and yes if this shows up. So now let's talk about the benefit of generating the HTML. So let's close Git for now, and I'll move this to the side here. So the benefit of generating the HTML is that if we want to add another product, we don't have to copy paste all of this HTML again. All we need to do is to go up to the data and add the data for a new product. So let's do an example and add a fourth product to our list. So at the end here, let's type a comma and create another object. And let's go to the final project. And we'll scroll down to this fourth product here. So we're going to take the data about this product and save it in our JavaScript. So first, let's create a property image :string, and we're going to take this image and put it in here. To do that, we can right-click the image, inspect, and then we're going to copy this source attribute. So we can double-click it, and we can select this attribute, right-click, copy, and then inside our JavaScript, we're going to right-click and paste. And at the end, we'll type a comma and create the name property and a string, and we're going to select this name, right-click, copy, and then in here, right-click, paste, comma, and a rating property, :, and object. We have the stars, which is 5, and the count, which is 2,197. And at the end, we're going to add the price in cents, $1,899. So now if we save this JavaScript file and then go back to our project and we scroll down, you'll notice that it automatically added the fourth product. And all we had to do was to add another object to our array. And then our loop will handle generating all the HTML for us. So you can see that generating the HTML with JavaScript is a lot easier than copy pasting this HTML every time. And that's why we use this technique. Next, we're going to add the rest of the products in the final project. Now, one thing we could do is to manually copy this over one by one, but to make this easier, inside the starting code, I've actually created a file that contains all the data. So if we scroll up and close this for now, and we're going to go to this data folder and open it. And inside this folder, I've provided a JavaScript file called products.js. And in here, it contains an array with the data for all the products in the final project. So we don't have to create it ourselves. So now let's use this products array in our code. So first, we need to load this file on our page. We can go to our amazon.html file and then scroll down to the bottom. And then at the bottom, in the script element, we're going to add another script element above it. So we'll type script, and then the source is going to be equal to this JavaScript file. So we'll type the folder called data, and then a slash to go into the folder and load the file products.js. So what this does is that it will run the files one by one. First, it will run the products.js file and create the array, and then it will run our amazon.js file and generate the HTML. So back here, let's save, and then go back into amazon.js. So now, instead of using our own products array, let's just use the products array in this file. So we'll go back to amazon.js, and we're just going to delete this array. So over here, we can click this arrow to collapse the code, and we're going to select it, and then just delete it. And save. So now this variable will be coming from this file. If we go back to our project and scroll down, you can see that we created all the products in our final project. So the way this works is that inside our amazon.html, we're loading two JavaScript files. this JavaScript file creates all the products, and then this JavaScript file loops through the products and creates all the HTML. So keep in mind that script elements are loaded one by one, so the order matters. We have to first create the products array, and then we can use it. If these two were reversed, then the code wouldn't work. So this is how a real-world website is created. We don't write all the HTML manually. Instead, we save the data for the website in a data structure like this, and then we use JavaScript to generate the HTML using the data. So now let's go into Git and look at our most recent changes. So here it will tell us that we changed two files. In the amazon.html file, we added a script element, and then in the amazon.js file, we deleted the products array that we created on our own. So let's type a message to describe our changes. Use products.js file, and then click commit, and yes. Now, one other thing I want to show you about Git is if we go back to our files here and then open amazon.js, Git has a really useful feature called a history. So we can open this timeline section and then click this filter icon and only check Git history. And now you can see that we actually have a history of all of our changes for this file. So if we click the first line in the history, it will show us that here we added all of the code. And then the second line in the history, we deleted this part of the code. So this gives us a step-by-step history of all the changes in our code. And in Git, this is called a version history. You can also see that the messages that we created when we commit show up here. And these messages help us understand what was changed in each version in the history. All right, so let's close this for now. And the last step in the process is to make it interactive. So let's take a look at our current project. So we'll go here and open this tab, and let's scroll up. So right now, if we click the Add to Cart button, it doesn't do anything. So we're going to add some JavaScript to make this interactive and actually add this product to a cart. So first, let's find the Add to Cart button in our code. We'll go back to our amazon.js file, close this for now, and to find the code, we can actually just search the text in the button. So inside here, let's type Control F or Command F, and we're going to search for the text Add to Cart. And this will take us to the code for this button. So now we're going to add an event listener to this button and make it do something when we click it. To add an event listener, we're first going to add a class js-add-to-cart, and then we're going to use the DOM to add an event listener to this button. So down here, after we've put this HTML on the page, we're going to use document.querySelectorAll, brackets, and then a string, a dot, and we're going to select all the js-add-to-cart. So js-add-to-cart. So this will give us a list of all the add to cart buttons on the page. And then we can loop through each of the buttons. So we can type dot for each, brackets, and then in here, we'll give it a function, bracket, arrow, and curly brackets, and a parameter. So the parameter is going to be the button element that we got from the page. So now for each of these buttons, we're going to add an event listener so we can do something when we click the button. To do that, we'll type button dot add event listener, brackets, and then the event that we want to listen for, which is the click event, and then a function that we want to run when we click this button. So brackets, arrow, and curly brackets. So for now, let's just console.log a message to make sure that this is working. So we'll console.log added product and save. And we can also remove this line for now because we're not using it. And save again. And then now on our page, we're going to click Add to Cart and then look inside our console. So right click, Inspect, and click the console, and it displays Added Product. So now whenever we click one of these buttons, it will display this message. So that means that our code here is working correctly. Next, we need to figure out how to add the product to a cart, and we need to figure out what this looks like. If we think about a cart is basically just a list, and inside this list, we have the product that we want to buy and the quantity or the number of this product that we want to buy. So we can actually represent this in JavaScript as an array. Inside the array, we can have some objects, and each object is going to contain the product and a quantity. So we can use something like this to represent our cart. So let's go ahead and create this cart array. Now to keep things cleaner, let's actually separate the cart into its own file. So we'll click up here to show our files, and then we'll go into the data folder and click this folder and click this icon to create a new file. And we'll name this file cart.js and press enter. So this file will contain all the code relating to the cart. And the reason we separate it is to keep our code organized. Each file will focus on one particular thing. So inside cart.js, let's create our cart. So we can just create a variable const cart and make it equal to an array. So we'll start off with an empty cart. And let's save this file. And now we need to load this file into our HTML. So we can open amazon.html. And again, we can just add another script element. So let's add it at the top to make sure we load the cart before running the rest of our code. So we'll type less than script and the attribute source, and we'll load the data folder / to go inside cart.js and save. So now it will run this file at the start, and it will create an array representing our cart. So now that we have a cart, we need to figure out what happens when we click a button. How do we add a product to this cart? So let's go back into amazon.js and we'll figure this out together. So down here, this is the function that is run when we click the button. So in here, we have to figure out how to add this product to the cart. One way to do this is to just add an object to the cart, like this. We have the product's name and the quantity that we want. However, when we click this button, how do we know which product we're supposed to add to the cart? To solve this problem, we're going to learn a feature of HTML called a data attribute. A data attribute is just another HTML attribute, except the purpose of a data attribute is that it allows us to attach any information to an HTML element. So let's do an example and create a data attribute. We're going to scroll up to the Add to Cart button here, and then at the end of the opening tag, after the class, we'll type enter, and then we're going to type data dash, and then we can type any name that we want, like product dash name. and we'll make it equal to double quotes. And then inside the double quotes, we're going to put the product's name, like a basketball or a t-shirt. So to do that, we're going to insert using $ and curly brackets, product.name, and save. So now let's inspect the HTML on the page. We're going to right-click on this Add to Cart button and inspect. And then in the Elements tab, it will show us the HTML for the button. And now you can see that each of these buttons now has a data attribute called data-product-name, and it's equal to the product name. So before we continue, let's learn the syntax rules for the data attribute. A data attribute is just an HTML attribute. That means it follows the same syntax rules. We have an attribute name on the left and an attribute value on the right. The one difference is that data attributes have to start with data dash. And then we can give it any name that we want, like product-name. But we have to make sure to separate the words with a dash. This is also known as kebab case. So the purpose of a data attribute is that we can attach any information to an element. So here we attached the product name to this button, but we can also attach the product's image or the price and so on. So now that we attached the product's name to this button, when we click this button, we can actually get the name, and this will tell us which product we should add to the cart. So let's see what this looks like in our code. So we'll go to our code, and then when we click the button, we're first going to get the product name from the button. To do that, we're going to type button and then the property dot data set. So the data set property basically gives us all the data attributes that are attached to this button. So now we're able to get the product name. So let's console.log this to see what it looks like. Console.log, open bracket, close bracket, and save. And then in here, let's click the basketball's Add to Cart button, and we'll go into our console, right-click, inspect, and the console. And I'm just going to move this to the left so we can see it side by side with our code. So this is what the dataset property looks like. It gives us all the data attributes that are attached to the element. So in our case, we have the product name. Now this works just like an object. So to access the product name, we just have to type dot product N name. So notice that the name gets converted from kebab case to camel case. So now if we save, and let's go back to our website and click the Add to Cart button, it will get that data attribute from the button and display it in the console. If we click the socks Add to Cart button, this will tell us which product we should add to the cart. So now that we have the product name, let's actually put this into our cart. So let's go into our code, and here, let's save the product name in a variable called const product name equals, and then here, we're going to add this to the cart. So we already created a cart variable here. So we're just going to type the variable cart, and we're going to dot push into the array. And let's push an object because we said we wanted a product and the quantity. So we'll add an object containing the product name, which is this variable product name, and a quantity of 1. And that's pretty much it. We first attached the product name to the button using a data attribute, And then when we click the button, we got the product name out. And then we add the product to the cart. So at the bottom, let's console.log the cart to see what it looks like. If we save and then go here and open the console, right-click, inspect console, and let's add a basketball to our cart. So we'll click here, and then in our cart, we now have a basketball with a quantity of 1. So now let's add another product to our cart. We'll go to the t-shirt and click Add to Cart. And now we have 2 products in our cart, 1 basketball and 1 t-shirt. So now we're successfully adding products to a cart. Next, let's try adding 1 t-shirt again. If we click Add to Cart, and unfortunately, this doesn't look quite right. The t-shirt product is repeated twice, and each of them has a quantity of 1. What we actually want to do is we want 1 t-shirt product with a quantity of 2, because this is how we're going to display it on the cart page. So let's figure out how to achieve this, and we'll do this step by step. First, we'll check if the product is already in the cart. If it is in the cart, we'll just increase the quantity by 1. If it's not in the cart, we'll add it to the cart. So let's convert these steps into code. So the first step is to check if a product is already in the cart. So how do we do that? Let's go back to our code. And one way to check this is we can loop through our cart and look for a particular product name. So up here, let's create some new lines, and let's check if this product name is already in the cart array. So we'll type cart, and we'll loop through the cart using dot for each, brackets, and then inside we'll give it a function, brackets, arrow, and curly brackets, and we'll give this a parameter, and let's just call it an item. So an item will contain a product name and a quantity. So we want to see if this product name is already in the cart. So we're going to check if the product name over here is equal to this item's product name. So we'll type equals the item dot product name and curly brackets. So if the product names match, that means this product is already in the cart. So let's save this matching item in a variable so we can use it later. So we're going to create the variable outside the for each loop and outside of its scope. So we'll type let matching capital I item, and we'll make it undefined to start. And if we find a matching item, we're going to save it in this variable. So matching item equals item. So this is how we figure out if a product is already in the cart. Now the next step is if the product is in the cart, we'll just increase its quantity by 1. So we'll type if matching item and curly brackets. So we can just type matching item here, because if we did find a matching item, it will be an object, which is a truthy value. So in here, we're going to increase the matching item's quantity by 1 using matching item dot quantity, and we'll plus equals 1. And finally, if the product is not in the cart, we'll add it to the cart, which is basically what we do here. So at the end, we can just type else if we did not find a matching item, curly brackets, and we'll move this code. So we'll select it, right-click, cut, and then in here, right-click and paste. and remove the new lines and save. So now let's go into our project. We'll right-click, inspect the console, and let's click the Add to Cart button for the basketball. So we'll click this, and then in our cart, we have a basketball with a quantity of 1. Let's add a t-shirt, and now we have 1 t-shirt with a quantity of 1. And if we click Add to Cart on the t-shirt again, now we have a t-shirt with a quantity of 2. So that's how we solve the problem of combining the quantities together. Now there's one last problem that we have to solve here, which is it's not good to use the product name to identify the product in the cart, because in an e-commerce website, we might actually have 2 products that have the same name, but from different brands. So to fix this, we should give each product an ID. And this ID should be unique, so no 2 products will have the same ID. So let's use an ID to identify these products instead of using the name. We'll go back to our code, and if we open our files here and go to data.products.js, you'll notice that I've actually added an ID for each of these products, and this ID is unique. So I added it here to save us a bit of work, so we don't have to create the IDs ourselves. So now let's just use this ID in our code. So we'll go back to amazon.js, and then in here, instead of using the product name, we're going to use the product's ID to identify it in the cart. But first, we need to attach the ID to the button. So we'll scroll up, and instead of a data-product name attribute, we're going to use a data product-id attribute. And we're going to save the product's ID instead. And now down here, we're going to grab the ID from the button. To do that, we'll change this to product ID. So remember, this gets converted from kebab case to camel case. And we'll rename this variable product ID. And then here, we'll compare product ID is equal to the item's product ID. And lastly, when we add to the cart, we're just going to add the product ID to the cart. And save. So now if we go to our website and click Add to Cart and check our console and expand this, you can see that we're saving the product ID so that 2 products with the same name will be able to be added to the cart. Okay, so that's how we make the Add to Cart button interactive. And now we finished all 3 steps. First, we save the data for the website in our JavaScript, and then we use this data to generate the HTML. And finally, we made it interactive. And this is the main idea of JavaScript. This is generally how we use JavaScript on a real website. Now let's go back to Git. So we'll open our code editor and open the Git section and review the changes that we made. So we'll expand it, and then in the HTML file, we just added the cart.js file, and then in here, we just created the cart array. And in our amazon.js file, we basically added a data attribute to the button, and then down here, we made the button interactive by adding an event listener. So now let's save these changes into Git. We'll type a message to describe our changes, make add to cart button interactive, and click commit. All right, so let's close this for now. And the last feature we're going to create in this lesson is we're going to make this cart quantity in the top right interactive. So we'll do this step by step. First, we need to calculate the quantity, or the total number of products in our cart. And then we're going to put that quantity on the page here. So how do we calculate the total quantity of the cart? So remember that the cart is an array of objects, and each object has a quantity. So to calculate the total quantity, we can loop through this array and add the quantities together. Let's go into our code, and we'll open amazon.js, and let's scroll to the bottom. So here, after we update our cart, we're going to calculate the total quantity. So let's create some new lines. And as we saw earlier, we can loop through the cart array. So we'll type cart.forEach, brackets, and a function, arrow, and curly brackets. And we'll give this a parameter item. So this is going to loop through each object in the cart. Next, we need a variable to store the total quantity. So let's create a variable up here. We'll type let and name it cart quantity and make it equal to 0 to start. And then as we loop through this array, we're going to add the item's quantity to this variable up here. So here we can type cart quantity plus equals the items dot quantity. So this will add up all the quantities and save it in this variable. So at the bottom, let's console.log the cart quantity to make sure that this is working. So we'll save and go back to our page and open the console, right-click, inspect, and console. When we click Add to Cart on the basketball, the quantity will be 1. If we click Add to Cart on the t-shirt, the quantity will be 2. If we click again, the quantity will be 3. So looking at the cart, it basically added 1 basketball and 2 t-shirts to get a total of 3. So that's how we can calculate the total quantity of the cart. So now that we have the total quantity, we're going to put it on the page here. And we can do this using the DOM. So let's go back to our code. And to use the DOM, we first need an HTML element where we're going to put this quantity. So let's find the HTML element for this number here. We can go back to our page. We're going to right-click this number and then inspect. And then we can click this icon in the top left, hover over this number, and click it. So this will tell us that the code for the number is this code right here, a div with the class cart quantity. So now we're going to search for this class cart quantity in our code. So let's go back to our code, and let's go to the amazon.html file, because the header is still in this file. And we'll type Control F or Command F to search for code, and we'll search for cart-quantity. And it will tell us that it's this line right here. So next, to use the DOM, we need to get this element into our JavaScript. To do that, we're going to add a class to this element. So let's add the class js-cart-quantity and save. Now let's go back to our JavaScript file, and I'm just going to move it down here so we can see it side by side. And we'll scroll down. After we calculate the quantity, let's get this element into our JavaScript using the DOM. So at the bottom, we'll type document.querySelector, brackets, and a string. We'll start with a dot and the class js-cart-quantity. And now that we have this element, we can change the HTML inside using the property dot inner capital HTML. And we'll make it equal to the cart quantity that we calculated above. So let's save and go back to our website. And let's click the Add to Cart button for the basketball. Now it will update the quantity to be 1. Let's click the Add to Cart for the t-shirt. It will update the quantity again, and it will be 2. If we click it again, it will increase to 3. So now the cart quantity up here is interactive. The last thing we need to do is we'll go back to our HTML, and instead of starting at 3, the cart quantity should start at 0. So let's save. And now the cart quantity starts at 0. If we click Add to Cart, it will increase to 1. So that's how we create this cart quantity feature in the final project. So now we're finished all the features that we're going to do in this lesson. Let's go back to our JavaScript, and I'm just going to move it back up here. And let's clean up this code by removing these console.logs. And save. And finally, let's check Git one more time to see the changes that we made. So we can expand this and go to the Git section. If we click amazon.html, it will tell us we added this class. And if we click amazon.js, it will show us the code that we added for calculating the cart quantity and putting it on the page. So finally, let's type a message to describe our changes. Make the cart quantity interactive and commit. So now we can close this. And that's the end of this lesson. In this lesson, we started the final Amazon project. We set up and learned how to use Git to track changes. We learned the main idea of JavaScript, which is save the data, generate the HTML, and make it interactive. We created a list of products on the homepage. We made the Add to Cart button interactive, and we made the cart quantity interactive. Thanks for watching this course so far. If you want to support this channel, you can check out the premium version of my courses just like this one, where you can get a certificate of completion and a better learning platform. If you're interested in extra videos from me, more in-depth videos, and behind-the-scenes content, you can check out these links here. You can also support the channel by liking the video, subscribing, and sharing this video with others. Thanks again, and let's continue with the course. Here are some exercises to help you practice what we learned in this lesson. In this lesson, we're going to learn a feature of JavaScript called modules, which is a better way to organize our code. So first, let's take a look at a problem that we have in our current code. We're going to go to our files here, and we're going to open amazon.html. And then we're going to scroll to the bottom of this file to our script tags. So right now, we're using 3 script tags to run all of our JavaScript. So this runs all the code in cart.js, and then it runs all the code in products.js. And finally, it runs all the code in amazon.js. So this is basically the same thing as combining all the files together into one big file and then running all of our code. However, there's a big problem with using script tags like this. And that problem is it can cause naming conflicts. So in our situation here, we created a variable named cart in cart.js. This means we can't use the variable named cart in any of our other files. So for example, if we went to amazon.js and then we scroll to the top here, and let's say that we try to create another variable named cart. So at the top, we type const cart equals square brackets and save. And now if we go back to our project, you'll notice that the website stops working. And if we right-click, inspect, and open the console, it will tell us that we got an error, and it says that cart has already been declared. So this is happening because we created a variable called cart in cart.js, and then later in amazon.js, we created another variable named cart. Now we can't have two variables with the same name in JavaScript, and this causes an error, and it causes our website to break. So this is called a naming conflict when we have two variables with the same name. So the big problem with script tags is if we go back to our code, you can see here that it's really hard to tell which variables have been created in other files. And it's really easy to accidentally create a naming conflict like this. So that's the problem with using script tags like this and running our code one file at a time. It's very easy to get naming conflicts. So now we're going to learn how to solve this problem using a feature of JavaScript called modules. So a module basically contains a variable inside a file. So now this variable is not going to cause conflicts with anything outside the file. For example, in our project, we created a variable called cart, and we want to contain this variable inside the cart.js file so that it doesn't conflict with the cart variable inside the amazon.js file. So we can do this using a module. So now let's learn how to create our first module. We're going to go back to amazon.html. And then here, to create a module, we're simply going to delete this line of code that uses a script tag to load cart.js. So we'll delete it and save. And you'll see that the website is working again. So how does this work? When we use a script tag, it will run all the code inside cart.js. So this code will create a cart variable, and this will cause a naming conflict. By removing the script tag, we're no longer running the code inside cart.js. So we're no longer creating a cart variable, and it will no longer cause a naming conflict. So to create a module, we simply do two steps. Number one, we create a file and write our code inside the file. And number two, don't load the file with a script tag. By doing this, any variables we create inside the file will be contained inside the file, and it won't cause naming conflicts. So that's basically how we create a module. Okay, so now we run into another problem in our code. If we open amazon.js, we created this cart variable as an example, but what we actually want to do is to keep the cart variable inside cart.js because we want to keep all the code that's related to the cart inside this file. So in amazon.js, we're going to delete this code. And if we save and then go back to our project and click Add to Cart, you'll notice that it no longer works. So let's look at the console again to see what error we get. We'll right-click, inspect, and open the console. And it's going to tell us that cart is not defined. So the problem that we have here is that in this file, we're using the variable cart. But now, because we're not loading cart.js using a script tag, the cart variable doesn't exist anymore. it's contained inside cart.js, and we can't access it from the outside. So now we're going to learn how to get a variable out of a file or a module. To do that, we're going to do 3 steps. The first step is to add a type equals module attribute. The second step is to export, and the third step is to import. Let's learn these steps one by one. So the first step is to add a type equals module attribute. We're going to open amazon.html, and we're going to scroll to the bottom, and here in the last script tag where we load amazon.js, we're going to add an HTML attribute here. So we're going to type equals module and save. So the type equals module attribute basically lets this file get variables out of other files. It basically enables this feature. Now the second step is to export. So we're going to go to cart.js, and now we're going to choose which variables can be accessed outside of this file. So for example, we want to access the variable cart outside of this file. To do that, in front of the variable, we're just going to type the word export and space and save. So now this variable can be used outside of cart.js. The last step is to import. So we're going to go to the place where we're going to use this variable, which is inside amazon.js. And now at the top, we're going to tell the computer which variable we want to get from another file. So we'll type import, open curly bracket, close curly bracket, and between these brackets, we're going to give the name of the variable we want to get, which is the cart variable. And then we'll tell the computer which file we want to get this variable from. So we'll type from single quotes and semicolon. And now inside these quotes, we're going to locate the file using a file path. So let's open up our files here so it's easy to see what files we have. So right now we're in amazon.js, and we want to locate cart.js. So the first step is we actually need to get out of the scripts folder. We're in the scripts folder, and we need to get out of it and into the data folder. So to get out of the current folder that this file is in, we're going to type ... So ... basically represents the folder outside of this current folder, which is this folder right here, JavaScript Amazon projects. And then we're going to type a / to go outside of the scripts folder. So now that we're outside of this folder, we're going to go into the data folder. So here, we're going to type data and then a / to go into this folder, and we're going to locate the file cart.js, and save. So what this code does is that it's going to take the variable cart out of the file cart.js, and we use this file path here to locate that file. So as a reminder, ... means to go outside of the current folder, outside of scripts, into here, and then we go into the data folder, and then inside the data folder, we find cart.js. So those are the 3 steps to get a variable out of a module. First, we add a type equals module attribute to enable this feature, and then we export the variables that we want to get out. And finally, we import the variables when we need them. Now there's 2 more things that we need to know about modules. Number 1, we have to put all of our imports at the top of the file. And number 2, in order for modules to work, we need to use live server. So for example, if I open the folder that contains amazon.html, so I open JavaScript Amazon project, and then I select this HTML file and right-click, open with Google Chrome, the website won't work. And that's because modules don't work if we open the HTML file directly like this. So let's close this for now. And to get modules to work, we need to open our code editor and then right-click the HTML file and open with Live Server. So in this course, in order for modules to work, we need to use Live Server to open our HTML files. So now that we learned how to use a module, let's talk about the benefits of modules. The first big benefit is that it helps us avoid naming conflicts. The only time that this causes naming conflicts is if we import this variable and we have another variable named cart inside this file, like this. So this will again create a naming conflict. If I save this, the website will stop working. But at least now we have control over when naming conflicts happen. They will only happen if we import the same variable name. Now modules have another feature that allows us to avoid this problem as well. So after the variable name that we import, we can type as and then a different name, such as my cart, and save. So this will basically take the import and rename it to my cart, so that this will no longer conflict with this variable name. So as you can see, modules have a lot of features that help us avoid naming conflicts when we have lots of files in our project. So now I'm just going to delete this and put the code back because that was just an example, and save. So the second big benefit of modules is that we don't have to worry about the order of our files. Before, when we loaded everything with script tags, we had to make sure that we load cart.js first, because we need the cart variable to be created, and then we can use it in amazon.js. So the order of our script tags really matter, and it becomes really hard to manage when we have lots of files in a big project. But now with modules, we can just import the variables that we need, and we don't have to worry about the order that we're loading our files. So as you can see, modules are a better way to organize our code, especially in bigger projects. So now let's use Git and save our changes. So we'll go to the Git section here, and it will tell us we changed 3 files. In amazon.js, we removed the script tag and added type equals module. In cart.js, we exported the cart variable. And in amazon.js, we imported the cart variable from cart.js. So now let's save these into Git. So here we'll type a message, use modules and import cart from cart.js, and commit. Now that we learned modules, let's use them in more places in our project. So let's close this for now, and we're going to open amazon.html. And next, we're going to turn products.js into a module as well. So we'll start off by deleting the script tag, because the script tag will just load all the code onto the page. So we'll delete this and save. So notice that our website stops working. And now inside amazon.js, we need to access products from products.js. So again, we're going to do 3 steps. The first step is to add a type equals module attribute, which we already have, so we don't need to do this again. The second step is to export the variables that we want to get out. So in this case, we want to get the products variable out of the products.js file. So let's open our files and open products.js, and we'll scroll to the top. So to get the products variable out of this file, in front of the variable, we're going to type export and space and save. And the last step is to import the variable that we need. So inside amazon.js, we need the products variable. So at the top, we're going to type import curly brackets, and then inside here, we're going to type the variable name that we want to get, which is products, and we're going to get this variable from single quotes, semicolon, and then inside here, we're going to locate the products.js file. So we're going to type ... and slash to go outside of the current folder, so outside of the scripts folder, and then we're going to go into the data folder. So we'll type data and a slash to go into the folder, and we're going to locate the file products.js and save. So now that we're importing this variable from this file, the rest of our code will work, and our website will start working again. So that's how we turn products.js into a module as well. So let's go into Git and take a look at our changes. So in amazon.html, we deleted the script tag, and then in products.js, we exported the variables that we wanted to get out, and then in amazon.js, we imported the variables that we need from the file. So let's type a message and save these changes into Git. Import products from products.js and commit. Let's close this, and let's open amazon.html. Now, the last thing is, you might be wondering, should we also delete this script tag that loads amazon.js? And the answer is no, because we still need one JavaScript file to load our code. So this file will import from all the other files that we created. And this is how we organize our code in a real website. So this file is called the entry point. So now that we've seen some examples of modules, we're going to use modules to organize our code better. So let's go into amazon.js. And then we're going to scroll down to the code for the Add to Cart button. So inside this file, we're going to scroll down here, all the way down to this code here. So this is the code that we run when we click Add to Cart. And you'll notice that we're running a lot of code here when we click that button. We're running code that adds the product to the cart, and we're also running code that calculates the quantity and updates the page. So a best practice in programming is that when we have a lot of code here that does different things, it's better to split these up into smaller functions to make our code easier to read. So here, this part of the code takes the product ID and then adds it to the cart. So it makes sense to split this into its own function. So let's scroll up, and at the top here, let's create a function for this code. So we'll type function, and let's call it add to cart, brackets and curly brackets. And then we're just going to move all this code into the function. So we'll select this code, and then right-click, cut, and then inside this function, right-click and paste. And then down here, we're going to run this function inside here. So when we click Add to Cart, we're going to run Add to Cart function that we just created and save. So now let's give this a try. So we'll click Add to Cart, and unfortunately, it doesn't work anymore. So let's take a look at the console to see if there's any errors. We'll right-click, inspect, and then open the console, and it's telling us that product ID is not defined. So if we look at our code here and scroll up in the function, you'll notice that we're using product ID, but it's no longer anywhere in the function. And that's because product ID is outside the function. So we actually want to keep this code outside because it's using this button. So instead, we're going to take product ID and put it into a function using a parameter. So at the top of the function, we're going to add a parameter product ID. And then when we call this function, we're going to pass it the product ID. So we're going to take this value, put it into the function, and save it in here, and then the function can run as normal. So now if we save and then go to our project and click Add to Cart, you can see that it's working again. Next, let's go back and scroll down. And we're going to put the rest of our code into its own function as well to make it more organized. So at the top here, let's create some new lines and create a function. And this code updates the cart quantity on the page here. So let's name this function update cart quantity, brackets and curly brackets. And we'll move this code into the function. So let's select this code and then right-click, cut, and then in here, right-click and paste. And then down here, we'll call the function using update cart quantity and brackets and save. So as you can see, by splitting up our code into smaller functions, it makes our code a lot easier to read. When we click Add to Cart, it's really easy to understand what's going on. First, we're going to add a product to our cart, and then we're going to update the cart quantity. So now let's save, and then go back to our project and try it out. And you can see that everything is working again. So we're going to do two more things to better organize our code. So let's go back to our code. And the first thing is we're going to scroll up to the Add to Cart function. And I made a small mistake in the previous lesson. I actually want to rename this parameter from item to cart item instead to make it a little more clear. So we're just going to rename this to cart item. And here as well, rename it to cart item and save. And we'll scroll down here and we're going to do the same thing for this parameter. So we'll rename it to cart item. And then here, cart item and save. And the last thing we'll do is let's scroll up to the Add to Cart function. So you'll notice that this code manages our cart. So it's actually a best practice to move this function into cart.js because cart.js contains all the code that's related to the cart. A best practice is to group related code together into its own file. So here, let's take the function add to cart. We'll select it and then right-click, cut. And then inside cart.js, we're going to right-click and paste. And just move that function into this file because this file contains all the code that's related to the cart. So now that this function is inside the file, we need to access it from amazon.js. And we can do that using modules, using the features export and import. So inside cart.js, in front of the function, we're going to export it so we can use it in other files. So let's save this file. And then inside amazon.js, we're going to scroll to the top. And you'll notice that we're already importing something from cart.js. So we actually don't need to write import again. Here, we can actually import multiple things from this file by typing comma and space, and then something else that we want to import. So in our case, we're going to import the function add to cart. So here, we'll type comma add to cart. So now it will import both the cart and the add to cart function from this file. So imports can import multiple things from a file. Imports have another syntax, import star as. This imports everything from a file and groups it together inside this object. And then we can access each import as a property or a method. So lastly, I'm just going to scroll down to my code here. And I'm just going to remove this extra new line and save. Now you might be wondering if we should move update cart quantity into cart.js as well. So this function actually handles updating the web page rather than managing the cart. So we're going to keep this function inside this file for now. So now let's go into Git and save our changes. So we'll go here, and inside cart.js, we moved the add to cart function, and then we exported it. And then inside amazon.js, we imported the add to cart function. And then down here, we took the big block of code that we had before, and we separated it into two functions, add to cart and update cart quantity. And this made our code a lot easier to read. So now let's type a message describing our changes. Move add to cart into cart.js and commit. Next, we're going to create the checkout page in our final project, and we're going to use modules to organize our code again. So let's open the final project, and we're going to click this cart icon in the top right. And this will take us to another page, which is the checkout page. So on this page, we can see the products that are in our cart. So if you're wondering how that cart icon works, it basically uses an HTML element called a link element, which looks like this. Link elements have a special attribute called href. When we click a link element, whatever is inside the href attribute, it will open it in the page. So if we put youtube.com inside the href and we click the link, it will open youtube.com in our browser. If we put a file like checkout.html inside href, it will look for a file called checkout.html and open that file. So in our project, if we look at our code and open our files, inside amazon.html, we're basically just using a link element or an A element. And this has an href of checkout.html. So what this does is it's going to look for a file called checkout.html beside the current file, amazon.html. So here's amazon.html, and it's going to look for checkout.html beside it, and then open that in our browser, which is how that cart icon works. So in our browser, at the top, you can see that it opened checkout.html. So that's basically how a link element works and how we can navigate from one page to another. You can learn more about link elements in my HTML and CSS full course. But for now, we're going to learn how to build the checkout page using JavaScript. So first, let's take a look at the code for this page. So again, the code is inside checkout.html. So in our code editor, we're going to open checkout.html. And this is the code for the page that we saw earlier that contains our cart. So just like with the home page, instead of writing all this HTML manually, we're going to use JavaScript to generate this HTML. So first, we need to add JavaScript to this page. So let's scroll down to the very bottom here. And right before the end of the body, we're going to create a script element to load some JavaScript. And we'll give it an attribute source equals double quotes, and then a file we want to load. So let's create a new JavaScript file for this page. So inside our scripts folder, let's click amazon.js and then click this icon to create a new file. And let's name this file checkout.js and press enter. And now we're going to load this page inside checkout.html. So here in the source attribute, we're going to locate this file. So first, we need to go into the scripts folder. So we'll type scripts and then a slash to go into the folder, and then we'll load the file checkout.js. And next, we're going to add another attribute, type equals double quotes module. So remember from earlier in the lesson, this attribute enables module features for this file. So now this file can import from other JavaScript files. So now let's save And let's open checkout.js. And we'll start creating this page with JavaScript. So let's go back to our page first and take a look at the structure of this page. So you can see on this page, we actually have two sections. We have the cart section on the left, which shows the products in our cart. And we also have the payment section on the right, which calculates the cost of our order. So let's use JavaScript to create the cart section first. So remember, the main idea of JavaScript is first, we're going to save the data, and then we're going to generate the HTML. And finally, we'll make it interactive. Let's start by saving the data that we need for this section of the page. So for this section, we're basically displaying a list of products along with the quantity of each product that we want to buy. And if you remember, we already created a data structure to represent this, which is our cart. Inside our cart, we have the ID of the product as well as the quantity that we want to buy. So we can just reuse this data structure to create this section. So let's go into our code, and we're going to open cart.js. So inside here, we have an array called cart that's supposed to represent our data here. So right now, our cart is empty. So to make it easier for us to develop, we're just going to add some default values into this array. So inside here, let's create an object and put one product into our cart first. So looking at this page, the product that we want to put is the socks. So we'll go back into our code, and I'll rearrange my windows so we can see it side by side. And we're going to get the product ID for the socks here. So we're going to go into products.js, and then here's the socks. We're just going to take this ID, right-click, copy, and then inside the cart. And remember, we structured our data so that each cart item has a product ID as well as a quantity. So here, we're going to create the same structure that our current code uses. So we're going to give each object a product ID, colon, and single quotes. And we're just going to right-click and paste the ID that we copied earlier. And then we'll type a comma, and we'll give it a quantity, colon, and for the first item, we're going to give it a quantity of 2. So we'll just create a cart that kind of matches what we see on this page. Next, let's create a second cart item to represent the basketball. So we'll type comma, curly brackets. We'll give it a product ID, colon, and single quotes. And then we're going to get the ID for this basketball. So inside products.js, we're going to scroll down to the basketball here. And we're going to copy this ID, right-click, copy, and then inside cart.js, in here, right-click and paste. And we'll give this one a quantity, colon, 1, and save. So what we're doing here is we're just creating some default values that we can use to write the code to generate this page. So this is just for development. When we're actually using the website, the cart will start off as empty. So if we compare our data to our page, you might notice that there's a few things that are missing, such as the product's image, the name, and the price. So how come we're not saving these into our data? And that's because we're using a special technique. We're just saving the product's ID, and then we can use this ID to search for this product inside the products array here. So using the ID, we can find all the other details of the product, like the image, the name, and the price. So there's no need to save this data twice inside the products array and inside the cart array. All we have to do is save the ID of the product that we want and then search for it. So this technique is called deduplicating the data or normalizing the data. And this is a very common technique in software engineering. Okay, so the one other thing that we probably need to save in our data is the delivery times and the delivery options. But we're going to leave this for the next lesson because it requires some more features that we're going to learn. So for now, we finished saving the data that we need. The next step is to use this data to generate the HTML. So let's open checkout.js. So I'm just going to drag it to the bottom here so we can see it side by side. So the first step we need to do is to take the cart array and import it into checkout.js so we can use it. So in here, let's import curly brackets, the cart array, and we're going to import it from single quotes and semicolon, and we're going to use a file path between the quotes to locate cart.js. So let's open our files again. And to get from here to here, we need to go out of the scripts folder. So to do that, we can type ... and then slash to go to the outer folder. And then we're going to go to the data folder. So we'll type data / to go into this folder, and we'll locate cart.js. So cart.js and save. And next, we're going to loop through this cart and generate the HTML, just like we did for the home page. So let's close this for now. And here, we're going to create a loop over the cart. So we'll type cart.for each, brackets, and a function. And then we'll give it a parameter. Let's call it cart item. And then for each cart item here, we're going to generate this HTML. So in here, let's create a template string for the HTML using backticks. And we'll create some new lines. And then here, we're going to copy and paste the HTML for one of these products. So first, let's find the HTML for one of these products. And to do that, we can right-click, inspect, and then click this top left icon. And then click the element we want to get the HTML for. So here's the HTML for one of these products. And we're going to search for this class cart item container in our code. So inside our code, let's open checkout.html. And we'll type Control F or Command F to search for code. And we'll search for the class cart-item-container, which is this code right here. So if we collapse it and collapse this, this is the code for these two products here. So we're going to take this HTML and we're going to move it into our JavaScript so we can generate it with JavaScript. So we'll right-click, copy, and then in here, right-click and paste. And if we need to fix the formatting, we can select all of these lines and then press Shift-Tab to remove some indents. And I'll add an indent here. Next, when we're generating this HTML, we want to replace this with the actual product's image and this with the actual product's name. So we're going to take this cart item and use it to get the data that we need. So let's open cart.js to see what each cart item looks like. So we have the product ID and the quantity. So first, we need to use this product ID to search for the product in order to get the other details, like the image, the name, and the price. So to do that, let's get the product ID out of the cart item first. So we'll create a variable const product ID equals the cart item dot product ID. And now we need to use this to search for the full product. So the full product, if we open our files, is inside products.js, which is this array right here. So I'm just going to move this up here so we can see it side by side. So to search inside this array, we actually need to import products into checkout.js. So let's use some module features again. At the top, we'll import curly brackets the products array, and we'll import it from single quotes and semicolon, and then here we'll locate the products.js file. So we'll type // to go out of the scripts folder, and then we'll go into the data folder, data, and then a slash to go into this folder, and we'll import from products.js. So products.js and save. So now we have access to this products array here, and we'll search the array for the full product details. So down here, let's create a variable to save the result. So we'll type let, and we'll name it matching product. And then down here, we'll loop through the products array. So we'll type products.for each brackets and a function, and then we'll give it a parameter, product. And now for each product here, we're going to check if the ID property is equal to our product ID here. So down here, we'll check if the product.id property is equal to our product ID up here. And then if they're equal, that means we found the matching product, and we're going to save it in this variable. So matching product equals this product that we're looping through. So now that we have the matching product, we have access to the image, the name, as well as the price that we can use to generate this HTML. So this is a good example of deduplicating or normalizing our data. So now at the bottom, let's console.log our matching product to see if it works. So matching product and save. Now if we go into our project and we right-click, inspect, and check our console, you can see that we were able to get the full product details for each of these products using the product ID. So now that we have the full product details, we can use this to generate all this HTML. So down here, instead of generating the same image every time, we're going to use the image in the matching product. So let's get rid of this code. And here, we're going to remove this, and we're going to substitute using $curly brackets the matching product dot image. And we'll scroll down, and instead of the same product name every time, we're going to replace this, and we're going to substitute the matching product dot name. So each time we're going to generate HTML with a different image and a different name. And down here, the same thing. Remove the price, and we'll replace it with matching product dot, and then we'll just check here what the property is. It's called price cents. And remember, this is in cents, and to display it as dollars, we have to convert it by dividing by 100 and save. And lastly, we're going to replace the quantity here. So if we scroll down, we can see that this is the quantity. So instead of 2 every time, we'll substitute. And for the quantity, remember it's not part of a product, it's part of our cart. So each cart item has a property called quantity. So down here, we're going to substitute the cart item dot quantity and save. So now we're generating all this HTML by looping through our cart. So the next step is we're going to combine all this HTML together and then put it on the page. So I'm just going to move this up here so we can see more of the code. So to combine all this HTML together, let's create a variable up here to store the result. So we'll type let, and let's call it the cart summary HTML equals an empty string. And now each time we loop through the cart, we're going to add this HTML up here so that we combine it. So here we'll type cart summary HTML plus equals this HTML that we generated. And at the bottom, I'll just add a semicolon. And then let's console.log the cart summary HTML. Console.log cart summary HTML to make sure that it worked. So we'll save, and then in here, we'll check the console, right-click, inspect the console. And now you can see that we generated the HTML, and each cart item is different depending on the product that is being displayed. So that's how we generate all the HTML for this section. And the last step is to take this and put it on the page using the DOM. So first, we need an element that we can put the HTML inside of. To find this element, let's right-click, inspect, and click the top left, and click one of these products. And let's find this order summary element, because this contains both of our products here. So we're going to replace all the HTML inside here with what we generated. So let's search for the class order summary in our code. So we'll go back to our code, and let's open checkout.html. And we'll type Control F or Command F to search for code, and we'll search for the class order-summary, and then it's right here. And we're going to add a class so we can select it using the DOM. So js-order-summary, and save. So now let's use the DOM and put this element in our JavaScript. So inside here, at the bottom, we'll use document.querySelector, brackets, and the class we just created, .js-order-summary, and we'll use the property .inner capital HTML, and we'll change the HTML to cart summary HTML, and we can remove this line. And now if we save, we're basically generating all this HTML with JavaScript and then putting it on the page. So now we can go back to checkout.html, and we can actually remove the code inside this order summary. So we can delete this code and save, and everything will still work because this is now being generated by JavaScript. So that's how we create the cart section of this page with JavaScript. Let's go into Git and save our changes. So we'll open the Git section, and then it will tell us that we changed 3 files. In checkout.html, we removed all the HTML that was written manually. And then at the bottom, we created a script tag to load our JavaScript. And then we also changed cart.js and added some default values to work with. And then we created checkout.js, which loops through the cart, creates the HTML, and puts it on the page. So let's create a message to describe our changes. Generate HTML for the order summary, and commit. Next, let's open our project again. And before we continue, we actually have 2 issues that we need to fix. The first issue is that the price is displaying as 1 decimal here instead of 2. And the second issue is that these delivery options are actually shared between the 2 products. For example, if I click this delivery option here, it will actually unselect for the second product. So they're sort of shared between the 2 products. But what we actually want is for each product to be able to select its own delivery options. So we're going to fix these 2 issues next. First, let's focus on the price, and we want to display it in 2 decimals. So we actually learned how to fix this on the home page using the method toFixed. So we're going to use the same code here. Let's go into our code, and we'll open our files, and let's open checkout.js again. So here, we're going to scroll down to where we display the price, which is here, price cents. And to show this in 2 decimal places, we're going to surround this with brackets to make sure we calculate it first, and then use the method .toFixed, brackets, and then 2 to show 2 decimal places. If we save and then open our project, now the price is displaying correctly. Before we move on, we're going to learn how to better organize this code. So if we go back, so notice that we're using this code inside the checkout page, as well as inside amazon.js, which is the home page. So we can actually share this code between the 2 files, so we don't have to repeat it. And to do that, we can use modules. So let's open checkout.js again. And what we'll do is we're going to create a function that does the same thing as this code. And then we can share this function between the 2 files. So let's create a file that's going to contain this shared function. So we're going to go to our scripts folder here, and inside we're going to create a new folder this time. And let's call this folder utils and press enter. So we're naming it utils because this code is sort of like a useful utility that we want to share. Now inside this folder, we're going to have different types of utils. So let's create a new file, and let's name it money.js. So this file is going to contain utilities that are related to money, which is this code right here. So let's press enter, and I'm just going to move this to the bottom so we can see it side by side. So now inside this utils file, we're going to create a function that does the same thing as here, and then we can share it between the 2 files. So here we'll create a function, and let's name it format currency, because that's what this code is doing, and then brackets and curly brackets. So this function is basically going to do the same thing as here. So we're going to add a parameter here, price cents, because we want to use this function for any amount of price cents. And then in here, we're going to do the same thing, which is price cents divided by 100. And then we're going to surround this with brackets to make sure we calculate this first, and then display it in 2 decimal places using .toFixed, brackets, and 2. And finally, let's return this result. Return and save. So what we just did is we created a function that does the same thing as this code here. And now we're going to share this function between checkout.js and amazon.js. So first, in order to share it, we need to export this function. So at the front, we're going to type export and save. And now inside each of these files, we're going to import this function and use it. So let's scroll to the top. And here, we're going to import curly brackets. We're going to import the function format currency, and we're going to import it from single quotes and semicolon. And then inside here, we're going to locate the file money.js. So here, we're in the checkout.js file, which is right here. And to go here, we're first going to go into the utils folder. So we're going to type utils and then a slash to go into this folder. And we're going to locate the file money.js. So money.js. Now for modules, we have to do one extra thing. At the front of this file path, we need to type /. So remember that .. represents the folder outside the current folder. So for checkout.js, if we go outside of this folder, we're going to go outside the scripts folder. Now, a single dot, on the other hand, means the current folder. So this dot means we're going to go into the current folder, which is the scripts folder, and then we're going to go into the utils folder. And then we're going to go and locate money.js. So for modules, if we want to start in the current folder, our file paths have to start with /. So that's one extra thing that we have to do. So now that we've imported the format currency function, let's use it in the rest of our code. So we're going to scroll down to here, and instead of writing this all over again, we're just going to use the function format currency, and then brackets, and we're going to remove the rest of the code here, and close bracket, and save. So we're basically running the same code, except we're using this shared function that's located in another file. So let's open our project, and we can see that the price is still displaying correctly. So now let's go back into our code, and we're going to share this function inside Amazon.js as well. So let's open Amazon.js, and then we'll scroll to where we show the price, which is here, and we're going to use this function again. So first we have to import it, so we'll scroll up to the top, and import curly brackets. We'll import the function format currency, and we'll import it from single quotes semicolon, and then here we'll locate the file money.js. So remember, for modules, if we want to start in the current folder, we have to type /. And then we're going to go to the utils folder. So utils, and then a / to go inside the folder, and locate the file money.js. And now we're going to use this function. So let's scroll down, and we're going to replace this code and use format currency and brackets. So we can remove the rest of the code here and save. And now let's look at our project, and we'll click up here to go back to the home page, and you can see that the prices are displaying as 2 decimal places. And that's it. If we look at our code again, we're essentially taking this function and sharing it across 2 files using modules. So using modules, we can reuse a lot of our code and reduce repetition. Next, let's work on the second issue that we saw earlier. So we'll go back to our project and click the top right to go back to the checkout page. And then here, the delivery options are shared between the 2 products, but we want each product to choose its own delivery options. So to fix that, let's go back into our code, and I'm just going to resize it here so we can see it side by side. And we'll open checkout.js again, and we can close this for now. So this is an HTML element called a radial selector. And here's the code for a radial selector. So the way that radial selectors work is that if a set of radial selectors have the same name, then we can only select one of them. So for example, if these 3 radial selectors have the same name attribute, then we can only select one of them. Now, if the 3 at the top have one name and the 3 at the bottom have a different name, then we can select one from the first 3 as well as one from the second 3. Now, what's the problem with the radial selectors here? Well, let's take a look at the code for these selectors. To do that, we're going to right-click one of them, and then inspect, and then click the top left, and click one of these selectors to get the HTML code. So here we have the code for the radial selector, and you can see that the name of the selector is delivery option 1. And now if we click the top left again and find one of these bottom selectors, you'll notice that these also have the name delivery option 1. So all 6 of these have the same name attribute. That's why we can only select one of these 6 at a time. So what we actually want to do is we want the first 3 selectors to have one name and the second 3 selectors to have a different name. So let's figure out how to give these a different name. So inside the console, we can see the code for this selector, and we have a name attribute delivery-option-1. So let's actually find this name in our code. So we'll go to our code editor and Control F or Command F to search for code, and we'll search for delivery-option-1. And if we scroll down, you'll notice that every time we're generating these radio selectors, we're always using the same name, delivery option 1. So every product is going to have the same name for the radio selectors, and all of these are going to be shared. So what we actually want to do is, instead of using the name delivery option 1 every time, each product is going to use a different name for these 3 selectors. So one way we can do that is, instead of the number 1 every time, we can replace it with the product's ID, because the ID is always unique for each product. So let's substitute using $ and curly brackets the product.id. And then down here as well, instead of using the name 1 every time, we're going to substitute product.id. And actually, we use the name matching product. So we'll scroll down and just update this to matching product. And then down here, matching product. And as well down here, instead of 1 every time, substitute the matching product.id and save. So now these 3 radio selectors will have a different name attribute than these 3 radio selectors. That means we can select 1 out of these 3, and we can select 1 out of these 3. So that's how we fix that error. Instead of using the same name, delivery option 1 every time, we're going to generate a name using the product's ID. So let's go into Git and save our changes. So in Amazon.js, we imported this shared function, and we used it to format the price in 2 decimal places. And then in checkout.js, we also used the shared function here, and we fixed the radio selectors. And then in this file, money.js, we created this shared function. So let's create a message to describe our changes: fix price formatting and radio selectors, and commit. The last step in our process is to make it interactive. So I'm just going to close these for now, and going to move it to the right again so we can see our project. And for the order summary, there's a few things we can make interactive. For now, we're going to start with this delete link. When we click this link, it should remove this product from the cart. So we're going to learn how to build this. So let's go back to our code. And first, let's add event listeners to all of these delete links. To do that, we're going to find the code for these delete links. So we'll right-click, inspect, and then in here, this is the code. So we're going to search for this class in our code editor, delete-quantity-link. So in here, let's open checkout.js, and we're going to Control F or Command F and search for delete-quantity-link, which is right here. Next, we're going to add a class to these elements so we can add event listeners. So at the end here, let's add a class js-delete-link and save. And then at the bottom, we're going to scroll down. And then down here, we're going to add the event listeners. So first, we're going to select all the delete links on the page using document.querySelector, all, brackets, and then a string. And we're going to select a class using dot and the class js-delete-link. And then we're going to loop through all these links. So dot for each, brackets, and a function And in here, it will give us the link every time. And then for each of these links, we're going to add an event listener. So link.add event listener, brackets. And here, we're going to give a string and the event we want to listen for, which is a click, and then a function that we want to run when we click these links. So for now, let's just console.log string delete to make sure that it's working. So we'll save this, and then in here, we click these delete links, and then open the console, right-click, inspect console. We can see that it's working now. So now let's go back to our code. So when we click delete, we're going to do two steps. The first step is we're going to remove the product from the cart. And the second step is we're also going to update our HTML and remove the product from the page. So let's start with the first step. So when we click delete, how do we know which product we need to remove from the cart? So we learned how to do this for the Add it to Cart button. We can attach the product's ID to the link element. So let's scroll up again to where the delete link is, which is right here. And we're going to attach the product's ID to this element using a data attribute. So at the end here, we're going to add data-product-ID equals double quotes. And then here, we'll substitute the matching product.id and save. And now that we attached the product ID to this element, we can get it in our JavaScript below. So let's scroll down. And then here, we're going to delete this line. And using the link element, we can get that product ID using link.dataset to access the data attributes. And we're going to access .productID. And let's save this in a variable so we can use it later. So const product ID equals this value. And let's console.log this to see if it works. And save. So now if we go to the project and click the delete link for the first product, and then look at the console, inspect and console, it will show us the product's ID. If we click the second product's delete link, it will show us the second product's ID. So now we have the ID that we need to remove from the cart. So now, how do we actually do that? So before we begin figuring that out, instead of writing all the code down here, let's actually create a function inside cart.js to do this task. The reason we're going to do this is because cart.js is supposed to contain all the code that's related to the cart. So this will help us organize our code better. So let's open our files again, and we're going to open cart.js. And we're going to scroll to the bottom, and we're going to create a function for removing a product from the cart. So let's type function, and let's name it remove from cart, brackets and curly brackets. So this function will take a product ID, which we have, and remove it from the cart. So here, let's create a parameter for the ID, product ID, and now in here, we're going to figure out how to remove it. So here's one way we can do this. First, we can create a new array, and then we can loop through our cart, and then add each product to the new array, except for this product ID. So now let's convert these steps into code. So inside this function here, let's create a new array using const, we'll call it new cart equals an empty array. The next step is we're going to loop through our cart. So we'll type cart.forEach brackets and a function, and we'll give it a parameter cart item. And the last step is that we're going to add each cart item to the new array except if it has this product ID. So we can do that by checking if the cart item dot product ID is not equal to the product ID that we're looking for. Product ID. So if it's not equal to the product we're trying to remove, we're going to add it to the new cart. So new cart dot push cart item. So the result of this loop is it's going to contain all the cart items that don't match this product ID. And that's the same thing as removing this from the cart. So now the last step is we're going to take our new cart and replace the cart up here. So we'll scroll down, and then here we'll make cart equal to our new cart. Because we're reassigning this variable, we have to scroll up and change it from const to let and save. So now that we created this function, let's use it in our checkout page. First, we're going to use the modules feature and export this function and save. And then inside checkout.js, we're going to import this function. So I'm just going to move this down to the bottom so we can see it side by side. So here. So in checkout.js, we're going to scroll up, and we're already importing from cart.js. So we're just going to import one additional thing by typing comma, and we're going to import this function, remove from cart, and save. And then we're going to use this function at the bottom. So we'll scroll down, and then here, we're going to remove from cart brackets, and we're going to give it the product ID we want to remove. So product ID. And lastly, let's just console.log the cart to make sure that this works. So console.log the cart and save. So now let's go into our project, and we're going to click this delete link for the first product. So delete, and let's open the console. Right-click, inspect the console, and now it's going to show us that we have one product remaining in the cart. And this product has a quantity of 1, which is the second product here. So by clicking that delete link, we successfully removed this product from the cart. So now if we refresh and tried clicking the second delete link and look at the console and then expand the cart, it will tell us that the remaining product has a quantity of 2, which is this product. So we successfully removed the second product from the cart when we clicked delete. So now let's go into Git and look at our changes. So we'll go into this section. Well, I can close this for now, and we'll open Git, and it will tell us that in cart.js, we changed it to let, and we created this new remove from cart function. And then in checkout.js, we import that function, and then at the bottom, when we click the delete link, we're going to remove this product from the cart. Now, finally, we can remove this console.log, save, and we're going to put these changes into Git. So we'll type a message to describe our changes, delete products from cart when clicking delete, and commit. The second thing we have to do when we click delete is to update our HTML. So if we go back to our project, when we click delete, we want to remove this product from the page. So one way we can do this is first, we're going to use the DOM to get the element we want to remove. And then we can use a method called .remove. So every element that we get from the DOM has a method called .remove, which removes it from the page. So first of all, how do we know which element to get from the page? So let's actually look at the HTML for one of these products. We're going to right-click, inspect, and then click the top left, and then click one of these products here. And this will give us the HTML. So these two products are represented by these two divs here, with the class cart-item-container. So one way to identify which product this is for is to add a special class to this element, and this class will contain the product ID. And then if we go back to our code and we open checkout.js and scroll to the bottom, when we click delete, we have the product ID here. So we can use this to select that special class that we're going to add. So first, let's add that special class to each of these elements. So we're going to scroll up to the HTML, and we're going to go to the top here to the div cart-item-container. And then here, we'll add a special class, js-cart-item-container dash, and then we'll substitute the product's ID. So we'll type the matching product.id. And let's put this class on a separate line, so the line is not too long. Now let's save. And now we're going to scroll to the bottom and use our code to get this class. So we'll scroll to the bottom. And here, we're going to use the DOM as well as this product ID to get that special class that we just added above. So here, we can type document.querySelector, brackets, and then inside, we'll type a string, and we'll select the class using a .js-cart-item-container dash, and then we're going to substitute the product ID. So because we want to insert something in here, we're going to switch this to a template string using backticks. And now we can substitute this product ID into this string. Product ID. So by creating the string like this, we're able to select the specific container that we need. So now let's save this in a variable so we can use it later. So const container equals this result. So for now, let's actually console.log this to see if it works. Console.log container and save. And then we'll go back to our project. So just move this here. And then in our project, if we click delete on the first product and then check the console, right click, inspect, and the console, you can see that we're getting the correct element that we should delete. If we go down here and click this delete link and check the console, you can see that this is also getting us the correct element that we want to delete. So now that we have the element we want to delete, the next step is to use the .remove method. So again, every element we get with the DOM has a method called .remove, which will remove it from the page. So if we go back into our code, down here, all we have to do is type out the element container.remove and brackets, and this will remove it from the page. If we save and try it out, so we'll go in here, we'll click delete on the first product, and it will remove it from the page. If we click delete on the second product, it will also remove it from the page. So that's it. Now let's refresh to bring the products back, and that's how we make the delete link interactive and remove the products from the cart as well as from the page. So now let's save our changes into Git. We'll go to the Git section, and it will tell us that in checkout.js, at the top, we added that special class, which contains the product ID. And if we scroll down to the bottom, we created the string, which will get us the specific element that we want to remove. And then we use the .remove method. So now let's create a message to describe our changes. Delete products from HTML when clicking delete and commit. The last thing we're going to do in this lesson is we're going to add local storage to our cart. So if we go back to our project, if we delete some products in our cart and then refresh, notice that our cart goes back to what it was before. And that's because right now, if we look at our code and we open cart.js, our cart is just a variable, and variables are reset when we refresh the page or when we go to a different page. So again, if we go back to our project and we go to a different page by clicking the top left, so on this home page, we can add as many products as we want to our cart. And if we go back to the checkout page, our cart will just get reset to whatever it is here. So that's the problem with just using a variable to save our cart. It gets reset when we refresh the page or we go to a different page. To solve this problem, we're going to use local storage to save our cart. So first, let's create a function for saving the cart to local storage, because we might want to reuse this code. So down here, let's create a function. We'll call it save to storage, brackets and curly brackets. And we're just going to save the cart to local storage using local storage dot set item, brackets. And set item takes two strings. The first string is the name of whatever we want to save. So we're going to save our cart. So we're just going to call this the cart. And then the second string is the data that we want to save. So remember that local storage can only save strings. So to save our cart, we need to convert it into a string first. And we can do that using JSON.stringify, brackets, and then inside we're going to give it the cart. So this will convert the cart into a string, and now we can save it in local storage. So now let's use this function. Whenever we update the cart, we need to save it to local storage so it doesn't get reset when we refresh the page. So here, when we add it to the cart, at the bottom, after we update the cart, we're going to use that function we created above. Save to storage and brackets. And also in the function remove from cart. So this function is also updating the cart. So after we update the cart, we're also going to save to storage and brackets and save. So now whenever we update the cart, we're going to save it in local storage. The last thing we need to do is at the top, at the beginning of our code, we need to get the cart from local storage instead of using this default value. So let's add some new lines here to separate the code for a bit. And here, we're going to get the cart from local storage. And we can do that using local storage.getItem and brackets. So getItem takes one string, and that is the name of what we saved earlier, which is the cart. So we're going to give it the string cart. So this will give us the cart that we saved. However, remember that local storage can only save strings. So it will give us the string version of our cart, and we need to convert it back into an array. To convert it back to an array, we can use the code json.parse and brackets and close bracket. The last thing we need to do is when we first use the website, we might not have a cart in local storage. So if we don't have a cart saved, local storage will give us null. So in this situation, if this value is null, we want to give the cart a default value, which is this value below. So to give the cart a default value if it's empty, we can use an if statement by typing if, brackets and curly brackets, and in here we can check if not cart. So if we don't have a cart in local storage, this will give us null. In this case, not null will become truthy, and we're going to run the code in this if statement. So if the cart is empty, we're going to make the cart equal this default value below. So let's just select this code, and we'll right-click, cut, and then in here, right-click, and paste. And remove the extra line and save. So now if the cart is empty, we'll just give it a default value. If we go back to our project and try out our code, so let's delete the first product and refresh the page, notice that the cart gets saved and the first product remains deleted. If we go to the home page and we add some new products and then go to our cart, notice that our cart is saved between pages. So by using local storage, we can save our cart even when we refresh the page or go between different pages. So that's all we're going to build in this lesson. So to clean up, let's delete all these products in the cart and then go to the home page, and we'll add back 2 socks and 1 basketball, which is the default value of the cart. Let's go back to the checkout page. And now we're done with this part of the page. So finally, let's save our changes into Git. We'll go to the Git section, and it will tell us that inside cart.js, we're now loading the cart from local storage when we open the page. If the cart doesn't exist, we're going to give it a default value, and we created a function to save the cart into local storage. So now let's add a message to describe our changes. Save cart in local storage and commit. And that's the end of this lesson. In this lesson, we learned about modules, which is a better way to organize our code. We created the checkout page in our final project. We learned about HTML link elements and radial selectors. We made the delete link interactive, and we saved the cart in local storage. Here are some exercises to help you practice what we learned in this lesson. In this lesson, we're going to learn about external libraries, and we're going to finish the checkout page in our final project. An external library is basically just code that is outside of our project. So far, we've only been using code that is inside our project, like these files. Well, a lot of developers write JavaScript code and then put their code on the internet, and we can actually load their code from the internet into our project and use it. We call this code an external library because it's code that is outside of our project. Let's do an example and load our first external library. We're going to go to the video description and we're going to click this link. For the Hello external library. And it will open up a page that contains JavaScript code. So I actually wrote this code myself, and you'll notice that this is just normal JavaScript code. We create a function called hello, and it just console.logs hello. So this is called an external library. It's code that is outside of our project. So the cool thing is, we can actually load this code from the internet into our project. So let's give that a try. We're going to go to our project, and we're going to open checkout.html. And we're going to scroll to the bottom, and above the script tag, we're going to add another script tag to load some code. So script, and we'll give it a source attribute. And then in here, instead of using a file path like we've done before, we're going to give this a URL of a website that contains JavaScript code. So if we go back to our browser, and here, the URL of this page is up here. So we're just going to copy this, right-click, copy, and then paste it into our code. Right-click and paste. So now, the computer will get all the JavaScript code from this URL or from this page. So it's going to get all the code from this page and load it into our project like normal code. So let's save, and let's give this a try. So this code creates a function called hello. So let's try running this hello function in our project. We'll go to checkout.js, and then scroll to the top, and then here, let's just run the function hello. So hello and brackets, and save. Now if we go back to our project, go to the checkout page, and check the console, right-click, inspect, and the console, you'll see that it displayed the message hello. So that's how an external library works. It's just code that is outside of our project. And we can load this code using a script tag like this. We just give it the URL of where this code is located. So there's two things you might be wondering about. How can we put this script tag at the top? So generally, we load external libraries first, and then we can use the library in our own code below. And the second thing is, how do you put code on the internet like this? To learn this, you can check out my video on how to put a website on the internet. It'll show you how to put any file like HTML, CSS, and JavaScript files onto a website like this. Next, let's talk about why we use external libraries. External libraries let us share code. Instead of writing all the code ourselves, we can use code that other people wrote, and this helps us save time and avoid duplicating work. Right now, we're loading a very simple library, so let's load a more complex library to show how we can save a lot of time and work. Let's go back to our project and go to the checkout page. Here, we have a section for choosing a delivery option for this product. And you'll notice that each option has a date. So this is the date that the product should be delivered by. So the way this works is that the cheapest option here takes 7 days to deliver. The $4.99 option takes 3 days to deliver, and the $9.99 option takes 1 day to deliver. So to get these dates here, we need to do 3 things. First, we need to somehow get today's date in our JavaScript. Number 2, we need to do calculations with the date, such as add 7 days or add 3 days. And number 3, we need to display the date in an easy-to-read format like this. Now, we could try to figure out how to do this ourselves by writing our own code, but this is going to be a lot of work. Instead, we can use an external library to help us work with dates. So in this project, we're going to use an external library called day.js. This is a popular library that helps us work with dates. So first, let's load day.js into our project. We're going to go to the video description, and we'll click this link. For the day.js external library. And when the page opens, you'll see a bunch of random code here. Now you might think that this is some special code, but this is actually just regular JavaScript code that has been compressed. So basically all the extra spaces have been removed and the variable names have been shortened to 1 letter. We compress JavaScript code like this because we need to load this code from the internet into our project. By compressing it, it makes this code smaller, so it will load into our project faster. So this compression process is called minification, or we minify the code. Okay, so this is the code for the external library day.js. Now let's load this code into our project. We'll go back to our code, and then go to checkout.html, and then here we're going to add another script tag, less than script, and the source attribute. And then here, we're going to give it the URL of the code we want to load. So let's go back to the code for day.js. And then up here, we're going to right-click and copy this URL. And then inside our code, in the source attribute, we're going to right-click and paste the URL and save. So again, this will take all the code that's located on this page and then load it into our project. Now let's give it a try. The day.js external library creates a function called day.js. So we'll go to checkout.js, and then at the top, we're going to run the day.js function and brackets. Now make sure this is all lowercase, because that's the name that the library used. So now let's actually console.log the result of this function. Console.log and save. And we'll go back to our project. In the checkout page, we're going to check our console. And you'll see that the day.js function gives us an object. And this object represents the current date and time. So we know that day.js is working. And that's it. We successfully loaded the day.js external library into our project. Now let's learn how to use day.js. External libraries usually have a documentation page that shows us how to use the library. We can find the documentation page by searching on Google the library name like day.js and then documentation. Or we can ask an AI tool how to use the library. To make things easier in this video, I'm going to show you the features that we need, and you can go through the documentation later if you want. So earlier we said we needed to do 3 things with a date. First, we want to get today's date. Number 2, we want to do calculations with the date. And number 3, we want to display the date in an easy-to-read format. Day.js helps us do all of these things. So first, let's use day.js to get today's date. According to the documentation, to get the current date and time, we can just use the day.js function like this. So if we go back to our code, that's what we have here. We call day.js, and it gives us an object that represents the current date and time. The second thing we need to do is to do calculations with the date. So for the delivery options here, we need to calculate today's date plus 7 days, or today's date plus 3 days. So again, the day.js library can help us do this. So let's go back to our console and look at the object that we get back from day.js. So this object represents today's date and time. And this object also has a method called add, which adds a certain amount of time to this date. So this is what we need for the project to calculate these dates here. Let's go to our code. And first, let's save this result in a variable. So we're going to remove this and create a variable const today equals day.js. And then down here, we're going to use the add method. So we'll type today.add and brackets. Now the add method takes 2 parameters. The first one is the number of time that we want to add. So if we want to add 7 days, we're going to type 7. And then the second parameter is the length of time that we want to add. So if we want to add 7 days, we're going to give it a string days. So this will add 7 days to today's date. So let's save this result in a variable. Const delivery date equals this result, and we'll console.log it to make sure it's working correctly. Console.log the delivery date and save. Now if we go back to our project and open the console, it will give us an object that represents 7 days after today, or 7 days after when you're watching this video. So that's how we use day.js to do calculations with the date. It gives us methods like add to add a certain amount of time to the date. Finally, we're going to use day.js to display this date in an easy-to-read format like this. So according to the documentation, this date object has another method called .format, which will display the date in an easy-to-read format. So let's go back to our code, and we'll remove the console.log, and we'll type delivery date dot format. And then inside these brackets, we're going to give this method a string. So this string tells Day.js what kind of format we want for the date. So in the documentation, it has a table showing us some special characters we can put into this string. For example, if we want to show the day of the week, like Monday or Tuesday, we can type 4 Ds into the string. And this will give us a string where this text is replaced by the actual day of the week. If we want to add a comma and a space to this format, we can just add a comma and space, and this will show up directly in the result. Now let's say that after this, we want to show the month. According to the documentation, to show the month, we can type 4 capital M's. And it will replace this with the month. And finally, we'll type a space. And according to the documentation, if we want to insert the day of the month into the string, we can type a capital D. So this method takes this date and converts it into a string with this format. So now let's console.log this to see what it looks like. Well, console.log and brackets and save, and then go into our project and open the console. And now you should see the date 7 days after today, but displayed in an easy-to-read format. So that's how we use the Day.js external library to help us work with dates. And as you can see, it saves us a lot of time and work. We don't have to figure out how to work with dates ourselves. We can just use someone else's code to solve this problem. So a best practice in programming is when we need to do something complicated, try to find an external library first before writing the code ourselves. To find external libraries, we can search in Google, JavaScript, and then what kind of library we're looking for, like date library. We can also use an AI tool to help us find external libraries. Next, we're going to learn how to use external libraries and JavaScript modules together. Right now, if we look at our code and go to checkout.html, we're loading these libraries using script tags. The problem with script tags is that it runs this code directly on the page, and this might cause naming conflicts. For example, the hello library creates a function called hello. So if something else is called hello in any of our other code, it might cause a naming conflict. A better way to load external libraries is to use JavaScript modules, because a module will contain this code inside a file, and any variables that are created inside the file will not conflict with anything outside of the file. To use external libraries and JavaScript modules together, we're going to use a special version of the library called an ESM version. ESM stands for ECMAScript modules. ECMAScript is just another name for JavaScript. So the ESM version of a library is just a version that works with JavaScript modules. So let's do an example. We're going to go to the video description, and we're going to open the ESM version of hello.js. So you can see that it's the exact same code as before. We're creating a function called hello, except this time I just added the word export in front of function. So this turns the library into an ESM version, and now it will work with JavaScript modules. So let's use the ESM version in our code. We're going to go back to our code, and we're not going to use script tags to load this anymore. So let's delete this and save. And then in checkout.js, at the top, we're going to use an import to import this function into our code. So we'll type import curly brackets, we'll import the function hello, and we're going to import it from a string, and then this time, instead of giving it a file path like before, we're going to give it a URL that contains our code. So on the web page, we're going to right-click and copy the URL at the top, and then inside our code, in here, we're going to right-click and paste. So this import works the same way as before, except now the code is coming from the internet rather than one of our files. So let's save, and then go back to our project, and check the console, and you can see that everything is still working. So that's how we use external libraries and JavaScript modules together. We just load the ESM version of the library, and we use import as normal, except this time we're importing from code that is on the internet. Next, let's use day.js with JavaScript modules. To do that, we're going to load the ESM version of day.js. So we're going to go to the video description and click this link for the day.js ESM version. And now we're going to load this code into our project. So let's go back into our code. And first, let's open checkout.html. And we're going to remove the script tag because we're going to load this with JavaScript modules. So let's save, and then go into checkout.js. And then at the top, we're going to import from the day.js ESM version. So we'll import, and we're going to use a slightly different syntax. We're just going to type day.js without the curly brackets. And then we'll type from a string, and we're going to give it the URL that contains the code. So we'll go to our browser, and then click the URL at the top. We're going to right-click, copy, and then in our code, inside these quotes, right-click and paste, and save. So now let's open our project and take a look at the console to make sure it works. So we'll right-click, inspect the console, and everything is still working. So that's how we use the day.js external library with JavaScript modules. So before we continue, we're going to learn about this new syntax that we used here. So this syntax is called a default export. A default export is another way of exporting something from a file. We can use it when we only want to export one thing from a file, and it makes the syntax a little bit cleaner because we don't have to type the curly brackets. So let's do an example of a default export to see how it works. We're going to open the utils folder and open money.js. And at the bottom, we're going to create a default export by typing export default, and then whatever we want to export. So let's say we want to export this function here. So we just type the name of the function, format currency, and save. And now when we import this, we can just import the name without the curly brackets. So the syntax is a little bit cleaner. Now each file can only have one default export. So if we only want to export one thing from a file, this is another syntax that we can use. So some people like using default exports because they feel that exporting only one thing from a file makes the code cleaner. However, in your own code, it's up to you which version of export you want to use. Let's go back to checkout.js. And then here, the day.js library only exports one thing, which is the day.js function. So they chose to use a default export instead of a normal export that we were using before. By the way, the syntax up here with the curly brackets is called a named export. So when we use external libraries in the future, some libraries will use named exports like this, and other libraries will use a default export like this. So it's useful to know both syntaxes. So that's how we use external libraries and JavaScript modules together. We just import from the ESM version of the library. Now keep in mind that not every library has an ESM version, so for some libraries, we still have to use a script tag. Okay, now that we learned external libraries, let's do some practical examples. We're going to go back to the checkout page, and we're going to use day.js to create the delivery options here. So the way this works is that we can select one of 3 delivery options. When we click an option, it should change the delivery date up here, and it should change the prices on the right side. So let's get started. As always, we're going to do 3 steps. First, we're going to save the data, and then we're going to generate the HTML. And finally, we're going to make it interactive. So first, what data do we need to save for this section? Well, each delivery option has a delivery time, like 7 days or 3 days. And each option also has a price. So right now, here's what our cart looks like. Now we could save the delivery option details inside the cart like this. However, notice that this data gets duplicated for each product in the cart. Instead, we're going to save the delivery options separately, and then just save an ID that points to the delivery option. As a reminder, this technique is called normalizing the data. We save the delivery options separately, and then we just save an ID that points to the full delivery option. So let's create the data for the delivery options. We'll go into our code, and then in the data folder, let's create a new file for this. And we're going to name this file delivery options.js and press enter. And in here, we'll create a list of delivery options that we can pick from. We'll create a variable const delivery options equals an array because we want a list. And then each delivery option is going to have multiple values, like the time to deliver as well as the price. So we're going to make each of them an object to group these values together. So I'm going to rearrange my windows here so that we can see the data that we're trying to save. And we can actually close these tabs for now. So here, let's save the data for the first delivery option. First, let's give it an ID property, because as we mentioned, we're going to save the ID in the cart, and then we're going to use that ID to get the full delivery option here. So to keep things simple, let's just give it a string and an ID of 1. And then we're going to give it another property, and we're going to save the delivery time. So for the first option, it's going to take 7 days to deliver. So let's create a property delivery days, colon, 7, and comma, and we're also going to save the price. So this one is free, so we're going to save the price, cents, and 0. Remember that a best practice when calculating money is to save it in cents. And next, let's save the data for the second delivery option here. We'll type a comma and another object, and let's give it an ID of 2 this time. And this one is going to take 3 days to deliver. So we'll type delivery days, colon 3, and we'll give it a price, cents, and this one is $4.99, so $4.99. And then finally, we're going to save the data for the third delivery option, comma, another object, ID of 3, and this one is going to take 1 day to deliver. So we'll type delivery days, colon 1, comma, and the price cents is $9.99. So price cents, $9.99, and save. So now that we've created our delivery options, for each product in the cart, we're going to save the ID of the delivery option that's selected. So for example, here we selected the first option. We're going to save an ID of 1 in our cart. So let's go back into our code, and we're going to open the cart. So here in the default cart, we're going to save the delivery option ID, colon, and let's say that the first product selected the first delivery option. So we're going to save the ID 1. And then for the second product, we're also going to save a delivery option ID, colon. And then let's say that for the second product, we chose the second delivery option here. So here, we're going to give it an ID of 2. Next, when we add a product to the cart, we also need to give it a delivery option ID. So if we scroll down to the add to cart function, here we're adding a product to the cart. So when we add a new product, we also want to give it a delivery option ID. So we'll type delivery option ID, colon. And for new products, let's give it a default delivery option of 1. So for new products, they'll select the first one. And now let's save. And lastly, we might have a cart that is saved in local storage. So we'll need to add the delivery option ID to local storage as well. But to keep things simple, let's just do a shortcut. We're going to delete the cart in local storage, and then it will go back to using this default value, which has the delivery option IDs. So to delete the cart from local storage, we're going to go into our page and open the console, right-click, inspect the console, and we're going to type local storage dot remove item, brackets, and the cart, and press enter. So this will erase the cart from local storage, and it will use those default values. So now let's go to our page and refresh, and it should be using the default cart. So that's how we save the data for the delivery options. By the way, in the rest of this course, if you get an error in your project, but your code looks correct, you may have some bad data saved in local storage. To fix this, you can try running localstorage.clear in your console to remove everything from local storage, and then refresh the page. The next step is to generate the HTML. First, let's find the HTML for the delivery options here. To do that, we can right-click this part of the page and inspect, and this will give us the HTML for this part. So we're going to find the element that represents this part of the page, and that's this one right here. It's a div with the class delivery-options. And to find this in our code, we're going to search for this class. So let's go back to our code, and then we're going to open checkout.js, which is right here. And we'll press Control F or Command F to find code, and we're going to look for the class delivery-options. And it will give us this code right here. So this is the HTML for the delivery options. So now instead of writing this HTML directly, we're going to generate this with JavaScript. To keep our code organized, let's create a function for generating this HTML. We'll scroll to the bottom, and then here, we'll create a function, and let's call it delivery options HTML, brackets and curly brackets. And now inside here, we're going to do 3 steps. First, we're going to loop through the delivery options we created earlier. And then for each option, we're going to generate some HTML. And then finally, we're going to combine all the HTML together. So first, let's import the delivery options at the top. So we'll scroll up, and we're going to import curly brackets from quotes, and we're going to locate the delivery options file, which is inside the data folder. So first we need to get out of the scripts folder. We'll type .. and then go into the data folder / delivery options.js. And we're going to import the delivery options. Now, one thing I forgot to do is that inside these delivery options, we need to make sure that we export this variable. So we're going to type export and save. And we'll go back to checkout.js. And then here, we're going to loop through the delivery options below. So we'll scroll back down to this new function and type delivery options dot for each, brackets and a function inside. And we'll name the parameter delivery option. So for each delivery option, we're going to generate some HTML. So let's use a template string to save the HTML. And then we're going to scroll up and we're going to find the class delivery-option. So this is the HTML for one delivery option. So we're just going to copy this HTML into our JavaScript below. So we'll right click, copy, and then down here, inside the string, give some new lines, and right click and paste. And if we need to reformat, we can select these lines and press tab. Okay, now when we're generating the HTML, instead of using the same date every time, we're going to calculate the date using day.js and then insert it into here. To calculate the date, we're going to get today's date first using day.js. So up here, let's create a variable const today equals, and according to the documentation, to get today's date, we can just call the day.js function. So we'll type day.js and brackets. Next, each delivery option takes a certain amount of days to deliver. So we need to add that to today's date. To do that, we have a method called .add. So below this, let's create a variable to save the result. Const delivery date equals today.add brackets. And we're going to give it two parameters. The first parameter is how many days we want to add. And this is saved in the delivery option. So here we'll give it the delivery option dot delivery days, comma, and then we'll give it the length of time we want to add, which is a string days. Now that we calculated the correct delivery date, we need to display it in an easy-to-read format. And again, day.js has a method called format that lets us do this. So below, let's create a variable const, and we'll call it date string, and make it equal to delivery date dot format brackets, and we'll give it a string. So the format we want is we want to insert the day of the week. So according to the documentation, we can use 4 Ds and then a comma and a space, and then we want to insert the month. And according to the documentation, that's 4 capital M's. And finally, we're going to insert the day of month, which is capital D. So now that we calculated this date string, we're going to insert it into the HTML instead of using this same date every time. So we'll remove this and then insert the date string. Next, let's insert the price because it's going to be different prices every time. So at the top, let's create a variable const, and we'll call it price string and make it equals. And remember, each delivery option has a property price cents. So if the price cents is 0, we want to display the text free. If the price cents is not 0, we want to display the price as dollars with a dash. So to do that, let's practice using a ternary operator. So first, we'll check if the price cents is 0. So we'll type delivery option dot price cents is triple equals to 0. And then we'll type a new line and question mark, and also a new line and colon. So remember, the way that a ternary operator works is that if the first part returns true, the value is whatever's after this question mark. If the first part is false, then the value is whatever is after the colon. So it's sort of like an if statement, except we can save the result in a variable. So if the price cents is 0, that means it's free. So we want to display the text free. So we'll create a string free. And if the price cents is not 0, we want to display the price as dollars. So here, we're going to type a template string a $sign, and we're going to insert the price cents as dollars. So here we'll type delivery option dot price cents. And to display this as dollars, we already have a function for this called format currency. So at the front, we're just going to type format currency, open bracket, and close bracket. And then at the end, let's add a dash. So here we'll add space and dash and semicolon. So that's how we create the price string for each delivery option. So now let's substitute this into the HTML. So we'll remove this and substitute the price string and save. So now, instead of using the same values every time, we're substituting the values into the HTML. Finally, let's combine all this HTML together. So we're going to scroll up to the top, and outside of this loop, we're going to create a variable to save the result. So let HTML equals empty string to start. And then every time we loop through, we're going to add this HTML to this result. So here we're going to type HTML plus equals. And finally, after we've created this HTML, we're going to return it from this function. So at the bottom, we're just going to return the HTML and save. Now that we generated the HTML for the delivery options, let's insert this into the HTML above. So instead of creating this HTML directly, we're going to delete it. And then here, we're going to insert, and we're going to run this function to generate it. So here, we're going to type delivery options HTML and brackets. Now, before we save, one thing that we're missing in this function is that if we scroll down, here we're using a variable called matching product. But this variable is not accessible inside this function. So let's actually pass the matching product into here. So at the top, we're going to add a parameter, matching product. And then when we call this function up here, we're going to pass in the matching product. So matching product. So now let's save and check our page. And now we're generating the HTML for these delivery options. And you'll notice that your delivery dates here will be based on today's date, or when you're watching this video. So this will be 7 days after today, or 7 days after when you're watching this video. This will be 3 days after today, or 3 days after when you're watching this video. And this will be 1 day after today. Now, one thing we need to fix here is that these selectors are empty. However, we want the delivery option that is saved in the cart to be checked. To do that, let's go back to our code. And in order to make one of these selectors selected, we're going to scroll down to the input element, and we're going to add an attribute called checked. And this attribute makes a selector checked. However, we don't want all of these delivery options to be checked. We only want it to be checked if it matches the delivery option ID that is saved in the cart. So let's write some code up here to figure out which delivery option should be checked. We're going to create a variable const is checked equals, and we only want it to be checked if this delivery option's ID matches the delivery option ID in the cart. So we'll test if delivery option.id is equal to the cart items.delivery option ID. Now inside this function, we actually don't have access to cart item. So let's actually pass it in as a parameter. Cart item up here. And then when we call the function, this outer function has access to the cart item. So we're going to give it the cart item. So we're going to put it into this function, and then we can use it down here. So now that we have this variable, instead of being checked all the time, we're going to remove this and insert, and we're going to use a ternary operator here. Is checked, question mark, and colon. So we can also use a ternary operator when we're inserting into a string. So again, if this is true, it's going to get the value after the question mark. So if it is checked, we're going to give it the value checked. If this is false, we're going to give it the value of empty string. So it's the same thing as if this attribute didn't exist. So now if we save, you'll notice that the correct delivery option is checked for each product. The first product, we saved delivery option 1, and the second product, we saved delivery option 2. Finally, let's replace this date at the top with the delivery date that we selected here. We'll go back to our code, and we'll scroll to the top until we see this date in our code here. So now we're going to calculate this date using the delivery option that we picked. So remember that inside the cart, we only saved the delivery option ID. So let's use this to get the full delivery option. So at the top here, let's get the delivery option ID out of the cart. Const delivery option ID equals cart item dot delivery option ID. Next, we're going to use this ID to find the full delivery option. Now we did something similar with the product ID. We looped through the products, found a matching ID, and then saved it in a variable up here. So we'll do the same thing. Let's create a variable to store the result. Let delivery option, and then we're going to loop through the delivery options. So delivery options dot for each brackets and a function, and let's name the parameter option because we use the name delivery option up here. So in here, we're going to look for a matching ID. So if this option.id is equal to the delivery option ID here, we're going to save this inside this variable. So delivery option equals option. So now we have the full delivery option in our code, and we can use it to get the delivery days property and then calculate the day that we need here. To calculate this date, we already wrote some code for this at the bottom. If we scroll down in our code, when we created the delivery options, we calculated the date for each delivery option. So we can reuse this code above. So let's select this code and then right-click, copy, and then at the top, after we get the delivery option, we're just going to right-click and paste that code again. And if we need to, we can reformat by selecting these lines and press Shift-Tab. So this code will take the delivery option that we selected and calculate the delivery date that we need to show down here. And now instead of using the same date every time, we're going to remove this and insert the date string that we created above. So date string and save. So now this date string up here will match the delivery date that we chose on the right side. So that's how we generate the HTML for the delivery options using the day.js external library. So now let's take a look at our changes in Git. We'll go to our code and open the Git section. And here it'll tell us in cart.js, we added delivery option IDs to the cart, as well as when we add to the cart. And then in this file, we created the list of delivery options. And in checkout.js, instead of writing this HTML directly, we generated it. And then in money.js, we learned about default exports. So let's type a message to describe our changes. Save data and generate HTML for delivery options and commit. The last step is to make it interactive. So when we click a delivery option, we need to do two things. First, we need to update the delivery option ID in the cart array. And number two, we need to update the page. So we need to update this date here to match the date that we select. Let's start with the first step. Let's create a function for updating the delivery option in the cart. We're going to go to our code, and we're going to open the file called cart.js. So because we're modifying the cart, a best practice is to put the code inside this file. This file should contain all the code that manages the cart. So we're going to scroll down to the bottom, and we're going to add a new function. So let's type function, and let's name it update delivery option, brackets and curly brackets. So when we update a delivery option, we need to know the product that we want to update, as well as the delivery option that we chose. So we're going to need two things for this function: the product ID and the delivery option ID. So the steps to do this is, first we're going to loop through the cart and find the product. And then we're going to update the delivery option ID of that product. So to find the product using the product ID, we already have some code for this. If we scroll up to the add to cart function, we have this code, which takes a product ID and finds the matching product in the cart. So let's just make a copy of this code. We're going to select it, right-click copy, and then paste it into our new function. So down here, right-click and paste. So this will give us the cart item that matches this product ID and save it in this variable. Next, each cart item has a property called delivery option ID. So we're just going to update that property. So down here, we can just type the code matching item dot delivery option ID and make it equal to the delivery option ID that we give to this function. So delivery option ID. And lastly, because we updated the cart, we should save it to local storage. So we can use this function we created earlier, save to storage, and brackets. Now let's save. Now that we have this function, let's use it on the checkout page. So first let's export it so we can use this in another file. We're going to export this function and save, and then open checkout.js. And then in our project, we need to add event listeners to each of these delivery options, so we run some code when we click them. So inside our code here, we're going to scroll to the HTML for each delivery option, which is right here. And then we're going to add a class, so we can select it using the DOM, js-delivery-option. And then we'll add an event listener to these. So we'll scroll down, and down here, we'll add the event listener using document.query selector all brackets and a string. We'll select that class we just created using .js-delivery-option, and then dot for each brackets and a function. So for each option, we're going to add an event listener and listen for clicks. So let's just call each of the options an element. So for each of these elements, we're going to element.add event listener brackets, and we're going to listen for clicks, comma, and we're going to run this function when we click it. So as we said, the first thing we'll do is to update the delivery option ID in the cart. So now let's import that function that we created earlier. We're going to scroll to the top, and we're already importing from the cart. So to import something else, we're going to add a comma, and we're going to import that function update delivery option. So now let's scroll back down and use it in our code. So here, when we click a delivery option, we're going to update delivery option, brackets. Now we said we need to give this function two things: the product ID that we want to update it for, as well as the delivery option ID that we picked. But how do we get these two values? And the answer is, if we scroll up, here we have access to the product ID, and we also have access to the delivery option ID. So we can use data attributes to attach it to this element here. So let's create a data attribute, data-product-ID equals double quotes, and insert the product ID, which is matching product.id. And we're also going to use a data attribute for the delivery option, data-delivery-option-ID equals double quotes. And we're going to insert the delivery option here. So delivery option.id and save. Next, let's scroll back down. And then here, we're going to get those values out of the data attributes by using const, and let's use the shorthand property here for practice, curly brackets equals the element dot data set. And then out of the data attributes, we're going to get the product ID, comma, as well as the delivery option ID. As a reminder, this is a shorthand property. It does the same thing as the code down here, but it's just a shortcut. Now let's save and try out the project. We'll go back, and here, if we click the second delivery option and then refresh the page, you'll notice that now this one is checked and the date here is correct. So that's how we make this section interactive. We just update the cart, and then when we refresh the page, it will regenerate the HTML based on the new cart. Now let's save our code into Git. We'll go back and open the Git section, and then it will tell us in cart.js, we added this function for updating the delivery option, and in checkout.js, we imported that function, and then at the bottom, we added some event listeners and data attributes, and we use that function to update the cart. Now let's add a message describing our changes. Make delivery options interactive and commit. Next, when we select a delivery option, we need to update the page. So right now in our project, when we click a delivery option, we need to refresh the page for the text to be updated. So what we're going to work on now is when we click this, we want the page to update immediately. So far in this course, the way we solve this problem is once we click this, we're going to use a DOM to get this element here and then update the text directly. However, the problem with this approach is that we need to update the page one by one. And later, there might be lots of places on the page that we need to update. For example, when we change a delivery option, we also need to change the numbers here on the right. So there's potentially a lot of things that we need to update one by one, and it's easy to make a mistake or forget something. So now we're going to learn a better way to update the page. We'll go back to our code, and let's open checkout.js again. And notice, if we scroll up, here we already have all of this code that takes our data and generates the HTML. So another way to update the page is after we update our data, we just need to rerun all this code and regenerate all this HTML. So let's give this a try. First, we're going to put all of this code inside a function so we can rerun it. We're going to scroll to the top, and let's put this in a function by typing function, and let's call it render order summary, brackets and curly brackets. So the word render just means to display on the page. And we're going to call this section the order summary. So this function should display the order summary on the page. Next, we're going to put all of this code inside our new function. So let's just remove this curly bracket here. And let's actually select all of this code, and we're just going to reformat it by pressing Tab and adding an indent. And then at the end, we're going to add back that closed curly bracket to finish the function. So all we did was we put all of our code inside a function. And then at the bottom, let's run this function because we still need to run all this code at the start of our page. So we're going to type render the order summary and brackets. So this shouldn't change anything because we're just running the same code, but now it's just in a function. Let's save and check. And everything's still working, so that's good. So now let's go back into our code. And this time, to update the page, instead of using the DOM to update the page directly like we did up here, we're just going to rerun all of this code and regenerate all the HTML. So after we update the data, we're going to rerun the code using render order summary and brackets. Now let's save and try it out. So here, let's say we start off with the first delivery option. If we click the third delivery option, you'll notice that the date up here updates automatically. If we click the second delivery option, it updates automatically as well. So that's a better way to keep the page up to date. Instead of using the DOM and changing the HTML directly one by one, we just update the data and then regenerate all of this HTML. So let's go back into our code, and there's two things that I want to point out here. So notice that we put our event listeners into this big function. And that's because when we're regenerating all the HTML, we're essentially deleting the previous HTML and replacing it. So we need to add the event listeners again. And the second thing I want to point out is that inside the render order summary function, we can call render order summary again. So a function can actually call itself or rerun itself. And this feature is called recursion. It's useful when a function needs to rerun all of its code. So now let's save our changes into Git. We'll open the Git section, and it will tell us in checkout.js, we basically moved all of our code into this function. And then at the bottom, we call the function at the start of the page, and we also call the function when we select a delivery option. So now let's add a message describing our changes. Regenerate HTML when updating delivery option and commit. So the technique we just used, where we update the data and then regenerate all the HTML, this technique is called MVC. MVC stands for Model View Controller, and it's a popular technique in software engineering. In MVC, we split our code into three parts. The first part is the model. This is all the code that saves and manages the data. So in our project, all the code in this data folder is called the model because this code saves and manages our data. The second part of MVC is the view. This is code that takes the data and displays it on the page. So in our project, if we open checkout.js and scroll to the top, here we have code that takes our data and then generates all the HTML. So this code is called the view. The last part of MVC is the controller. So this runs some code when we interact with the page. So in our project, at the bottom, these event listeners here would be called the controller because they do something when we interact with the page or with the view. So in MVC, we divide our code into these three parts, and then they interact with each other in a loop. First, we use the model to generate the view. So in our code, that's what we did here. We took the model or the data, which is our cart, and then we generated the HTML or the view. Then, when we interact with the view, it will run the controller. So that's what we did at the bottom here. When we interact with the page, we run some code. Then the controller will update the model. So that's what we did here. Inside the controller, we just updated our data using this function. And finally, we use the updated model to regenerate the view. So that's what this code does. It takes the updated data and then regenerates all the HTML, or regenerates the view. So that's how MVC works. Instead of updating the page directly with the DOM, we just update our data and then regenerate all the HTML. So we use MVC because doing this makes sure that the page always matches the data. So MVC is known as a design pattern. It's a way to organize and design our code. In the future, you might use a technology called a JavaScript framework to build websites. Many JavaScript frameworks are based on MVC, so it's useful to know how it works. Okay, now that we learned the MVC design pattern, let's do some practical examples using MVC. We're going to open our project again to the checkout page, and we're going to create this payment section on the right. Now, before we start, if we look at our code in this checkout.js file, you'll notice that we already have a lot of code here. Instead of adding even more code to this file, let's actually split this up into two different files. So one file will be responsible for this left section, and then one file will be responsible for this right section. We're doing this to keep our code more organized, and so that we don't have too much code in one file. So let's go back, and let's create two new files for the checkout page. So up here, we'll create a file, and let's call this one the order summary.js, and press enter. And let's create another file for the right section, and let's call this one the payment summary.js, and press enter. Now, both of these files are related to the checkout page. So let's create a folder and group them together. We'll create a new folder up here, and let's call it checkout, and press enter. And we're going to move these two files into this new folder. So we'll move that, and we'll move that. Next, let's open checkout.js, and let's move all of this code into the order summary. So we'll press Ctrl A or Command A to select all the code, and then right-click, cut, and then in here, we're going to right-click and paste. Now, there's a few things that we need to fix here. So first, our checkout.html file is still loading checkout.js. So we actually need to run this function inside checkout.js instead of inside here. So let's actually remove this and save. And we're going to scroll to the top. And let's export this function so we can run it inside here. So we'll type export and save. And then inside checkout, we're going to import curly brackets, the render order summary function from a string. And to locate this file, we're going to type a // first. That means to start from the current folder, and we'll go into the checkout folder. Checkout/order summary.js. And finally, we're going to run this function when we load the page. So render order summary and brackets, and save. Another thing we need to fix is if we open order summary.js, we moved this file into a folder. So now all of these file paths need to be updated. // is now inside the scripts folder, and we can't find a data folder anymore. So this is going to cause an error. So to find the data folder, we need to get out of the checkout folder, and then we need to get out of the scripts folder. So we need to get out of 2 folders. So we'll just add an additional //. And then same thing for this. We'll add another //. And for the utils, now we need to get out of the checkout folder and then into the utils folder. So we'll change this to //utils. And then for here, we're going to go out an additional folder, so another // and save. So now let's check if this still works. We'll go to our project and refresh and try it out. And the page still works because we're still running all of the same code, but we just organized it into its own file. So now let's open Git and save our changes. So it's going to tell us that in here, we removed all this code, and then we separated it into the order summary file and the payment summary file, which we're going to work on next. So let's type a message describing our changes, move order summary into its own file, and commit. Now let's start creating the payment summary on the right side. So in our code, let's open paymentsummary.js. And just like the order summary, let's put all our code in a function so we can regenerate the HTML if we need to. So we'll type function, and let's call it render payment summary, brackets and curly brackets. And let's just console.log the string payment summary, just to make sure it's working. So we'll save, and let's export this function and then run it inside checkout.js. So export, save, and then in checkout.js, at the top, we're going to import, curly brackets, the render payment summary function from a string, the current folder, go into the checkout folder, and the payment summary.js file. And then at the bottom, we're going to run the function. So render payment summary brackets and save. So let's go back to our project and open the console, right-click, inspect the console, and we'll see the message payment summary. So now we know that our code here is working and the export is working correctly. Now let's remove this code and actually build the payment summary. As always, we're going to do 3 steps. Save the data, generate the HTML, and make it interactive. So let's start with saving the data. In MVC, this is called the model. So if we go to our project, for this section, the data that we need is just to calculate these numbers here. So let's start by calculating this first number here, which is the cost of the products. To calculate this, we can loop through the cart, and for each product in the cart, we can multiply the product's price times the quantity, and then add everything together. Now let's convert these steps into code. We'll go to our project, and inside the payment summary file, first we need to get the cart, so let's import it. Import curly brackets, the cart from the string, and we'll locate cart.js. So first we'll go out of the checkout folder, // and then go out of the scripts folder, // and then into the data folder, data/cart.js, and save. And now we're going to loop through the cart. So we can type cart.forEach brackets and a function. And let's name the parameter cart item. So for each cart item, we have the product ID and the quantity. So we need to multiply the product's price times the quantity. So first, we need to use the product ID and get the full product details. And we already have some code for this. Inside orderSummary.js, if we scroll down, here we have some code that takes a product ID and finds the matching product. Now, instead of copy and pasting this code, let's actually put this into a function so we can reuse this, and we'll practice some modules. So let's select this code and right-click and copy it first. And then let's go into the products.js file. And at the top, we're going to create a function so we can reuse that code. So let's type function, and let's name it getProduct, brackets and curly brackets. And we're going to give this function the product ID that we're looking for. And then let's paste the code we copied earlier. Right-click and paste. So this finds the matching product using the product ID. And then at the end of the function, let's return the matching product. So we can use this outside of the function. So now let's export this function so we can share it across files. So export and save. First, we'll go to the order summary. And at the top, let's import that function. So we're already importing from products.js. We're going to import something else using a comma, the getProduct function. And then down here, instead of all this code, we're going to run that function. So we'll make this equal to getProduct and run the function. And we need to give the function the product ID. So let's just give that here, product ID. And because we're no longer updating this variable, we can change from let to const and save. Let's go to our project to make sure everything's still working. So that looks good. And now let's use this function inside paymentSummary.js. So the same thing, we will import curly brackets, the getProduct function from a string, and we'll go to the data folder, //data/ and products.js. And let's run that function to get the full product. So get product brackets, and then each cart item has the product ID. So we're going to give it to the function, cart item.product ID. And let's save this product in a variable so we can use it for our calculations. So const product equals getProduct. So now, as we said, we're going to multiply the product's price by the quantity. So down here, we can do product, and it has a property called .price_cents, and we're going to multiply it by the cart item, and this has a property .quantity. And the last step is to add all of these together. So outside of the loop, let's create a variable to save the result of adding them together. Let's type let, and we'll name it product price cents equals, and we'll make it 0 to start. And then every time we loop through the cart, we're going to add this to this variable. So we'll type product price cents plus equals this value here. And that's how we calculate the cost of the products. So at the bottom, let's console.log the product price cents, just to make sure that this is working. We'll save, and in our project, we're going to check the console, and it will give us this number here. And this number should match the number on the page, except it's in cents. And assuming you also have 2 socks and 1 basketball in your cart. Okay, so that's how we calculate this first number here. Now let's calculate the second number, which is the cost of shipping. So to calculate this, we're going to loop through the cart and add all the shipping costs together. So let's go into our code. And here, we're already looping through the cart. So instead of creating another loop, let's just calculate the shipping cost in the same loop. So let's create some new lines. and each cart item has a property delivery option ID. So we need to use this ID to get the full delivery option, which has the price. So in the order summary, we also have this code that takes the delivery option ID and finds the full delivery option. So again, let's create a function to share and reuse this code. So first, let's select this code, and we'll right-click and copy. And let's go to the delivery options.js file. And then at the bottom, we'll create a function. Let's call it get delivery option, brackets and curly brackets. And we'll give this function the delivery option ID. And inside here, we'll right-click and paste the code that we copied earlier. So this will take this ID and get the delivery option from this array. And let's return this delivery option so we can use it outside of this function. And just to be safe, let's also give this a default value if we don't find a delivery option. So we'll use the default operator or, and let's make the default value the first delivery option. So delivery options square bracket 0. So now let's export this and save. And then inside order summary, we'll use this function. So at the top, we're already importing from delivery options. So we'll type a comma and get delivery option. And then down here, instead of running all this code, we'll select it and make this equal and run the function get delivery option, brackets. And we'll give it this delivery option ID. Delivery option ID. And we can change from let to const, since we're not changing this variable. So now let's save, and let's use this function inside payment summary as well. So in here, at the top, we'll import curly brackets, the get delivery option function, from quotes, the data folder .. .. data/ and the delivery options.js file. And now we'll run this function, get delivery option and brackets. And each cart item has a delivery option ID. So we'll put that into the function, cart item.delivery option ID. And let's save this in a variable, const delivery option equals. And now we can get the price for the delivery option using delivery option dot price cents property. And finally, we're going to add all these together. So at the top, let's create a variable to save the result. Let, we'll call it shipping price cents equals 0. And when we loop through the cart, we're going to do shipping price cents plus equals this delivery options price. And let's also console.log this to make sure it's working. So shipping price cents and save. Now let's go to our project and check the console. And this value here should be the same as adding these two numbers together in cents. So that's how we calculate the second number, the shipping price. So note that this $4.99 number is just a practice number right now. The actual shipping price should be the total of adding all the shipping prices together. The next number we need to calculate is the total before tax. So it's just adding these two numbers together. Inside our code, let's remove these console.logs, and we'll create const total before tax cents and make it equal, and we'll add these two together. Product price cents plus shipping price cents. And the next number is the tax. So we're going to calculate a 10% tax on this number here. To calculate 10% of something, we can multiply this by 10 divided by 100. That's what percent means. So 10 divided by 100 is also equal to 0.1. So we can also multiply this number by 0.1. Let's go into our code, and we'll create a variable const tax cents, make it equal to the total before tax cents times 0.1, or 10%. Finally, to calculate the total, we're going to add these two numbers together. So const total cents equals the total before tax cents plus the tax cents. So that's how we calculate all the numbers in the payment summary. And now we have all the data that we need. Next, we're going to generate the HTML. In MVC, this is called the view. So at the bottom here, let's create a variable to store the HTML. Const payment summary HTML. And we'll make it equal to a template string. And then inside here, we're going to copy and paste the HTML. So let's open checkout.html. And we're going to scroll up until we find the class payment-summary. So we're going to generate all the HTML inside here. So let's actually select this HTML and move it into our JavaScript. So we'll select it up until this button, and then we can right-click, cut, and remove the new line, save, and then inside the payment summary, inside the string, we'll right-click and paste the HTML. And if we need to reformat, we can select these lines and press Tab a few times to reformat it. And save. Next, instead of using the same numbers every time, we're going to take the numbers we calculated up here and insert it into this HTML string. So instead of 42.75 every time, we're going to insert the product price cents. And let's give it some new lines to make it a little easier to read. Now remember that this number is in cents, and we want to display it as dollars. To do that, we already have a function for this. So in the utils/money.js file, we have a function format currency that displays it in dollars. So let's use this function inside payment summary. So at the top, let's import the function first. Import curly brackets, the format currency function from a string. And to locate this folder, we'll go out of the checkout folder, // the utils folder /money.js. And then down here, we're going to run the function format currency, open bracket, and close bracket. So that's how we insert the product price into this HTML. Let's do the same thing with all of these other numbers here. So this one is the shipping price. So we can insert format currency brackets the shipping price cents. And let's give it some new lines to make it a little easier to read. Next, let's insert the total before tax. So we'll remove this number and insert format currency brackets the total before tax cents and new lines. And next is the tax. We'll remove this and insert format currency brackets the tax cents. And we'll enter some new lines. And finally, the total. So we'll remove this insert format currency brackets total cents and add some new lines. And save. Now before we continue, I actually learned of a small issue with the format currency function. So let's open the money.js file. And I recently learned that this toFixed method has a small issue with rounding. So for some numbers that end in 5, it won't round the number properly. One way to fix this issue is to round the price cents first, so that this method doesn't have to do any rounding. So at the front here, let's just type math.round, open bracket and close bracket. So this is just a tricky issue that I discovered with the help of AI recently. We just need to add a little bit of code here to fix it. So now let's save this file and go back to payment summary. So now that we generated all this HTML and inserted our numbers into it, let's put this HTML on the page. So inside checkout.html, let's give this payment summary another class, js-payment-summary. And then we'll select this using the DOM. So now let's save this file. Inside payment summary, at the bottom, after we create the HTML, we're going to document.query selector, brackets and a string, and we'll select .js-payment-summary to get that element. And we'll change the HTML inside that element using .inner capital HTML, and we'll make it equal to the payment summary HTML that we just created. So now let's save and check our project. And now these numbers on the right should match what we have in the cart and the delivery options that we selected. So that's how we generate the HTML for this section here. Now let's save our changes into Git. We'll open Git, and it will tell us in checkout.html, we removed the HTML we created manually. In deliveryoptions.js, we created this shared function for finding the full delivery option, and the same thing in products.js for finding the full product. Inside checkout.js, we're now running all the code inside payment summary. In order summary, we're just using those shared functions that we created. And then in payment summary, we calculated the numbers and generated all the HTML. And finally, in money.js, we fixed a small bug related to rounding. Let's type a message to describe our changes. Save data and generate HTML for payment summary and commit. The last step is to make it interactive. In MVC, this is called the controller. Let's go to our project. And one thing we can make interactive in this section is the place order button. However, we haven't figured out how orders work yet. So we'll work on this in the next lesson. Another thing we can make interactive, however, is when we change the cart on the left, these prices should also update. So let's make this interactive. First, when we delete a product, the prices here should update. So let's actually practice using MVC to create this functionality. According to MVC, when we click delete, we should update the data and then regenerate all of this HTML. So let's get started and go to the code for the delete link. So this is in the order summary section. So in our code, let's open the order summary.js file. And we'll scroll down and find the event listener for the delete link, which is right here. When we click delete, first we're going to update the data. So we already update the data using this function, remove from cart. And now the next step, according to MVC, is to just regenerate all the HTML. So to regenerate the HTML for the payment summary, we created this function at the top, render payment summary. So this will recalculate all the numbers and then regenerate the HTML. So let's import this function. In orderSummary.js, we'll scroll to the top, and down here we can import curly brackets, the render payment summary function from a string, and we'll locate the payment summary file. So it's in the same folder. So we're going to start with a ./ which is the current folder, the payment summary.js file. And now let's use this function in the event listener. So let's scroll down. When we click delete, we're going to update the data and then regenerate all the HTML using render payment summary brackets. Now let's save and go to our project. Focus on the numbers on the right here, and now let's click delete. And you'll notice that all of these numbers updated to match our new cart. So that's another example of using MVC. When we click delete, instead of using the DOM to change these numbers one by one, we just update the data and then regenerate all of the HTML. MVC makes sure that the HTML always matches the data, or that the view always matches the model. Let's do one last example of MVC for this lesson. When we change the delivery options here, we also want these numbers on the right to update. So let's find the code for the delivery options. Again, this is in the order summary section. So in our code, we'll open orderSummary.js, scroll down, and then here, we updated the data, and then we're just going to regenerate the HTML for the payment summary using render payment summary and brackets. Now let's save and then look at our project, and let's try changing the delivery option here. And you'll notice the numbers on the right update automatically to match the cart. And that's it. We finished the checkout page. So now let's save our code into Git. We'll go into the Git section here, and inside order summary, we basically imported the render payment summary function, and then at the bottom, we used MVC. So when we click delete, we update the data or the model, and then we regenerate all the HTML or regenerate the view. Down here, same thing. When we click a delivery option, we update the data and then regenerate all the HTML. The last thing we're going to do is at the top of this file, we're going to remove this practice code that we use to learn external libraries. So let's open orderSummary.js. And at the top, we're going to remove this code and save. Now let's go back into Git, and that looks good. Finally, let's type a message describing our changes. Make payment summary interactive and commit. And that's the end of this lesson. In this lesson, we learned about external libraries, which is code that is outside of our project. We learned about the day.js external library, which helps us work with dates. We also learned how to use external libraries with JavaScript modules together, as well as the default export syntax. We created the delivery section of the checkout page. We learned MVC, which is a better way to design our code. And we created the payment section of the checkout page. Thanks for watching this course so far. If you want to support this channel, you can check out the premium version of my courses just like this one. where you can get a certificate of completion and a better learning platform. If you're interested in extra videos from me, more in-depth videos, and behind-the-scenes content, you can check out these links here. You can also support the channel by liking the video, subscribing, and sharing this video with others. Thanks again, and let's continue with the course. Here are some exercises to help you practice what we learned in this lesson. In the rest of this course, if you get an error in your project, but your code looks correct, you may have some bad data saved in local storage. To fix this, you can try running localstorage.clear in your console to remove everything from local storage, and then refresh the page. If you see an error like this, object, that means that you saved something directly into local storage, but you have to JSON.stringify it first. So check your code to make sure that you're always stringifying before saving to local storage, and then clear your local storage and refresh the page. In this lesson, we're going to learn how to test our code. So when we're writing code, it's important to test our code to see if it's working correctly. And if you're working at a company in the future, you'll also be expected to test your code. So let's learn how to do that in this lesson. The easiest way to test our code is to just open the website and try out the code. For example, in our code here, let's open the file utils/money.js. And then inside this file, we have a function called format currency. So let's say we want to test format currency. How do we check if this is working correctly? So as I mentioned, the easiest way to test this is to just open our website and try out this code. So let's open the website. If you don't have the website open, you can right-click checkout.html and then click Open with Live Server. So on this website, we have a couple of prices here, as well as here. And we created these prices using the function format currency. So if we just look at the website, we can see that these prices look correct. And this tells us that the function format currency is working correctly. So that's one way to test that function. We just open the website and try it out. So this is called manual testing, when we manually open the website and try our code. So manual testing is really useful for quickly checking to see if everything is working. So now let's talk about the disadvantages of manual testing. One disadvantage is it's hard to test every situation. For example, here we just happen to have the number 2095 and we test with that. However, what if we want to test with different numbers, like the number 0, or a number that requires rounding, like 2000.5? In order to test all these situations, we have to manually set up our website so that our code runs with those numbers. So here we ran with 2095 as well as 0, so we covered those situations. However, we did not cover 2000.5, so we had to do a bunch of setup in order to test that situation. So as you can see, it takes a lot of time and effort to test different situations in our code. The second disadvantage of manual testing is that it's hard to retest the code. For example, if we change some of our code, how do we retest format currency and make sure that it's still working correctly? Well, we would have to open the website and set up all the situations again and retest all those situations manually. So this takes too much time and effort to retest the code. To solve these two problems, we're going to learn another way to test our code called automated testing. Automated testing basically means using code to test code. Instead of manually opening the website and clicking around to try our code, we're going to tell the computer to do these tests for us, and this will save a lot of time and effort. So let's go ahead and create our first automated test. We're going to go back to our code, and again, let's test this format currency function. To create an automated test, we're just going to write some code to test this function. So first, let's create a folder to group all of our test code together. We're going to click this icon to create a folder, and let's just name this tests and press enter. And we're going to move this folder, so we'll drag it to the top level here beside the HTML files. So we want the test folder to be beside the scripts folder. Next, let's click on the test folder, and we're going to create our first test file. We'll click this, and we're going to test format currency, which is inside the money.js file. So let's name this file money.test.js. So we know that this file contains tests for money.js. So let's press enter. And inside this file, we're going to write some code to test format currency. So first, let's import format currency so we can test it. At the top, we'll type import curly brackets format currency from a string, and from here we're going to locate money.js. So we start out in money.test.js, and we need to get out of the test folder. So we'll type .. to get out of this folder, and then we'll go into the scripts folder, scripts / and then into the utils folder, utils / and locate money.js. So as a reminder, format currency takes a number in cents, like 2,095 cents, and then converts it into dollars, like $20.95. So first, let's test this function using that number 2,095 as an example. We're going to run the function format currency brackets and give it 2,095. And now we're going to check if the result of this function is correct. To do that, we can just use an if statement. So we'll type if, open bracket, close bracket, and we said we expect format currency 2095 to give us the string 20.95. So we're just going to check if this is triple equals to the string 20.95 and curly brackets. And if these two are equal, that means the code is working correctly. So we're going to console.log the string passed to say that this test has passed. Now, if it is not equal to 20.95, we're going to say that this test has failed. So we're going to give it an else curly brackets, and then here we're going to console.log the string failed and save. And that's it. This is our first automated test. It checks if the result of this function is correct. If it is correct, we're going to display passed, and if it's not correct, we're going to display failed. Now let's run this test code. So remember, we can't run JavaScript files directly. We need to load this JavaScript file using an HTML file. So let's create an HTML file to run this test. Inside the tests folder, we're going to create a new file by clicking up here. And let's name this file tests.html and press enter. And in here, we're going to start by creating a basic HTML structure. So as a reminder, at the top, we'll type exclamation doc type space HTML greater than, and we'll create an HTML element. And then inside, we'll create a head element as well as a body element. And then inside the body, we're going to create a script tag to run JavaScript code. And we're going to give the script tag an attribute called src or source equals double quotes. And we're going to give it this JavaScript file to run, moneytest.js. And also, because this file uses import, we also need to add an attribute called type equals module to give this file access to JavaScript module features like import. So now let's save, and we're going to run this file in live server. So we're going to click it and then right click, open with live server. And then we're going to check the console by right clicking, inspect, and open the console. And our code displays the text passed. So if we look at our code and open moneytest.js, it's telling us that the result of this function matched what we expected, and this test passed. So that's how we run an automated test. We just load it like normal JavaScript. So as you can see, automated tests are pretty straightforward. We're just using code to test code. Okay, so I mentioned earlier that a disadvantage of manual testing is it's hard to test every situation. Now let's solve this problem using automated tests. So inside moneytest.js, if we want to test format currency in different situations or with different numbers, we can just add some more tests at the bottom. So at the bottom, let's create some new lines, and we'll just add another test using if, brackets, and curly brackets. And inside here, let's test format currency with the number 0. So we'll type format currency, brackets, 0, and we expect this result to be the string 0.00. So we'll check if this triple equals the string 0.00. If this result matches, we're going to console.log the string passed. And if this result does not match, we're going to type else, curly brackets, and console.log the string failed. So that's how we test format currency in a different situation with the number 0. So now let's save and then go back to our test page, which is here, and then open the console, right-click, inspect the console, and it will tell us that both of our automated tests passed. So as you can see, automated tests help us test our code in different situations very easily. This is a lot faster than manually opening our website and setting it up to test with different numbers. So let's go back to our code. And by the way, another name for a situation that we're testing is called a test case. So here, instead of saying we're testing 2 different situations, we usually say we're testing 2 test cases. Okay, now let's get more practice and add another test case. At the bottom of this file, we're going to create another if statement, if, brackets, and curly brackets. And this time, let's test format currency, brackets, and we'll give it a number that requires some rounding. So when we calculate the 10% tax on our website, the result could be a decimal, like the number 2000.5. If we use the number 2000.5, this will convert into $20 and 0.5 cents. However, we can't have 0.5 cents, so we're going to round this up to 1 cent. So we're going to have $20 and 1 cent. So let's check if this result triple equals the string 20.01. And if it is equal, we're going to console.log passed. And if it is not equal, else curly brackets console.log failed. And save. And open our test page and open the console. And you can see that all 3 of our test cases passed. And that's it. We just created 3 test cases for format currency using automated tests. Now let's go back to our code. And currently we have 3 test cases. And you might be wondering, how many test cases should we have? Generally, we create 2 types of test cases: basic test cases and edge cases. A basic test case just tests if the code is working or not. So here, our first test case is a basic test case. We use a normal number like 2095, and we see if format currency is working correctly. The second type of test cases that we should have are edge cases. This means we test the code with values that are a little bit tricky. They're on the edge of what our code can handle. For example, in our test here, the last 2 test cases are edge cases. 0 is sort of a special number that's not positive or negative, and 2000.5 is a number that requires some rounding. So these numbers are acceptable. We can use them with format currency, but they're a little bit tricky and on the edge of what our code can handle. So when creating test cases, make sure to create basic test cases as well as edge cases, if there are any edge cases. Now, we could have added another basic test case like format currency 1095. However, this is very similar to 2095. It's basically testing the same thing, so we don't need another test case like this. Generally, we should try to test something different in each test case. For example, an edge case that we have not tested is the number 2000.4. So this would check if the code rounds down correctly to $20.00. However, I'll leave creating this test case as an exercise. Now let's move on and talk about the second disadvantage of manual tests, which is it's hard to retest the code. Automated tests also solve this problem. For example, let's say that we change the format currency function. So inside util/money.js, let's say that we change the code and we remove this rounding code. So we remove math.round and the brackets here. And now after we change this code, how do we check if this code still works correctly? If we were only doing manual testing, we would have to open up the website, set up everything manually, and then click around to see if it's working. However, with automated testing, all we need to do is to rerun all of this test code, and it will instantly retest all of these cases. So let's go back to money.js and save this code, and then go into our test page and check our console. Right-click, inspect the console. And you can see that it instantly reruns all the test cases, and it tells us that the last test case failed. So automated tests make it really easy to retest our code after we make any changes. Okay, now we have another problem here. We can see that the test cases passed, and failed, but it's not clear which ones passed and which ones failed. We don't really have a name for these tests, so we don't know what they're doing. So that's what we're going to add next. We're going to give each of these tests a name. So let's go back to our code and open moneytest.js. And now we're going to give each of these test cases a name. So above the first test case, let's just console.log a string, and we're going to give this test a name. So the name should describe what this test is doing. So in here, let's just use the name converts cents into dollars. And that's how we give the test case a name. Let's do the same thing with the other two test cases. So down here, we're going to console.log brackets and a string, and we'll give the second test case a name. So this one tests the number 0. So let's use the name works with 0. So again, the name just describes what the test is doing. And let's do the same thing for the third test case. We'll console.log a string, and here we're testing if the function rounds up to the nearest cent. So let's use the name rounds up to the nearest cent and save. If you're wondering how I came up with these names, a naming convention that we use is to describe what the code is doing. For example, the code works with 0, or the code rounds up to the nearest cent. And then we remove the code. Some people also like to use the word it instead of the code. So now each of these test cases has a name above it. If we open up our test page and open the console, now we can see exactly which test case passed and which test case failed. So this failed test case tells us we have a rounding problem in our code. So now we can go back to our code into money.js and investigate the rounding problem. So of course, we removed math.round as an example. We're just going to add it back to fix that failing test. Capital M math.round, open bracket, and close bracket. And save. And then open the console for our tests, which is here. And now all of our test cases passed. Next, another thing we do when naming our tests is to group related tests together. For example, these 3 test cases are for the format currency function. So we're going to group these tests together and give this group a name. By the way, a group of related tests is called a test suite. So let's go back to our code and open moneytest.js. And at the top, let's give this group of tests, or this test suite, a name by typing console.log brackets and a string. We're going to name it test suite format currency and save. So now let's open the console for our tests. And now at the top, it will show us test suite format currency. So this makes it clear that this group of tests here are for the format currency function. In the future, if we are testing some other code, for example, a calculated tax function, we can create another group of tests or another test suite like this. And this makes it clear that the second group of tests is for the calculate tax function. So this is how we name our tests and group our tests together to make it more clear what is being tested and which tests have passed or failed. And now we created our first set of automated tests. As you can see, automated tests are basically using code to test code, and they make it really easy to check if our code is working correctly. So now let's save this into Git. We're going to open the Git section, and our first change in moneytest.js, we created the tests for format currency, and then we created an HTML file to load our test code. So let's create a message describing these changes. Create automated tests for format currency and commit. Next, we're going to learn how to use a testing framework to write automated tests. So what is a testing framework? In the previous lesson, we learned about external libraries, which is code that is outside of our project that someone else wrote. And we can load external libraries into our project and use them. So a testing framework is an external library that helps us write tests easier. Let's go back to our code, and we're going to open the moneytest.js file. And notice that in our tests, we need to do several things. First, we create a test suite and we give it a name, and then we create some tests. And for each test, we give it a name. And then we compare the values and display the result in the console. So a testing framework helps us do all of these things automatically and gives us many other features. So now let's learn our first testing framework. In this course, we're going to use a popular testing framework called Jasmine. Now, if you're working at a company in the future, you'll definitely be using a testing framework, but it might not always be Jasmine. And that's okay, because most testing frameworks are pretty similar. So by learning Jasmine, you'll be able to easily use other testing frameworks in the future. To load Jasmine into our project, we're going to go into the video description, and we're going to click this link to download Jasmine. So once that link opens, we're going to be on this page, and we're going to scroll down, and we're going to click this jasmine-standalone.zip file to download it. Now, once that's finished downloading, we're going to open our downloads folder. And if you're on Windows, we're going to right-click the zip file and click Extract All, and click Extract. Now, if you don't have that Extract All option, you can also create a folder with this name and then double-click the zip file and drag everything into that folder. If you're using a Mac, you can just double-click the zip file. So this folder contains the code for Jasmine, and we're going to drag this folder into our project. So let's open the code for our project. And then we're just going to drag this folder down here and click Copy Folder. So just make sure that this folder is beside the Scripts and Images folder. Next, we're going to rename this folder. So we'll right-click, rename, and let's rename it to tests-jasmine. To make it clear, this folder contains tests created with Jasmine. So now let's press Enter. And now we have Jasmine inside our project. So inside the lib folder, we have some JavaScript files here. And this is the code for the Jasmine testing framework. So this is another way to load an external library into our project. We can just download all the code and put it into our project. And this is useful if an external library has lots of different files like this. Before we continue, let's save the changes into Git. So if we make any changes later, it will be easier to see them. We'll open the Git section, and then we just added all the code for Jasmine. So at the top, let's type the message, add Jasmine testing framework, and commit. Now that we loaded Jasmine into our project, let's learn how to use it. So Jasmine has a documentation page that shows you how to use the testing framework. However, to save time, I'm just going to show you the features that we need, and you can read the documentation later if you want. So first, let's learn how to run tests using Jasmine. I'm going to close this for now, and then in our code, we're going to open the test-jasmine folder, and at the bottom, we're going to open this spec runner.html file. So this file loads all of the tests. So this does the same thing as our test.html file from before. And by the way, in Jasmine, spec is another name for test. So spec runner just means test runner. This file runs all the tests. So let's actually rename this file to tests.html so we can match what we had before and compare the two. So here we're going to right click and rename tests.html and press enter. And now let's open this file and take a look at the code that's inside. So here at the top, this is the code for the Jasmine testing framework. So we're just loading the framework up here. Below that, here we have the code that we want to test. So this code is sort of like the money.js file that we were testing earlier. And then at the bottom, these files contain the tests. So these files are sort of like the money.test.js file that we had earlier. And you'll notice that these are in a spec folder. So as a reminder, in Jasmine, spec is another name for test. So this is basically the test folder. This folder contains all of our tests. So now let's run these tests. And to do that, we just need to open this HTML file in Live Server, just like we did before. So for this file, we're going to right click and open with Live Server. And I'm just going to make this a little bigger by pressing Control equals, so it's easier to see in the video. So this is what Jasmine tests look like. Up here, we have 5 green dots. This means we have 5 tests that we ran, and the green color means that all of them passed. So down here, each test has a green dot, and you'll notice that each test also has a name next to it, which tells us what the test does. And don't worry if this is in a different order for you. Jasmine randomizes the order of the tests. Also notice that some of these tests are grouped together into a test suite. And up here, we have the name of the test suite. So as you can see, a testing framework helps us do all of the things we were doing before. And it also provides a nice looking website where we can see the test results. So a testing framework is just an external library that helps us write tests easier. Now that we know what Jasmine and a testing framework is, let's learn how to write our tests using Jasmine. First, we're going to go back to our code. And we're going to remove the example code provided by Jasmine. So down here, we'll remove these 4 script tags. And let's also remove the source folder. So we'll right click, delete, as well as the spec folder. Right click, delete. But make sure we keep this lib folder because this contains the code for Jasmine. And now inside test-jasmine, we're going to create a new file for our tests. So we'll create a new file. And let's say that we're testing money.js again. So let's name it the same thing here, money.test.js, and press enter. And now let's create the same tests we had before, but using Jasmine this time. So to make it easier for the video, I'm just going to take this file and drag it to the top here, so we can see these two side by side. So like before, we're going to create tests for format currency. First, we'll need to import this function at the top. So let's just actually select this and right click, copy, and then down here, right click and paste. And just make sure that this file path still works. So our money.test.js file has to be inside tests-jasmine, and this folder should be beside the previous test folder. Next, we're going to create a test suite and name the test suite. So in Jasmine, to create a test suite, we're going to use a function called describe. So this describe function is provided by Jasmine, and it creates a test suite. Next, we're going to give a name to the test suite. So to name a test suite in Jasmine, we're going to give describe a string. And this string is the name of the test suite. So let's name it the same thing as before. Test suite format currency. Next, we're going to add some tests inside the test suite. To do that, we're going to give describe a second parameter, which is a function, brackets, arrow, and curly brackets. And inside here, we're going to create a test and give the test a name. To create a test in Jasmine, we're going to use another function called it and brackets. So it is another function provided by Jasmine, and this creates a test. Next, let's give a name to our test so that we know what it's doing. To name a test, we're going to give it a string, and this is going to be the test name. So let's name it the same thing we had before. Converts cents into dollars. And now we're going to add some code into our tests. To do that in Jasmine, we're going to give it a second parameter, which is another function, brackets, arrow, and curly brackets. So this is the code inside the test. And in this test, we need to compare these two values and display the result. In Jasmine, instead of creating an if statement and displaying the result ourselves, Jasmine provides us another function to do all of this. And that function is called expect and brackets. So expect lets us compare a value to another value. For example, let's give expect the first value that we want to compare, which is format currency 2095. So we'll type format currency brackets 2095. And now to compare this value to another value, expect gives us an object. And this object has many methods we can use to do comparisons. So one of the methods we can use in this object is dot to equal brackets. And then inside these brackets, we'll put another value that we want to compare this to. So we want to compare this to the string 20.95. And that's it. This checks if this value is equal to this value, and then displays the result on the page. So it does everything that we did before, except with one line of code. And you'll also notice that Jasmine's code is designed so that it reads like English. For example, we expect format currency 2095 to equal this string. And this makes the test code easier to read. So we just created our first test suite and our first test using Jasmine. Now let's run this test. To do that, we just need to run this JavaScript file inside test.html. So first, let's save this file. And then inside test.html, we're going to load this file. So in here, at the bottom, we're going to create a script tag. And we'll give it a source attribute, src equals double quotes. And we're going to load moneytest.js. Test.js. And remember, our test file uses import. So we also need to give it the attribute type equals module. So this file has access to JavaScript module features. So now let's save. And we'll open this file in our browser. So we should have it open from before. If you don't, you can right-click and open with live server. So we'll open the test page. And now you can see that we have our one test that we created here. And it's passing, so it's green. You can see here that we created a test suite with a name. And we also created a test with this name. So we just created the first test that we had before, except using Jasmine this time. And you can see that Jasmine also creates a nice website for us to see the test results. Okay, now that we learned how to use Jasmine to create a test, let's get some practice and create the rest of our tests from before. We'll go back to our code and open moneytest.js. And here, we're going to create the other two tests that we had here. So at the bottom, inside the same test suite, we're going to create another test using the function it, brackets, and we'll give it a string, which is the test name. And let's name it the same as before. Works with 0, comma, brackets, arrow, and curly brackets. And now we can put something inside this test. So inside the second test, we're going to compare these two values. To compare values, we're going to use the function expect, brackets, and the first value is going to be format currency, brackets 0. And then expect gives us an object. And this object has a method called .toEqual, which lets us compare this value to another value. So we'll call this method using brackets and compare it to this string, the string 0.00. And now let's save, and Live Server will update our web page automatically. So we'll open the test page, and now we have two tests, and they both passed. So that's how we create the second test using Jasmine. And again, don't worry if this is in a different order for you. Jasmine randomizes the order of the tests. Finally, let's create that third test that we had before. We'll go back to our code, and then in our old money test file, we're going to create this third test. Feel free to pause the video if you want to give it a try yourself. So we'll scroll down, and we'll create another test inside this test suite using the function it, brackets, and a string, and we'll give it the same test name as before. Rounds up to the nearest cent, comma, brackets, arrow, and curly brackets. And we're going to compare these two values. So we use expect, brackets, and give it the first value, format currency, brackets 2000.5, and to compare it, we'll use the method .toEqual, brackets, and compare it to 20.01, and save. And let's go back to our test page, and now we have 3 tests, and all 3 of them passed. So we recreated the tests that we had before. Now let's try making one of these tests fail to see what it looks like in Jasmine. We'll open our code, and let's open the file utils/money.js. And just like before, let's try removing this math.round function and remove the brackets here to make one of the tests fail. So we'll save and then open our test page. And now it will tell us that one of our tests failed. And here it will show us the details of the failing test. So it tells us the test suite name and the test name that failed. And it will also tell us the two values that are not equal to each other. And here it will tell us where this test failed. So it will tell us that it failed in moneytest.js at line 13. So if we go back to our code and we open the Jasmine moneytest.js, line 13 is right here. So it's just telling us that this line failed the test. Here we can see the full list of tests, and it will tell us that we have 3 tests, 2 of them passed, and 1 of them failed. So Jasmine gives us a lot of details on where a test failed to help us fix the issue. Now let's add back math.round to make everything pass again. We'll open our code and open utils/money.js, and we'll just add back capital M math dot round, open bracket and close bracket, and save. And if we check our test page, everything passes again. So this is how we use a testing framework like Jasmine to create tests. The testing framework gives us a bunch of functions such as describe, it, and expect, and then we use these functions to create our tests. So these functions have a lot of features inside them. They do all of the setup for us, and they also display the tests on a nice web page for us. Now there's one more thing I want to mention, which is we can use describe inside describe. This helps us organize our tests further. So now let's save our changes into Git. We'll open the Git section, and let's close this file at the top for now. So inside moneytest.js, we created all the tests that we had before for format currency, but using Jasmine this time. And for spec runner, we renamed this file to test.html. And finally, we deleted all the test code that came with Jasmine. So now let's add a message to describe our changes. Remove default tests and add money tests and commit. Now let's test a different function using Jasmine. And along the way, we're going to learn some more features of testing frameworks. Let's go back to our code. And we're going to scroll to the top and open the data/cart.js file. So inside this file, we have a function called add to cart. So we're going to create tests for the add to cart function. First, since this function is in a different file, we're going to create a new test file. So we're going to scroll down and let's close the test folder so we don't get confused. And then inside test-jasmine, we're going to click in this folder and then create a new file. And let's name it cart-test.js and press enter. So we name it the original file name, which is cart, and then just add test at the end. And to better organize our test files, we usually try to match the folder structure of the code. So for example, in our code, money.js is inside this utils folder. So inside our tests, we should also create a utils folder and put this file inside. So we'll create a new folder by clicking up here, and let's name it utils, and press enter, and then move the moneytest.js file inside. If it asks you if you want to update imports automatically, you can click yes. If you check your code, scroll to the top, make sure that your file path starts with .. because now we're inside another folder. VS Code sometimes updates the file paths for us automatically, but if it doesn't, we can just add an extra .. in front ourselves. And we're also going to open moneytest.js and save this file. Next, if we scroll up, cart.js is inside a data folder. So inside our tests, we're also going to create a data folder. Let's click cart-test.js. We'll create a new folder, and let's name this the data folder and press enter. And then move cart-test.js inside here. Now you'll notice that this folder structure doesn't perfectly match the folder structure that we have up here, because utils is inside the scripts folder. But usually this data folder should also be inside the scripts folder. I just made a mistake when structuring the project. So let's just use this folder structure in our tests. Okay, so now let's open cart-test.js, and now we're ready to test the add to cart function. So first, let's import add to cart at the top. we'll import curly brackets, add to cart from a string, and we're going to locate cart.js. So first, we need to get out of the data folder using .. and then get out of the test-jasmine folder, .. and we'll go into this data folder, data/cart.js. Next, let's create a test suite for this function. So we'll create some new lines, and to create a test suite in Jasmine, we'll use the function describe, brackets, and we'll give this test suite a name by giving it a string. So let's use the name test suite : add to cart. And we'll give it a second parameter, which is a function, brackets, arrow, and curly brackets. And now inside this test suite, we're going to add some tests. So let's look at the code for add to cart to see what kind of tests we should add. So we'll open data/cart.js. And then inside add to cart, you'll notice that this function uses an if statement. A best practice in testing is to test each condition of the if statement. This is known as test coverage. Test coverage means how much of the code is being tested. And a best practice is we try to maximize test coverage. So for this if statement, we'll create a test for the first condition, which is when the product is already in the cart. And we'll create a test for the else condition, when the product is not in the cart. Let's go back to cart.test.js. And inside this test suite, we're going to create a test using the function it, brackets, and we'll give it a string. And this will be the test name. So for the video, I'm just going to scroll up and take this cart.js file and put it at the top here, so we can see our code and our tests side by side. So I'm going to scroll down to the add to cart function. And we mentioned that we're going to test each condition of this if statement. So the first test is going to be when the product is already in the cart. So down here, let's name it adds an existing product to the cart, comma, brackets, arrow, and curly brackets. And let's add another test for when the product is not in the cart, so this else condition. So down here, we'll create another test using it, brackets, and a string, and the test name adds a new product to the cart, comma, and a function, brackets, arrow, and curly brackets. So these are the two tests that we need for the two conditions of this if statement. Let's actually start with adding a new product to the cart, since it's a little easier to test. Now, unlike the format currency function, add to cart doesn't return a value, so we can't really compare it to another value using expect. Instead, we're going to call add to cart to modify the cart, and then check if this cart looks correct. To do that, inside here, let's call the function add to cart, brackets. And this function takes one string, which is the product ID. So inside here, let's give it a string. And to find a product ID that we can test with, we're going to go to the left and scroll up. And we're going to open the data/products.js file. And inside here, we have a list of products. So let's just take the first product ID and use it in our test. We're going to select this ID and right-click, copy, and then inside cart.test.js, in this string, we're going to right-click and paste. So this will add this product ID to the cart. And now to check if this code is working correctly, we're going to check what the cart looks like. So first we need to import the cart. We're going to scroll up, and since we're already importing from cart.js, to import the cart, we can type a comma, cart. And then at the bottom here, we're going to create a new line. And first, let's check if the cart.length is correct. So if we assume that we start with an empty cart, when we add a product, the cart.length should be 1. So we can compare these two values, cart.length and 1. So to compare values, we're going to use the function expect, brackets, and we'll compare the cart.length. And then here, we'll use the method .to equal, brackets, 1. So now let's save this file, and we're going to run these tests. To run them, we're just going to load this file inside test.html. So we'll open this, and then at the bottom, we'll create a script tag, give it a source attribute, double quotes, and we're going to load this file. So this file is inside the data folder, so we need to type data / to go into the folder, and then load cart test.js. And this file also uses import. So we're going to give it the attribute type equals module to enable JavaScript module features. And one thing that I forgot to do is we moved money test into the utils folder. So we need to update the source attribute to add the utils folder, and then / to go into the folder, and then locate moneytest.js. So now let's save this HTML file and open this test page in our browser. And now we should have 2 additional tests, and the test that we just created should fail. If it doesn't fail for you, you can go into your console and run localstorage.clear, and then refresh the page, and it should fail. So this tells us that the failure happened in the test suite add to cart. In the test, adds a new product to the cart, which is the one we just created. So it's telling us that the cart.length is not equal to 1. It's equal to a different number. So why is this happening? Let's go back to our test, open cart.test.js, and in here, remember that we assumed the cart starts as empty, and if we add a product, the cart.length would be 1. However, the cart doesn't actually start as empty. In cart.js at the top here, we're loading the cart from local storage. If there's nothing in local storage, we use this default cart. So our starting cart depends on what's inside local storage. And this is a big problem when testing, because local storage can change. If there's an empty cart saved in local storage, our test will pass. But if there's not an empty cart in local storage, then this test will fail. This is known as a flaky test, a test that sometimes passes and sometimes fails, even if we don't change the code. Now, to solve this problem, we're going to use a feature of Jasmine called mocks. A mock lets us replace a method with a fake version, and then we can make the fake version do anything we want. For example, when we load the cart from local storage, we're using local storage.getItem. So we can use a mock to create a fake version of getItem. And then we can make this fake version do anything we want, like return an empty array. So let's go ahead and create our first mock. We'll go back to cart.test.js, and at the top of this test, we're going to create a mock using another function of Jasmine called spy on and brackets. And we'll give spy on 2 parameters. The first parameter is the object that we want to mock. In our case, it's local storage. So we'll type local storage, comma, and then we'll give it a string. And this string will be the method that we want to mock. In our case, we want to mock the getItem method. So here we'll type getItem and make sure I is uppercase so that we exactly match the method name. So now this will replace local storage.getItem with a fake version. And we can make this fake version do anything we want. To do that, spy_on gives us an object. And this object has a property we can use. So at the end, we'll type dot and the property called and. And this result is also an object. And this object has a method called dot call fake brackets. So don't worry about all the dots here. Jasmine just organizes its code so that it reads like English. So we're spying on local storage.getItem and call fake. So next we're going to give call fake a function, brackets, arrow, and curly brackets. And this function is what we want getItem to do. So we're essentially overriding the original getItem with whatever is inside this function. So earlier, we said we wanted getItem to return the empty array for this test. So inside this fake function, let's make getItem return the empty array. Now remember that local storage only supports strings, so we need to return this as a string. To do that, we're going to use the code JSON all uppercase dot stringify, open bracket and close bracket. So this will convert whatever's in the brackets to a JSON string. And that's what we need for local storage. So now let's test out this mock to see if it works. Below this, we're going to console.log brackets and run local storage.get capital I item brackets the string cart. Let's save this file and then open the test page in our browser. And we're going to open the console. So right click, inspect, and the console. And you'll see that here, local storage.getItem is no longer loading from the actual local storage. It's giving us an empty array every time. So now we have mocked the getItem method. However, you'll also notice that our test is still failing. So how come it still fails? To understand what's happening, let's take a closer look at our code. We'll go back to our code. And inside our tests, here we're mocking local storage.getItem. But notice that above this, if we scroll up, we import the cart at the top. So the order of this code matters. First, we load the cart from local storage, and after we're mocking local storage.getItem. So the cart is already loaded at this point, and this code doesn't have the effect that we want. So one way to solve this problem is after we mock local storage here, we should reload the cart. So inside cart.js, just gonna give it a little more space. To reload this cart after we mock, we just need to rerun all of this code. So let's create a function so we can rerun this code. At the bottom here, we'll create a function and we'll call it load from storage, brackets and curly brackets. And we're just going to move all of this code inside the function. So let's select all the code up to cart equals. We'll right click, cut, and then in the function, we'll right click and paste. And at the top, let's create the cart variable again. Let cart and semicolon. And lastly, when we load this file, we need to run this function so that we run this code at least once. So down here, we'll just run this function, load from storage and brackets. So let's save So we're basically running the exact same code as before, except this code is now inside a function. And now in our tests, after we mock local storage.getItem, we're going to reload the cart using this function. So first let's export it so we can use it in our tests. We'll type export and save this file. And inside our tests, let's scroll up to the top. We're already importing from cart.js. So we'll type a comma and we'll import load from storage. And then we'll scroll down back to our tests. And here, after we mock local storage.getItem, we're going to load from storage, brackets, and save. So this time, we mock local storage.getItem first to return an empty array. And then when we reload the cart, this is going to be an empty array, and the cart will be empty. And now in our tests, when we add a product to an empty cart, the cart length will be equal to 1. So this test will pass. So we can actually remove the console.log here and save and check our test page. And now this test should be passing. Next, let's go back to our code. And if we look at the add to cart function in cart.js, so in here, at the bottom of this function, you'll notice that we're saving the cart to local storage. So this is going to call local storage.setItem. However, we don't actually want to save to local storage because this is just test code. We don't want our test code to be modifying local storage or affecting our real code. To prevent this, we're also going to mock local storage.setItem. So down here, we're going to create some new lines at the top of the test, and we're going to mock local storage.setItem using the function spy on brackets, and we'll give it local storage, comma, a string, and the method we want to mock, which is setItem, and save. And remember, the order of the code matters. So we want to mock local storage.setItem first, and then we call add to cart. So now setItem will be replaced with a fake version, and this will no longer save to local storage. Next, spy-on has another useful feature, which is it records every time a method is used. For example, what if we want to make sure that add to cart saves the cart to local storage at the end? In our tests, setItem is mocked, so we can't really check what's inside the local storage. Instead, we can just check if add to cart calls setItem at some point. To check if setItem was called, at the bottom, we can use the function expect, brackets, and we're going to give this the method that we mocked, which is local storage.setItem. And remember that expect gives us an object, and this object has many useful methods to check stuff, like .toEqual. So another method we get from expect is .to have been called times, brackets. So make sure that you write this method in camel case. To is lowercase, and every word after starts with a capital. So this method checks how many times local storage.setItem was called in the code above. So we expect it to be called once inside add to cart. So we're going to give it the number 1. So keep in mind that this only works if this method has been mocked with spy on. So now let's save and open our test page. And you can see that all of our tests passed. And local storage.setItem was called once. So after we mock a method, we can check how many times this method was called. And we can even check what values this method received, but I'll leave that as an exercise. Another thing you'll notice here is that each test can have multiple expectations, and the test will only pass if all of its expectations pass. Now let's add a few more expectations to this test for practice. So one thing we can check is we can check the first product in the cart and make sure that its product ID matches this string here. So below this, let's use another expect brackets, and we're going to check the first product in the cart using cart square bracket 0. So this is going to be an object, and this object is going to have a property called product ID. So down here, we'll get the dot product ID. And we're going to check if this product ID is equal to this string. So to do that, we'll use the dot to equal method, brackets, and we'll give it this string here. So let's just select this and right click, copy, and here, right click and paste. Another thing that we can check is the quantity. When we add a new product to the cart, the quantity should start out as 1. So down here, we're going to add another expect brackets, and we're going to check the first product, cart square bracket 0 dot quantity dot to equal brackets 1 and save. Now let's open our test page, and you can see that all of those expectations passed. Now let's move on and create the test for adding an existing product to the cart. So we'll go back to our code and scroll up to the first test here. So first, we need to set up the cart so that it already contains the product that we want to add. To do that, we're going to mock local storage.getItem again. So down here, we can just reuse this code. So we're going to select this code and right click, copy, and then in the first test here, right click and paste. And this time, to set up the test, we're going to put a product into the cart at the beginning. And then we're going to add the same product to the cart. So inside this cart array, let's add an object. And each product has a property called product ID. So we're going to add this property, product ID colon, and let's just give the same product ID that we used down here. So we'll select this and then right click, copy, and then up here, we're going to right click and paste, comma, and each product also has a quantity. So we'll give it a quantity, colon, and let's just give it 1, comma, and also a delivery option. So delivery option ID, colon, and let's just give it the string 1, and save. So now when we do local storage.getItem, it will give back this array as the starting cart. And then we need to make sure that we reload the cart from storage. Next, let's scroll down and let's copy the rest of the test because it's going to be very similar. So we're going to select this code and right click, copy, and then up here, create some new lines and right click and paste. And also one thing I forgot to copy over is to mock local storage.setItem. So at the top, let's also spy on brackets, local storage, comma, a string, set item. So a mock only lasts for one test. Once that test is finished, the method is no longer mocked. So that's why in this test, we also have to mock local storage.setItem. And now in this test, we're just going to modify these expectations. so that they make sense for this test. If we add an existing product to the cart, the cart.length will still equal 1 because these product IDs match, and we're just increasing the quantity. We're still going to call local storage.setItem once, so this is correct still. The first item in the cart is going to have this product ID, and the only thing we're going to change is that the quantity is now going to increase by 1. So it's going to go from 1 to 2 this time. So everything is the same, except if we add an existing product, we're just increasing the quantity. Now let's save and check the test page. And now the existing product test is passing. And that's it. We created tests for the add to cart function. So now let's do some cleanup. And we're actually going to remove everything from local storage since we were modifying it earlier in the test and we might have messed it up. So on this page, we're going to right click, inspect, and open the console. And to remove everything from local storage, we're going to type the code local S storage dot clear and brackets and press enter. And then we'll refresh the page. Now finally, let's go into Git and save our changes. So we'll open our code and we can close this one for now. And we'll open the Git section. So in cart.js, at the top, we basically put all the code that loads the cart into a function so we can use it in our tests. And then here we moved moneytest.js into a utils folder. In test.html, we're loading the new cart.test.js file. And then inside cart.test.js, we added some tests for the add to cart function. So now let's create a message describing these changes. Create automated tests for add to cart and commit. The last thing we're going to learn in this lesson is how to create more complicated tests. So far, we've only been testing a single function. For example, we tested the add to cart function as well as the format currency function. So these are called unit tests because we're only testing one unit or one piece of the code. Now, what if we want to test a whole page or part of a page? This requires a more complicated test called an integration test. An integration test tests many units of code or pieces of code working together. For example, in our code, we're going to go to scripts/checkout/the order summary.js file. And we're going to test this render order summary function. So this function creates a whole section on the checkout page. And it uses many different functions and libraries to create the page. So testing this function will be considered an integration test because it uses many different pieces of code or units of code together. So let's start by creating a test file for this function. So this is in the order summary.js file. Inside our tests here, let's match the file structure that we have here. So we're going to click test-jasmine. First, we're going to create a checkout folder. So we'll click here to create a folder. And we're going to name it checkout and press enter. And then inside the checkout folder, we're going to create a new file. So we'll click this to create a new file. And we'll name it the same as above, order summary, and add test.js and press enter. So by matching the file structure, it's clear that this test file is going to test order summary.js. And again, for the video, I'm just going to drag this file to the top here. So we can see this and the test side by side. And now we're going to test this render order summary function. So first we're going to import this function into our test file. So at the top, we'll import curly brackets, the render order summary function from a string, and we're going to locate this file. So first we need to get out of the checkout folder and out of the test Jasmine folder. So we'll use // And then we're going to go into the scripts folder and into the checkout folder, scripts /checkout / and we'll load order summary.js. We'll create some new lines, and let's start by creating a test suite using the function describe brackets. And inside we'll give it a string, and we'll name this test suite test suite : render order summary, a comma and a function, brackets, arrow, and curly brackets. And now, what test cases should we create? Render order summary creates a part of the page. So when we're testing a page, the two things we need to test is how the page looks and how the page behaves. Let's start by testing how the page looks. Inside our test suite, we're going to create a test using it, brackets, and we'll name this test with a string. And this will just be a basic test case. So we'll describe what this function does, which is displays the cart, comma, and we'll give it a function, brackets, arrow, and curly brackets. And now we're ready to create the test. So render order summary usually displays the cart on the page. However, in our tests, where does this cart get displayed? So if we look at the code in this function and we scroll down, here we generate the HTML for the cart. And then after we generate the HTML, we put the HTML inside an element with the class js-order-summary. However, we don't have this element in our tests. So to fix this, we're just going to create an element with the class js-order-summary. To do this, we're going to scroll down and we're going to open the test.html file. And then at the bottom, we're going to go to the body, and then inside here, we're going to create a div. So less than, div, and greater than. So remember how we said we need to create an element with the class js-order-summary? We're going to create that element and put it inside this div. So this div is going to act like a container. The reason we use a container is that when we create elements in our test, we don't want to be modifying the entire body because the body might contain our test results from Jasmine. So we put everything inside a container. So now let's give this div a class so we can use it in our JavaScript. We're going to give it a class equals double quotes, and we're going to call this the js-test-container. To make it clear, this is a container for all of our test code. And save. And now let's get this container into our tests. We can do that using document.querySelector, brackets, and a string, and we'll select the class using a .js-test-container. And then inside this container, we're going to create an element with the class js-order-summary. So to put something inside this element, we're going to use the property .inner capital HTML equals a template string. And inside this template string, let's create a div element, less than, div, greater than, less than / div, greater than. And as we mentioned, we'll give this element a class equals double quotes of js-order-summary. So this basically takes this HTML and puts it inside our test container. So it will put it inside here. And now we have the element that we need for render order summary. So when we call this function, it's going to create the cart and display it in this element here. Next, if we look at the code for render order summary and we scroll to the top, you'll notice that it takes the cart and then displays it on the page. But remember that by default, we load this cart from local storage, and this can cause problems in our tests, depending on what is inside local storage. So to fix this, we're going to mock local storage.getItem again to control exactly what's inside this cart. So let's actually open the cart test that we had before, and we're just going to copy paste this mock that we created. So we're going to start from here, this function, and we're going to select the code up to spy on get item, and then right click, copy, and then down here, we're going to right click and paste. And one other thing we need to do here is we don't have access to load from storage right now. So we need to import it. At the top, let's also copy the import that we had here. So we're going to select this and then right click, copy. And then down here, we're going to right click and paste the import. And we just need to make sure that this file path locates cart.js. So .. It's going to go outside checkout and outside test-jasmine. And then it will go inside the data folder and then locate cart.js. So this file path is correct. And currently we're not using these two values, so we can just remove them. And now let's set up this cart for this test. So we could just use this cart here. However, to make our tests a little more detailed, let's open the cart.js file. And at the top here, we're going to use this default cart instead because it has two products with different quantities. So we can test more things. So we're just going to select this cart here and then right click, copy, and then down here, open order summary test. And we're going to select this cart and remove it. And inside these brackets, we're going to right click and paste that default cart. And now that the HTML and the cart is set up for this function, at the bottom, we can call the function render order summary and brackets and save. So now let's run this test file. We're going to open test.html. And then beneath these tests, we're going to add another script tag, less than script source equals, and we'll load the checkout / order summary test.js file. And we need to give it the attribute type equals module because we used imports. And let's save so we run this test. So we'll open our test page, and you can see that the cart was rendered onto this test page. And we still have our Jasmine results at the bottom here. So you notice that when we render this, it didn't load any CSS or images. And this is okay because we can't really use code to check if the page visually looks correct. However, we can use this to check the contents of the page, like if the products and the quantities are correct. So first, our cart has two products in it. So we can check if there were two products that were rendered on the page. Let's go back to our tests. And let's take a look at the order summary.js file. And when we render the order summary, we scroll down. For each product in the cart, we create an element with the class cart-item-container. Since we have two products in the cart, let's check that we created two of these elements on the page. So we're going to open the order summary tests.js file. And then in the first test, at the bottom of this test, we're going to add some lines, and we're going to check if we have two of these elements. To do that, we can use the DOM using document.query selector all brackets and a string. And we could select the class cart-item-container. However, this class is used for CSS. So remember, if we're going to use a class in JavaScript, we start with JS-. Let's add a new class to this element that we can use for the tests. We'll add js-cart-item-container. So now we're going to select all the elements with this class using .js-cart-item-container. And let's save the order summary.js file. And then down here, we're going to check if we have two of these elements on the page. So again, to check something in our tests, we're going to use the function expect, open bracket, and let's create a new line to make it a little cleaner. And at the end, we'll give a close bracket like this. And this code gives us an array of elements. So here, we're going to check if the dot length of this is equal to 2. So expect gives us an object which has a method called dot to equal brackets and 2. So this checks if we have two of these elements on the page. So let's save and then check the test page and scroll to the bottom, and you'll see that this test passed. So that's how we check if we rendered the page correctly. Next, let's do another check of what we rendered on the page. So another thing we can test is if the product quantities are correct. So first, we need to get this quantity element into our tests. So we'll go back to our code, and then inside the HTML of the order summary, we're going to scroll down until we see a div with the class product-quantity, and we're displaying the quantity here. So now we're going to take this element, put it into our test, and check that the quantity here is correct. So to do that, let's give another class to this element so we can select it using JavaScript. So here we'll add another class, js-product-quantity. And we want to check the quantity for each product. So we need to identify which product this is for. We can do that by adding a dash to this class and then inserting, using $ and curly brackets, the product's ID, which is the matching product dot ID, and save. And now let's get this element into our tests. So down here, we're going to document.query selector brackets, and we'll give it a template string because we're going to insert a product ID. So we're going to select this class using a .js-product-quantity dash and then insert the product ID. So in our cart, we have two products, and let's start with the first product ID. Now, to make this easier, let's put this string inside a variable so we can reuse it below. So above this, let's create a variable with const, call it product ID 1 equals, and we're going to select this ID and then right click, cut, and then up here, right click and paste. And then we're just going to use this variable down here, product ID 1. And then when we're getting this element into our code, we're also going to insert the product ID, which is product ID 1. So now we're going to check if the text inside is correct. So for the first product, we have a quantity of 2. So the text inside this element should say quantity : 2. So to check this, at the bottom of our tests, As usual, we're going to use the function expect, open bracket, and a new line. And then here we can remove the semicolon and close bracket. And we're going to get the text inside this element. Now we're not going to use .inner HTML because this element contains a bunch of HTML inside, but we only want the text. To get just the text, we're going to use the property .inner text. So we expect the text inside this element to contain quantity:2. However, this element also has some other text like update and delete. So we just want to check if quantity2 is somewhere inside this element. So how do we check that? To do that, we're going to use a different method of expect called .toContain and brackets. And we're going to give it the string that we want to check for, which is capital Q quantity:2. So the toContain method checks if this value contains this string. So they don't have to be an exact match like with toEqual. As long as quantity:2 is somewhere in this element, then this expectation will pass. And this is exactly what we need when this element has some extra text that we don't really need to check. So now let's click our test file and save and open the test page. And scroll to the bottom, and you'll notice that the test passed. So for the first product, we're displaying the quantity of 2 correctly. Let's also check the quantity of the second product. We'll go back to our tests, and just like before, let's create a variable to store this ID. So we'll create a variable with const product ID2 equals, and we'll select this ID and right click, copy, and then here, right click and paste. And then we'll remove this and use the variable product ID2. And then at the bottom, we're going to get the quantity element for product 2. So let's just copy this code because it's very similar. We'll select it, right click, copy, and then down here, right click and paste. So this time we're going to get the quantity element for product ID 2. And in our cart, product 2 has a quantity of 1. So down here, we're going to check if the text contains quantity:1 and save. And let's open our test page and scroll to the bottom, and this test passed. So we're displaying the quantity of both products correctly on the page. The second thing we can test in an integration test is how the page behaves. For example, on this page, we can click the delete link to remove a product from the page. So let's create a new test to make sure that the delete link behaves correctly. We'll open our test code, and at the bottom, we're going to create a new test using the function it and brackets. We'll give it a name, and let's describe what the behavior should be, which is removes a product, comma, and a function, brackets, arrow, and curly brackets. Now let's do the same setup as the first test. So we start with 2 products in the cart. So we can select from load from storage, and we'll select all of this code up here, and then right click, copy, and at the bottom, we're going to right click and paste. So this will set up the HTML element that we need for the order summary, as well as the cart. And after this, let's render the order summary using the function render order summary and brackets. So once we've displayed this on the page, we're going to get the delete link and click it. So first, let's get the delete link into our code. So we'll go to the order summary.js file, and inside the HTML, we're going to scroll down a bit till we see the delete quantity link. And let's test the delete link for the first product in the cart. So first, we need to add a class to this element so we know which product this is for. So here, we're going to add a class js-delete-link- and insert the product ID, which is the matching product .id. And I'll add a new line to make the code a little bit cleaner. And now we can save. And then down here, we're going to get the delete link for the first product ID. So at the bottom, we use document.querySelector brackets, and we'll give it a template string because we're going to insert the product ID, and we'll select this class using .js-delete-link- and then insert $curly brackets product ID 1. And now we need to click this delete link to remove the first product from the page and from the cart. To click an element using code, we can just get it using the DOM and then use the method .click and brackets. So this will click delete on the first product and remove it. So let's save and take a look at our test page. And unfortunately, this test failed. So let's take a look at the details of the failure to figure out how to fix it. So it's telling us that we cannot set properties of null. This means that a value in our code is null, and we're trying to give it a property. And here, it will tell us which line we got this error from. So this error happened in our test file, and the line that created this error was in order summary.js on line 132, or whatever line that you see here on your page. So inside our code, we're going to open order summary.js, and I'm going to scroll down to line 132. And you can scroll down to the line that you got on your page. So this line of code is actually part of the code that we run when we click delete. So remember that when we click delete, we also update the payment summary on the right side of the page. And that's what this line does. Now, the reason this is not working is if we open the payment summary.js file and we look at what this does, at the bottom, after we generate the HTML, we try to put the HTML in an element with a class js-payment-summary. And this element does not exist in our tests. So one way to fix this is to add this element to our tests. So let's open our tests again. We'll open the order summary test.js, and then we'll scroll up. And then here, when we create the order summary element, we're also going to create the payment summary element. So we'll create a less than div greater than, less than slash div greater than, and here we'll give it a class equals double quotes, and we'll give it the class that the payment summary needs, which is js-payment-summary, and save. So now that the payment summary element is set up, we can open our test page, and our tests should no longer have a failure. So you also notice that the payment summary got rendered or displayed on the page. Okay, so in our tests, we only clicked the delete link for the first product, but we didn't actually check if the page looks correct. And that's what it shows here with this yellow dot. This test has no expectations yet. So let's go back to our test and add some expectations at the bottom. So we'll scroll down, and down here, after we click delete for the first product, we expect that there's only one element left on the page for the cart. So in our first test, we actually had a check for this. So we can scroll up, and here we check if we have two cart item containers on the page. So let's just reuse this check because it's very similar. We'll select it, right-click, copy, and then down here, we're going to right-click and paste. And this time, we only expect one cart item container to be left on the page. So we'll change this to 1. So we'll save, open the test page, scroll down, and now this test passed. Let's also do a more detailed check. So we're going to check that the first product is no longer on the page. We'll go back to our tests, and then down here, we're going to get the cart item container for the first product. We'll use document.querySelector, brackets, and to get the element for the first product, we're going to open ordersummary.js and then scroll up in the HTML until we find the cart item container element. And we're going to look for this class right here, which tells us which product this element is for. So in here, we'll give it a template string because we'll insert the product ID, and we'll look for this class using a .js-cart-item-container- and insert the first product. So product ID 1. And because we removed this product from the page, we expect this result to be null. So we'll use the function expect, open bracket, and a new line, and then down here, a close bracket, and we'll use the method .to equal brackets, and we expect this to be null, and save. Let's also check that the second product is still on the page because we didn't delete it. So let's just make a copy of this check. We'll select it, right-click, copy, and then here, right-click and paste. And we'll get the element for product ID 2 this time. And we want to make sure that this exists so that it is not equal to null. In Jasmine, to check if something is not equal to, expect gives us another property we can use called .not. So if we use the .not property, it will check the opposite of whatever is next. So this will check if this value is not equal to null. So remember, the code for Jasmine is designed to read like English. Let's save and check the test page and scroll down. And this test passed. So we're displaying the correct products on the page after deleting. Now there's one more thing that we need to check here, which is after deleting, is the cart array itself updated? So we'll go back to our code and add that check. So first, we need to import the cart so we can use it in this test. We're going to scroll up to the top. And we're already importing from cart.js. So we'll add a comma and import the cart. And then at the bottom, we're going to check if the cart is correct. So the cart started out with 2 products inside. After removing the first product, the cart should have a length of 1. And the remaining product should have product ID 2. So let's add both of these checks at the bottom. So we'll scroll back down, and we'll use expect brackets, and we'll check if cart.length.to equal brackets 1. And we'll also expect brackets, and we'll check the first product in the cart, which is cart square bracket 0, and we'll check its .product ID .to equal and it should equal product ID 2. So product ID 2. And save. So let's open our test page and scroll to the bottom, and this test still passed. So once we click delete, the cart array is also correct. So that's how we create an integration test. It tests many units of code or pieces of code working together, and it lets us test how our page looks and how our page behaves. Now, there's one thing that I forgot to do when we created these tests. If we look at our code, and I'm going to open ordersummary.js. When we click delete, at the bottom here, it uses a function called remove from cart. And if I look at the code for this function, which is right here, remove from cart, this function actually saves the cart to local storage and calls local storage.setItem. However, it's recommended not to modify local storage in our tests. So inside the order summary test file, we should also mock local storage.setItem in this test. So we'll scroll to the top. And at the start of the test, let's mock setItem using spy on brackets, local storage, comma, the string set item, and save. And we'll open the test page and make sure that the test still passes. And we might have messed up our local storage because of that mistake. So let's reset the local storage again. We'll right click on this page, inspect, open the console, and we'll type the code local storage.clear brackets and press enter and refresh the page just to be safe. Now, another thing that we might want to add is that when we render the order summary on the page, it's taking up a lot of space and it pushes the test results to the bottom. So what we can do is after our test, we can actually remove all of this HTML. So let's go back to our code. In the order summary test file, at the end of the first test, we'll create some new lines and remove the HTML that we created. To do that, we can scroll up to this code. So to remove the HTML, we can just set this element's inner HTML to the empty string. So we'll select this code, right click, copy, and then down here, right click and paste. So in our test, all the HTML we created was placed inside this test container, and we're just going to remove all that HTML by setting the inner HTML to the empty string. And we'll do the same thing for the second test. So we'll select this code, right click, copy, and then down here at the bottom, we'll right click and paste. So this is just some cleanup we can do at the end of each test. Let's save and look at our test page. And now all the HTML that we generated is gone, and we can see the test results more clearly. Lastly, we're going to learn a shortcut we can use in Jasmine called hooks. A hook lets us run some code for each test. For example, if we go back to our code, notice that before each of our tests, we do a bunch of setup here. So we can actually share all of this code between our two tests using a hook. So to create a hook, we're going to scroll up to outside of both of these tests. And at the top of the test suite, we're going to use another function provided by Jasmine called before capital E each brackets, and we'll give this a function, brackets, arrow, and curly brackets. So this is called a before each hook, and it will run this function before each of our tests. So inside this function, we can put our setup code. so that we run the setup code before each of our tests. Let's actually take the setup code for the second test because it's a little more detailed. So down here, we're going to select the code starting from render order summary all the way up to mocking local storage.setItem, and we'll right-click and cut this code and remove these new lines. And then at the top, inside before each, we're going to right-click and paste. So now before each of our tests, it's going to run this function and it's going to run all of our setup code. So this is a great way to share code between our tests and remove duplication. So now that we're running this inside before each, if we scroll down to the first test, we don't have to run this code again. So we can actually remove it. And we'll remove this mock, and we'll remove the render order summary as well. And all we're left with are the expectations for our test. Now, before we save, we need to fix one thing with this code here. So right now, these two variables are inside this function. And because of scope, these will be contained inside this function, and we can't use it down here in our tests. So to fix this, we can just move these variables outside of this function up here. So we're going to select these lines and then right-click, cut, and up here, we're going to right-click and paste. So now any code inside this outer function can use these two variables, including our tests. So now let's save and check the test page, and everything is still passing. So that's how we use a hook to run some code before each test. Now, before each is not the only hook that we can use. Jasmine provides several hooks that we can use in our tests. Another common hook is after each, which lets us run a function after each test. So this is really useful for cleanup code, like we have down here when we remove the HTML. I'll leave using after each as an exercise. Now let's go into Git and save our changes. And I can close these three files at the top for now. So we'll open the Git section, and then inside ordersummary.js, we added some classes that we're going to use in our tests. Inside test.html, we are loading our order summary test file, and we also created a test container where we're going to put our HTML that we generate. And then for the order summary test file, this contains the tests that we created for the order summary. Now let's create a message describing our changes. Create automated tests for order summary and commit. Now that we've created all these tests for our project, when we make some changes to our code, we can just open the testing page, and it will rerun all of our tests. So here's the process that we do when we write code. First, we make changes to our code, and then we rerun the tests to make sure that everything still works. And finally, we save our changes into Git. Now, before we end the lesson, we're going to do one more cleanup. We'll go back to our code, and we'll open our files. And here, we usually organize all of our tests into a folder called tests. However, in this lesson, we named this folder test-jasmine because we wanted to compare this folder to tests that were created without a testing framework. But now that the lesson's over, we're going to rename test-jasmine to just tests to make it more standard. First, we need to rename this folder up here. So we'll right-click, rename, and let's rename it to test-simple. because this folder contains tests that were created without a framework. Let's press enter. And now we can rename test-jasmine to tests by right-clicking, rename, and rename it to tests, and press enter. Another thing we can do is we're going to drag test-simple into the test folder so that all of our tests are contained in one folder. So if it asks you to update the imports, you can click yes. And we also need to open moneytest.js in the test-simple folder because it updated the imports, and then save this file. Finally, we're going to run all of our tests again to make sure everything still works after we move things around. So because tests.html is inside a different folder now, we need to reopen this with live server. So we'll right-click and click Open with Live Server. And it'll show us that all the tests are still passing, so our code is still correct. So now we can close some of these extra tabs here and save our changes into Git. We'll open the Git section, and all of these changes are related to renaming the folders. So we'll give a message at the top, rename test-jasmine folder to tests, and commit. And that's the end of this lesson. In this lesson, we learned how to test our code using manual and automated tests. We learned how to organize our tests using test cases and test suites. We learned how to use a testing framework like Jasmine to help us write tests easier. We learned how to mock and spy on methods. We learned how to test web pages using integration tests. And we learned about hooks, which lets us share code between our tests. Here are some exercises to help you practice what we learned in this lesson. In the rest of this course, if you get an error in your project, but your code looks correct, you may have some bad data saved in local storage. To fix this, you can try running localstorage.clear in your console to remove everything from local storage, and then refresh the page. If you see an error like this, object, that means that you saved something directly into local storage, but you have to JSON.stringify it first. So check your code to make sure that you're always stringifying before saving to local storage, and then clear your local storage and refresh the page. In this lesson, we're going to learn object-oriented programming. Object-oriented programming, or OOP, is another style of programming. So it's another way that we write our code. It's useful to know because many programming languages use OOP. Now, how do we use object-oriented programming? Object-oriented programming is basically organizing our code into objects. Let's look at an example. We're going to go to our code, and we're going to scroll up and open data/cart.js. Inside this file, we have the code for our cart. And you'll notice that for the cart, we have some data at the top And then we have a bunch of functions at the bottom that modify the cart. And these are separate from each other, the data and the functions. So this style of programming that we've been using throughout this course is called procedural programming. Procedure means a set of step-by-step instructions. And this is basically a function. So in procedural programming, we organize our code into separate functions like we did here. On the other hand, in object-oriented programming, we organize all of this code into an object. So we put everything together into an object. So let's do an example and convert this cart code into object-oriented programming. We're going to click cart.js, and inside this folder, we're going to create a new file by clicking here. And let's name this file cart-oop, or object-oriented programming.js, and press enter. And now we're going to copy all of the code in cart into this new file. So let's open this, and we'll click in this file, and then we'll type Control A or Command A to select all the code, and then right-click, copy, and inside cart-oop, we're going to right-click and paste. And let's scroll back up to the top. And now to convert this code into object-oriented programming, we're going to group all the data and the functions together into an object. First, at the top, let's create an object that we can put all of these inside of. So we'll create a variable, const, let's call it cart equals an object. And now we're going to group our data and all of our functions into this object. So let's do it step by step, and we'll start with this cart variable. As a reminder, cart semicolon is actually a shortcut for cart equals undefined. To make things easier to understand, let's actually write this out in full instead of using the shortcut. So we'll type cart equals undefined. And now we're going to move this into the object. So we'll select this line, and then right-click, cut, and then inside the object, we're going to right-click and paste. Now, inside an object, we can't use the word export or let. So to move a variable into an object, we're going to convert it into a property and a value. So we'll remove these words, and then type cart and colon undefined, and remove the semicolon and replace it with a comma. So this is the same thing as cart equals undefined, but we move that value into an object. Now, one problem here is that if we access this cart property, we're going to do cart.cart, which can be a bit confusing. So let's actually rename this property to cart capital I items instead, to make it a bit more clear that this contains the items in the cart, or the products that are in the cart. Next, we're going to group all of our functions into this object as well. So let's create some new lines, and we're going to move this function inside here. So let's select this function, and then right-click, cut, and inside the object, we're going to right-click and paste. And again, we can't use the word export inside an object. So we're going to convert this into a property and value as well. So let's remove these words, and let's make the property name load from storage, and then we'll type a colon, and we'll make the value a function, brackets and curly brackets. So that's how we move a function into this object. Now make sure that you use a regular function syntax here and not an arrow function. and I'll explain why later in this lesson. Now, as a reminder, when we have a function inside an object, we call this a method. Also, JavaScript has a shortcut for methods called the shorthand method syntax. So instead of typing colon and function, we can actually just remove this code and just type brackets and curly brackets after the function name. And this is a shortcut for the code that we had before. Now, the code inside this function doesn't actually work anymore because cart was actually renamed to cart items. So we have to rename this variable. So instead of cart, we're going to do cart dot cart items to access this value. And same thing here, cart dot cart items, and here cart dot cart items. So this code works. However, we have a small problem here. If we change the name of the object up here, this code will no longer work. To solve this problem, JavaScript has a feature called this. This gives us the object that contains this function. So it gives us this outer object up here. So to improve our code, we're going to change from using a variable named cart to this. And here as well, this.cart items and this.cart items. So this will give us the outer object. And now this code will always work, and it doesn't matter what the variable name is. The last thing we're going to change in this function is we're currently loading from local storage cart. However, our original cart was also loading from local storage cart. So let's actually change this to cart-OOP so that we don't affect our original cart. Let's move on, and we're going to move the other functions into this object. So let's go down to the next function, which is save to storage. We're going to select this, and then right-click, cut, and then inside this object, at the end, we're going to add a comma and some new lines, and we're going to right-click and paste. And we can't use the word function at the front here, so let's remove this word and just use the shorthand method syntax. So this is a shortcut for colon function. And here we're saving to local storage cart. So let's also change this to cart-OOP so we don't affect our original cart. So we'll change it to cart-OOP. Another thing we need to change is that the cart was renamed to cart items. So here, we're going to change from cart to this, which gives us the outer object, and then dot cart items, which is this property. So it should do the same thing as before, except this function is now inside an object. Let's continue and move another function into the object. So we're going to do add to cart this time. So let's select this code and then right-click, cut, and inside the object, we're going to add a comma and some new lines, and then right-click and paste. So again, instead of using export function, we're just going to remove this code and use the shorthand method syntax, which is a shortcut for this code. And now let's update the code inside this function as well. So instead of the cart, we rename this to this.cart items. So we'll change it to this.cart items. And then down here, we're going to change from cart to this.cart items. And also the function save to storage was moved inside the object. So now to access this function, we're going to get the outer object again using this and then dot save to storage. So down here, we'll add this dot in front to access the function inside the object. And now let's move on and move the next function into the object. So we'll select this code and then right-click, cut, inside the object, add a comma and some new lines, and right-click and paste. We'll remove export function and use the shorthand method syntax. And again, we'll change from cart to this dot cart items. We're going to change cart here to this dot cart items and change save to storage to this dot save to storage. So we access save to storage inside this object. Next, let's move this last function into the object. So we'll select the code and then right-click, cut, and inside the object, we're going to type a comma and some new lines, right-click, and paste. We'll remove export function and use the shorthand method syntax and update the code in this method. So we'll change cart to this dot cart items and save to storage to this dot save to storage. Now let's remove the extra lines. And the last thing we need to update is that load from storage was moved inside the cart object. So to access this function, at the front, we're going to type cart dot load from storage and save this file. And that's it. This is the basic idea behind object-oriented programming. We organize our code into objects. So we group the data and the functions together into an object like this. Now let's talk about why do we use object-oriented programming. Object-oriented programming tries to represent the real world. In the real world, a cart is a physical object. So in object-oriented programming, we represent this physical object as a digital object, or in this case, a JavaScript object. A physical cart can have products inside. So our JavaScript object can also have products inside. A physical cart also has actions we can take to modify the cart, like we can add a product or remove a product. Our JavaScript object also has actions we can take to modify the cart, like the add to cart function or the remove from cart function. So as you can see, object-oriented programming tries to represent the real world. We take a physical object like a cart and represent it as a digital object like a JavaScript object. And some people feel that this makes the code more intuitive or easier to understand. Now let's try out the code in this object to make sure it actually works. We're going to scroll down to the bottom, and here we're just going to type console.log the cart and save this file. And now let's load this code into the project. To do that, we're going to open the scripts folder and open the file checkout.js. And at the top, below the imports, we're going to import our new file. So let's type import, and we're going to use a slightly different syntax. We're just going to type a string and give it the file that we want to load. So we need to load cart-oop.js. So first, we need to get out of the scripts folder using .. and then go into the data folder, data/ and load cart-oop.js. So this is another syntax we can use for imports. this just runs all the code inside this file without importing anything, which is what we need in this situation. So let's save this file and then open this page in the browser. So if you don't have this page open, you can scroll down to checkout.html and then right-click and open with Live Server. I already have this page open, so I'm just going to open that tab. And if the page is too big, we can zoom out by pressing Ctrl- or Command- a few times. And now let's check the console to see what the cart looks like. On this page, we're going to right-click and click Inspect, and then open the console. And in the console, we'll see this cart object. So inside this object, we have the data as well as all the functions for our cart, but it's grouped inside an object. And you'll see that the code still works the same as before. Cart items has the two default products. If we look at our code and open cart-OOP, at the beginning, we run cart.load from storage. And then inside this function, if we scroll up, it will give the cart items this default cart with two products inside. And that's what we see in the console here. So we know that the code inside this object still works the same way as before. So now let's try another method to make sure that it's working. So let's try using the add to cart method to add a product to the cart items up here. So we'll scroll down to the bottom, and then above console.log cart, we're going to call add to cart. Now add to cart was saved inside this cart object. So to access it, we're going to type cart.add to cart and brackets. Now add to cart takes one parameter, which is a string, and this is the product ID that we want to add. So to find a product ID, we can go to the data folder and products.js. And then inside here, we have this list of products. So let's actually scroll down to the third product, which is right here. So this t-shirt product. And we're going to add this product ID to the cart. So let's select this ID. We're going to right-click, copy, and then inside cart-OOP, inside the string, we're going to right-click and paste that product ID. And let's save. And let's check the console. So I'll open the console here. And now inside the cart object, if we expand it, cart items now has 3 products because we just added a new product to the cart. So this shows that all of the code is working the exact same way as before. We just organized it into an object. And that's object-oriented programming. Now that we're done with this example, let's remove these 2 lines of code. And save. Next, another reason we use object-oriented programming is it's easy to create multiple objects. For example, the real Amazon.com has a feature called Amazon Business, where you can have a separate cart for your business purchases. So how do we create 2 separate carts in our code? With object-oriented programming, this is easy. We can just make a copy of the cart object. So we can scroll up in this code, and I'm just going to click this arrow here beside the cart variable to collapse this code. And to create a separate cart for business purchases, we're just going to select this code and then right-click, copy, and at the bottom, right-click and paste. And now we have 2 separate carts. So let's scroll up to the top of this second cart, which is right here. And we said that we wanted this cart for business purchases. So let's rename this to business, capital C, cart. And when we load from storage, let's load it from cart-business instead, so that it doesn't conflict with the cart up here. And if we scroll down, same thing in save to storage. Let's save this cart to cart-business. And finally, let's scroll down to the bottom. And here, instead of cart.load from storage, we're going to change this to business cart.load from storage. And that's it. We just created a completely separate cart simply by copying this object. So object-oriented programming makes it easy to create multiple objects. So now let's console.log both of these carts to see what they look like. We're going to scroll to the bottom, and here we're going to console.log the cart and console.log the business cart and save. And if we open the console for the checkout page, it will show us that we have two carts. The regular cart has 3 products inside, and the business cart has 2 products inside. And these are just the default products that we get when we first load the cart. So you can see that these 2 carts are completely separate from each other. In the real world, we can have 2 physical carts that are completely separate from each other. And in programming, we can also have 2 carts that are completely separate from each other by simply making a copy of the object. So again, object-oriented programming tries to represent the real world. Now, currently, there's an obvious problem with how we're creating multiple objects, which is we're copy-pasting a lot of code. And this can make our code messy and hard to manage. So now we're going to make our code cleaner by using a function to create multiple objects. So first, let's delete this business card that we copy-pasted. So we're going to select this object, and then up to here, the business card, we're going to remove it. And now instead of copy-pasting this object, we're going to use a function to generate these objects. So at the top of this file, let's create a new function, and we'll name it capital C cart, brackets and curly brackets. So by the way, in object-oriented programming, a naming convention is to use Pascal case for things that create or generate objects. In Pascal case, we start every word with a capital, including the first word. So that's why we started cart with a capital C. Now inside this function, we're going to create cart objects. So let's actually move this object into the function so we can create it using the function. So we're going to select this object to here, and then we'll right-click and cut, and then move it into the function by clicking in the function and then right-click and paste. So now every time we run this function, it will generate a new cart object. And we don't have to copy-paste this code over and over to create multiple objects. So at the bottom, I'm going to click this arrow to collapse this object for now. And at the bottom of this function, we're going to return this cart object so we can use it outside the function. Okay, now let's give this a try, and we'll use this function to generate cart objects. So first, let's create the normal cart using const cart, make it equal, and we'll run this function to generate an object. Capital C cart and brackets. And let's generate another object using the function, using const, and we'll name it business cart equals capital C cart and brackets. And we'll still load from storage for both of these, and then console log both of these. So basically, instead of copy pasting all the time, we're going to use a function to generate objects. So now let's save and then open the console. And now we have two cart objects again. However, now both of these carts have 3 products inside. But before, the regular cart had 3 products and the business cart had 2 products. So what happened? If we go back to our code and look inside this cart object, you'll notice that we're loading from the same key in local storage, which is cart-OOP. That means every cart that we generate will be getting its data from the same place in local storage. So to fix this, we're going to replace cart-OOP with a parameter, so different carts can use a different key in local storage. So at the top, let's create a parameter called local storage key. And then instead of using the same string every time, we're going to use the parameter local storage key. And the same thing for save to storage. Instead of saving to the same key every time, we're going to replace this with the parameter local storage key. And finally, when we run this function at the bottom here, we need to give the function a local storage key. So for our regular cart, let's use the string cart-OOP. And for the business cart, we can use a different key, like the string cart-business. So now these two carts will load from different keys in local storage, and they can have different data. So let's save and then check the console. And now our regular cart has 3 products and our business cart has 2 products like before. So let's go back to our code. And this is a better way to create multiple objects. Instead of copy pasting a bunch of code every time, we can create a function that generates objects. So now let's save this example into Git. We'll go into our Git section. And then at the top here, we created a function to generate these objects. And in checkout.js, we are loading that cart-OOP practice file. So we'll type a message to describe these changes. Create OOP, or object-oriented programming, version of cart, and commit. Next, we're going to learn an even better way to generate objects. Object-oriented programming has a feature called a class. A class is specifically designed for generating objects. A class is basically an object generator. So currently, if we open our code and then open cart-OOP, we learn how to use a function to generate objects in object-oriented programming. So now we're going to switch this to using a class to generate these objects instead, because classes are cleaner and have more features than using a function. So first, let's create a new file for learning classes. Inside the data folder, we're going to click cart-OOP and then create a new file. And we'll name this file cart-class.js and press enter. So first, let's copy over all the code so we can compare it. We're going to open cart-OOP, click this file, and then press Ctrl-A or Command-A to select the code, and right-click, copy, and in cart-class, we're going to right-click and paste. And we'll scroll to the top, and at the top, we're going to create our first class using the word class. And now we're going to give a name to this class. So let's name it the same as here. Capital C, cart, and then curly brackets. As a reminder, a naming convention is to use Pascal case, for things that generate objects. So that's why we start this cart with a capital C. So this is a class. A class is basically an object generator. So now inside the class, we're going to put the properties and methods that we want for each object that we generate. So here we have our properties and methods. We're just going to move them into the class. So first, let's select the cart items property. We're going to right-click, cut, and then move it into the class by clicking in here and then right-click and paste. And classes use a slightly different syntax than objects. So to create a property called cart items, we're going to type the property name, and instead of a colon, we're just going to make it equal to undefined. And instead of a comma at the end, we're going to put a semicolon. So that's how we add a property to a class. And now every object that we generate will have this property, just like we did before. Next, let's move the methods into the class. So we'll delete these lines for now, and we'll move load from storage. So we'll select this method, and then right-click and cut. And inside the class, we're going to move it by right-clicking and paste. And classes use a slightly different syntax to create methods as well. So instead of having a comma at the end, we can just remove it. And every object that we generate will now have this method. So now let's move the rest of the methods into this class. We're going to scroll down and we'll move save to storage. So we'll select the method and right-click, cut, and at the bottom of the class, we're going to right-click and paste, and remove the comma at the end. Same with add to cart. We'll select this method, and then right-click, cut, and inside the bottom of the class, we're going to right-click and paste, and remove the comma at the end, as well as remove from cart. So we'll select this method, right-click, cut, and at the bottom of the class, right-click and paste, and remove the comma at the end. And finally, we'll move the last method, update delivery option, and right-click, cut. Inside this class, we're going to right-click and paste. So this method did not have a comma at the end, so this looks good. So that's how we create a class. We basically give it some properties and methods, and now when we generate objects using this class, every object that we generate will have these properties and methods. Now, one thing we need to fix here is that local storage key doesn't exist anymore. To fix this, we're going to save this in a property instead. So at the top, we're going to give a new property to every object that we generate called local storage key and make it equal to undefined to start. And then inside the methods, we're going to switch this to this dot local storage key. So this is going to point to the object that we generate, just like before. And then dot local storage key will access this property. And another place we need to fix this is inside save to storage. So instead of using a variable local storage key, we're going to use the property this dot local storage key. And that's it. So if we scroll down, we basically converted this whole function into a class. So now we can remove it. And the final step here is now that we have this class, let's use it to generate these two objects again. To do that, instead of this code, we're going to type the word new, and then type the class name, which is capital C, cart, and brackets. So you see that a class uses a similar syntax as a function, except we use the word new in front of it. So this generates a new object using our class. And this new object will have all the properties and methods that we added above. So let's do the same thing for the business card. We'll use the class to generate it. We'll remove this code, and then we'll type new and the class name capital C cart and brackets to generate another object using this class. Now there's one thing we need to fix here. Each of these objects has a property called local storage key, and they're currently undefined, so we need to set this property. So at the bottom here, we're going to type cart dot local storage key, and we'll make it equal, and we'll use the same string as before, which is cart-OOP. And we'll do the same thing for the business cart. We'll type the business cart dot local storage key and make it equal the same string that we had before, which is cart-business. And then we'll load the cart from storage as well as the business cart from storage, and we'll console.log them. So we have the same code as before, except we converted it from a function to a class. So now let's save, and we're going to run this code. So currently, if we go into our code and open checkout.js, we're still loading cart-OOP. So we're just going to update this and load cart-class instead, and save. And we'll open cart-class again. And now if we open the console, you can see that we created two cart objects just like we did before. And the regular cart has 3 products inside, and the business cart has 2 products inside. And if we click this arrow beside prototype, we can see the methods that each of these objects has. So we're basically creating the same objects that we had before, except this time we used a class. By the way, each object that we generate from a class is called an instance of the class. We can also check if an object is an instance of a class using the code business cart and then instance of and then the class name capital C cart. So this will check if this object was generated from this class. So we can console.log this result, console.log, and close bracket, and save, and then check the console, and it will tell us that this is true. So business cart was generated from this class. Okay, don't worry if classes are a bit confusing at first. Just remember that object-oriented programming means organizing our code into objects, because this tries to represent the real world. And then classes are a feature that help us generate these objects, so they make it easier to create these objects. A class is basically an object generator. Now that we learned how classes work, let's talk about the benefits of classes. If we scroll up, when we generate an object, it's going to have these properties and these methods. And you'll notice that a class actually looks like the object that we generate. And this is cleaner than using a function like we had before. Another benefit of classes is that they have extra features for object-oriented programming. The first feature is called a constructor, which lets us run some setup code after creating an object. So if we scroll down in our code, you'll notice that after we create these objects, we run some setup code. A constructor lets us put this setup code inside the class. And this makes our code cleaner because we can group everything together inside the class. To create a constructor, we're going to scroll up in the class. And below these properties, we're going to create a new method called constructor, brackets and curly brackets. So the constructor method works like a normal method. We can put code inside and it will run the code. But the special thing about the constructor is that when we generate an object, it will run this constructor automatically. So this is a great place to put our setup code. So let's scroll down to the bottom. And here, instead of running the setup code outside the class, we're just going to move this into the class and into the constructor. So we'll select this code and then right-click, cut, and scroll to the top. And inside the constructor, we're going to right-click and paste. So now, after we create an object, it will run the code in the constructor and set up the object. So there's a few things that we need to fix here. The first thing is each object that we create is going to run the constructor. So we only need one of each of these lines. So let's remove the setup for the business card. So now the setup code has two steps. We set the local storage key, and then we load from storage. The next problem is that the object that we create is not going to be called cart every time. To solve this, we can replace cart with this. And here as well, this.load from storage. So as a reminder, this points to the object that we generate. So whatever object that we generate, we're going to get its local storage key and set it, and we're going to get its load from storage method and run that method. Now the second problem here is that we don't want local storage key to be cart-OOP every time. To fix this, the constructor can also have parameters. Let's give the constructor a parameter, and we'll name it local storage key. And instead of the same string every time, we're going to use local storage key. Now the last thing is, how do we save a value into this parameter? So if we scroll down to the bottom, when we call the class, between these brackets, we can put the parameters for the constructor. So for the cart, we want the local storage key to be the string cart-OOP. And for the business cart, we want the local storage key to be the string cart-business. So the values inside here are saved in the parameters in the constructor. So cart-OOP will be saved inside local storage key, and then we use it. And then the same thing for cart-business. So now let's save this code and then open the console. And you'll see that the cart objects are correct. So after we generated each object, we also ran this setup code. So that's how the constructor works. Every time we generate an object, it will run the code inside here. So this is a great place to put setup code and make our code cleaner. So here are a few more details about the constructor. The method has to be named constructor. We can't just use any name that we want. We also should not return anything from a constructor. So lastly, a shortcut that we can use in a class is when we have a property and it's equal undefined, we can actually remove equal undefined and just use a semicolon. So this is the same thing as the code before. And same thing here. We can remove equal undefined and just use a semicolon. and save. So we finished converting our code from using a function to using a class. And as you can see, a class is just a better way to generate objects in object-oriented programming. So now let's save our code into Git. We'll open the Git section. Inside cart-class, we created our cart class. And inside checkout.js, we're basically loading the cart-class file. So we'll type a message to describe this change. Create class version of cart and commit. Next, we're going to learn an important feature of classes called private properties and methods. So let's open our code again and open cart-class. And you'll see that this class has a property called local storage key. So this property is useful inside the class, but it's not really meant to be used outside the class. For example, at the bottom here, we could take this object, cart, and then change the local storage key using .local storage key equals something else. Now, this is a problem because it will mess up how this object works, and it will start saving to a different local storage key. So this is a common problem in programming, where if you're working on a team, somebody might accidentally change properties that they're not supposed to. To prevent this, classes let us make a property or a method private, which means it can only be accessed inside the class. So let's remove this line and scroll up. And to make local storage key private, we're just going to add a number sign in front, or a hash. And also, whenever we access this property inside the class, we're going to add the hash in front. So we'll type this .hash local storage key, this .hash local storage key, and inside save to storage, this .hash local storage key. So this is called a private property. This means it can only be used inside this class, or inside these curly brackets. It cannot be used outside the class. A property without a hash in front is called a public property, meaning it can be accessed anywhere. So now let's save and open the console. And the code still works. So we made this property private, and we're able to access it inside the class. So now let's try accessing this property outside the class to see what happens. We're going to scroll down, and we're going to try to access cart.hash local storage key and change it to something else, like test, and save. And if we open our console, you'll see that when we try to access a private property here, it will give us a syntax error saying this is a private field. And by the way, a field is the same thing as a property. So that's how a private property works. It prevents us from accessing this property outside the object and messing it up. We can also have private methods. So let's remove this line and scroll up. And the method load from storage should also only be used inside this class. There's really no reason for code outside to be calling load from storage. So to make our code safer, we're going to make this a private method. To make a method private, we're going to do the same thing. In front of the method, we're going to add a number sign or a hash. And we're going to update the rest of our code. So we're going to do this dot hash load from storage. And now we can save and check the console to make sure that everything is still working. So everything still looks good because we're only using this private method inside this class. So a class lets us create private properties and methods. And this is useful on a bigger project where people might not be sure which properties and methods they're supposed to use outside the class and which ones to avoid. So now let's save our changes into Git. We'll go into the Git section, and inside here, we made local storage key and load from storage private. We'll create a message to describe these changes. Make local storage key and load from storage private and commit. Now that we learned object-oriented programming and classes, we're going to use it in our project. So one thing we could do is to take this cart class and replace everywhere we use cart in our project. However, we use cart in a lot of places, and this would take too much time. So I'm going to leave replacing the cart as a challenge exercise. Instead, we're going to work on the home page. So first, let's go back to our code, and we're going to open checkout.js, and we're just going to comment out this import because we're just using this file for practice. So let's save this, and then let's open the checkout page. So I already have it open. If you don't have it open, you can right-click checkout.html and open with live server. On the checkout page, we're going to click this icon in the top left to go to the home page. On this page, we have a list of products here. And the code for these products is, if we go back to VS Code, and on the left side, we're going to open data/products.js. So here is the code or the data for all the products on the homepage. And you'll notice that each product is an object. We're going to learn a technique called converting an object into a class. So what this means is, instead of using regular objects in this array, we're going to use a class to generate these objects. So above this array, let's create a new class using the word class, and let's call it capital P product and curly brackets, because this class is meant to generate products. So now each of our products is going to have some properties like the ID, image, and the name. So let's add these to the class. We'll add the ID property and a semicolon so that it starts off as undefined, and then an image property and a name property. And each product will also have a rating and the price cents. Rating and price cents. And you'll notice each object here also has a property called keywords. Now we're not currently using this in our project, so we're going to leave it out of the class for now. And if we need to use it later, we can always add it back in. So now we have all the properties that we want for each product. So now let's test this by generating a product using this class. So down here, let's create a variable const product1 equals, and to generate an object, we're going to use the word new, and then the class name, capital P product, and brackets. And let's console.log this to see if it worked. Console.log product1 and save. So now we're going to open the web page and then open the console. So right click and inspect and open the console. And inside here, you'll see that we created a product object using the class. So right now, all of these properties are undefined. So now let's set the values of these properties. We'll go back to our code. Don't follow along here, but one way to set these properties is to access them outside the class. For example, product1.id equals something, and then do product1.image equals something, and then product1.name, and so on. So this is not a good way to set these properties because we have to do this for each product that we create, so it makes our code repetitive and messy. Instead, notice that when we create a product, this is kind of like the setup code. We create a product and then set all of its properties. And remember, classes have a specific feature for setup code called the constructor. And now you can follow along. So inside this class, we're going to create a constructor, brackets and curly brackets. So whenever we generate an object, it's going to automatically run this constructor. So this constructor is where we should put our setup code. So let's remove this code and then do all of that inside the constructor. So first, we want to set the ID property. We're going to do this.id and make it equal. And now what value do we set the ID to? So the value of the ID is inside each of these objects. So when we create a product up here, we're going to put this object inside these brackets. And then that's going to go into the constructor in here. So in the constructor, let's create a parameter to save this data. So we'll name it product details. And now to save something inside this parameter, we're going to put it between these brackets. So let's actually give this entire object to the constructor. So we're going to right click and copy. And then between these brackets, we're going to right click and paste. So whenever we create a new product, we're going to give it this object with all the details. It's going to get saved in here. And now we can set the properties. So this.id is going to be equal to the product details.id property. So product details.id. And for the image, we're going to do this.image equals the product details, which is this object that we passed in, dot the image property. Same thing for the name. So this dot name equals product details dot name, which is this property here. Same thing for the rating. This dot rating equals product details dot rating. And finally, the price cents. This dot price cents equals the product details dot price cents. So this is called converting an object into a class. What we're doing is we're basically taking a regular object like this, we put it inside a class, and then we copy over the properties. You can also visualize it like this. We have a regular object, and we're basically wrapping it inside a class. And the reason we do this is that classes have extra features we can use. Like we can add methods, and we can also have private properties and private methods. So we basically have the same object as before, except we have an enhanced version of that object. It has some extra features from classes. So for now, let's save this code. And then down here, we console.log product1. So let's take a look at it in our console. So we'll open the console. And now we can see that we created a product object. So it's the same object as before, except now it's enhanced. It has some extra features from classes. So next, we're going to take this technique and apply it to this entire array. So instead of having an array of regular objects, we're going to convert each of these objects into the product class. Now, one way we could do this is that in front of the object, we can just type new product, open bracket, and then close bracket at the bottom. And this will essentially convert this regular object into the product class. However, we're going to have to repeat this code for every object in the array, and it's going to be a lot of work and repetition. So instead, let's just loop through this array and then use code to convert each of these objects. So instead of typing this out manually, we're going to remove this and remove the round bracket at the end. And then I'm going to click this arrow beside the array to collapse it. And at the end of the array, we're going to use an array method called .map and brackets. So map basically loops through an array, and for each value, it runs a function. So we're going to give this a function that we want to run for each value. So arrow and curly brackets. And this inner function is going to get a parameter. So this parameter is basically each value in the array. So it's going to take the first value and then save it inside this parameter, run the function, and then take the second value, save it in here, run the function, third value, save it, and run the function. So let's name this parameter the product details, because each object in this array contains product details. So now it's going to take each object, save it in the parameter, and run the function. And here, we're going to convert the object into a class. To do that, we're going to use the code new capital P product brackets, and we're going to give it this regular object, which is the product details. And now there's a second part to how map works. So .map creates a new array, and whatever we return from this inner function is going to go inside that new array. So here, we're going to return this class. So this result is going to be put inside a new array. So you can think of map as we take each value in an array, we run this function on it, and we transform it, and then put it inside a new array. So here, we're essentially transforming each of these products or these regular objects into a class. So at the bottom, let's console.log the products array to confirm this. So we'll save and open the console. And now you can see we have an array, and each of the values is a product class instead of just a regular object. So we converted all of our products from regular objects into this product class. And now let's open the web page to make sure that everything still works. So if we open the page, you'll notice that everything is still working correctly. And that's because we have the exact same objects as before, except they're now just sort of enhanced objects. Next, let's use those extra features of classes to simplify our code for this page. We'll go back to our code, and on the left side, let's open amazon.js. So this is the code that creates the home page. So in here, we're going to scroll down until we see the rating section, where we calculate the stars and the rating count. So notice that inside our HTML, we're constructing this URL here for the number of stars a product has. And we're also creating the price that we want to display on the page. Now, instead of doing this all in the HTML, our code would be cleaner if we moved this logic into our class, because we want to group this related code together. So let's use the features of classes to make this code a little bit cleaner. We'll open products.js and we'll scroll up to the product class. And inside here, let's add some methods for calculating the stars and the price. So we're going to add a method and call it get stars URL brackets and curly brackets. And let's create another method called get price brackets and curly brackets. And now we're going to move the code from our HTML into this class. So we'll open amazon.js. And then here, we're creating the URL of the stars. So let's actually select all this code and right-click, copy, and inside products.js, inside get stars URL, we're going to right-click and paste. And this is going to be a string. So at the front, let's add a backtick. So we're going to use a template string because we're going to insert a value inside. And at the end, we'll add another backtick. So now that we created the string, we're going to return it from this method. So return and semicolon at the end. And one thing we need to fix is that product is not defined anywhere. So to get the rating property of whatever object this is, we're going to use this .ratings.stars. So now each product is able to construct its own stars URL here. So let's save this file. And then inside amazon.js, instead of doing this calculation directly inside the HTML, we're going to delete it. And we're going to insert the product.get stars URL method and brackets. So you'll notice that we have the same product object as before, but now it's sort of an enhanced product. We can add methods to group related code together and make our code cleaner. Let's do the same thing with the price down here. We're going to calculate this using the method instead of directly in the HTML. So we're going to select this code and then right-click, copy, inside products.js, inside the getPrice method, we're going to right-click and paste. And again, we want to return the price as a string. So at the front, we'll create a template string because we're inserting a value, and at the back, a template string or a backtick. And we're going to return this from the method. And another thing we need to fix is that product is undefined. So to get the price sense property, we're going to use this .priceSense. Now, one extra thing we need to do here is that we're using the format currency function, but we didn't import it. So we're going to scroll to the top and import format currency. Import curly brackets, the format currency function from a string. And here we're going to locate this function. So we're inside the data folder. We need to get out of the data folder using .. and then go into the scripts folder, into the utils folder, and load money.js. So scripts/utils/money.js, and save this file. So now we have two methods that will simplify our code. We'll open amazon.js, and instead of calculating the price inside the HTML, we're going to remove this and then insert the product.getPrice method and brackets. So now let's save, and let's open the home page to make sure that it's working. So now you see that everything is still working, including the stars and the prices. So we'll go back to our code. And now that we have these methods, let's use them in our other page, which is the checkout page. So we'll open scripts/checkout/order-summary.js, and this basically displays the products on the checkout page. If we scroll to the HTML and find the delivery date, the product image, and the product name, we're going to see that here we're also calculating the product's price directly in the HTML. So instead of doing this, let's use the method we just created. So we'll select this code and remove it and insert the matching product this time. So matching product. And remember, we converted all of our products into classes. So this is not a regular object anymore. It's more of an enhanced object. It's a product class. And that means this will have the method dot get price and brackets and save. So now let's open the checkout page to see if this works. We'll open the web page, and then at the top right, we're going to click the cart. And now you can see that on the checkout page, the price is still displayed correctly. And that's it. If we go back to our code, you'll see that by converting our objects into classes, we're able to use extra features of classes like methods to make our code cleaner. So now let's make sure that all of our tests are passing. We'll go to the left and scroll down, and we're going to open test.html in the browser. So if you don't have it open, you can right click and open with live server. But for me, I already have it open. So I'm going to open the test page, and all of our tests are still passing. So our code is still correct. And now let's save our changes into Git. We'll open the Git section, and in products.js, we created the products class, and at the bottom, we converted all of our objects into the products class. So actually, one thing I forgot to do is to clean up these console.logs. So let's do that right now. We're going to open our code and go into products.js. And we'll scroll down right after the product class. And let's remove this product one because it was just an example. And we'll also remove the console.log products at the end. And save. So now if we go back into Git and open products.js, we just have the code where we convert our objects into a class. In amazon.js, we use the feature of classes called methods to make our code cleaner. In checkout.js, we stop loading our cart class practice file. And in order-summary.js, we also used a method to make our code cleaner. So now let's create a message to describe these changes. Convert products into classes and commit. Next, we're going to learn an important feature of object-oriented programming called inheritance. Inheritance lets us reuse code between classes. So first, let's learn the concept of inheritance. To do that, we're going to open our project. So we'll open this page here to our checkout page, and we're going to go to the home page by clicking the top left. And on this page, we have a bunch of products. But you also notice that we have different types of products. For example, we have clothing, like this t-shirt, and we have appliances, like this toaster. So clothing and appliances are still products. They have a name, a price, and a rating, but they are a more specific type of product. For example, clothing can have all the properties of a regular product, but it can also have specific properties like a size chart. So how do we represent this kind of relationship in our code? We have a product, and then we have a more specific type of product. One way to represent this is to create a new class called clothing. And this class will have all the properties of a regular product, but also more specific properties. However, there's a problem with this, which is we're duplicating a lot of code. Instead, object-oriented programming has a feature called inheritance that allows one class to get all the properties and methods from another class, so we don't have to copy-paste this code. For example, we can make a clothing class and then use inheritance to get all the properties and methods from the product class. This is similar to how a child inherits things from their parents, like their hair color or the shape of their eyes. In fact, we call the product class the parent class, and we call the clothing class the child class. So now let's learn how to use inheritance in our code. We're going to open VS Code and open our code on the left, and then open products.js. And we're going to scroll to the product class, and then below this class, we're going to create a more specific type of product called class and capital C clothing and curly brackets. So we said that clothing is just a specific type of product. So that means clothing should have all the properties and methods of a product. So first, let's inherit all these properties and methods into the clothing class. To use inheritance, after the class name, we're going to use the word extends. And then we're going to give it the class that we want to inherit from, which is the product class above. So this means that clothing will get all the properties and methods of this class, or it will inherit all the properties and methods. To demonstrate this, let's leave this empty and create a new clothing object. So down here, let's create a variable first using const, and we'll name it a t-shirt. Make it equal, and we'll generate a new clothing object. To do that, we'll use the word new, capital C clothing, and brackets. And next, we're going to expand the products array, and we're going to give the product details to this class. So we're going to scroll down to the third product, which is the t-shirt. And we're going to select this object and then right-click, copy, and scroll up. And now between these brackets, we're going to right-click and paste. So now we created a new clothing class. We gave it all the data that it needs. And let's console.log it to see what it looks like. So down here, we're going to console.log brackets and the variable name, which is t-shirt. So here, t-shirt, and save. And now let's open the console. So we'll open our web page, and then on this page, we're going to right-click, inspect, and open the console. And you'll see that we created a new clothing object. And if we open it, you'll see that this has the same properties as the product class. So this inherited all the properties from product. So let's see if we inherited the methods as well. We'll go to our code, and let's try the method getPrice. So we'll console.log t-shirt.getPrice and brackets and save. And now if we open the console again, you'll see that getPrice also works. So clothing inherited the methods from product as well. So even though this is empty, this class gets or inherits all the properties and methods of product. So we use inheritance when we have one class, which is a more specific type of another class. For example, clothing is a more specific type of product. We want all the properties and methods of the product still, but we just don't want to copy paste all this code down here. So inheritance lets us reuse code between classes. So now that we have this clothing class, we can add properties and methods that are more specific to clothing. For example, clothing can have a size chart. So for convenience, inside this t-shirt object, I've actually added a size chart link. So let's add this to our clothing class. So up here, we're going to add a property, size chart link. And now to set this value, we're going to use the constructor like we did before. So down here, we're going to use a constructor, brackets and curly brackets. And we're going to give this a parameter called product details. So when we create the clothing, we save this object into product details, and then we can use it to set the properties up here. So we're going to do this dot size chart link and make it equal to the product details, which is this object, and we're going to get the size chart link property. Dot size chart link. Now, one problem we have here is that clothing inherits all the properties from the product. So we also need to set the ID, the image, the name, and so on. So if we scroll down, we could do something like this.id equals product_details.id. However, instead of doing this one by one all over again, inheritance gives us a shortcut. We can actually just use the constructor in the parent class up here. So to call the parents constructor, we're going to use a special feature of classes called super and brackets. So super basically calls the constructor of the parent class, which is the product. So this will call the constructor up here. And we also need to give this the product details. So down here, we're going to call super and give it the product details. So this will call the constructor of the parent class, which is product, and that will set the ID, the name, and the rating. So now let's save this and check our console again and open up the clothing object, and you'll see that now we have a size chart link property. So that's how inheritance works. A class can get or inherit all the properties and methods of another class and reuse that code. And this class can also have more specific properties and methods, like a size chart link. One last thing to know is that if we don't create a constructor, by default, it will run the parents constructor. So that's why when this class was empty, the code still worked. Now that we have this clothing class, we're going to use it in our project. So right now, if we scroll down to our products array, we converted all of these into a product class. However, we're going to convert some of them, like the t-shirt, into a clothing class instead to make it more specific. So how do we know which objects to convert into a product and which ones to convert into clothing? To help us do that, I included a property called type. So type tells us which class we should use when we're converting this into a class. This is sometimes called a discriminator property. It tells us which class we should convert this to. So we're going to go down to the bottom of this code. So I'm going to do a trick here where I'm going to scroll up to the products array and click this arrow to collapse it. And then at the bottom, we're going to use that type property to decide which class to use. So inside this function, we're going to use an if statement, brackets and curly brackets. And inside, we're going to check the type property, product details dot type. And we'll check if it is equal to the string clothing. If it is equal to clothing, we're going to convert this object into a clothing class instead. So let's return new capital C clothing and brackets. And we're going to give the constructor product details. So now our array will contain a mix of regular products and clothing. Next, for each of our clothing, we're going to display the size chart link on the page. But first, let's make sure that we have this image here, the clothing size chart. So if we go into our images folder, you might see the image here called clothing size chart.png, but currently I don't have this, so I need to download this first. To do that, we're going to click this link in the description, which will open the size chart. And then on this image, we're going to right-click, save image as, and then find the folder that contains all our code. So for me, it's on the desktop, inside the JavaScript Amazon project, and inside the images folder. And we'll save it here. And if we go back to our code, we should have the closing size chart image inside the images folder. Now let's display the size chart on the page. So if I go to the home page, whenever we have a clothing product like this t-shirt, we're going to display a size chart underneath. Let's go back to our code and open amazon.js, which creates the home page, which is right here. And we're going to scroll down the HTML below the product price and the quantity selector here. And underneath this, if we have a clothing product, we're going to display a size chart link under the quantity selector like this. So one way we can do this is to use something like an if statement or a ternary like this. If it's a clothing, then display some HTML. If it's not a clothing, then just display nothing. However, we're going to learn a different way to do this using inheritance. So first, we're going to create a new method on the clothing class that's going to generate the HTML that we need here. So we're going to go to our code and scroll up and open products.js. And we're going to scroll up to the clothing class. And at the bottom, we're going to create a new method, and let's call it extra info HTML, brackets and curly brackets. So this method will generate some HTML that contains some extra information about this product, like the size chart. So here, we're going to return some HTML, and we'll use a template string because we're going to insert some values inside. And inside here, let's create some HTML for a link. To create a link, we're going to use the code less than a greater than less than slash a greater than. So this HTML element creates a link. When we click this link, it will open another page. Inside this link, let's put the text size chart. So this is what's going to show up on the page. And link elements have two attributes. The first attribute is called href equals double quotes. So this tells the computer which page this should open when we click this link. inside here, we're going to insert the size chart link. So we're going to insert this dot size chart link. So when we click this, it will open a page containing the size chart image. We'll scroll back up. And link elements can have another attribute called target equals double quotes. And we're going to give it a value of underscore blank. And I'll add some new lines here to make it a little easier to read. So target equals blank tells the link to open in a new tab. So now let's save this file and we'll go back to the home page. So I'll scroll down here to amazon.js, and below the quantity selector, let's insert, and we'll call the method that we just created, which is the product.extra info HTML and brackets. So this will insert some HTML containing extra information about the product, like the size chart. Now, before we run this code, there's one thing that we need to fix. Currently, only the clothing class has this method. If it's just a regular product, it's not going to have this method, and it's going to cause an error. To fix this, we're also going to create this method on the product class. So we'll go back to our code and open products.js. And we're going to scroll up to the products class here. And at the bottom, we're going to add the same method. Extra info HTML, brackets, and curly brackets. And for regular products, we don't have any extra info we want to display. So let's just return an empty string and save. So now if we call extra info HTML, it doesn't matter if it's a product or a clothing. Both of these will have this method defined. So we'll go back to amazon.js. And now this should always work. So let's click this file and save. And then open the web page to see the result. So now you notice that products that are clothing have a size chart underneath, and regular products don't have any extra information. And if we click the size chart link, it will open a new tab to the size chart image. So that's how we create this size chart link for only the clothing products. Let's go back to our code and we'll learn more about this new technique that we just used. So on the left, we'll go back to products.js first. So notice that the product class has a method called extraInfoHTML, and then clothing extends this class. That means clothing will automatically get the extraInfoHTML method. But then we define this method again inside clothing. So this will actually override or replace the parent's method. And this technique is called method overriding. One more thing to know about method overriding is that if we really need access to the parent's method, there's a feature that we can use called super. So super gives us access to the parent class. So if we want to call this method up here, we can do super and then dot extra info HTML. So it's the same super as we used up here, except this calls the parent's constructor and this calls one of the parent's methods. So let's comment this out since it's just an example. And let's save. And lastly, let's go back to amazon.js. And we'll take a look at this code. And notice that when we call extra info HTML, we don't know what class this is. This might be a clothing class, or it might just be a product class. This technique is called polymorphism, which means we can use a method without needing to know exactly what class this is. Polymorphism is sort of like an alternative to doing if statements here. Instead of doing if it's clothing, do this, if it's a regular product, do something else, we can just have both of the classes use the same method, and then the class itself will determine what this method does. If we add a new class, like an appliance class, we don't need to change any of this code. The appliance class will determine what extra info HTML does. And that's it. We learned about inheritance, which lets us reuse code between classes, and we learned some of the techniques we can do with inheritance, like method overriding and polymorphism, which can make our code a little bit cleaner. Now let's check our test to make sure that everything still works. So we'll open the test page and make sure that everything is still passing. And then we'll go back to our code and we'll save this into Git. Open the Git section, and in products.js, we created the clothing class, which inherits from product. And one thing I forgot to do is to remove this practice code. So let's actually go back to our code in products.js, and below the clothing, let's remove this practice code and save. We'll go back to Git and just make sure that it's been removed. And then we added the size chart image. And in amazon.js, we used polymorphism to add some extra info below each product. So let's create a message describing our changes. Use inheritance and polymorphism to add size chart and commit. In the rest of this lesson, we're going to learn more details about classes. The first detail is how to test classes. So testing classes is the same as writing normal tests. So we generate an object using a class, and then we test if its properties and methods are correct. I'll leave writing tests as an exercise at the end of this lesson. The second detail we're going to learn is built-in classes. These are classes that are provided by the language. So let's go back to our code and open products.js again. And we're going to practice using a built-in class. An example of a built-in class is date. This class generates an object that represents the current date. Below the classes that we created, we're going to create some new lines, and we're going to practice using the built-in date class. First, we'll generate a new date object using the code new, and then the class capital D, date, and brackets. And now let's save this object in a variable. So at the front, we'll use const, and we'll call it date, and make it equal to this object that we just generated. And below this, let's console.log the date to see what it looks like. So we'll save, and then open the page, and we'll go back to our project here, and we're going to check the console. So right-click, inspect, and the console. And we can see that the date object represents the current date and time. So this is the current date and time that I'm recording this video. So this date object has properties and methods that we can use that are related to the date. For example, we'll go back to our code, and every date object has a method called toLocale timestring. This basically gives us the current time. So let's try it out. We'll create a new line and type the code date dot to locale time string and brackets. So make sure that this is in camel case. 2 is lowercase, and every other word starts with an uppercase. And we'll console.log this to see what it looks like. Console.log and brackets. So let's save this file and open the console. And that method gave us the time. So for you, you should see your current time here. So that's the built-in date class. It lets us create objects that represent the current date and time. An interesting thing to know is that we used the external library day.js earlier in the project. Day.js uses this date class behind the scenes. However, day.js gives us a lot of extra features, so we usually use day.js instead of using the date class directly. So now let's comment out this code because it was just an example. So at the top, we'll type /* and below it, */. The last thing we're going to learn is more details about this. As a reminder, inside an object, we can use the value this, and this will point to the outer object. So this feature lets an object access its own properties. Now in JavaScript, this can actually be used anywhere in our code. For example, we're going to create some new lines. And here, we can just directly console.log this. So here we're using this, but we're using it outside of any object. In this situation, there's no object for this to point to. So this will be undefined, which actually makes sense. If we save and we check our console, this will equal undefined. Now, originally, this actually equaled the window object. However, this behavior caused confusion. So when they released JavaScript modules, inside a module, this is now undefined, which makes more sense. Let's go back to our code. And another place we can use this is when we're creating an object. So let's go down here. And we're going to create a new object using const. We'll call it object2 and make it equal to curly brackets. And we're going to give this object a property. Let's just call it a : give it a value of 2, comma, and add another property, b : and we'll set the value of this property to this dot a. Now you might think that because we're inside this object, this will point to object2. However, at this point in the code, object2 has not been created yet. So this doesn't have anything to point to, and this will be undefined. If we save and then open the console, it will give us an error because this is undefined. Let's go back to our code. So far, if we're inside a method, we can use this, and it will point to the object. If we're outside of a method, there's no object to point to, and this will be undefined. And everything makes sense so far. So let's comment this out using /*, and at the bottom, */. Now the last important place we can use this is inside a function. So at the bottom here, we're going to create a function, and let's call it log this, brackets and curly brackets. And inside, we're just going to console.log this. So again, we're not inside of any object. So there's nothing for this to point to. And in this situation, this will be undefined as well. Below this, if we run the function, log this and brackets, and save, and check the console, it will tell us that this is undefined when it's just inside a regular function. Next, this actually has a special feature. So inside a function, we can change this to whatever we want. To do that, functions have a method called .call. So below this line, let's type the function name, log this, and use a method .call and brackets. So .call runs this function. So it does the same thing as the line above, except we can set the value of this to be whatever we want. So the first value that we give to .call is going to be the value of this. For example, we can give it the string hello. And now this will run the function, and this will be equal to hello. If we save and open the console, you can see that we set this to be equal to hello. So that's a special feature of this. Inside just a function, we can change this to whatever we want using a method like .call. So .call is the same as calling or running the function, except we add an extra parameter in front. This first parameter is the value of this. The last important thing to know about this is that arrow functions do not change the value of this. For example, below this, let's create a method by using an arrow function this time. So we'll create some new lines. And first, we're going to create an object using const. We'll call it object3 equals curly brackets. And inside, we'll give it a method and colon. And we're going to create this method using an arrow function this time. Brackets, arrow, and curly brackets. And inside, we'll just console.log this. So usually, this will point to the object itself. However, arrow functions do not change the value of this. Here, this will have the same value as outside the arrow function. Outside the arrow function, let's type this. Here, this has no object to point to, so this will be undefined. And then inside the arrow function, it will also be undefined. Basically, this keeps the value that it had outside the arrow function. As a test, below this, we'll run object3.method and brackets. If we save and check the console, it will show us that inside here, this is also undefined. So in an arrow function, this will be whatever the value is outside the arrow function. Now you might be wondering, why are arrow functions designed this way? So JavaScript had a common problem in the past. When we are inside a method, this points to the object. But if we try to do a for each loop, inside the for each loop, this does not point to the object anymore. It points to undefined. And that's because we created a whole new function here. And remember, inside a regular function, this becomes undefined. So this caused problems because we no longer had access to the outer object up here. So that's why we created arrow functions. if we replace this with an arrow function, this would be equal to whatever it is outside the arrow function. Arrow functions do not change the value of this. So outside for each, this points to the object, and inside for each, this also points to the object. So that's why arrow functions are designed this way, to avoid accidentally overriding this. So let's summarize what we learned about this. Inside a method, this points to the outer object. Inside a function, this is undefined, but we can change it to whatever we want using something like .call. And arrow functions do not change the value of this. Don't worry if these rules are a bit confusing at first. They are actually sort of reasonable. If there's an object to point to, this will point to that object. If there's no object to point to, this will be undefined. And we have tools like .call and arrow functions to kind of manipulate the value of this to be what we want. The more that you work with it, the more you just get used to it. So now let's comment out this practice code. At the top, we'll type /*, and at the bottom, */ and save. And we'll save to Git. We'll open the Git section. Inside products.js, we added some practice code to learn more details about classes and this. Let's type a message describing our changes. Learn more details about classes and this, and commit. Now that we learned object-oriented programming, you might notice that it's a very different style of programming than just writing out a bunch of functions directly. So you might be wondering, which style of programming should we use? Object-oriented programming or procedural programming, which is the step-by-step style that we used in the earlier lessons? The answer is, it's up to you. I personally prefer procedural programming in JavaScript because I think it's simpler. I only use object-oriented programming if I'm working on a team that also uses it. Also, object-oriented programming is much more popular in other languages. So it's still useful to know object-oriented programming in case you work with other programming languages in the future. And that's the end of this lesson. In this lesson, we learned about object-oriented programming, which means we organize our code into objects. We learned how to use a function to generate objects, and we improved that by using a class to generate objects. We learned that classes can have private properties and methods. We learned about inheritance, which lets us reuse code between classes. And we learned about method overriding and polymorphism, which lets us call a method without needing to know what the class is. And lastly, we learned more details about this and how to control the value of this. Thanks for watching this course so far. If you want to support this channel, you can check out the premium version of my courses just like this one, where you can get a certificate of completion and a better learning platform. If you're interested in extra videos from me, more in-depth videos, and behind-the-scenes content, you can check out these links here. You can also support the channel by liking the video, subscribing, and sharing this video with others. Thanks again, and let's continue with the course. Here are some exercises to help you practice what we learned in this lesson. In this lesson, we're going to learn about Backend. and this will prepare you for the next step after finishing this course. First of all, what is Backend? A backend is just another computer that manages the data of a website. For example, in our Amazon project, we created this website where we can pick which products we want. But how does Amazon, the company, know which products that we ordered? In this situation, there has to be a second computer somewhere that's owned by Amazon. And then our computer sends the order information to this second computer. And now Amazon will know what we ordered. So this second computer is called the backend computer, or just the backend. It manages the data of a website. On the other hand, our computer, or the web page, where we can see and interact with the products, this is called the front end. Now that we know what a backend is, how does our computer, or the front end, send information to the backend? When two computers are connected to the internet, they can actually send messages to each other using a feature called HTTP, or Hypertext Transfer Protocol. In an HTTP message, we can actually attach information, like our Amazon order. When Amazon's backend receives this HTTP message, now Amazon will know what we ordered. Now that we know what HTTP is, let's send our first HTTP message using JavaScript. So we'll go to our code, and on the left, we're going to create a new file just for practicing backend. So we'll scroll up to the data folder, and we'll click inside this folder, and then create a new file. And let's name this file backend-practice.js and press enter. And now to send an HTTP message, we're going to use a class called XML HTTP request. So this is a built-in class, meaning it's provided by JavaScript. First, we'll generate an object using this class, using the code new and the class name XML, all capital HTTP, capital R request, and brackets. So this creates a new HTTP message that we want to send to the backend. A message is also known as a request. So now let's save this request in a variable. At the front, we'll create a variable with const and name it xhr equals this request. Next, we need to set up this request. So we'll create a new line, and to set it up, we'll do xhr.open and brackets. And to set up this request, we're going to give open two parameters. The first parameter is what type of HTTP message to send. So one type of message we can send is the string get. Get means we want to get some information from the backend. There are several common types of requests that we can give to the backend, but we're going to start by learning get. Next, we're going to give open a second parameter. And this parameter tells the computer where to send this HTTP message. So using HTTP, we can send a message to any computer that's connected to the internet. Now to locate another computer on the internet, we need to use a URL. URL stands for Uniform Resource Locator, and it's kind of like an address, but for the internet. A URL helps us locate another computer on the internet. So URLs look like this. This is the URL for Amazon, YouTube, and my website. The HTTPS in front means we're using HTTP to communicate with this computer. The S after the HTTP means we're using a secure version of HTTP. The second part of a URL is called a domain name. This is like an address. It points to another computer on the internet. So Amazon.com points to one of Amazon's backend computers. YouTube.com points to one of YouTube's backend computers. And SuperSimpleDev points to one of my backend computers. If you want to learn more about domain names and how the internet works, you can check out my video on how to put a website on the internet. Now, for this lesson, I actually set up a backend computer that we can practice with. So my backend is located at the URL https supersimplebackend.dev. So in the second parameter of open, we're going to give it a string. And we're going to give it the URL of the backend that we want to send the message to. So the URL for my backend is https://supersimplebackend.dev. So that's how we set up an HTTP message. We give it the type of message we want to send, and also the URL, which is where to send this message to. The last step is to just send this message. So we'll create a new line, and we'll type xhr.send, brackets, and save. So this creates a new HTTP message, sets it up, and then sends this message across the internet to my backend computer, located at supersimplebackend.dev. So now let's actually run this code and see the result. We're going to go to the left, and we're going to open checkout.js. And in here, just like we did before, we're going to load that practice file that we just created. So we'll create a new line, and we're going to import a file or a string, and we'll locate that practice file. So first we need to go to the data folder using /data/ and load backend-practice.js and save. So we'll go back to the practice file. And now when we open the website, it will run this code and send the HTTP message. To see that, let's open the website. So we'll scroll down. And if you don't have the website open, you can open it again by right-clicking checkout.html and then open with live server. I already have the website open, so I'm going to open it, and then I'm going to go to the checkout page. And now we're going to look at the console. So we'll right-click and inspect. And this time, instead of going to the console tab, we're going to go to a new tab called the network tab. If you don't see this tab, you can make this window wider, or you might find it under these arrows. So we'll open the network tab. And in here, this will show us all the HTTP messages that are coming in and out of our computer. Now, before we start looking at the HTTP messages, there's one important thing to know about the network tab. And that is, messages will only appear here after we open the console. If we send some messages and then we open the console, it's not going to show up here. So to make sure our HTTP messages are recorded here, we need to open the network tab first, and then we're going to refresh the page to resend those messages. And now if we open the network tab, we should be able to see the HTTP messages at the bottom. Okay, so inside this list, we should be able to see that we sent a message to supersimplebackend.dev. If you don't see it, we can also search this list by using the text box up here. So in here, we can type part of the URL that we sent the message to. For example, super simple, and the message that we sent should appear here. So now we can click this message to get more details about it. On the right side, we have several tabs here. The Headers tab gives us details about our message or about our request. So it tells us which type of request that we sent, which is GET, and the URL that we sent it to, which is SuperSimpleBackend.dev. This sends the request across the internet to my backend. And then when my backend receives this message or this request, it will send back a message, which is called a response. To see the response from my backend, we can open the Response tab. And you can see that my backend responded with, "Hello, this is SuperSimpleDev's backend," and a documentation page that we can check out. So we have successfully sent an HTTP message or a request to my backend, and we got back a response. Another useful tab here is the Preview tab. It basically takes a response and displays it in an easy-to-read format. So now let's learn some terminology. When we send a message to the backend, this message is called a request. We are requesting something from the backend. When the backend receives our request, it will send an HTTP message back to us. And this message is called the response. So each request that we make will get one response from the backend. And this is called a request-response cycle. It's always one request, one response. Next, currently we're viewing the response in the Network tab, but we can actually get this response in our code and then do something with this response. So let's go back to our code. And here, after we send the request, we can get the response using a property called xhr.response. However, there's a slight problem with doing this. When we send a request to the backend, it takes time for the request to travel across the internet to the backend and for the response to come back. So the response is not available right away, and xhr.response will be undefined at first. So xhr.send is known as asynchronous code. Asynchronous code means it does not wait for this line of code to finish. It just sends the request and then immediately goes to the next line. The response might come back later in the future, but we don't have access to it here. So in this situation, in order to get this response, we need to wait for the response to come back first, and then we can access .response. In order to wait for the response to come back, at the top, after we create the XHR, we're going to use this code, xhr.add capital E event, capital L listener, and brackets. So this method listens or waits for an event, and then it can run a function. So this method takes two parameters. The first parameter is the event that we want to listen for or to wait for. In this case, we want to wait for the response to come back, so we're going to give it the string load. Load means the response has loaded. The second parameter is a function that we want to run after this event happens. So in this case, after the response has loaded, we're going to run a function. Brackets, arrow, and curly brackets. So because this function runs after the response loaded, inside here, we can access xhr.response. and this will not be undefined. It will contain the response that we saw earlier in the network tab. So let's console.log this to see what it looks like. Console.log and brackets, and we'll remove this line at the end and save. So now let's go back and check the console for the response. So we'll open the console and then open the console tab. And here you can see that we have the response in our code and we console.logged it. So this response is a string. And now we can save this in a variable or do whatever we want with it in our code. Now, one thing you might be wondering is, why do we put the event listener up here at the top? So first, we need to set up the event listener and then trigger the event or send the request. This is the same as setting up an event listener for clicking a button. We need to set up the event listener first, and then we click the button after. So that's how we send a request to the backend, wait for the response, and then save the response in our code. Next, we can send different messages or different requests to the backend using URL paths. A URL path is the part that comes after the domain name. For example, in this URL, the URL path is /hello. In this URL, the URL path is /products/first. In this URL, if there is no URL path, the URL path is /. We can send a request to these URL paths, and each URL path will give us a different response. So let's try sending requests to different URL paths and see what different responses that we get. So for this example, let's send the request to SuperSimpleBackend.dev and then the URL path /hello and save. And now let's open our console to see the response. And here you can see that this URL path gave us a different response than last time. Let's go back and try another URL path to see what it looks like. So we'll delete this and then send the request to /products/first and save. And we'll open the console to view the response. And here, this URL path gave us a JSON, and this contains the details of the first product in our Amazon project. So we can send requests to different URL paths, and we will get different responses from the backend. Next, a backend only supports a certain set of URL paths. For example, when I created my backend, SuperSimpleBackend.dev, I had to decide which URL paths are supported and how my backend would respond to each URL path. If we send a request to a URL path that is not supported, the backend will respond with an error. Let's go back to our code, and we'll try a URL path that is not supported. So let's remove this at the end, and we'll try sending the request to not-supported and save. And now if we look at our console, you'll see that the backend responded with an error message saying this URL path is not supported. The browser will also console.log this red error message. This red message is displayed automatically when there's an error. So this message tells us the type of request that we sent, which is GET, and the URL that we sent it to, and also this number, which is called the status code. Whenever we get a response from the backend also gives us a status code, which tells us if a request succeeded or failed. A status code that starts with 4 or 5 means the response failed. Starting with 4 means it was our problem. We sent the request to a URL path that was not supported. Starting with 5 means it was the backend's problem. For example, the backend crashed. A status code starting with a 2 means the response was successful. So we can also see the status code in the Network tab. So we can search for our request, and then when we click the request, in the Headers tab, it will show us the status code in this row. So this tells us if our request succeeded or failed. So now you might be wondering, how do we know which URL paths are supported and which are not? So there's actually no way to figure out all the URL paths that are supported, and this is for security reasons. However, some backends do provide a documentation page that lists the URL paths that are supported and also what kind of response that they give. For my backend, I created a documentation page, and we're going to take a look at that. So we'll open the browser, and at the top, we're going to create a new tab. And to see the documentation for my backend, we're going to go to SuperSimpleBackend.dev/documentation and press enter. So this is the documentation page for my backend. It gives us a list of which URL paths that are supported and what each URL path does. So when we make a request to /, it will give us this message, which we saw earlier. If we make a request to /hello, it will give us this message, which we also saw earlier. So by the way, the list of all the URL paths that are supported is called the Backend API. API means Application Programming Interface. Interface means how we interact with something. So this list of URL paths are all the ways that we can interact with the backend. And that's why we call this the Backend API. Next, the backend can respond with different types of data. So one type of data the backend can respond with is text. For example, when we sent the request to get/hello, it gave us some text back. So in our code, if we change this URL path to /hello and save, and we open the console and click the console tab, it gives us back some text. We can also see what type of response that we got using the Network tab. So we'll open the Network tab and then search for the request. And then here, when we click it, inside the Headers tab, if we scroll down to the Response section, here it will give us the content type, or the type of response that we got back. So in this example, /hello gave us some text, and the type is text/plain. Another type of data the backend can respond with is JSON. So if we go back to our code and change the URL path to products/first and save, and then look at our console, in the Network tab, we'll open this request, and inside the headers, if we scroll down, it will tell us that the type of the response is application/JSON. So the backend sent us back some JSON. If we open the console tab, we can see the JSON string here. So once we get this JSON from the backend, we can use json.parse to convert this back into a JavaScript object. Basically, this allows us to send JavaScript objects across the internet to the backend. Another type of data the backend can respond with is HTML. We'll go back to our code and we'll change the URL path to documentation. So this was the documentation page that we saw earlier. If we save and then open the console, you'll see that the backend responded with a bunch of HTML. If we look at the network tab and search for the request and open the request here, and in the headers tab, we scroll down to the content type, it will tell us that the type of the response was text/HTML. Finally, another type of data the backend can respond with is an image. For example, we'll go back to our code and change the URL path to images/apple.jpg and save. And we'll open the console. And in the network tab, we can open this request. And in the headers tab, we can scroll down and it will tell us that the type of response was an image/JPEG. As you can see, the backend can respond with different types of data, not just text. Okay, so we got this image back from the backend, but what does this look like in the console? We'll open the console, and we'll see that we just get a bunch of random characters here. And that's because the console is trying to display the image as text, but the image is not really text. This is the image's raw data, so that's why it shows all these random characters here. However, it would be better to display this as an actual image instead of raw data. We can display this as an image by using the browser. So if we open the browser, when we type a URL at the top of the browser, it actually sends a GET request to that URL. So typing in here actually does the same thing as our code. It makes a GET request. The one big difference is that in the browser, when it gets back the response, it will display the response on the page. For example, if we enter SuperSimpleBackend.dev and change the URL path to just nothing or slash and press enter, this actually sends a GET request to my backend. The backend responds with some text and it displays this response on the page. So using the browser is the same thing as making a GET request. Now the cool thing about this is that if the browser gets back an image, it will display it as an actual image instead of raw data that we saw in the console. So here, if we change the URL path to /images/apple.jpg and press enter, it will get back the same image as before, except the browser will display it as an actual image on the page. Same thing happens when the backend responds with HTML. So at the top, if we change the URL path to /documentation and press enter, if the response from the backend is HTML, the browser will display this HTML as an actual web page instead of raw HTML. So again, using the browser is the same thing as making a GET request. And depending on the type of response, the browser can display the response in a more useful way on the page. And that's it. We learned the basics of how a backend works, how to send requests to a backend, and how to send requests to different URL paths. So now let's go back into our code and we'll remove this URL path and just do .dev so that we don't keep console logging an image, and then save. And let's save this practice code into Git. We'll open the Git section in backend practice, we learned how to make requests to the backend, and in checkout.js, we loaded that backend practice file. So let's type a message describing our changes. Add backend practice file and commit. Now that we learned what a backend is and how to communicate with a backend, let's use a backend in our project. So first, we're going to open our code, and we're actually going to open checkout.js, and we're going to comment out this import statement because we're not going to run the practice file anymore. So we'll type / to comment that out and save. Next, SuperSimpleBackend.dev has a URL path called /products. This gives us a list of all the products in the Amazon project. So first, let's open our browser and visit this URL path to see what the response looks like. We'll open this tab to SuperSimpleBackend.dev, and we're going to change the URL path at the end to /products and press enter. And you can see that this URL path gives us a JSON response. So this contains all the details of the products for our project. Now, instead of using a file on our computer to load the products, let's use the backend to load the products. So let's go back into our code. And on the left, we're going to open data/products.js. And we're going to scroll down to the array of products at the end. So now, instead of loading the products from this file, we're going to load the products from the backend. So first, let's comment out all this code. If you need to, you can click this arrow on the left to collapse this array. And we're going to comment this out using /*, and at the end, */. And above this, we're going to load the products from the backend. First, let's create a variable to save the products again. So we use let products equal an empty array. And let's export this so we can use it outside of this file like before. At the front, we'll type export. Next, let's create a function to load these products from the backend. We'll create a function, and let's name it load products, brackets and curly brackets. And inside here, we're going to create an XML HTTP request again to make a request to my backend. So to create a request, we're going to use new and the class XML HTTP request and brackets. So this will generate a new request object. And let's save this in a variable. So at the front, we'll use const, and we'll name it xhr equals this object. Next, we're going to set up the request using xhr.open and brackets. So open takes two parameters. The first parameter is the type of request that we want to send. In this case, the type of request will be the string get. And we're going to give open a second parameter, which is the URL that we want to send this request to. So we'll give it a string, and the URL of my backend is https://SuperSimpleBackend.dev. And then we'll add the URL path, which is /products. Finally, we're going to send this request using the code xhr.send and brackets. So this will create and set up a request and then send it to my backend. Now remember that .send is asynchronous. That means it will just send the request, but it will not wait for a response to come back. in order to wait for a response, above this code, we're going to create some new lines and set up an event listener using xhr.add event listener and brackets. And this takes two parameters. The first one is the event we want to listen for. In this case, it's the string load, which means the response has loaded. Next, we're going to give it a second parameter, which is a function. So brackets, arrow, and curly brackets. And this is a function that we want to run after the response has loaded. So inside here, after the response has loaded, we can access it using xhr.response. For now, let's console.log this to see what it looks like. So we'll console.log and brackets. Finally, let's run this function so that we run all this code. At the bottom, we're going to load products and brackets and save. So this will send a request to my backend, and then once we get the response, it will display it in the console. So now let's go to our website. We're going to open the project tab. And don't worry if the page is blank for you. We're going to fix this in a bit. For now, we're going to open the console by right-clicking, inspect, and open the console. And in here, you'll see that xhr.response gave us this JSON. And this represents all the products in our Amazon project. Now that we have all this JSON, we're going to convert this back into a JavaScript object and then use it in the rest of our code. Let's go back to our code. And here, the response is a JSON. We're going to convert it back into a JavaScript object, or in this case, a JavaScript array, using the code json.parse and brackets. So once we've converted this back to an array, we're going to replace the products up here with what we loaded from the backend. To do that, we'll do products and make it equal to this result that we got from the backend. Now, one more thing we need to do is previously we converted the product objects into a class. So we're just going to do that again with this array. So we'll select the code from .map all the way to the end, and then right-click, copy, and here, after this products array that we got from the backend, right-click, paste. We're also going to transform this array from objects into these classes. And at the end, let's console.log this products array to see what it looks like now. So we'll console.log products and save. And now if we open the console for our project, you'll see that products is now an array of product classes and clothing classes. So we converted the response from a JSON into a JavaScript array and then into these classes. So that's how we load data from the backend and then convert it into a JavaScript object or array that we can use in our code. Next, let's go back to our code, and instead of console.logging the products every time, which will display a lot of stuff in the console, let's just console.log a message to make sure that this is working. So we'll change this to the string load products. And now that we have this function, let's use it in each of our pages. First, we're going to remove calling this function for now. And we're going to export this function so we can use it outside of this file. So export and save this file. And we're going to start from the home page. So we'll scroll down to the bottom to amazon.js. And we're going to scroll to the top. And first, we're going to import load products. We're already importing from products.js, so we'll just add a comma and load products. And now before we run all of this code, at the top, we're going to load the products first and brackets. So now let's save and open the project in our browser. And we'll click the top left icon to go to the home page. And you'll see that the home page is actually empty. So what went wrong here? Remember that HTTP requests are asynchronous. If we go back into our code, load products will send a request to my backend, but it takes time for the request to travel across the internet to my backend and to travel back. So here, it will just send the request, and at the next line, the response has not loaded yet. So the products array is still empty. And when we run this code with an empty array, the page will be empty. To solve this problem, we need to wait for this HTTP request to finish first, and for the response to come back. And then we're going to run the rest of this code. So how do we do that? So we're going to go to the left, and we're going to scroll up to data/products.js. And I'm going to drag this file to the top so we can see the code side by side. And I'll scroll down to the HTTP request, which is right here. And remember that we used an event listener to wait for the response to come back. Once the response is loaded, we're going to run this function. So basically, we want to run all of this code at the bottom of this event listener. So after we've loaded our products. So one way to solve this problem is maybe we can just copy all this code and then paste it at the bottom here. Now, obviously, this doesn't make sense because we're copy pasting a bunch of code, and then we can't really reuse this function. A better solution is we're going to put all this code in a function. And then we can give this function to load products. Let's do this step by step. So first, at the top, let's create a function to group all of this code together. We'll use the word function, and let's name it render products grid, brackets and curly brackets. And now we're going to move all of this code into the function. So we can do that by removing this closing curly bracket. And then at the bottom, we're going to scroll down all the way to the bottom. Here, we're going to add back the closing curly bracket to put all this code inside the function. And now let's also select this code so we can fix the indents. So we'll select it all the way up to here, and then press Tab to add an indent. So now we put all the code inside render products grid. Next, we're going to put this function inside load products using a parameter. So between these brackets, we're going to give it this function, render products grid. So remember, in JavaScript, functions are values, and we can use a function as a parameter. So now inside load products, if we go up here, at the top, this function will be saved in a parameter. So let's create a parameter at the top, and we'll name it fun to say that this parameter will contain a function. So we basically saved this function inside this parameter. And now after we load the response, we're going to run the function. So at the bottom here, after we've created the products array, we're going to run fun and brackets. So that's how we run all of this code after we've loaded the products. We group this code into a function, and then we save the function up here. After we load the response, we're going to run the function. So let's save these two files. We'll save products.js, and then down here, we'll save amazon.js. And then open our website, and you'll see that the products loaded again, because this time we're waiting for the response to come back, and then we run our code. So that's how we wait for an HTTP request to finish first, and then we run some code. By the way, this function that we provide to load products, this is known as a callback, because we're giving it a function to run in the future or to call in the future. So this function will be called back in the future. And we've actually used callbacks before. When we wrote the code setTimeout, we provided setTimeout a function to run in the future or to call in the future. So this function is also known as a callback. Don't worry if this technique is a little complicated at first. The more you work with callbacks, the more you'll get used to it. Let's get some more practice and use the backend and callbacks on the checkout page. So we're going to open checkout.js, which is the checkout page. And first, we're going to import load products. So at the top, we'll create an import, curly brackets, load products from a string, and we'll locate products.js. So inside here, we're in the scripts folder. We're going to get out of it using .. And then we're going to go into the data folder. And then we'll add /data/ and we'll load products.js. And then down here, we're also going to load products and brackets. And again, we're going to give load products a callback or a function that we want to run in the future. This time, instead of creating a whole new function, we're just going to create a function inside these brackets using brackets, arrow, and curly brackets. So we don't need to create a function name every time. We can also just create an anonymous function or a function without a name, and then give this to load products to run in the future. Now, inside this anonymous function, we're just going to move this code into here. So we'll select this code and then right-click, cut. And then inside here, we're going to right-click and paste. And if you need to, you can fix the formatting. So again, this is going to save this function inside the parameter fun. And then we're going to call fun after we've loaded all the products. So let's save this file and open our website. And we'll click the cart in the top right to go to the checkout page. And now the checkout page is loading again. So that's how we use a backend in our project. We need to send a request and then use a callback to wait for a response and then run the rest of our code. So now let's save our changes into Git. We'll go to the Git section, and in products.js, we created the load products function. In amazon.js, we used load products and gave it a callback. And in checkout.js, we also used load products and we gave it a callback using an anonymous function or a function without a name. Let's create a message describing our changes. Load products from the backend and commit. Next, we're going to learn testing with a backend. Now that we're using a backend in our code, we need to update our tests. First, let's go to our code and we're going to run our tests. So we'll scroll to the bottom, and if you don't have the tests open, we can run them by right-clicking test.html and then click Open with Live Server. Now, I already have the test open in my browser, so I'm just going to open that tab. And for the video, I'll zoom in using Control equals or Command equals. And we have some failing tests now. So if you did the exercises from the previous few lessons, you might have more than 2 failing tests, but we're going to focus on fixing these 2 tests here for the video. So first, let's open the code for our order summary tests. We'll open VS Code, and then on the left, we're going to go into the test folder /checkout/order summary test.js. So now we're going to scroll down in this test and notice that here we are rendering the order summary, which creates the cart on the checkout page. However, this cart requires the products to be loaded from the backend. And currently we're not loading the products in our tests. So that's why the tests are failing. We need to load the products first. To do that, let's import the load products function at the top. So we'll scroll up and we're going to add another import, curly brackets, the load products function from a string, and we'll locate products.js. So we need to get out of checkout and out of tests using .. and then we'll go into the data folder, data/ and load products.js. And now we could call load products inside before each, but this will load the products before each of our tests. So it will load it multiple times. And we don't really need to do this. We only need to load the products once for all of our tests. To do that, we're going to use another hook provided by Jasmine called before all. So above before each, we're going to use the function before all and brackets. So this is the before all hook. It will run a function before all of our tests. Inside these brackets, we're going to give it a function to run. So brackets, arrow, and curly brackets. And now, before all of our tests, we're going to load the products. So let's load products and brackets and save. And now let's open our tests in the browser. And unfortunately, the tests are still failing. Let's go back to our code and see what the problem is. We'll open VS Code. And here, remember that load products is asynchronous. That means it just sends a request to my backend, but it doesn't wait for the response to come back. So it would just send a request and then continue with the rest of the test code. And unfortunately, at this point, the response has not come back yet. Products is still an empty array. To fix this issue, we need to wait for load products to finish first, and then continue with the rest of the test. To do that, Jasmine has a feature for waiting for some code to finish called a done function. So in before all, we can give this inner function one parameter called done. So done is a function and it's provided by Jasmine. When we add this done parameter, before all will not automatically go to the next step. Now it's just going to wait, and it will only go to the next step when we call this done function. So when we do done and brackets, then it will go to the next step. If we don't call done, then before all, we'll just keep waiting forever. So this done function allows us to control exactly when before all finishes and goes to the next step. And this is what we need to fix the test. We need to wait for load products to finish first, and then we're going to call done and then go to the next step. To wait for load products to finish, remember, we're going to give it a function. So between these brackets, we'll create a function using brackets, arrow, and curly brackets. Now, once the products have finished loading, it will run the function. Inside here, we're going to call done and brackets. So this makes sure that the products load first, and then we call done, and then it goes to the next step, which is the before each hook, and then eventually it runs the tests at the bottom. So now let's save and take a look at our test page, and you'll see that those order summary tests are now passing. If you have any other failed tests, I'll leave that as an exercise. Let's go back to our code. And that's how we test with a backend. We wait until the backend code is finished, and then we use the done function to control exactly when to go to the next step. By the way, we can also use done inside before each and inside it as well to wait for backend code to finish. Now let's save our changes into Git. We'll open the Git section, and inside order summary test, we imported load products, and then we called load products and used the done function to make sure that the products are loaded first, and then we go to the next step. Let's create a message describing our changes. Load products in before all hook and commit. Next, we're going to learn promises, which are a better way to handle asynchronous code. Promises are similar to Jasmine's done function that we just learned. They let us wait for some asynchronous code to finish before going to the next step. So now let's create our first promise. We're going to open our code, and on the left, we're going to go to checkout.js. And in here, at the top, we're going to practice promises. Promise is a class. So we're going to type the code new, capital P, promise, and brackets to create a new promise object. Now inside these brackets, we're going to give it a function. So brackets, arrow, and curly brackets. So that's just how promises are designed. It's a built-in class, and when we create a promise, we need to give it a function. So when we create this promise, it's going to run this function immediately. So inside here, let's console.log the string promise to show that it runs immediately. So we'll save this file and then go to the website, and we'll open the tab for our project. And I'm going to zoom out a bit by pressing Control or Command minus, and then open the console. Right-click, inspect, and the console. And you'll see it logged promise. So when we create a promise, it runs this inner function immediately. Now this inner function gets a parameter called resolve. And resolve is a function, and it works very similar to Jasmine's done function. So resolve lets us control when to go to the next step. For example, let's add some asynchronous code into this promise. We'll remove the console.log, and we're going to run load products, which is asynchronous. So here we'll type load products and brackets. And now we're going to give load products a callback function, like we did down here. Brackets, arrow, and curly brackets. So it will run this function after load products is finished. Once this is finished, we want to go to the next step. So here, we're going to call resolve. So resolve and brackets. So you can see that the syntax here is very similar to Jasmine's done function. We run some asynchronous code, and then we wait for it to finish, and then we call resolve to go to the next step. Now, what is the next step to this promise? So you might think that this code down here is the next step. However, a promise actually creates a separate line of code or a separate thread of code. So here, these two groups of code are sort of running at the same time. Feel free to pause the video to get a longer look at this diagram. The reason promises are designed this way is it allows JavaScript to do multiple things at the same time. So when the promise finishes, it can do a next step. But this next step is going to be separate from the rest of the code. It sort of does the next step on the side. So right now, this promise creates a separate thread of code. But this separate thread doesn't actually have a next step. So we're going to add one. To add a next step to a promise, at the end, we're going to use a method called .then and brackets. And we need to give .then a function. So we're going to type brackets, arrow, and curly brackets. And inside here, let's just console.log the string next step. So first, we run this asynchronous code, and then we wait for it to finish, and then we run resolve. And resolve makes it go to the next step. To make this easier to see in the console, let's actually add some console.logs to track the progress of this code. So at the top, let's console.log the string start promise. And then in here, let's console.log the string finished loading. And we'll also comment out the code that we had before. So we'll type /* and at the bottom, //. And now let's save and check our console. So let's go through this step by step. First, we start the promise, which we see here, and then we call load products, which we see here. Once the products are finished loading, it's going to run this function, and then we'll display finished loading. And then we're going to call resolve, which goes to the next step, which runs this function. And we display next step. So resolve lets us control when to go to the next step. In this case, we waited until load products was finished, and then we called resolve to go to the next step. So that's how promises work. They let us split our code into separate steps, and then we can wait for one step to finish before going to the next step. Now that we understand promises, let's convert the code that we had before from a callback to using a promise. So first, let's remove these console.logs to make our code a little easier to read. Now, in our previous code, we actually had two steps. The first step is to call load products. And then once this is finished, the second step is to call render order summary and render payment summary. And in our promise, we have the same thing. Our first step is load products. Once this is finished, we're going to call resolve and then go to the second step. So we're just going to copy this second step into the second step up here. So we'll select this code and then right click, copy, and in .then we're going to right click and paste. And now let's save and let's check the web page. So we'll open the project and you can see that everything is loading correctly. So this promise does the same thing as the callback that we had before. Both of them have two steps. The first step is to load the products, and then we wait for the products to finish loading, and then we do the second step, which is to render the page. So now you might be wondering, why do we use promises? It looks like it's more work and more code than just using a callback. So callbacks have a big problem, which is multiple callbacks cause a lot of nesting. Nesting means having code inside code, like this. To see why this is a problem, let's say that we want to load the cart from the backend as well. I actually set up a URL path that we can use to practice, called /cart. So first, let's go into products.js, and we're going to copy load products and change it to load the cart. So we'll select this function, and then right-click, copy, and let's open cart.js, since we're going to load the cart from the backend. And let's scroll down to the bottom. And here, we'll right-click and paste that code. And now, instead of loading the products, let's load the cart from the backend. So first, let's rename this function to load C cart. And the first thing we need to change is the URL path. So instead of loading /products, we're going to load /cart from my backend. So normally, when we load /cart, the backend will give us a cart array. However, since we're just practicing, my backend will just give us some text when we load /cart. Next, we don't need this products code anymore, so we can select it and then delete it. And instead, let's just console.log brackets, and we'll just display the response that we get back. xhr.response. And we can remove this other console.log. And save. So now let's use load cart in our previous example. On the left, we'll scroll down and open checkout.js. And at the top, let's import load cart. So here we'll import curly brackets, load cart from a string, and we'll go to the data folder, which is /data/ and we'll load cart.js. And now we're going to use this in our callback code to show the problem with callbacks. First, let's comment out this promise so we can focus on the callback code. At the top, we'll type /*, and here //, and we'll remove the comments for the callback. And after we load the products, we're also going to load the cart. So inside this function, we're going to type load cart brackets, and we're going to give it a function. So this function is going to run after the cart has loaded. So now let's say that we want to wait for the products and the cart to load before we render the page. To do that, we need to move this code inside this inner function. So we'll select this and then right-click, cut. Inside load cart, we're going to right-click and paste and remove this extra line. So now this code is going to load the products, wait for it to finish, and then it's going to load the cart, and then wait for the cart to finish, and then it will render the page or display the page. So let's save and check the console. And now you can see that we loaded the products, and then we loaded the cart. And if we open the page, everything was displayed properly. So now let's go back to our code and notice that when we added another callback, we created another layer of nesting. So we have code inside code inside code. The problem with this is that each layer of nesting adds some indents at the front or spaces at the front. This means if we have lots of callbacks, our code will become more and more nested, like this. This is a big problem with callbacks. Multiple callbacks cause a lot of nesting, and all these indents make our code hard to work with. Promises solve this problem by letting us flatten our code. For example, let's load the products and the carts again, but this time using our promise instead. First, let's comment out the callback using /*, and at the bottom, */, and we're going to uncomment the promise. So here, we'll remove the comments. And then in the next step, instead of rendering the page, we're going to load the cart like we did down here. So we'll type load cart and brackets. Now we have a problem here. We want to wait for load cart to finish and then go to the next step. However, we usually do this using resolve, but we don't have resolve inside this function. To solve this problem, inside .then, we can actually return a new promise. So at the top, we're going to return a new promise and brackets. So we're going to give this promise a function, just like we did up here. So we'll type brackets, arrow, and curly brackets. And this function gets one parameter called resolve. So inside .then, if we want to use resolve to wait for some code to finish, we can return a new promise. So now let's move our code into this new promise so we can use resolve. So we'll select this code and then right-click, cut, and inside here, we're going to right-click and paste and remove these new lines. And we can give load cart a function to run when it's finished. So we'll type brackets, arrow, and curly brackets. Once load cart is finished, it runs this function, and then inside here, we're going to call resolve so that we move to the next step. So here, we'll call resolve and brackets. So now this will go to the next step, And we currently don't have a next step to this promise. So let's add the next step. At the end, to add another step, we're going to use .then, brackets. And we'll give this a function, brackets, arrow, and curly brackets. So the third step is to render the page. So we're going to do the same thing inside here. So let's select this code, and we'll right-click, copy. Inside the third step, we're going to right-click and paste. And adjust the formatting if you need to. So that's how we do these 3 steps in the callback using a promise. We do the first step, wait for it to finish, call resolve, and then it goes to the second step. We do the second step, wait for it to finish, call resolve, and then we go to the third step. So a promise lets us have as many steps as we want, and we can use resolve to wait for each step to finish before going to the next step. So let's save this and check the console to make sure it worked. So we'll open the console, and inside here, we have the same messages as last time. First, we load the products, we wait for it to finish, and then go to the next step. Then we load the cart, wait for it to finish, and then go to the next step. And then we render or display the page. If we open the page, you'll see that everything displayed properly. So now let's go back and compare promises and callbacks. So even though promises require a bunch of setup code, you can see that it keeps our code relatively flat. The third step doesn't get more and more nested, like in callbacks. So if we have lots of steps in our promise, this is what the code will look like. You can see that even when we add more steps, the code does not become more and more nested. So promises help keep our code flat and avoid too much nesting. So that's why it's recommended to use promises instead of callbacks. Promises will keep our code more flat. So let's actually add some new lines here, as well as here, to better separate these steps, so it's a little easier to read. Lastly, we're going to learn 2 more features of promises. The first feature is we can give resolve a value. So inside here, let's give it a value like the string value1. So whatever we give to resolve is going to be saved in a parameter inside .then. So inside this function, we can add a parameter called value. And now whatever we give to resolve is going to be saved inside here. And now we can use it. So this lets us share a value between 2 steps of a promise. So in here, let's check if this worked using console.log value and save. And if we look inside our console, you'll see that it displayed value1. So whatever we give to resolve will be saved in this parameter. The second feature is we can run multiple promises at the same time. Currently, we wait for things to load one at a time. For example, we wait for the products to load, and then we wait for the cart to load, and then we go to the next step. To make this more efficient, we can actually load the products and the cart at the same time. To do that, we can use a feature called promise.all. Promise.all lets us run multiple promises at the same time and wait for all of them to finish. So let's scroll to the top and we'll do an example. So here, we'll type the code capital P promise dot all and brackets. Inside these brackets, we're going to give this an array. Inside this array, we can give it multiple promises to wait for. So let's just copy paste the two promises that we have here into this array. So we'll start from here at the end of the first promise, and we'll select this code, right-click, copy, and in this array, we're going to right-click and paste. And remove this line. So we have our first promise, and at the end, we're going to add a comma, and we're going to give it a second promise. So we'll scroll down to our second promise here, and we're going to select this code, starting from here, and select the promise, right-click, copy, and at the top, we're going to right-click and paste. So we basically created an array of promises, and then we're going to give this array to promise.all, and it's going to wait for all of the promises to finish before going to the next step. So now let's add a next step. At the end, to add a next step, we're going to use .then and brackets, and we'll add a new line to make it a little easier to read. So as usual, .then adds a next step to a promise. And we'll give it a function to run. So brackets, arrow, and curly brackets. After we load the products and we load the cart, we're going to render the page. So let's copy paste that code inside this next step. So we'll scroll down to the render code and we'll select it, right-click, copy, and at the top, inside .then, we'll right-click and paste. So now let's comment out our old promise and try out promise.all. Above our old promise, we're going to type /*, and below it, we're going to type */. And let's save. We'll go to our console, and you can see that it did the same thing. It loaded the products, and it loaded the cart, and it's going to wait for both of them to call resolve before going to the next step, which is to render or display the page. If we open the page, you'll see that everything displayed properly. So that's promise.all. We can give it an array of promises, and it will run both of them at the same time, instead of waiting for each promise one by one. Also, the values that we give to resolve are saved in a parameter. So inside .then, we can add a parameter called values, and then these values that we give to resolve are going to be saved inside here. So if we console.log values and save and check the console, and it gives us an array of values. The first value is from the first promise, and the second value is from the second promise. So here we didn't give anything to resolve, so the second value is undefined. So that's an overview of promises and promise.all. Promises are a better way to wait for asynchronous code to finish versus callbacks, because they help us avoid nesting and keep our code relatively flat. Promises also have more features, like promise.all, which lets us run multiple promises at the same time. Now let's save our changes into Git. We're going to open the Git section. Inside cart.js, we added a function to practice loading the cart from the backend. And then in checkout.js, we learned promises and converted our code from a callback to a promise. Let's type a message describing our changes. Learn promises and convert code to promises and commit. Now that we learned promises, we're going to learn another feature called fetch. Fetch is a better way to make HTTP requests. Let's go back to our code, and we're going to open products.js. And we're going to scroll down to the load products function. Currently, we're using XML HTTP request to make requests to the backend, and this uses a callback. Fetch also lets us make requests to the backend, but fetch uses a promise. So let's do an example, and we'll make the same request except using fetch this time. We'll scroll up, and above load products, let's create another function using function, and we'll name it load products fetch and brackets and curly brackets. And to use fetch, we're going to use the built-in function fetch and brackets. So this makes an HTTP request, just like we did down here. So let's make the same request as we did in this function. At the bottom, we made a GET request to this URL. So by default, fetch will make a GET request. So we just need to give it the URL that we want to make the request to. So at the bottom, let's select this URL, and we're just going to right-click, copy, and at the top, inside fetch, we're going to right-click and paste. So this will make the exact same request as we did below. So you can see that fetch is a lot more simple than XML HTTP request. We don't have to create a new object or do any setup. We can just call fetch and tell it where we want the request to go. So this will send a request to the backend. And now, how do we get the response? So instead of using a callback to get the response, fetch uses a promise. When we call fetch, this is going to create a promise. And we can add a next step to this promise using .then and brackets. So we'll give .then a function, brackets, arrow, and curly brackets. So the way this works is that fetch is going to send a request to the backend. When we get a response, it's going to go to the next step. It's also going to save the response inside a parameter in here. So we'll add a parameter called response. And this will contain the response from the backend. So instead of using a callback to wait for the response, fetch uses a promise to wait for the response. So here, let's console.log the response to see what it looks like. And now let's run this code. At the bottom, we'll run this function using load products fetch and brackets. So now let's save and take a look at the console. So here's the response that we get from fetch. If we open it, you can see it gives us a bunch of information about the response, like the status or whether it succeeded or failed, as well as the URL that we made the request to. So how do we get the data for the products from this response? To do that, we'll go back to our code, and to get data that's attached to this response, we're going to use response.getData. JSON and brackets. So this gives us the JSON or the data attached to the response. In this case, it's our products data. Next, response.json is actually asynchronous. It returns a promise. So we need to wait for this promise to finish before we continue to the next step. To do that, inside .then, we can actually return another promise. So here, we're going to return this promise. When we return a promise, it will wait for this promise to finish before going to the next step. So now let's add another step to this promise using .then brackets, and we'll give this a function again. So brackets, arrow, and curly brackets. When response.json finishes, it's going to give us the data that's attached to the response, and it's going to save it inside this parameter. So this response should contain our products data. So let's name this parameter products data. And let's console.log this to see what it looks like. So here, we'll console.log the products data and save. And let's open the console. And you see here that the products data is the array of products that we're going to use in our Amazon project. You'll also notice that instead of giving us just a big JSON string like before, it actually converted the JSON into an array. So basically, it did JSON.parse on the response for us. So this saved us a little bit of code. Finally, now that we have the products array, let's do the same thing that we did down here. So we'll scroll down and select all of this code, and we'll right-click, copy, and then up here, we'll remove this, and right-click, and paste. So we'll do the same steps as before, except using a promise this time. First, instead of doing JSON.parse on the response, we already have the array of products. So we can remove this and replace it with products data. And then we're still going to convert this from objects to classes like before. We'll keep this console.log so we can track the progress. This last line of code let us do something after we finish loading the products. However, instead of using a callback like before, we're going to remove this line. And to do something after this step, we can actually return this entire promise. So to make it easier to read, let's save this entire promise into a variable using const. Let's call it promise equals fetch. So let's add some new lines here as well as here to make the code a little easier to read. So we're basically calling fetch, which creates a promise, and then we're going to save this promise inside this variable. And then at the end of this function, we can just return the promise. So we're just going to return this whole promise out of the function, and then we can add even more steps after this promise. So down here, this is going to give us the promise, and then we can attach another step using .then brackets, and inside here, we can give it a function. Brackets, arrow, and curly brackets. So this attaches another step to the end of this promise. So basically attaches another step here. So after we load all the products, let's just console.log next step and save. So we'll check the console, and we'll see that we loaded the products, and then after, we did the next step. So we can actually return a promise out of a function and then keep attaching more steps to that promise. So that's how we use fetch. It's a better way to make HTTP requests because it uses promises directly. So now let's use fetch in our project instead of using XML HTTP request. So first, let's comment out this code because we were just practicing. We'll type /* and at the bottom, */. And let's scroll up to load products fetch, and we're going to export this function so we can use it outside this file. Let's save. We'll go to the left and open checkout.js. And here, instead of using load products, which uses callbacks, let's switch to load products fetch, which uses promises. We'll scroll up, and we're going to import load products fetch. So here we're already importing from products.js. We'll type a comma, load products fetch. And now we'll replace load products. So remember that we need to give this a promise. And also remember that fetch returns a promise. So all we need to do is to remove this code and just call load products fetch and brackets. This will return a promise, and we can use it with promise.all. So now let's save. We'll check our website, and you'll see that everything is still working. So fetch helps us make our code a lot cleaner because it can return a promise directly, and we don't have to type out all of this extra code. Finally, let's use fetch inside our tests. On the left, we'll open order-summary-test.js. And remember that inside here, we used load products. So let's switch this to using load products fetch instead. First, we'll import it. At the top, we're importing from products.js. So we'll type comma and import load products fetch. And instead of load products, we're going to call load products fetch and brackets. So remember that this returns a promise, and we can attach more steps to this promise using the method .then and brackets. And we'll give .then a function to run. So brackets, arrow, and curly brackets. Once the products are finished loading, it's going to run .then, and inside here, we're going to call done to go to the next step of the test. So here, we'll just call done and brackets, and we'll remove the old code. So now let's save to make sure this is working, and we'll open the tests, go to the browser, and open the test, and the order summary test should be passing. So now let's save our changes into Git. We'll open the Git section. Inside products.js, we learned how to use fetch, which returns a promise directly. Inside checkout.js, we used load products fetch inside our project. And in order summary test.js, we used load products fetch inside our tests. Let's create a message describing these changes. Convert load products from XHR or XML HTTP request to fetch and commit. Next, we're going to learn Async Await, which is an even better way to handle asynchronous code. Let's go back to our code and we'll open checkout.js. Currently, we're using promises to handle asynchronous code. But the problem with promises is that it creates a lot of extra code. For example, we need to create a new promise, we need to use resolve, and we need to use .then. Async Await is a shortcut for promises, and it removes all this extra code. So let's do our first example of Async Await. We're going to scroll up, and at the top, we're going to create a function using function, and let's name it load page, brackets and curly brackets. And inside, we're going to console.log the string load page. And now we'll learn the first part of async await, which is async. In front of the word function, we're going to add the word async and space. So async makes a function return a promise. So this code is a shortcut for this code. It basically wraps the code in a promise. So now let's run this function to show that it actually returns a promise. So below this, we'll call load page and brackets. And because this returns a promise, we can add a next step to this promise using .then brackets. And we'll give .then a function, brackets, arrow, and curly brackets. And inside here, let's just console.log the string next step. Now let's save and we'll check the console. So we'll open the console and you'll see that we loaded the page, and then in the next step, we displayed next step. So when we put async in front of function, it makes this function return a promise. This code is a shortcut for this code. Next, if we return something from this function, for example, we're going to return a value like the string value2. This gets converted into resolve value2. So this value is going to be saved in a parameter in the next step. So here, we'll add a parameter value, and value2 is going to be saved inside here. If we console.log the value and save, and then check the console, we'll see that value is equal to this string. And that's it for async. It just makes a function return a promise. Now you might be wondering, what's the point of this feature? So the reason we use async is because it lets us use the second feature called await. Await lets us wait for a promise to finish before going to the next line. So let's do an example. Inside here, let's run some code that creates a promise. Let's run load products fetch. So we'll type load products fetch and brackets. So this loads the products from the backend. And usually this returns a promise. So one way to wait for this to finish is to use .then and then give it a function. So this runs this function after load products has finished. Now await gives us another way to wait for this promise to finish. Instead of using .then, at the front, we can just type await. So await lets us write asynchronous code like normal code. So now it will wait for this line to finish and get the response from the backend before going to the next line. So we don't have to do any more .then. We just write it like normal code, line by line. This code is a shortcut for this code. And this makes our code a lot easier to read than what we have down here. So now let's see what this looks like in the console. Before we save, let's comment out this promise at the bottom so we don't get confused. So we'll type /* and at the bottom */. And now we're going to save this code and check the console to see what it did. So you see that we loaded the page, and then notice that it finished loading the products before going to the next step. So this actually waits for this line to finish before going to the next line in the code. And this makes our code a lot cleaner. Now, one very important thing to know is that we can only use await when we're inside an async function. That's actually the main reason we use async, so that we can use await to make our code cleaner. Now that we learned async await, let's use it in our project. So previously, we loaded the products, and then we loaded the cart, and then we rendered the page. So let's recreate this using async await. First, we want to load the products, which we did here, and we're going to wait for this to finish. And then we're going to load the cart. So to load the cart, let's use this promise down here. Async await can only be used with promises. It doesn't do anything with a callback. So we'll select this promise and right-click, copy, and then up here, we're going to load the cart with a promise by right-clicking and paste. So now we want to wait for this promise to finish before going to the next line. To do that, at the front, we can simply type await. Finally, after we load the products and we load the cart, we're going to render the page. So we'll scroll down and we'll select this code. And we're going to right-click, copy, and at the top, we're going to right-click and paste. And that's it. You can see that our asynchronous code is a lot cleaner now. We load the products, and then we just wait for it to finish. Then we load the cart, and we also wait for it to finish. And then we run the rest of our code. So we can write asynchronous code like normal code. So now let's remove the console.log at the top and also remove this return value because we don't need it. And we'll remove .then at the end. And let's save. So now if we open our website and open the project, you can see that everything loaded properly. Inside the console, you can see that we loaded the products first, wait for it to finish, then load the cart, wait for it to finish, and then we displayed the page. So that's how we use async await to make our code a lot cleaner than what we had before. So now we'll learn some more details about async await. As I mentioned, we can only use await inside an async function. Also, the closest function has to be async. For example, here we have an async function at the top, and inside we have a normal function. So we can't use await inside the normal function. we have to make this one async. Another detail is if a promise resolves with a value, for example, here, we give resolve a value like the string value 3. Normally, this value will be saved in the next step. So if we did dot then and gave it a function, this value would be saved in this parameter. However, if we use await, this value just gets returned and we can save it in a variable. So instead of using dot then, we can simply save whatever is resolved inside a variable using const value equals. And this makes our code a lot easier to read. Instead of having to use dot then, we can simply save this inside a variable, like normal code. And finally, we can use await with promise.all as well, but I'll leave that as an exercise. So that's async await. It's a shortcut for promises, and it lets us write asynchronous code like normal code. So when working with asynchronous code, a best practice is to use async await over promises and callbacks because they are much cleaner. So now let's save our changes into Git. We'll open the Git section. In checkout.js, we created the load page function where we learned async and await. Let's create a message describing these changes. Convert from promises to async await and commit. Now we're going to learn about error handling. When we're sending HTTP requests across the internet, we could get unexpected errors. For example, the internet connection might stop working. So we're going to learn how to handle these kinds of unexpected errors. Let's go back to our code, and we're going to open data/products.js. And we're going to scroll to the load products function. So this uses a callback to send a request and get a response. Now, what if there's an error along the way? For callbacks, we usually set up a separate callback just for errors. For example, below this, we're going to add another event listener using xhr.add_event_listener brackets, and the first parameter is the event. This time, we're going to listen for the error event, and then we're going to give it a function. So now, if we get an unexpected error, it's going to run this function. So if we get an error, let's just console.log a message. Console.log a string unexpected error. And usually when we get an error, we give some instructions on what to do. Here, let's just type, please try again later, and save. So this is called error handling. If we get an error during the request, we can handle it with this function. So we just display a message. So now let's try out this code. To simulate an error, we're going to change the URL of the request to error.supersimplebackend.dev. So this will create an error because this URL doesn't exist. So now down here, let's call this function so that we run this code and get the error. So we'll type load products and brackets and save. Let's check the console. and you'll see that we displayed this error message. So we got an error, and it ran this error function, and it did not run the load function above. Also, usually this callback gets a parameter called error, and this contains some information about the error. So that's how we handle errors when using callbacks. We usually set up a separate callback just for errors. So now let's remove this line since it was just for practice, and we'll remove error from the URL and change it back to SuperSimpleBackend.dev and save. Next, we'll learn how to handle errors in promises. So we'll scroll up to the load products fetch function, and this makes the same request as below, but it uses promises. To handle an error in promises, promises give us two methods, .then and another method called .catch, brackets, and we're going to give .catch a function, brackets, arrow, and curly brackets. So now, if this request has an error, it's going to go to this catch method, and it's going to run this error function. So inside here, let's also display a message. So let's just copy the message that we had below. We're going to select this message, and then right-click, copy, and then inside catch, we're going to right-click and paste. And again, to simulate an error, we're going to scroll up and change the URL. So we're going to add error at the front, .supersimplebackend.dev. So now let's call this function and test out this error code. At the bottom, we'll type load products fetch and brackets and save. So now let's open the console, and you'll see in here that we displayed the error message. So we're successfully creating an error, it's going inside catch, and it displays this message. So just like callbacks, .catch gets a parameter called error, and this contains information about the error if we need it. So that's how we handle errors with promises. We have another method called .catch that will run this function if there's an error. So now let's remove this practice code and switch back the URL. So remove error and dot and save. Lastly, we'll learn how to handle errors in Async Await. So let's go to the left, and we're going to open the checkout file. So we'll scroll down and open checkout.js. And inside here, we're using Async Await. So to catch errors when using Async Await, we're going to use some new syntax called try catch. Above this, we're going to type the word try and curly brackets. And now we're going to put the code that could cause an error into try. So here, we're making a request to the backend, and here we're also making a request to the backend. So this code could cause an error. So we're going to move it inside try. So we'll select it, right-click, cut, and then inside here, we'll right-click and paste. And now, if any of this code inside a try gets an error, we can catch it using this code. At the bottom, we'll type catch, brackets and curly brackets. Now catch is going to get one parameter in these brackets called error. And this contains information about the error if we need it. So catch works similarly to .catch for promises. if there's an error inside here, it's going to catch the error, or it's going to handle the error and run the code inside catch. So in here, we can put our error message. So let's go back to products.js and let's copy the error message. So we'll select this and right click, copy, and back to checkout. Inside catch, we'll right click and paste. So now I'll remove this new line and add a new line here to make it a little easier to read. And let's test out this code. To do that, we'll go inside products.js again, and we're going to modify the URL again. So at the front here, we're going to add error.SuperSimpleBackend. And also, we're going to comment out the .catch, because right now, the error is going to be handled here, and it's not going to be handled outside in the try catch. So we're going to comment this out using /* and at the end, // and save. So we'll go back to checkout.js, and here we'll also save. And now let's open the console, and you'll see that we had an error here. We caught the error, and it ran this code and displayed the error message. So that's how we handle errors with Async Await. We put our code that can cause an error inside try, and if there is an error, it's going to run the code inside catch. So now let's go back to products and remove error from the URL and the dot, and we'll also uncomment .catch and save. Next, we're going to learn some more details about try catch. So we'll open checkout.js. And one thing to know about try catch is that we don't have to use it with async await. We can actually use try catch with synchronous code or normal code. For example, here we try to run a function that does not exist, and this will cause an error. Try catch will catch this error and display a message. So notice that we're not using async await here. This is just normal code. So we can use try catch to catch errors in normal code as well. Another detail is whenever we get an error, it will skip the rest of the code. So here, it will not console.log next line. It will skip the rest of this code and go directly into catch. Now, one thing you might be wondering is, why don't we just use try catch everywhere and prevent all of our errors? So try catch and any error handling is meant to handle unexpected errors. That means our code is correct, but something outside our control caused the error. So we can give some instructions on what to do. So that's why we don't use try catch everywhere. We only use it for unexpected errors or errors outside of our control. So the last thing to know about error handling is that we can manually create errors. To manually create an error in try catch, at the top, we're going to use the word throw. So throw creates a new error, or it throws an error that we're going to catch later. And now we need to give this error a value. So we can use any type of value for an error, like a string, number, or an object. For an example, we're just going to use the string error1. So this will manually create an error. When we get an error, it's going to skip the rest of the code inside these curly brackets, and it's going to go straight into catch. So this error value is going to be saved inside this parameter, and it's going to run the code inside catch. So if we save and then check the console, throw creates an error, and it's going to display this error message up here. So now let's comment out this example and save. Next, if we're using promises, there are two ways to manually create an error. So inside this promise, if we want to manually create an error, we can also just throw an error, like the string error2. And this will throw an error and go inside .catch. By the way, if we await a promise, instead of going into .catch, it's going to go inside catch here. So await makes it behave sort of like synchronous code or normal code. If we save and check the console, it will get an error, it will not load the cart, and it will display this error message. So now let's comment out this example, and we'll learn the second way to create an error in a promise. Inside a promise, if we need to create an error in the future, then we need to use different code. For example, here we load the cart, and then once it's finished loading, we're going to run this function. So this function runs in the future. Inside this function, throw does not work because throw does not work in the future. Instead, promises give us another way to create an error. When we create a new promise, it gives us a second parameter called reject. Reject is a function, and it lets us create an error in the future. So here, after we load the cart, in the future, let's create an error using reject, brackets, and a string error3. So let's comment out resolve as an example. So now let's save and check the console. And you see that reject created an error in the future, and then it goes down here and runs the code inside catch and creates the error message. So to manually create an error in a promise, we have two ways. We can use throw if we're creating the error synchronously or right away, or we can use reject if we're creating the error asynchronously or in the future. So now let's comment out reject and uncomment resolve and save. So that's error handling. It lets us handle unexpected errors, and it also lets us create our own errors. So now let's save these changes into Git. We'll open Git inside products.js. We added .catch for promises and an error function for callbacks. And then in checkout.js, we added try catch for async await. And we also learned how to manually create our own errors. So we'll type a message describing our changes, learn error handling, and commit. Now that we learned backend, promises, and async await, let's use them in our project. We'll open our project and open the tab for the project, and we're going to go to the checkout page. So the feature we're going to work on is in the checkout page, we're going to make this place order button interactive. When we click this button, it's going to take our cart and turn it into an order. This time, instead of writing this code ourselves, we're going to use the backend to create an order. So first, let's set up an event listener for this button. We'll go back to our code and open our files. And that button is in a section called the payment summary. So we're going to open scripts/checkout/payment-summary.js. So now let's find the code for the button. To make it easier, we're going to press Ctrl F or Command F to search for code, and we're going to search for the text in the button. So we'll search for place your order. And now we have the code for the button right here. So we're going to set up an event listener so we can do something when we click it. First, we'll add a class to the button so we can get it in our JavaScript. At the end of the class, let's create a new line and add a class js-place-order. And now after we put this HTML on the page, we're going to set up an event listener. To do that, we're going to get this button into our JavaScript using document.querySelector, brackets, and a string. And to select this class, we're going to start with a .js-place-order. And now that we have this button, we're going to add an event listener to it. So we'll create a new line and use the method .add-event-listener, brackets. And we'll give this two parameters. The first parameter is the event we want to listen for, which is click. And the second parameter is a function we want to run when we click this button. So we'll type brackets, arrow, and curly brackets. And now when we click this button, we're going to make a request to the backend to create the order. So for this example, I set up a URL path in my backend for creating orders called /orders. So inside here, we're going to make a request to the backend using fetch, brackets, and then we're going to give it the URL of the request, which is https://SuperSimpleBackend.dev, and the URL path /orders. However, this time we need to send some data to the backend. So we need to send our cart to the backend in order to create an order. To send data in a request, we need to use a different type of requests. So there are 4 common types of requests: get, post, put, and delete. Get means we want to get something from the backend. Post means we want the backend to create something. Put means we want it to update something. And delete means we want to delete something. So far, we only use get requests, which let us get data from the backend. However, get requests don't really let us send data to the backend. So in this situation, we want to create an order. So we're going to use post to create something. Post lets us send data to the backend. So to create a post request instead of a get request, we're going to give fetch a second parameter, which is an object. And inside this object, we're going to give it a property called method, and this is the type of the request. In this case, we'll use a string post. And after this, we're going to give another property called headers, and this is going to be an object. Headers gives the backend more information about our request, and this is needed when we're sending data to the backend. Inside this object, we'll add the property string C content -T type, and the value will be the string application/JSON. This tells the backend what type of data we're sending in our request. Here, we're going to send some JSON, which is basically a JavaScript object. Next, we're going to add another property called body, and this is the actual data we're going to send to the backend. According to the documentation, we need to send an object with a property called cart, and this contains our cart array. So in the body, let's send an object with a property called cart, and give it the cart array. So we should have the cart array in this file, and it should be called cart. And finally, we can't send an object directly in our request. We need to convert it into a JSON string. To do that, at the front, we'll use JSON.stringify, open bracket, and close bracket. So this will convert this data into a JSON string, and now we can send it to the backend. Okay, so after we send this request, we need to wait for the response to come back. To do that, fetch returns a promise. However, instead of using .then to add a next step, let's use Async Await because it's cleaner. So first we need to make this function async. Remember, we can only use await inside an async function. So at the front of this function, we'll type the word async. And now in front of fetch, we can use await. This is going to wait for fetch to finish or for fetch to get a response from the backend, and then go to the next line. Now, because we used await, we can save the response in a variable. So at the front, we'll create a variable, const, and call it response, and make it equal to this result. Next, remember that to get the data that's attached to the response, we need to use response.json. So down here, we're going to use response.json and brackets. Now remember that response.json is also a promise. So at the front, we can use await to wait for this promise to finish before going to the next line. So this will give us the data that's attached to the response, which should be the order that was created by the backend. So let's save this in a variable using const order equals. And finally, let's console.log the order to see what it looks like. So now let's save, and then we'll open the project and make sure you have some products in your cart. And then we'll click place order. And now we can check our console to see what the order looks like. And you'll see that we got an order object from the backend. It has an order ID, an order time, and the products in our order, including a delivery time and the quantity that we want. So we successfully used the backend to create a new order. Let's also check the network tab up here and open network. So I'll resize this to make it a little easier to read. And we'll search for the super simple URL. And then we'll find this request, orders, with a status 200, and we'll click it. So inside the details, you'll see that it was a post request sent to /orders, and the status code was 200, so it was successful. Inside the payload tab, this is what we sent to the backend, which is our cart. in the Preview tab, this is what the backend sent back, an order object. And the Response tab is the same thing. We got the order object back. So that's how a real-world website works. Instead of creating the order on the web page or on our computer, we send an HTTP request to the backend to create the order. Okay, now that we created an order, let's save it somewhere. We'll go back to our code, and on the left, inside the data folder, let's create a file for our orders. So we'll click inside this folder, and then click here to create a file, and let's name it orders.js, and press enter. At the top, let's create an array to contain all of our orders. We'll use const orders equals an empty array. And let's export this so we can use it in other files. Export. Next, let's create a function for adding an order to this array. So we'll create a function, add order, brackets and curly brackets, and we'll give this function an order object, and we're just going to add it to the array. Now for orders, we usually want the most recent order at the top. So we're going to add this order to the front of the array. To do that, we'll type the array name, orders, and use the method .unshift, brackets, and we'll give it the order. So this will add the order to the front of the array instead of the back. Finally, let's save our orders into local storage. So we'll create a function to save to local storage, function save to storage, brackets and curly brackets, and we'll run local storage.set item, brackets, and a string. We'll use a local storage key orders, comma, and remember, local storage only supports strings, so we'll use json.stringify, brackets, orders. And now when we modify this array, we're going to save to storage and brackets. Finally, at the top, let's load the orders from storage. So here, we'll use local storage.get item, brackets, the string orders. And remember that this will be a string, so we need to convert it back into an array using the code json.parse and brackets. Now, in the beginning, we're not going to have any orders saved in local storage. So we can give this a default value using or and an empty array. So if there's nothing in local storage, it's going to use this empty array as a default and save. So now let's use add order in the payment summary. So first, we'll export this function and save, and then open the payment summary again. And at the top, we're going to import that function. So here we'll import curly brackets, add order from a string, and we'll go into the data folder, which is /data/orders.js. And we'll scroll back down. And now after we create an order from the backend, we're going to add it to the array and save it in local storage using the function add order, brackets, the order object, and save. Now, if we go to our web page and click Place Order, this should create an order from the backend and save it in local storage. So now we can open our console and go to the console tab, and let's check if it's inside local storage using local storage dot get item brackets and a string orders, and press enter. And you'll see that we saved an order in local storage. If you ever want to remove the orders from local storage, you can use this code. Local storage dot remove item brackets and the string orders. Press enter and then refresh the page. Let's go back to our code and let's get some practice and add some error handling to this code. So at the top, for async await, we're going to use try catch. So we'll type try curly bracket and catch brackets and curly brackets. And catch gets a parameter called error. So now we're going to move our code inside try. We'll select this code and then right click, cut, inside try, right click and paste. And I'll create a new line. And now if we make a request and there's some sort of network error, that error will go down here and we'll run the code inside catch. So in here, let's display a message. Console.log, the string unexpected error. Try again later. The last step is after we create an order, we should go to the orders page. To do that, at the bottom here, we're going to use an object called window.location. Window.location is a special object provided by JavaScript, and it lets us control the URL at the top of the browser. If we change the location object, it will change the URL at the top. So let's give this a try. We'll go into our code and we'll type window.location. Now location has a property called .href. This gives us the URL at the top of the browser. And if we change the href property, it will change the URL at the top of the browser. So we'll try that in our code. We're going to change .href and make it equal to the string orders.html. So this will replace everything after the slash here with orders.html. And this will open the orders.html file, which is at the bottom here. And this will open the orders page. By the way, orders.html is a file path. The current file is checkout.html because this code is running on the checkout page. So it starts from checkout.html and then looks for a file called orders.html beside it, which is this file here. And it loads this file in the browser. So now let's save. We'll open the project and then click Place Order. So it should create a new order using the backend, and it will take us to the orders page. So right now, we have a list of order objects, and that's all the data that we need to create this page. I'll leave generating the HTML and making this page interactive as exercises. So now let's check our tests to make sure that everything is still working. We'll open the tab for our tests and I'll refresh just in case, and it looks good, and we'll save our changes into Git. We'll go to the Git section. Inside orders.js, we created some functions for saving our orders, and in paymentsummary.js, we made the place order button interactive, and we use the backend to create an order. Let's create a message describing these changes. Create order using the backend and commit. So we're going to learn one more thing in this lesson, and this is needed to create the tracking page. We're going to learn how to use URL parameters. So first, let's open our project, and we'll go back to the orders page. And on this page, we have these track package links beside the products. If we click this link, it will take us to the tracking page at tracking.html. However, right now this page is just plain HTML. There's no JavaScript. So if we go back to our orders and then track a different product, you'll notice that all of the tracking pages are the same. So we need to make each tracking page different depending on the order and the product. So how do we know which product to track on this page? To create this, we can use a feature called URL parameters. URL parameters let us save data directly in the URL. To create a URL parameter, at the top, after this URL, we're going to type question mark and then order capital ID equals 1, 2, 3, for example, and press enter. So the question mark means we're adding a URL parameter to this URL. So a parameter is a property value pair. The left side is the property and the right side is the value. This is sort of like an object like this. So using URL parameters, we can save some data in the URL like this. And then we can use JavaScript to get this data out of the URL. To do that, we'll go back to our code and we'll open our files here and we'll scroll down to the bottom to the tracking page. And let's scroll all the way down to the bottom. And at the bottom of the body, let's add a script tag to run some JavaScript. So we'll type less than script greater than. And to get the parameters out of the URL, we can use a built-in class called URL. First, let's generate an object using this class. We'll type new capital URL and brackets. And we'll give it the URL that we want to get the parameters from. So in here, we'll type window.location.href. Remember that window.location.href gets the URL at the top of the browser. And now let's save this object in a variable. At the front, we'll create const URL equals this object. So this URL class analyzes the URL that we give it and breaks it down into different parts. One of the parts are the URL parameters. To get the parameters, we're going to use the property URL dot search capital P params. By the way, URL parameters are also called search parameters because they're used for features like YouTube search. So search params will let us get the URL parameters up here. So let's say that we wanted the order ID parameter. Inside our code, search params has a method called .get, brackets. And this lets us get individual parameters. So inside here, we'll give it a string, and we'll get the order capital ID parameter out of the URL. So let's console.log this. Console.log and brackets. If we save and then open our project and go to the tracking page and then open the console, right click, inspect the console, you'll see that it gave us the order ID that we saved up here. So using that code, we can get URL parameters out of the URL at the top and then use them to create this page. We can also save multiple parameters in the URL. To save another parameter, at the end, we can just type and now we can give it another property value pair, like product capital ID equals 456, and press enter. And now inside our code, we can get this second parameter. So inside here, we're going to make a copy of this line, select it, right click, copy, and then down here, right click, paste. And this time, we're going to get the parameter product capital ID and save. If we open the page and open the console, we got the order ID as well as the product ID out of the URL. So URL parameters lets us save different data in each URL. And we can actually go back and forth between them. So if we click the back button, it will go to this URL, and this URL has different data or parameters saved inside. If we click forward, this URL has different parameters or data saved inside. And this is how YouTube's search works. If we search for something, our search is saved as a URL parameter. If we search for something else, our search is also saved as a URL parameter, and we can go back and forth between the two. So this is actually all the data that we need to create the tracking page. We need to know which order it is and which product it is. Now there's one more thing to know to create this page. We'll go back to our code, and we're going to open the orders page at orders.html. And we're going to find the track package button using Control F or Command F. And we'll type the text in that button, track package. So notice that these buttons are just a link to the tracking page or tracking.html. So when you're generating this HTML, make sure that you add URL parameters after this tracking page URL. Using question mark, the order capital ID equals, and then you substitute the order ID like 1, 2, 3, and then also attach the product ID. Product capital ID equals 456. So when generating this HTML, make sure you substitute the order ID and product ID into this URL so that when it opens the tracking page, you know which order and which product to track. I'll leave generating the HTML and making the tracking page interactive as exercises. So now let's save this file and let's check our tests. So we'll open the browser and open the test tab, and everything is still working. And we'll save these changes into Git. open the Git section. In orders.html, we added an example of adding URL parameters to the tracking page link. In tracking.html, we added an example of getting the parameters out of the URL at the top. Let's create a message describing these changes. Add URL parameters example and commit. And that's the end of this lesson. In this lesson, we learned what a backend is and how to make HTTP requests to the backend. We learned how to use XML HTTP request and fetch. We learned how to handle asynchronous code using callbacks, promises, and async await. We learned how to test asynchronous code. We learned about error handling for unexpected errors. We used the backend in our project, and we learned URL parameters. Before we look at the exercises, you might be wondering, what's the next step after this course? Instead of just using a backend, the next step is to learn how to create our own backend. To do that, you'll need to learn the command line. And after that, you'll learn a technology called Node.js, which lets us create our own backend. Also, after this course, you can learn how to put a website on the internet using this video right here. Here are some exercises that'll help you practice what we learned in this lesson. Thanks for watching. Here are some other videos and courses that you might be interested in. If you want to support this channel, you can click like, subscribe, and share this video with others. Thanks again, and I'll see you in the next one.